Hello everyone. Welcome to Sallyann Bytes. This is your complete Python programming course, advanced level, covering everything from a quick review of Python basics to functions, libraries, data file handling, data structures, stacks and queues, and exception handling. Whether you're a student, beginner, or just curious about Python, you're in the right place. This full-length video brings together 34 plus lessons into a single, easy-to-follow journey. Use the timestamps in the description or pinned comment to jump between topics. Grab your notebook, sit back, and let's master Python step by step, together. Review of Python Basics, Part 1. In this video, we are going to discuss about introduction of Python programming, tokens, structure of a Python program, variables and data types, dynamic typing, keywords, mutable and immutable types. So let's dive in and get started. What is Python programming? Python programming is an open source, which means it is a powerful interactive language and it is free for everyone to use and alter as needed. Python is object-oriented, which means objects help breaking down complex real-life problems into such that they can be coded and solved to obtain solutions. Python is a high-level programming language, which means language of writing computer instructions. The way of the syntax or style of the code are in a way that is easily understandable and close to human language. Python is based on the ABC language, a teaching language created to replace the programming language BASIC, which was developed earlier. And the name was inspired by the famous BBC comedy show Monty Python's Flying Circus. Python is a general-purpose programming language that can be used effectively to build any kind of program that does not require direct access to the computer hardware. Python was developed by Guido van Rossum in 1991 at the National Research Institute for Mathematics and Computer Science, the Netherlands. Let's discuss about interacting with Python, Python IDLE. To write or run Python programs interactively, we can either use the command line window or the IDLE. IDLE is a simple integrated development learning environment that comes with Python. The most important feature of IDLE is that it is a program that allows the user to edit, run, browse, and debug a Python program from a single interface. Python IDLE comprises Python shell, interactive mode, and Python editor, script mode. Let's discuss about the Python shell, interactive mode. Python shell window is an interactive window where we can type in the Python code or commands directly at the command prompt, $3 As soon as we press the enter key, we can see the output in the same window. In this example, we have given two print statements for displaying two different messages, hello world and welcome to Python programming, upon pressing the enter key. So we can give commands at the primary prompt and see the immediate results in Python shell, interactive window. Let's discuss about the Python editor, script mode. The drawback of interactive mode is that we cannot save the commands that we type. This can be overcome by script mode. In order to switch over to the script mode, click on the File menu option, New option, or press the shortcut key Ctrl+N from the shell window. While working in the script mode, when we enter the statements to be executed and press Enter key, we won't automatically see the results the way we would see in the interactive mode. To see output from a script mode, we have to run this script or invoke the print function. It must be remembered that even if we enter the print statements in the script mode, the output shall be displayed only in Python shell. To execute a Python script file, we have to choose the Run module option from the Run menu or press the function key F5. Look at the picture, right side, you can see the script mode. We can save the commands that we type. To see output from a script mode, we have to run this script or invoke the print function. You can see the print statement typed in script mode with the message Hello World. Now, look at the left side, output of the program Hello World, displayed in the Python shell or the interactive window. Let's see the different types of files in Python. By default, a file is saved with .py extension in Python. There are different types of files in Python. .py is the normal extension for a Python source file. .pyc is the compiled bytecode. .pyd is a Windows DLL file for Python. .pyo is a file created with optimizations. .pyw is a Python script for Windows. .pyz is a Python script window. You can see the difference between script mode and interactive mode in Python. First point. In script mode, you write your Python code in a file and save with a .py extension and then run it using the command line or an IDE. But, in interactive mode, you can write commands in front of Python command prompt, $3 and run Python code one line at a time. You can type Python code and see the results immediately. Second point. In script mode, the code is executed from top to bottom and the results are displayed in the console that is in the interactive window. In interactive mode, you can enter interactive mode by starting the Python interpreter from the command line or by using an IDE with a Python console. Third point. In script mode, you can use script mode to write and save complex programs for later use. Used by professionals. But in interactive mode, it is useful for testing small pieces of code or for exploring the language. Used by beginners. The basic element of Python is tokens. A token is the smallest element of a Python script that is meaningful to the interpreter. Python programs are made up of various types of tokens, which includes identifiers, keywords, literals, operators, and delimiters. An identifier is the name given to any variable, constant, function, or module in a program. Some of the rules for defining identifiers are given here. First character of an identifier should start with a character or an underscore but not with a digit. No special characters are allowed except underscore. Reserved words, keywords, cannot be used as an identifier name, for example, reserved words like print function. Space is not allowed. Upper and lower case are treated differently. Examples of valid identifiers are ABC, X24Y, California _123, swap, name, etc. Examples of invalid identifiers are 12-digit, here, first character of an identifier should start with a character, but it starts with 1, it's a digit. So, it is invalid identifier. Roll number, here space should not be allowed, so, it is invalid identifier, name $, no special characters are allowed. It's invalid. Pin code, here no space allowed. So it's invalid. The next token in Python is the keyword. Keyword is the reserved words of Python that have a special fixed meaning for the interpreter. No keyword can be used as an identifier, as keywords have specific meaning for the interpreter. For example, if, else, while, for, def and class. The next token in Python is the literals. A fixed numeric or non-numeric values that are directly used in a program is called a literal. Such as numbers, strings, Boolean values, or other data that represents values to be stored in variables. They are also known as constants. Here is the list of types of literals and examples. String literals, A equals XYZ, B equals Mississippi, etc. String literals are enclosed in quotation marks. Numeric literals, A equals 5, P equals 2,500, etc. Floating literals, salary equals 30,000.00, area equals 2.5, etc. Boolean literals, value equals true, value 2 equals false, etc. Collection literals, list 1 equals 1, 2, 3, 4, 5, enclosed in square brackets, tuple 1 equals 10, 20, 30, 40, 50, enclosed in parentheses, that is round brackets, etc. Literals are data items that have fixed value. The next token in Python is the operators. A symbol or a word used to perform operations on data and returns the result. Example, arithmetic operators, addition, subtraction, multiplication, division, comparison operators, equal to, not equal to, less than, greater than, and logical operators, and, or, not. The next token in Python is the delimiters. The symbols used as separators of values or to enclose some values. For example, parentheses, braces, lists, commas, semicolon, and colon. Python uses whitespace to separate tokens, which means that spaces, tabs, and line breaks are all used to delimit tokens in a program. This makes Python code easy to read and write, and also helps to ensure that the code is structured correctly. Hashtag symbol used to insert comments is not a token. Any comment itself is not a token. Here you can see an example for identifying the tokens in Python script. Observe the following script and enlist all the tokens used in it. For each token, write its category to. X equals 68, Y equals 12, Z equals X/Y, print X, Y, ZR, X, Y, Z. Now, look at the tabular column. Here, X, Y, and Z are identifier or variable. Print is a keyword. Equal to and slash are delimiters or operators, 68, 12, X, Y, Z are our literals. Let's see the structure of a Python program. Programs consists of modules which contain statements. Statements contain expressions that create and process objects. Let's see the components of a Python program. Comments. Comments are additional information provided against a statement. Interpreter ignores them and does not count them as commands. Symbols used for writing comments include hash for single-line comments or triple-single or triple-double quotation marks to write multiple-line comments. 3 triple quotation marks to start the comment and 3 triple quotation marks to end the comment. Next is function. I have marked in white color. Function is a set of instructions defined under a particular name that performs a specific task which, once written, can be called whenever and wherever required. Here, you can see the function is called below and the comment line given inside the program is called inline comments. Next is expression. Expression represents something, like a number, a string, or an element. Any value is an expression. Here, you can see the yellow boxes containing value 5, value 10, b plus a, b plus 10 are all expressions. Next is the statements. Anything that does something is a statement. Any assignment to a variable or function call is a statement. Any value contained in that statement is an expression. Here you can see red boxes holding statement a equals 5, b equals 10, c equals b plus a. Next is blocks. You can see blocks in blue color here. A block refers to a group of statements which are part of another statement or function. All statements inside a block are indented at the same level. I have marked the indentation in green color for your reference. Variables are used to store values, such as numbers, strings, or other data types. Through a variable we store the value in the memory of a computer. A program manipulates its value. Every variable has a type and this type defines the format and behavior of the variable. A variable is a name that refers to a value. You can assign a value to a variable using the equal sign operator. Here's an example: x equals 5. In this example, x is the variable name, and 5 is the value that is being assigned to it. In Python, you can create variables and assign values to them using the assignment operator, equal sign. Look at the example 1. In this example, a variable named mathematics and assigns it the value 98, print function outputs the value of the variable mathematics as 98. Here you have to note that in an assignment statement, the variable must be on the left side of the assignment, equal sign operator, otherwise it will generate error. Look at the example 2, 98 equals mathematics. We have reversed the order and attempted to assign a value to the literal 98, which is not permissible. The error message we encountered is, syntax error, cannot assign to literal, occurs because we are trying to assign a value to a literal, which is not allowed in Python. Look at the right side corner box. Multiple variables can be declared in a single statement. Example 1, x, y equals 2, 3. Here, it binds x to 2 and y to 3. Example 2, total marks equals count equals 0. Here, both variables total marks and count holds the value 0. Identity of a variable refers to the variable's address in the memory, which does not change once it has been created. The address of an object can be checked using the method ID of variable or object, which is the syntax or rule. For example, variable x holds the value 10. When we print the identity, that is ID of x, the output displays 140652663 for 145296, which is the address of memory location storing value 10. Let's learn about the data types in Python. In Python, data type refers to the type of value that a variable or an expression represents. Let's see the data types one by one. Now let's see about integer data type. Integer is termed as int. Integer represents whole numbers without any fractional part. They can be positive or negative and have unlimited size in Python. An integer in Python can be of any length. Let's look at the examples. In these examples, variables are created with positive, negative, 0 and printed. You can pause the video and see one by one. Here, you have to note that while writing a large integer value, do not use commas to separate digits. Also, integers should not have leading zeros. You can represent integers as hexadecimal, base 16, and octal, base 8, values. Look at the right side examples. In line 1, the value 0x, a, 0f is assigned to the variable x. The prefix 0x indicates that the value is in hexadecimal format. Hexadecimal numbers use the base 16 system, which includes digits from 0 to 9 and letters from a to f to represent values from 10 to 15. The hexadecimal value 0x, a, 0f represents the decimal value 2575 and printed. In line 4, the value 0037 is assigned to the variable x. The prefix 00 indicates that the value is in octal format. Octal numbers use the base 8 system, which includes digits from 0 to 7 to represent values. The octal value 0037 represents the decimal value 31 and printed. Boolean data type is a subtype of integer. It represents one of the two possible values, true or false. Any expression which can be true or false has the data type bool. A Boolean true value is non-zero, non-null, and non-empty. Let's look at the examples. In example 1, the expression compares the values 62 and 100, checking if 62 is greater than 100. Since this is not true, the expression evaluates to false. In example 2, the expression compares the values 124 and 224, checking if 124 is less than or equal to 224. Since this is true, the expression evaluates to true. Floating point numbers denote real numbers or floating point values, that is, numbers with fractional part. Floating point numbers are written in decimal point that separates the integer from the fractional numbers. The fractional part of a floating point number can also be 0. Let's look at the examples. In these examples, floating point numbers are created with different variables and printed. Float can also be represented in scientific notation where the lowercase or uppercase letter e or e signifies the 10th power. Now, look at the right side example. In line 1, 3.14e2 represents the float value 314.0 in scientific notation. The e2 indicates multiplying the mantissa, 3.14, by 10 raised to the power of 2, resulting in 314.0. In line 4, 1.5e-3 represents the float value 0.0015 in scientific notation. The e-3 indicates multiplying the mantissa, 1.5, by 10 raised to the power of -3, which is equivalent to dividing by 1000, resulting in 0.0015. You can use either lowercase e or uppercase e as the exponent marker, and they both function the same way. Complex numbers in Python are made up of pairs of real and imaginary numbers. Let's look at the examples. In example 1, a variable named x is created and assigned the complex number 2 plus 5j. The syntax a plus bj represents a complex number, whereas the real part and b is the imaginary part. X.real returns the real part of x, and x.imag returns the imaginary part of x, and finally printed. The output will be the real part is 2.0 and the imaginary part is 5.0. In example 2, a variable named y is created and assigned the complex number for -2j. The syntax a plus bj represents a complex number, where a is the real part and b is the imaginary part, and finally printed. The output will be the real part is 4.0 and the imaginary part is -2.0. In example 3, a variable named z is created and assigned the result of adding the complex numbers x and y. Both x and y are complex numbers defined earlier in example 1 and example 2. Finally, the value of z is printed. The output will be the result of the addition of complex numbers x and y, which is 6 plus 3j. A sequence is a group of items with a well-defined ordering where each item is indexed by an integer. String is categorized under sequence data type. A string is a sequence of characters that can be a combination of letters, numbers, and special symbols enclosed within quotation marks, single, or double, or triple. These quotes are not part of the string. They only define the starting and ending of the string. A string may have any character, sign, or even space in between them. Now look at the examples. In the first example, a variable named str1 is created and assigned the value hello world. The value is enclosed in double quotation marks, indicating that it is a string literal. Finally printed as the string hello world as output. In the second example, a variable named str2 is created and assigned the value 12,345. The value is enclosed in double quotation marks, indicating that it is a string literal. Finally printed as the string 12345 as output. It's important to note that the value of str2 is a string, even though it consists entirely of numeric characters. In Python, strings are a sequence of characters and can contain alphanumeric and special characters. In the third example, a variable named str3 is created and assigned the value Python 3.9.2. The value is enclosed in single quotation marks, indicating that it is a string literal. Finally printed as the string Python 3.9.2 as output. Next sequence data type is lists. List is a sequence of items separated by commas and the items are enclosed in square brackets. Let's look at the example. The provided Python code demonstrates the creation and printing of a list. Let's analyze each line. In this example, a variable named list1 is created and assigned a list containing multiple values. The list consists of integers, 20, 33, a floating point number, 6.5, and strings, New York, D34. Finally, it prints the entire list, 20, 6.5, New York, D34, 33, as output. Lists are enclosed within square brackets. Next sequence data type is tuple. Tuple is a sequence of items separated by commas and items are enclosed in parentheses. Note that once created, we cannot change the tuple. Let's look at the example. The provided Python code demonstrates the creation and printing of a tuple. In this example, a variable named tup1 is created and assigned a tuple containing multiple values. The tuple consists of integers, 180, strings, sam, p, and a floating point number, 4.5. Finally, it prints the entire tuple, 180, Sam, 4.5, p, as output. Tuples are enclosed within parentheses, round brackets. A mapping object maps immutable values to arbitrary objects. This data type is ordered and mutable. There is currently only one standard mapping type, the dictionary. A dictionary holds data items in key-value pairs and is accessed using keys, which are immutable data type and their values of any data type. Items in a dictionary is enclosed in curly brackets. Dictionaries permit faster access to data. Every key is separated from its value using a colon sign. In order to access any value in the dictionary, we have to specify its key in square brackets. Now look at the example. The provided Python code demonstrates the creation and printing of a dictionary. In this example, a variable named dict is created and assigned a dictionary containing key-value pairs. The keys are strings, name, age, class, and the corresponding values are nishant, 16, and 11. Finally, it prints the entire dictionary, name, nishant, age, 16, class, 11, as output, enclosed within curly braces. None is a built-in constant in Python that represents the absence of a value or the null value. This is a special data type with a single value. It is used to signify the absence of value or condition evaluating to false in a situation. It is represented by none. Python doesn't display anything when we give a command to display the value of a variable containing value as none. None will be displayed by printing the value of the variable containing none using print statement. Now, look at this example. A variable named value1 is created and assigned the value 30. This means that the integer 30 is stored in the variable value1. Next, a variable named value2 is created and assigned the special value none. None is a built-in constant in Python that represents the absence of a value or the null value. The print function is used to display the values of the variables value1 and value2 on the console. The output of the code will be 30 and none. This means that the value 30 will be displayed on the first line of the console when the code is executed, and none will be displayed on the second line. Set is an unordered collection of values of any type with no duplicate entry, enclosed within curly braces. Example, set1 equals 10, 20, 30, 40, enclosed in curly braces. Dynamic typing is a feature of the Python programming language where the type of a variable is determined at runtime, as opposed to being statically declared at compile time. In dynamically typed languages like Python, you can assign values of different types to the same variable without any explicit type annotations or declarations. Let's see some examples. In line 1, we assign the value 5 to the variable x. Since 5 is an integer, Python infers that x is of type integer. We then use the print function to display the value of x, which will output 5. Next, we use the type function to determine the type of x, and it will return class int, indicating that x is of type integer. In line 5, we reassign the value hello world to the variable x. The previous value of x, which was an integer, is discarded, and now x references a string. We then print the value of x, which will output hello world. When we use the type function on x, it will return class str, indicating that x is of type string. In line 9, we assign the list 1, 2, 3 to the variable x. The previous value of x, which was a string, is replaced, and now x refers to a list. We then print the value of x, which will output 1, 2, 3. When we use the type function on x, it will return class list, indicating that x is of type list. Thus, the code demonstrates dynamic typing in Python, where the same variable x can hold values of different types throughout the program execution. Python determines the type of the variable based on the value it is assigned at runtime. Let's discuss about the keywords in Python. Keywords in Python are reserved words that have a special meaning in the language. These words cannot be used as variable names, function names, or any other identifiers. For checking or displaying the list of keywords available in Python, we have to write the following two statements. Import keyword, print, keyword.kwlist. You can see, a list of all the keywords in Python are displayed in this picture. These keywords have a specific meaning and purpose in Python. Example, if and else are used for conditional statements, while is used for loops, def is used to define functions, and so on. All these keywords are in small alphabets except for false, none, and true, which start with capital alphabets. In Python, data types can be classified as either mutable or immutable. A mutable data type is one whose values can be changed after they are created. Mutable data types in Python include lists, dictionary, set, etc. Here's an example that demonstrates the mutability of a list. First line, my_list equals 1, 2, 3, creates a list containing the elements 1, 2, 3, and assigns it to the variable my_list. In Python, lists are ordered, mutable collections of objects enclosed in square brackets. In the second line, my_list of 0 equals 4 modifies the value at index 0 of the my_list list. It assigns the value 4 to the first element of the list. Look at the table. In Python, lists are 0 indexed, so index 0 refers to the first element 1. It assigns the value 4 to the first element of the list. Next line of the code uses the print function to output the contents of the my_list list. The output of the print statement is 4, 2, 3. This output indicates that the first element of the my_list list has been modified from 1 to 4, while the other elements remain unchanged. An immutable data type is one whose values cannot be changed after they are created. Any attempt to modify an immutable value will result in a new value being created. Immutable data types in Python include int, float, string, bool, complex, and tuples. Here's an example that demonstrates the immutability of a string. Example 1. S equals hello assigns the string hello to the variable s. Second line, s of the 0 equals h. This line attempts to modify the first character of the string s to uppercase h. However, since strings are immutable, this operation is not allowed. As a result, when you execute the code, it will raise a type error indicating that the string object does not support item assignment. The error message will be similar to type error, str object does not support item assignment. In example 2, s1 equals hello assigns the string hello to the variable s1. Next line, s2 equals s1.upper function, calls the upper function on the string s1 and assigns the result to the variable s2. The upper function returns a new string where all the characters are converted to uppercase. Next line, print of s1 uses the print function to output the value of s1. The output of the first print statement is hello. This is because the upper function does not modify the original string s1. It creates a new string with uppercase letters and assigns it to s2, leaving s1 unchanged. Next line, print of s2 uses the print function to output the value of s2. The output of the second print statement is uppercase hello. This is the result of calling the upper function s1 and storing the uppercase version of the string in s2. Note that once an immutable object loses its binding to its variable, the Python interpreter may delete the object and release the allocated memory to be used for other tasks. This process of automatic memory management is called garbage collection. Now, we can see the difference between mutable and immutable objects in Python. Mutable objects can be modified after creation. Operations that modify the object directly affect its state, whereas immutable objects cannot be modified after creation. Any operation that appears to modify an immutable object actually creates a new object with the modified value. Examples of mutable objects include lists, dictionaries, sets, and custom mutable objects. Examples of immutable objects include integers, floats, strings, and tuples. Mutable objects are not hashable, meaning they cannot be used as dictionary keys or elements in sets. Whereas, immutable objects are hashable and can be used as dictionary keys or elements in sets. Mutable objects may use more memory due to in-place modifications, as the original object is modified rather than creating a new object. Whereas, immutable objects are typically more memory efficient as creating new objects allows for reusing existing objects. Modifying a mutable object may result in changes reflected in other references to the same object. Whereas, modifying an immutable object requires creating a new object with the modified value. Review of Python Basics Part 2. In this video, we are going to discuss about operators and operands, input and output, Python's built-in function, typecasting, comments in Python, sequential statements, selection or conditional statements, iteration or looping constructs. So let's dive in and get started. In Python, operators are special symbols or functions that are used to perform operations on one or more operands. An operand is a value or variable that an operator acts upon. Operators, when applied on operands, form an expression. Same operator can behave differently on different data types. Let's see about mathematical or arithmetic operators, which are used to perform various mathematical operations on numeric data types such as integers and floating point numbers. These operators include addition, which adds values together. In example 1, we add x and y, which is 13, as output. In addition, second example, we concatenate strings with plus operator. Here, we concatenate strings hello plus world and get the output as hello world. Next arithmetic operator is subtraction. It subtracts the second value from the first value. In example 1 of subtraction, we subtract 30 minus 80, resulting in minus 50. Next arithmetic operator is multiplication, which multiplies two values together. In example 1 of multiplication, we multiply 10 and 3, resulting in 30. In example 2 of multiplication, we have string multiplication. Here, the string hello is multiplied by 5 using the asterisk operator. This operation results in the string being repeated 5 times, generating hello 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 as output. Next arithmetic operator is division, which divides the first value by the second value. In example 1 of division, the expression x/y divides x by y, resulting in 3.3333333333333335. The result is a floating point number. Division operation automatically promotes the result to a float. Next arithmetic operator is remainder or modulus. It returns the remainder of the division of the first value by the second value. In example 1 of remainder or modulus, the expression x modulus y calculates the remainder when x is divided by y, resulting in 1. In this case, 10 divided by 3 equals 3 with a remainder of 1. Next arithmetic operator is exponentiation, which raises the first value to the power of the second value. In example 1 of exponentiation, the expression x exponentiation y raises x to the power of y, resulting in 1000, since 10 raised to the power of 3 is 1000. Next arithmetic operator is integer division or floor division, which performs integer division and returns the largest integer value that is less than or equal to the result. In example 1 of integer division or floor division, the expression x floor division y performs floor division, which divides x by y and rounds the result down to the nearest whole number. In this case, 10 divided by 3 equals approximately 3.3333333333333335, but since floor division rounds down, the result is 3. You can work out the other examples given here. An operator can be termed as unary or binary, depending upon the number of operands it takes. A unary operator takes only one operand and a binary operator takes 2 operands. In this example, in the expression -5*3 plus 6 to 1, the first minus sign is a unary minus and the second minus sign is a binary minus. The multiplication and addition operators are binary operators. Arithmetic operators in Python have different precedence levels, which determine the order in which the operations are performed, that is from highest to lowest, parentheses, exponentiation, multiplication, division, and modulus, addition and subtraction. Here's an example that demonstrates how the order of operations is determined by operator precedence. In the expression, x equals 5 plus 10 asterisk 2 exponentiation 2/4, first, the exponentiation operator is evaluated. In this case, 2 to the power 2 equals 4. Next, the multiplication operator is evaluated. 10 times 4 equals 40. Then, the division operator, slash, is evaluated. 40/4 equals 10.0. Note that when dividing two integers in Python 3, the result is a float. Finally, the addition operator, plus, is evaluated. 5 plus 10.0 equals 15.0. Therefore, the final value of x is 15.0. Relational operators, also known as comparison operators, are used to compare two values or variables and return a Boolean value, true or false, based on the comparison. In an expression, comprising both arithmetic and relational operators, the arithmetic operators have higher precedence than relational operators. In Python, the following relational operators are available. Equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to. Here are some examples of how these relational operators can be used. Consider variable x and y are assigned the values 5 and 10 respectively for all these 6 Python statements. In the first statement, it compares the values of x, 5 and y, 10 using the equality operator. It evaluates to false. You can work out the other examples given here. Relational operators are applied to strings also. When the relational operators are applied to strings, strings are compared left to right, character by character, based on their ASCII code values. In the ASCII table, each character is assigned a unique numerical value. The lowercase letters have ASCII values ranging from 97A to 122Z, while the uppercase letters have ASCII values ranging from 65A to 90Z. In first example, it compares two string literals, lowercase hello and uppercase hello, using the less than operator. In this case, the ASCII value of lowercase h in hello is greater than the ASCII value of uppercase h in hello. Therefore, lowercase hello is considered greater than uppercase hello in lexicographical order. It evaluates to false. You can work out the other codes. Logical operators in Python are used to perform logical operations on Boolean values. They are used in control statements and loops to make decisions based on the truth value of expressions. The three logical operators in Python are AND, returns true if both operands are true, and false otherwise. OR, returns true if at least one of the operands is true, and false otherwise. Not returns the opposite of the operand's truth value, reverses the state of operand or condition. Here are some examples of using logical operators. In the given example, it assigns the values 5, 10, and 5 to the variables x, y, and z, respectively. In the first print statement, the AND operator returns true if both operands are true, and false otherwise. In this case, the expression x equal to z evaluates to true because x and z both have a value of 5. The expression y greater than x also evaluates to true because 10 is greater than 5. Since both operands of the AND operator are true, the overall expression x equal to z and y greater than x evaluates to true. In the second print statement, the OR operator returns true if at least one of the operands is true, and false if both operands are false. In this case, the expression x greater than y evaluates to false because 5 is not greater than 10. The expression x equal to z evaluates to true because x and z both have a value of 5. Since one of the operands of the OR operator, x equal to z, is true, the overall expression x greater than y or x equal to z evaluates to true. In the third print statement, the NOT operator reverses the truth value of an expression. If the expression is true, NOT makes it false. If the expression is false, NOT makes it true. In this case, the expression x equal to z evaluates to true because x and z both have a value of 5. The NOT operator then negates the truth value of x equal to z. Since x equal to z is true, NOT x equal to z evaluates to false. Logical operators in Python also have different precedence levels, which determine the order in which the operations are evaluated. The precedence of logical operators in Python is as follows, from highest to lowest. Not, and, or. Here's an example that demonstrates how the order of operations is determined by operator precedence. X equals true or false and not true, print x. This expression follows the order of operations, precedence, in Python. The NOT operator has the highest precedence, so not true evaluates to false. Next, the AND operator is evaluated. False and not true evaluates to false because one of the operands, false, is false. Finally, the OR operator is evaluated. True or false and not true evaluates to true because one of the operands, true, is true. Therefore, the final value of x is true. Shorthand or augmented assignment operators in Python are used to combine an arithmetic or bitwise operation, binary operation, with an assignment in a concise way. Instead of writing x equals x plus y, for example, you can use the shorthand operator plus equals. These operators modify the value of the variable in place, rather than creating a new variable, and can be used with all of the basic arithmetic and bitwise operators. Here is a list of shorthand operators in Python, along with examples of their usage. Pause the video and work out by your own. Membership operators in Python are used to test whether a value or a variable is a member of a sequence, such as a string, list, tuple, or set. Python provides two membership operators, in and not in. First, we will see how to use membership operators in strings. In operator returns true if a character or substring exists in the given string. Not in operator returns true if a character or substring does not exist in the given string. To use membership operators in strings, it is required that both the operands used should be of string type. Substring in string, substring not in string. In this example, it assigns the string hello, world, to the variable my_string. Then, it uses the in operator with the not operator to check if certain substrings are present or not in my_string. In the first print statement, world not in my_string checks if the substring world is not present in my_string. Since world is indeed present in my_string, the expression evaluates to false. In the second print statement, goodbye not in my_string checks if the substring goodbye is not present in my_string. Since goodbye is not present in my_string, the expression evaluates to true. Therefore, when you print the results, the output will be false for the first print statement, true for the second print statement. Identity operators in Python are used to compare the memory location of two objects. They check whether two objects are the same object or not. Python provides two identity operators, is and is not. First one is operator returns true if the left operand and the right operand refer to the same object in memory. That is, both variables are pointing to the same object. var1 is var2 results to true if id of var1 is equal to id of var2. Second one is not operator returns true if the left operand and the right operand does not refer to the same object in memory. That is, both variables are not pointing to the same object. var1 is not var2 results to true if id of var1 is not equal to id of var2. In example 1, here, it checks if x, list 1, 2, 3 and y equals x, refer to the same object using the is operator. Since both x and y refer to the same list object, the expression x is y evaluates to true. In the second part, a new list, 1, 2, 3, is created and assigned to the variable z. The print statement checks if x and z refer to the same object using the is operator. However, even though x and z have the same values, they are separate objects in memory. Hence, the expression x is z evaluates to false. Therefore, when you print the results, the output will be true for the first print statement, false for the second print statement. In example 2, it assigns the strings hello and world to the variables a and b, respectively. Then, it checks if a is not the same object as b using the is not operator. Since a and b are different string objects, the expression a is not b evaluates to true. In the second part, two separate lists, 1, 2, 3, are created and assigned to the variables c and d. The print statement checks if c is not the same object as d using the is not operator. Since c and d are separate list objects even though they have the same values, the expression c is not d evaluates to true. Therefore, when you print the results, the output will be true for the first print statement, true for the second print statement. Let's discuss about the user input. While writing a program, we need to fetch some input from the user. The values inputted by the user are fetched and stored in variables. First function is the input function. The input function reads a line of text from the user and returns it as a string. Here's an example of how to use the input function to get user input. Example 1. Name equals input of enter your name. In this example, the input function is used to get the user's name from the command line. The user's input is assigned to the name variable, which is then used to print a personalized greeting. When you run this program, it will prompt the user to enter their name, enter your name. The user can then type their name and press enter, enter your name, Alice. The program will then print a greeting that includes the user's name, hello, Alice. On the left-hand corner, you can see how it is practically implemented. You can also use the input function to get numerical input from the user. However, you need to convert the input to an integer or float before using it in mathematical operations. Here's an example. This program prompts the user to enter two numbers, n1 and n2. The int of input function is used to read the input as integers. After obtaining the input from the user, the program calculates the sum of the two numbers by adding n1 and n2 together and stores the result in the variable sum. And calculates the product of the two numbers by multiplying n1 and n2 and stores the result in the variable prod and finally prints the output. If value 20 and 30 are given, the sum is 50 and product is 600. Note that the int function takes a number, expression, or a string as an argument and returns the corresponding integer value. If the argument is an integer value, int function returns the same integer. Example, int of 20 returns 20. If the argument is an integer expression, the expression is evaluated and int function returns this value. Example, int of 20 plus 30 returns 50. If the argument is a float value, int function returns the integer part before the decimal point of the number. Example, int of 20.56 returns 20. If the argument is a string value, int function evaluates the string as integer. Example, int of string 200 returns 200. In Python, eval function is a built-in function that takes a string as an argument, evaluates this string as a number and returns the numeric result, int or float as the case may be. If the given argument is not a string or if it cannot be evaluated as a number, then eval function results in an error. Here's an example of using the eval function. Print of eval of string 50 plus 50 foot results in 100. The eval function is used to evaluate the value of a string. It takes a string as an argument, evaluates the string as a number and returns the numeric result. But in the second line, print of eval of integer 50 plus 50 results in type error. Typecasting, also known as type conversion, refers to the process of changing the data type of a variable from one type to another. Such data type conversion can happen in two ways: explicit and implicit conversion. Explicit conversion refers to the manual and intentional conversion of a value from one data type to another in a programming language. The programmer forces it in the program. The general form is new underscore data underscore type of expression. Let's see some examples. In line 1 of the Python code, converting a float value of 30.0 into an integer type, that is int of 30.0, will discard the fractional part 0 and shall return the value as 30. Next in line 3, converting an integer value of 40 into a float type, that is float of 40, will include the fractional part 0 and shall return the value as 40.0. Next in line 5, the argument for 50.0 is already a float, but since it's passed to the str function, it gets converted into a string representation of the number 450.0. Next, in line 7, the integer 98 represents the ASCII code value for the character B. When chr of 98 is called, it returns the character B. Now, look at the right side. Next is implicit conversion. Implicit conversion, also known as coercion, happens when data type conversion is done automatically during runtime by Python and is not instructed by the programmer. Now, look at the example. An integer value stored in variable n1 is added to a float value stored in variable n2, and the result gets automatically converted into a float value stored in variable n1 without explicitly telling the system. This is an example of implicit data conversion. The reason for the float value not being converted into an integer instead is due to type promotion that allows performing operations whenever possible by converting data into a wider size data type without any loss of information. It is also called type promotion. In Python, comments are used to document code and provide context for other developers. Comments are statements in a script that are used to explain Python code and are ignored by the Python interpreter and do not affect the execution of the program. Single-line comment in Python start with the hash symbol and continue until the end of the line. For example, hashtag this is a single-line comment, can be written either on the top, right side, or bottom of the statement. Multi-line comments can be created using triple quotes, either single triple quotes or double triple quotes. This is sometimes called a docstring and is typically used to document functions or modules. Look at the example 1, how multi-line comments are used. In addition to describing the purpose and functionality of your code, comments can also be used to temporarily disable code that is not currently needed or to leave reminders for future modifications. Look at example 2. We are temporarily disabling the print hello world code. The way in which the statements are executed defines the flow of execution in a Python program, which is categorized as sequential, conditional, and iterational statements. Python, sequential statements refer to a sequence of statements that are executed one after the other in the order they are written, in a sequential order or linear fashion. Sequential statements are simple statements or compound statements that are executed sequentially in the order, default, as they appear in the code. This picture includes the default flow of statement and is the simplest one. Statement 1 will be executed first, followed by statement 2 and then statement 3. Here's an example of sequential statements in Python. In this example, the statements are executed one after the other in the order, to find the area of a circle, as they appear in the code. In Python, selection or conditional statements are used to control the flow of execution based on a certain condition. They allow the program to choose or decide between two or more possible paths of execution based on the value of a condition. The simplest form is the if statement. The syntax is if condition statements. If condition is true, then the indented statement gets executed. However, it will not do anything if the condition evaluates to false. The execution of the indented statements are dependent on the header. Do not forget to place colon after if condition. Let's see an example. In this program, the user is prompted to enter a number. The program uses an if statement to check if the number is greater than 0. If the condition is true, it means the number is positive, and the program prints the number is positive. There is no else clause, so if the number is 0 or negative, no message will be printed. The second type of conditional if statement, called if, else, provides two possibilities. The condition is an expression that evaluates to either true or false. If the condition is true, then the code block under if statement will be executed, otherwise, the code block under else statement will be executed. In this example, the if statement checks if the value of number is greater than 0. If it is, the program prints the number is positive to the console. If the condition is false, it goes to the else part, that is, the number is negative, the program prints the number is negative. The if-elif else statement in Python is used when you have more than two conditions to check. It allows you to execute different code blocks based on multiple conditions. In if-elif else statement, each condition is checked in order. If the first is false, the rest is checked and so on. If one of them is true, the corresponding branch executes, and the statement ends. Here, else is optional. Number of elif is dependent on the number of conditions. Let's see an example for if-elif else statement. Program to accept salary from the user and calculate the tax payable. First line prompts the user to enter the salary of a person and stores it in the variable salary. If salary less than equal to 50,000. The next line calculates the tax amount by multiplying 0.055% with the salary value and assigns it to the variable tax. Elif salary less than equal to 60,000. The next line calculates the tax amount by multiplying 0.077% with the salary value and assigns it to the variable tax. Elif salary less than equal to 70,000. The next line calculates the tax amount by multiplying 0.088% with the salary value and assigns it to the variable tax. Now we look into the else part. If none of the preceding conditions are true, the code calculates the tax amount by multiplying 0.1010% with the salary value and assigns it to the variable tax. Finally, it prints the original salary value and the calculated tax amount to the console. The condition in an if or elif clause can be any Python expression, even a statement that returns a value, even a none value. A nested if-elif-else statement in Python is a structure where you can place one if-elif-else statement inside another if-elif-else statement. This structure is used when you have more complex conditions that require multiple levels of checks. Let's see an example for nested if-elif-else statement. Divisibility checker, to check if a number is divisible by 2 or 3 inch. In this Python program, the input function is used to prompt the user to enter a number. The int function is used to convert the input into an integer so that it can be used in the calculations and conditions of the program. The program uses nested if-elif-else statements to check the divisibility of the number by 2 and 3. If the number is divisible by 2 and 3, it prints the number is divisible by both 2 and 3. If the number is divisible by 2 but not by 3, it prints the number is divisible by 2 but not by 3. If the number is divisible by 3 but not by 2, it prints the number is divisible by 3 but not by 2. If the number is not divisible by either 2 or 3, it prints the number is not divisible by either 2 or 3. Let's check the output for this program. If number is 24, the output will be, the number is divisible by both 2 and 3. But when the number is 27, the output will be, the number is divisible by 3 but not by 2. In Python, iterative or looping statements are used to execute a block of code repeatedly. They allow the program to perform the same task multiple times, without the need to repeat the code manually. The iteration construct means repetition of statements depending upon a condition test. The statements will be executed till the condition is true. As soon as the condition becomes false, the repetition stops. There are two main types of iteration, for loop and while loop. For loop is a definite loop. Statements are executed for a definite number of times. While loop is an indefinite loop. Statements are executed until a logical condition remains true. Let's learn about the for loop. The for loop statement is used to iterate or repeat over a range of values or a sequence, such as a list, tuple, or string. The basic syntax of a for loop is for variable in sequence : statements in body of loop, else : statements. In each iteration of the loop, the variable takes on the next value in the sequence, and the code block inside the loop is executed. Here, variable is a variable that takes a new value from the range each time loop is executed. Sequence may be a list, string, tuple. Else statement will be executed after all the iterations of for loop, if provided. Here are some key points to remember for loop. The for loop in Python is used to iterate values from range of values, strings, lists, tuples, or dictionary. Else statement is optional and will be executed after all the iterations of for loop are over. Repeated execution of a set of statements is called iteration. The loop variable contains the highest value of the list after for loop is over. Value of for loop variable cannot be defined beforehand. We shall now discuss about the range function. The range function in Python is a built-in function that generates a sequence of integers, typically used in for loops. The syntax is range of start, stop, step. Can you repeat? Range of start, stop, step. Here, start is an optional parameter. An integer number specifying at which position to start. Default value is 0. Stop is a required parameter. An integer number specifying at which position to stop. Stop value is not included. Step is an optional parameter. An integer number specifying the incrementation. Default value is 1. Here, you have to note that range function is often used in for loops. The arguments of range function must be integers. The step parameter can be positive or negative other than 0. Key points of start value in range function. If start value is not given, the default value is 0. Key points of step value in range function. If step value is positive, move in forward direction. If step value is negative, move in backward direction. If step value is not given, the default value is 1. Key points of stop value in range function. Stop value will not be included. Here are some examples of range function. Range of 10 gives the output 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Range of 1,11 gives the output 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Range 0,30,5 gives the output 0, 5, 10, 15, 20, 25. Range of 0,-9,-1 gives the output 0, -1, -2, -3, -4, -5, -6, -7, -8. Let's see an example. Write a Python program to generate the table of a number using for loop. Here you have to note that the range of 1,11 used in this program will generate values as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I is loop control variable and will be assigned each generated value, for which the body of for loop will be executed. Now look at the Python code. This code prints the table of a given number. Here's how it works. The code prompts the user to enter a number using the input function and converts the input into an integer using int function. The entered number is stored in the variable num. The for loop iterates over the range of values from 1 to 10 exclusive, using range 1,11. In each iteration, the loop body executes, which includes a print statement to display the multiplication table. The print statement prints the value of num, the iteration variable I, the multiplication symbol x, and the result of multiplying num by I. After executing the code inside the loop body, the loop moves to the next iteration. This process continues until the loop completes all iterations. For example, if the user enters the number 5, the output will be. The code prints the multiplication table of the entered number 5 from 1 to 10. Now let's learn about the next conditional statement, while. While statement is used to execute a code block repeatedly as long as a certain condition is true. Look at the picture. If test expression is true, the body of the loop is executed. Again, the control condition of the loop is tested and the loop continues as long as the condition remains true. When the test outcome of this condition becomes false, the loop is not entered again and the control is transferred to the statement immediately following the body of the loop. The four elements of a while loop in Python are initialization expressions. It initializes the loop control variable and it is given outside the while loop before the beginning of the loop. Next one is the test expression. If its truth value is true, then the loop body gets executed, otherwise not. Next one is the body of the loop. It is the set of statements that are executed repeatedly in loop. Last one is the update expression. It updates the value of loop control variable and it is given inside the while loop. The syntax of the while loop is initialization. While test expression : body of while loop. Code block to execute while the condition is true. Update expressions. In while loop else statement is optional. Here, initialization. It initializes the loop control variable and it is given outside the while loop before the beginning of the loop, while is a reserved word. Test underscore expression is the condition to be checked for true or false value. Body of while consists of single or multiple statements. Update expressions, it updates the value of loop control variable and it is given inside the while loop. Here is an example of using a while loop in Python to calculate the factorial of a number. The factorial function says to multiply all whole numbers from our chosen number down to 1. The factorial of any number is that number times the factorial of that number minus 1. Now look at the Python code. The user is prompted to enter a number using the input function, and the value is stored in the variable num as an integer. The variable factorial is initialized to 1. This variable will store the calculated factorial. The while loop is used to calculate the factorial. As long as the value of num is greater than 0, the loop will continue executing. Inside the loop, the current value of num is multiplied with the factorial variable, and the result is stored back in the factorial variable. This is equivalent to factorial equals factorial asterisk num. After multiplying, the value of num is decremented by 1 using num equal to num minus 1. The loop continues until num becomes 0. Finally, outside the loop, the program prints the calculated factorial value using the print function. So, when you run this program and enter a number 5, it will calculate the factorial of number 5 and displays the result as 120. Review of Python Basics Part 3. In this video, we are going to discuss about strings and lists. It's revision time. So let's dive in and get started. Strings are a sequence of characters enclosed in either single quotes or double quotes. This sequence of Unicode characters may include a letter, a number, special character, white space, or a backslash. Python treats single quotes the same as double quotes. Triple quotes are typically used for strings that span multiple times. Strings are used to represent textual data and are one of the fundamental data types in Python. Strings are immutable, which means once created, their contents cannot be changed. Example: a string named Sallyann Bytes is created and stored in variable name. The string is enclosed in single quotes. An individual character in a string is accessed using a subscript, index. The subscript should always be an integer, positive or negative, and begin with 0 in case of positive indexing and with -1 while working with backward indexing. Never use str as name of the variable, otherwise the functionality of the str function will be overwritten. Str function is used to change any data type to string. Strings can be manipulated using operators like concatenation, that it adds or joins two or more strings using plus operator. Repetition concatenates multiple copies of the same thing using asterisk operator. Membership in and not in returns true if a character exists in the given string and returns false if the character does not exist in the string. Comparison operators compares strings using a ASCII or Unicode value of the characters. Unicode values are also called ordinal values. String slicing extracts the character from the given index. Now, look at the examples. In line 1 and 2, str1 is assigned the value hello, and str2 is assigned the value Python. In line 3, string concatenation, the plus operator is used to concatenate str1 and str2. The result is hello Python, which is printed in output 1. In line 4, string repetition, the asterisk multiplication operator is used to repeat str1 3 times. The result is hello hello hello, which is printed in output 2. In line 5, membership operator in, the in operator checks if the character h is present in str1. Since it is not present, the result is false, which is printed in output 3. In line 6, membership operator not in, the not in operator checks if the character s is not present in str2. Since it is not present, the result is true, which is printed in output 4. In line 7, string comparison, the greater than operator compares str1 and str2 lexicographically. Since hello is not greater than Python, the result is false, which is printed in output 5. In line 8, string slicing, the square brackets 0:4 are used to extract a substring from str1 starting at index 0 and ending at index 3, 4 is excluded. The result is hell, which is printed in output 6. Traversing a string means accessing all the elements of the string one after the other by using the subscript or index value. Each character in a string has an index value. Indexing starts at 0 and must be an integer. Individual elements or slots can be accessed by typing index value inside square brackets. Now, we can see, iterating through the elements of a string using for loop. Each character of the string can be accessed sequentially using for loop. This is done using the indexes and iterating over it results in displaying the elements of a string, one character at a time. Syntax is for iterable object, in string : print I. Let's look at an example, traversing through string using a for loop. Now, look at the Python code. The variable my_string is assigned the value hello, world. It is a string that contains the text hello, world. The for loop is used to traverse or iterate over the characters in the string my_string. In each iteration of the loop, the variable char takes on the index value of each character in the string, one at a time. You can see on the left side picture how forward indexing is done. For index value 0, character h is printed within the loop. Next, for index value 1, e is printed and so on till index value 12 exclamation point is printed, that is, until the character of the string ends. Each character of the string is printed on a separate line. As a result, when you run this code, it will print each character of the string hello, world, on a new line, giving the output, as shown on the console. The loop iterates over the string from the first character, h, to the last character, exclamation point, and the print statement is executed for each character, causing it to be displayed on the console. String traversal using range function. Range method along with for loop can be used to extract the characters from a string. Syntax is, for I range of 0, len of, str1, print, str1 of I. Let's see an example. str1 is assigned the value Python. The for loop iterates over the range from 0 to the length of str1, exclusive, with a step of 2. This means it will iterate over the indices of str1 taking every second index. Inside the loop, str1 of I retrieves the character at index I in str1. The retrieved character is printed using the print statement. Range, start, stop, step, start value is 0, stop at length of the string. Here, length of the string Python is 6, that is the number of characters of string Python. We are stopping at 6, so 6 is not included. Step value is 2. The character at index 0 in str1 is p, so it is printed. The character at index 2 in str1 is t, so it is printed. The character at index 4 in str1 is o, so it is printed. Note, the index of a string starts from 0, so the first character is at index 0, the second character is at index 1, and so on. Let's see an example. Write a Python program to input a string from the user and print it in the reverse order without creating a new string. Now, look at the Python code. In this program, the user is prompted to input a string using the input function, and the input is stored in the input_string variable. To print the string in reverse order, we use a for loop with the range function. The loop starts from the last index of the string and stop value at -len of input_string -1, and iterates in reverse order, decrementing the index by 1 in each iteration, -1 as the step value. Now, pause the video and check the range values of start, stop and step values, which I have clearly explained below the program. Now, inside the loop, input_string of index of I accesses the character at the current index, I, and prints it. The end equals blank space argument is used to prevent printing a new line after each character. After the loop completes, we use print without any argument to print a new line, ensuring that subsequent output appears on a new line. When you run the program, it will ask you to enter a string. Here, we have entered Hello World. Once you provide the input, it will print the string in reverse order on the same line. So the output will be DLROW blank space OLLEH. In Python, string slicing refers to the technique of extracting a portion or a substring from a string by specifying the starting and ending indices. So what is a slice of a string? A slice of a string is a substring. This extracted substring is termed as slice. Chunk of characters can be extracted from a string using slice operator with two indices in square brackets separated by colon. The basic syntax for string slicing in Python is string name open square brackets, start colon, stop colon, step, close square brackets. Here stop is excluded. Here's what each part of the slicing syntax means. String_name. The original string from which you want to extract a substring. Next is start. The index representing the start position of the substring, inclusive. Next is stop. The index representing the end position of the substring, exclusive. Next is step. It is optional. The step or increment value for selecting characters. It determines how many characters to skip while slicing. If step value is positive, move in forward direction. If step value is negative, move in backward direction. Let's see some examples. In line 1, str1 is assigned the value hello Python. In line 2, str1 of 2:6 selects a substring from index 2 to 6, exclusive, so it includes characters at indices 2, 3, 4, and 5. The selected substring is LLO, which is printed. In line 3, str1 of 5 selects a substring from the beginning up to index 5, exclusive, so it includes characters at indices 0, 1, 2, 3, and 4. The selected substring is hello, which is printed. In line 4, str1 of 3: selects a substring from index 3 to the end, so it includes all characters starting from index 3 till the end of the string. The selected substring is LO space Python, which is printed. In line 5, str1 of 2 selects a substring with a step of 2, which means it selects every second character from the beginning to the end. The selected substring is HLOPTO, which is printed. In line 6, str1 of -5:-2 selects a substring from the index -5, -4, -3. The selected substring is YTH, which is printed. In line 7, str1 of 5:2:-1 selects a substring from index 5 to index 2 in reverse order due to the step of -1. The selected substring is space OL, which is printed. In line 8, str1 of -2:5:-1 selects a substring from the second last index to index 5 in reverse order. The selected substring is OHTYP, which is printed. In line 9, str1 of -2:5:-2 selects a substring from the second last index to index 5 in reverse order with a step of -2. The selected substring is OTP, which is printed. Let's have a quick revision of the string methods, which we have already learnt in grade 11. If you want a detailed explanation of each string method, you can check the strings video of class 11. The first method is len. This method returns the length of the string, the number of characters including spaces and special symbols. Revise the example given here. Python string is alpha returns true if a given string consists of alphabets only. It returns true only if all characters of a string are alphabets, both uppercase and lowercase, only. One thing to note is white space is not considered as an alphabet, thus if there is a white space in string then this method returns false for that string. The syntax is str. is alpha function. From the syntax it is clear that this method does not take any parameters. If any parameter will be passed, then it will raise an error. Revise the example given here. The isDigit function returns true if the string contains only digits, otherwise false. The syntax is str.isDigit function. Revise the example given here. Split method breaks up a string at the specified separator and returns a list of substrings. Syntax is str.split of separator, max split. The split method takes a maximum of two parameters. One of the parameter is the separator and the other parameter is the max split. Here, the separator parameter is optional. The separator is a delimiter. The string splits at the specified separator. If the separator is not specified, any white space, that is space, new line, string is a separator. The next parameter max split is also optional. The max split defines the maximum number of splits. The default value of max split is -1, which means no limit on the number of splits. Revise the example given here. String lower method is used to return a copy of a specified string where all case-based characters turned into lowercase. The main aim of this function is to convert the string into lowercase. The syntax is str.lower function. Revise the example given here. In is lower method. If all case-based characters, letters, of a string are in lowercase, then this method returns true, otherwise returns false. The syntax is str.isLower function. Revise the example given here. String upper is used to return a copy of a specified string where all case-based characters are in uppercase. The main aim of this function is to convert the string into uppercase. The syntax is str.upper function. Revise the example given here. In is upper method. If all case-based characters, letters, of a string are in uppercase, then this method returns true, otherwise returns false. The syntax is str.isUpper function. Revise the example given here. Python string replace is an built-in function. This function replaces all the occurrences of the old string with the new string. It is used to replace a specified phrase or string with another phrase or string and returns the result after replacement. This method does not modify the original string. This method basically returns a copy of a string where all occurrences of its substring are replaced by some other substring. It replaces the old substring with the new substring and returns the copy of the string. One thing to remember is that it does not modify the original string. This method comes under the category of class str. There are three parameters of replace function. Old value. It is a mandatory attribute used to specify the substring that is needed to be searched. New value. It is a mandatory attribute that is used to specify the value we need to replace. Count. It is an optional parameter and is a number that is used to specify how many occurrences of the old value you want to replace. Revise these examples for replace function. Also, the second example is Python string replace function using count parameter. Revise both examples. Python string find is an inbuilt function. This function is used to search the first occurrence of the substring in the given string. If you are finding a substring that exists inside a string, then this function returns the index of the first occurrence of the string. If the substring does not exist in a string, then the function returns -1. The syntax is str.findOf, sub, start, end. Here, sub is the substring which needs to be searched in a given string. Start is starting position where substring is to be checked within the string. End is the end position, which is the index of the last value for specified range. Revise the example given here. Revise these examples also for string find function. If the substring is not found, it returns -1. Python string lstrip function returns the string after removing the spaces from left of the string. The syntax is str.lstrip or str.lstrip of characters. Here, chars is optional, a string specifying the set of characters to be removed from the left. All combinations of characters in the char's argument are removed from the left of the string until left character of the string mismatches. Revise all these examples by your own. Python string strip function removes all the trailing white spaces from the right of the string. The syntax is str.rstrip or str.rstrip of characters. Here, chars is optional, a string specifying the set of characters to be removed from the right. All combinations of characters in the char's argument are removed from the right of the string until right character of the string mismatches. Revise the examples given here. Python string is space function returns true if the string contains only white space characters, otherwise returns false. The syntax is str.isSpace function. Revise the examples given here. Python string is title function doesn't take any arguments. It returns true if the string is properly title cased, else returns false if the string is not a title cased string or an empty string. The syntax is str.is title function. Revise these examples given here. Python string join function returns a string in which the string elements have been joined by a string separator. The syntax is str.join of sequence. In sequence, join function takes an argument which is of sequence data type, capable of returning its element one at a time. This method returns a string which is the concatenation of each element of the string and the string separator between each element of the string. Revise these examples given here. Python string swap case function converts and returns all uppercase characters into lowercase and vice versa of the given string. It does not take any argument. The syntax is str.swap case function. Revise these examples given here. Python string partition, separator, function is used to split the given string using the specified separator and returns a tuple with 3 parts. Substring before the separator, separator itself, a substring after the separator. The syntax is str.partition of separator. Separator argument is required to separate a string. If the separator is not found, it returns the string itself followed by 2 empty strings within parentheses as tuple. Revise these examples given here. Python string ends with function returns true, if the given string ends with the specified substring else returns false. The syntax is str.ends with function. Revise these examples given here. Python string starts with function returns true, if the given string starts with the specified substring, else returns false. The syntax is str.starts with function. Revise these examples given here. In internal storage or memory of the computer, the characters are stored in integer value. A specific value is used for a given character and it is based on ASCII code. Python provides 2 functions for character encoding: ORD function and CHR function. First, we will learn about the ORD function on the left side of this screen. In ORD function, it returns the ASCII or Unicode or ordinal of the character. Revise these examples given here. Now, look at the right side of the screen. We will learn about CHR function. The CHR function is used to convert an integer representing a Unicode code point into the corresponding character. Revise these examples given here. A string can be unpacked to its individual characters. These characters can be assigned to individual variables, to a list or a tuple. You can revise these examples given here. Let's have a quick glance about lists. A list is a collection of values or an ordered sequence of values or items. The items in a list can be of any type such as string, integers, float, objects, or even a list. Elements, the values that make up a list, are called its elements. Elements of a list are enclosed in square brackets, separated by commas. Lists allow duplicate values as well. The element of the list can be accessed by its index. Lists are mutable, that is, values in the list can be modified, which means that Python will not create a new list when you make changes to an element of a list. Elements of the list need not be of the same type. List is a sequence data type like strings. Now, look at the example. List 1 equals 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. This list in computer memory shall be represented as shown in the below picture with positive and negative indexes. On the basics of the index values, the elements in the list are accessed and retrieved. You can revise these examples given here. In Python, list comprehension is a concise way to create lists based on existing lists or other iterable objects. It allows you to create a new list by applying an expression or transformation to each item in the existing list, optionally filtered by a condition. The syntax is new_list equals expression for item in list if condition. This is equivalent to for item in list if condition expression. You can see how the left side example is equivalent to the right side example. Both have the same output. List slicing is a feature in Python that allows you to extract a portion of a list. It provides a way to create a new list by specifying a range of indices. The general syntax for slicing a list is list of open brackets start : stop : step close brackets, where start is the index where the slice starts, inclusive. If not specified, it defaults to the beginning of the list. Stop is the index where the slice ends, exclusive. If not specified, it defaults to the end of the list. Step is the increment between indices. If not specified, it defaults to 1. You can revise these examples given here. Nested lists in Python are lists that contain other lists as elements. Each element within a nested list can be of any data type, including other lists. Let's see some examples. Example 1. List L1 holds the values 10, 20, C, M, a nested list holding the values 6, 7, 8, and 30, 40. The next line print of L1 of 4 retrieves the element at index 4 of the list L1. Now, look at the above picture. I have marked the positive indexing of the list in green color. It starts from index 0. Index 0 holds the value 10, index 1 holds the value 20, index 2 holds the string C, index 3 holds the string M, index 4 holds the nested list containing the element 6, 7, 8, index 5 holds the value 30 and index 6 holds the value 40. The element at index 4 is 6, 7, 8, which is a nested list. So the output displayed is a nested list 6, 7, 8. Example 2. Print of L1 of index 4 of index 1. Accesses the element at index 1 within the nested list at index 4. Look at the above picture. I have marked the nested list indexing with pink color. It starts from index 0. So index 0 holds the value 6, index 1 holds the value 7 and index 2 holds the value 8. The nested list 6, 7, 8 is at index 4 and the element at index 1 within that nested list is 7. Therefore, the output would be 7. Let's learn about copying a list. Given a list, the simplest way to make a copy of the list is to assign it to another list. Let's see some examples. Example 1. List 1 holds the elements 10, 20, 30. In the next line, the variable L2 is assigned to L1. However, it's important to note that this assignment does not create a new copy of the list. Instead, both L1 and L2 refer to the same underlying list object. Therefore, modifying the list through one variable will affect both variables. So print of L1 will display the list 10, 20, 30. And print of list L2 will display the list 10, 20, 30 respectively. At this point, both L1 and L2 contain the same elements, 10, 20, and 30. You can check the output on the console. Example 2. Here, we are appending or adding the value 40 to list L1. After appending the value 40 to L1, both L1 and L2 reflect the change since they refer to the same list object. At this point, both L1 and L2 contain the same elements, 10, 20, and 30, 40. You can check the output on the console. Let's have a quick revision of the list's methods. The first method is the len function. The len function returns the length of the list, that is, the number of elements in a list. It returns the integer value which indicates the length of an object. Revise the examples given here. Python list max function returns the maximum value present in the list. To use max function, all values in the list must be of the same type. The syntax is max of listname. Here, listname is the name of list in which we have to find the maximum value. It returns the maximum value present in the list. Revise the examples given here. Python min function returns the element with the minimum value from the list. To use the min function, all values in the list must be of the same type. The syntax is min of listname. Listname is the name of list in which we have to find the minimum value. It returns the minimum value present in the list. Revise all the examples given here. In Python, the list function is used to convert an iterable object, such as a sequence, example, string, tuple, range, into a new list. It takes the iterable as an argument and returns a new list containing the elements of the iterable. Revise the examples given here. In Python, the sum function is used to calculate the sum of all the elements in an iterable, such as a list. It takes the iterable as an argument and returns the sum of its elements. Revise the given example. The append function is a built-in method in Python lists that allows you to add an element to the end of an existing list. It doesn't create a new list, rather it modifies the original list. The single element can also be a list. The syntax is list.append of item. Here, the item can be numbers, strings, another list, dictionary, etc. An item to be added at the end of the list, the parameter is mandatory and omitting it can give an error. The method doesn't return any value. You can revise the given example. The index function in Python returns the index of first matched item from the list. It returns the first occurrence of an item for which the index position is to be searched in the list. If the element is not present, value error is generated. The syntax is list.index of item. You can revise the given example. Python list insert method inserts a given element or object at a given index in a list using Python. This function takes two arguments: the index where an item or object is to be inserted and the item or element itself. The syntax is list underscore name dot insert of index underscore number comma value. Here, list underscore name is the name of the list. Index underscore number is the index where the new value is to be inserted. Value is the new value to be inserted in the list. Revise the examples given here. The sort function can be used to sort the list in both ascending and descending order. It can be used to sort lists of integers, floating point numbers, strings, and others. This modifications is done in place, that is, it does not create a new list. The syntax is list.sort function. The sort does not return anything but alters the original list according to the passed parameter. Revise the examples given here. The remove function is used when we know the element to be deleted, not the index of the element. The syntax is list.remove of element. Here, element is the element to be removed from the list. This method does not return any value but removes the given object from the list. Exception. If the element doesn't exist, it throws value error. Remove method removes the first occurrence of the object from the list. Revise the given examples here. The reverse function in Python reverses the order of the elements in a list. This function reverses the item of the list. It replaces a new value in place of an item that already exists in the list, that is, it does not create a new list. The syntax is list.reverse function. There are no parameters. The reverse method does not return any value but reverses the given object from the list. Revise the examples given here. Python list count method returns the count of how many times a given object occurs in a list using Python. The syntax is list.count of element. Parameters. Element is the item whose count is to be returned. It returns the count of how many times object occurs in the list. Revise the examples given here. The extend method adds one list at the end of another list. All items of a list are added at the end of an already created list. The syntax is list1.extend of list2. Here list1 is the primary list which will be executed. List2 is the list which will be added to list1. Revise the examples given here. Review of Python Basics, Part 4. In this video, we are going to have a quick revision on tuples and dictionary. So let's dive in and get started. Let's learn about tuples in Python. What do you mean by the term data structure? A data structure is an efficient way to organize and store data or information. We have learned that lists are data structures that store related data items. Now, we are going to discuss on another Python sequence, tuples. Tuple is a data structure in Python that allows you to store multiple values together as a single entity. It is another sequence data type that is similar to the list. It is an ordered collection of elements. It consists of multiple values in a single variable separated by commas and enclosed within parentheses. Example. Open parentheses, red comma blue comma green close parentheses. The values that make up a tuple are called elements. Tuples allow duplicate values. Tuples are heterogeneous, that means, tuples can contain elements of different data types. For example, a tuple can have a mix of integers, strings, floats, or other data types. The syntax of tuple is, tuple underscore name or variable name equals open parentheses, value 1 comma value 2 comma up to value n, close parentheses. For example, fruits equals apple, strawberry, grapes. In this example, we have a tuple named fruits, with 3 elements, as apple, strawberry and grapes. The elements in a tuple are addressed using their index value. The index value of tuple starts with 0. The main difference between lists and tuples are lists are enclosed in square brackets and their elements and size can be changed, while tuples are enclosed within parentheses and cannot be updated. Tuples are thought of as read-only lists. Let's see some examples. Example 1. Variable tup1 holds a tuple with elements of different data types, a string, an integer, a float, and another integer and printed. Output is a tuple holding Sallyann bytes, 20, 40.05, 250. Example 2. Variable tup2 holds an empty tuple is printed. Output is empty tuple. Example 3. Variable tup3 holds a tuple defined without using parentheses, with 4 integer elements and printed. Output is a tuple holding elements 20, 40, 60, 80. Example 4. A variable tup4 holds a nested tuple containing 2 tuples as its elements and printed. Output is a nested tuple inside a tuple holding elements 10, 20, 30, 40, 50, 100, 150, 200. Example 5. A variable tup5 holds a nested tuple with a tuple and a list as its elements and printed. Output is a nested tuple holding a tuple and a list 20, 40, 60, 80, tuples in Python. Example 6. A variable tup6 holds a tuple containing two lists as its elements and printed. Output is tuple holding two lists, 2, 4, 6, 1, 3, 5. Each tuple is printed to show its contents. Note that each output is enclosed within parentheses as it represents a tuple. Let's revise about singleton tuple. When creating a tuple with a single item in Python, you need to include a trailing comma after the item to differentiate a tuple from a parenthesized expression. Example, my_tuple equals 42. In this example, my_tuple is a tuple with a single item, the integer 42. The trailing comma after the item distinguishes it as a tuple. Without the comma, it would be interpreted as just an integer value. It's important to note that if you don't include the trailing comma, Python will treat the item as the data type itself, rather than a tuple containing that item. Let's see some examples. Example 1. In this example, my_tuple is defined as a tuple with a single item, the integer 42. The trailing comma after the item ensures that it is recognized as a tuple. When printed, the output shows 42, indicating a tuple containing the value 42. Example 2. In this example, my_tuple is assigned a single value, the integer 42. However, since there is no trailing comma, Python interprets it as an integer rather than a tuple. When printed, the output is simply 42, representing the value of the integer itself. You can check the output and find the difference. Tuples are immutable, that is, we cannot change the elements of a tuple in place. We cannot perform insert, update, and delete operations on them. An attempt to modify an element of a tuple yields an error. Let's see some examples. Example 1. In this code, we first define a tuple called my_tuple with three elements, 1, 2, and 3. The elements are enclosed in parentheses and separated by commas. This tuple is assigned to the variable my_tuple. Then, we use the print function to display the value of my_tuple on the console. So the output is a tuple holding 1, 2, 3. Example 2. In this example, my_tuple is initially defined as a tuple containing the values 1, 2, and 3. When we attempt to modify the value at index 0 by assigning a new value, 10 in this case, a type error is raised. This error occurs because tuples are immutable, meaning their elements cannot be changed once they are created. The immutability of tuples ensures that their values remain constant throughout their lifetime. If you need to modify a collection of elements, you would typically use a mutable data structure like a list instead. Elements of the tuple can be accessed sequentially using loop. Tuple elements can be accessed using for loop with range function. Tuple indices start at 0. In this example, we have a tuple named my_tuple containing 5 elements. We use a for loop and the range function to iterate over the indices of the tuple. The len function is used to determine the length of the tuple, which gives us the number of elements in the tuple. By iterating over the indices, we can access each element of the tuple using indexing my_tuple of I and print it to the console. The output is 10, 20, 30, 40, 50. Let's see some basic operations of tuple. Now look at these examples. Line 1. The len function is used to calculate the length of the tuple, that is the number of elements. The output is 3. Since the tuple has 3 elements. In line 3, the plus operator is used to concatenate two tuples. The output is 10, 20, 30, 40. In line 5, tuple repetition, the asterisk operator is used to repeat the tuple, good, 3 times. The output will be good, good, good. In line 7, the membership in operator is used to check if the value 47 is present in the tuple, 23, 45, 69. Output is false, since 47 is not present in the tuple. In line 9, iteration over a tuple. The for loop is used to iterate over each element of the tuple, 2, 4, 6. The print function is used to display each element x with a space separator. Output is 2, 4, 6. Each element of the tuple is printed on the same line with spaces in between. Tuple slicing is a technique used to extract a portion of a tuple by specifying a range of indices. It allows you to create a new tuple that contains a subset of elements from the original tuple. A slice of a tuple is basically its subtuple. In Python, tuple slicing is done using the square bracket notation. Here's the syntax for tuple slicing. Tuple_name of open square brackets, start, stop, step, close square brackets. Here, start is the starting point. Stop is the stopping point, which is excluded. Step is the step size, also known as stride. Some key points to remember. If start value is not given, slice starts from index 0. If stop value is not given, it will take it to the end. If step value is not given, default value is taken as 1. It includes the first element but excludes the last element. The first value in a tuple is at index 0. You can use the index values in combination with square brackets to access items in a tuple. Tuple slicing is a technique used to extract a portion of a tuple by specifying a range of indices. It allows you to create a new tuple that contains a subset of elements from the original tuple. In this picture, if we consider the positive index, that is forward indexing, index 3, 4, 5 are sliced and a new tuple with elements 40, 50 and 60 are formed. If we consider the negative index of step 1, that is backward indexing, it means to increment the index every time by -1, meaning it will traverse the list by going backwards. Now look at the negative index. Index -5, -6, -7 are sliced and a new tuple with elements 60, 50 and 40 are formed in backward direction. Let's see some examples. Example 1. A tuple with elements of different data types are given. Now look at the top picture. Here, I have marked the positive indexing and negative indexing for this tuple. In positive indexing means forward direction, look at the green arrow in forward direction and follow with me. Index 0 holds a string apple, index 1 holds the integer value 1, index 2 holds a list holding elements 2, 3, 4. Index 3 holds a nested tuple containing 2 strings banana and orange. Index 4 holds a float value 5.5. Now, let's learn the negative indexing that means backward direction. Look at the red arrow in backward direction and follow with me. Index -1 holds the value 5.5, index -2 holds the nested tuple holding 2 strings banana and orange, index -3 holds the list containing 3 elements 2, 3, and 4, index -4 holds the integer value 1, and index -5 holds the string apple. Now, look at example 1, second line. We use tuple slicing to extract a slice from index 2 to index 3, exclusive. The slice, 2:3, includes the element at index 2 but excludes the element at index 3. Since slicing returns a new tuple, the resulting slice is printed as a tuple containing the list 2, 3, 4. I have given a detailed explanation below. Just pause the video and recall the start, stop and step value, with the above indexing picture of the tuple given. Len function returns the length or the number of elements in a tuple. It counts the total number of elements in a tuple. Revise the given examples. Let's revise the min and max function in tuple. Min function shall return the element with minimum value from the tuple. Max function shall return the element with maximum value of the tuple. To use the min and max function, all values in the tuple must be of same type. Revise the given examples. The expression tuple of a seq is used to convert a sequence seq into a tuple in Python. A tuple is an immutable ordered collection of elements, enclosed in parentheses. A sequence can be any iterable object like a list, string, or another tuple. In this example, the list my_list is converted into a tuple using the tuple function. The resulting tuple my_tuple contains the same elements as the original list. As the output is a tuple, it's enclosed in parentheses. Sorted is used to sort the elements of a tuple. It returns a list after sorting. Revise these examples given here. Let's learn about dictionary in Python. A telephone directory can be compared to a dictionary. It is a book that contains names and phone numbers of people. A telephone directory is like a dictionary, where names are the keys and phone numbers are the values. In Python, we can create a dictionary to store similar information as a telephone directory. The names will be the keys in the dictionary, and the corresponding phone numbers will be the values. Now look at this example. A dictionary named telephone_directory holds the key value pairs of elements. Each name, for example, Sam, Alice, Bob, is a key, and each phone number, for example, 12345678890, 98765432210, 55512345667, is a value. Similarly in Python 2, we have a concept of key-value pair using dictionary. Python dictionary is an unordered collection of items where each item is a key-value pair. Dictionary in Python is a collection of keys values, used to store data values like a map, which, unlike other data types which hold only a single value as an element. You can see in this picture how each key holds a single value as an element. Let's learn about the features of dictionary. Key-value pairs. Dictionaries store data in the form of key-value pairs. Each key is unique and associated with a corresponding value. This allows for efficient and fast lookup of values based on their keys. Each key is separated from its value by a colon, the items are separated by commas, and the entire dictionary is enclosed in curly braces. Mutable. Dictionaries are mutable, meaning that you can modify, add, or remove key-value pairs after the dictionary is created. This flexibility makes dictionaries useful for dynamically changing data. Unordered dictionaries are unordered, which means that the order of key-value pairs is not guaranteed. The order in which the items are stored in a dictionary may vary and is not important for their retrieval. Flexible key types. Dictionary keys can be of various data types, such as strings, numbers, or even tuples. However, keys must be immutable types because they are used as hash values to access values quickly. Arbitrary data types for values. Dictionary values can be of any data type, including numbers, strings, lists, other dictionaries, or even custom objects. This flexibility allows dictionaries to store and retrieve a wide range of information. No duplicate keys. Dictionaries cannot have duplicate keys. If you try to assign a value to an existing key, it will replace the previous value associated with that key. Let's learn how to create a dictionary. To create a dictionary in Python, you can use curly braces and specify key-value pairs separated by colons. Syntax is dictionary_name equals open curly braces key1 value 1 key2 value 2 key3 value 3 upto key n value n close braces. Let's see some examples. Now, look at example 1. In the line my_dict equals curly braces, you are creating an empty dictionary named my_dict. In this case, by assigning curly braces to my_dict, you are initializing an empty dictionary with no key-value pairs. This provides you with a dictionary object that you can populate with data later on by adding key-value pairs. Now, look at example 2. The line creates a dictionary named my_dict1 with 4 key-value pairs. Key R, value rainy. This key-value pair associates the letter R with the value rainy. Key S, value summer. This key-value pair associates the letter S with the value summer. Key W, value winter. This key-value pair associates the letter W with the value winter. Key A, value autumn. This key-value pair associates the letter A with the value autumn. Let's see some examples. Example 1. In this code, an empty dictionary named my_dict is created using curly braces. The printf my_dict statement outputs an empty dictionary. Since no key-value pairs are added, the dictionary is empty. Example 2. In this code, a dictionary named my_dict1 is created with 3 key-value pairs. I have marked key-value pairs in pink color for your reference. The keys are integers, 100, 200, 300, and the corresponding values are strings, red, blue, green. The print statement outputs the dictionary my_dict1 with its key-value pairs. The output is 100 red, 200 blue, 300 green, enclosed in curly braces. Example 3. In this code, a dictionary named my_dict2 is created with 4 key-value pairs. I have marked key-value pairs in pink color for your reference. The keys have different data types. An integer, 1, a string, 2, a tuple, 3, 4, and a float, 3.14. The corresponding values are integer, string, tuple, float. The printf statement outputs the dictionary my_dict2 with its key-value pairs. The output displayed is 1 integer, 2 string, a tuple holding values 3, for tuple, 3.14 float, enclosed in curly braces. To access elements in a dictionary in Python, you can use square brackets along with the keys of the dictionary to retrieve their corresponding values. Let's see some examples. Example 1. In this line, a dictionary called my_dict is created with 3 key-value pairs. Key, name, value, Nancy. Key, age, value, 12. Key, city, value, New York. The next line prints the value associated with the key name in the dictionary my_dict. You can see the square brackets used along with the key name of the dictionary to retrieve the corresponding name. Since the key name exists in the dictionary, the output will be Nancy. Example 2. This line prints the value associated with the key age in the dictionary my_dict. The key age exists in the dictionary, so the output will be displayed as 12. Example 3. This line tries to print the value associated with the key grade in the dictionary my_dict. However, the key grade does not exist in the dictionary, so an error will occur as key error grade. Let's learn about traversing a dictionary. To traverse or iterate over a dictionary in Python means accessing each element of a dictionary. This can be done by using a for loop. Iterating over keys using a for loop. You can use a for loop to iterate over the keys of the dictionary. Within the loop, you can access the corresponding values using the keys. Let's see an example. In line 1, a dictionary called my_dict is created with 3 key-value pairs. Key, name, value, Nancy. Key, age, value, 12. Key, city, value, New York. In the second line, this code uses a for loop to iterate over the keys of the dictionary my_dict. During each iteration, the current key is stored in the variable key. The line value equals my_dict key retrieves the value associated with the current key and assigns it to the variable value. Finally, the print statement prints the key, a colon, and the corresponding value. The output will be name Nancy, age 12, city New York. The for loop iterates over each key in the dictionary, and for each key, it accesses the corresponding value. Thus, the loop effectively traverses the dictionary and prints each key value pair. Let's learn about appending values to a dictionary. To append or add values to the existing dictionary in Python, you can extend it with single pair of values or join two dictionaries into one. Syntax is dictionary_name of key equals value. Now look at the example. In the first line, a dictionary called my_dict is created with four key value pairs. Key mon value Monday. Key to value Tuesday. Key wed value Wednesday. Key thurs value Thursday. The second line adds a new key value pair to the dictionary my_dict. The key fry is assigned the value Friday. Since the key fry doesn't exist in the dictionary, a new key value pair is appended. The third line prints the dictionary my_dict after adding the new key value pair. The output will be open curly braces mon Monday, to Tuesday, wed Wednesday, thurs Thursday, fry Friday, close curly braces. To update elements in a dictionary in Python, you can modify existing key value pair or by merging another dictionary with an existing one. Syntax is dictionary_name of key equals value. Now, look at this example. In the first line, a dictionary called my_dict is created with three key value pairs. Key name value Nancy. Key age value 12. Key city value New York. The next line updates the value associated with the key age in the dictionary my_dict. The line my_dict of age equals 13 assigns the new value 13 to the existing key age. After the update, the dictionary is printed using print of my_dict. The value associated with the key age is updated from 12 to 13. The dictionary my_dict is modified, and the updated dictionary is printed. The output displayed is open curly braces, name Nancy, age 13, city New York, close braces. Now, look at example 2. This code adds a new key value pair to the dictionary my_dict. The line my_dict of grade equals A assigns the value A to the new key grade. Since the key grade doesn't exist in the dictionary, a new key value pair is added. After the addition, the dictionary is printed using print of my_dict. Output displayed is open curly braces, name Nancy, age 13, city New York, grade A, close braces. The dictionary my_dict now contains four key value pairs, including the newly added key grade with the value A. Two dictionaries can be merged into one by using update method. It merges the keys and values of one dictionary with another and overwrites values of the same key. Syntax is dic_name1.update of dic_name2. Using this, dic_name2 is added to dic_name1. Now, look at example 1. In this example, dict1 and dict2 are initially separate dictionaries. After calling dict1.update of dict2, the key value pairs from dict2 are merged into dict1. The resulting merged dictionary is A:1, B:2, C:3, D:4, enclosed in curly braces. However, dict2 remains unchanged. The output of dict2 is C:3, D:4, enclosed in curly braces. Now, look at example 2. In this example, both dict1 and dict2 have a common key value pair. When dict1.update of dict2 is called, the value of the common key B in dict1 is overwritten by the value from dict2. The resulting merged dictionary is A:1, B:5. Again, dict2 remains unchanged. The output of dict2 is A:1, B:5, enclosed in curly braces. The update method merges dictionaries by adding or overwriting key value pairs from the second dictionary into the first dictionary. The original dictionaries are modified in place, and any modifications to one dictionary do not affect the other. Let's learn about removing an item from dictionary. To remove an item from a dictionary in Python, you can use the del command or the pop method. First, we will learn using the del command. The syntax is del dict name of key. Let's see some examples. Example 1. In this example, a dictionary named my_dict is created with four key value pairs representing different fruits and their quantities. The print function is used to display the initial contents of the dictionary. The output shows the dictionary with all its key value pairs. Apple: 3, banana: 5, orange: 2, grape: 4, enclosed in curly braces. Now, look at example 2. Here, the del statement is used to remove the item with the key banana from the dictionary my_dict. After removal, the updated dictionary is displayed using the print function. Apple: 3, orange: 2, grape: 4, enclosed in curly braces. As shown in the output, the item with the key banana is no longer present in the dictionary. Now, look at example 3. In this part of the code, an attempt is made to remove an item with the key cherry from the dictionary my_dict using the del statement. However, since the key cherry does not exist in the dictionary, it will result in a key error being raised. The code will terminate at this point and the key error message will be displayed. The key error is raised because del my_dict of cherry is trying to remove an item with a key that does not exist in the dictionary. Let's revise the built-in dictionary functions. In Python, the len function returns the number of items or elements in a collection, such as a string, list, tuple, or dictionary. When used with a dictionary, the len function returns the number of key value pairs in the dictionary. The syntax is len of d. Here, d is the dictionary. It returns number of key value pairs in the dictionary. Revise these examples here. In Python, the clear method is used to remove all the elements from a dictionary. It modifies the dictionary in place, resulting in an empty dictionary. Revise these examples here. In Python, the items method is used to return a view object that contains tuples of key value pairs from a dictionary. Each tuple represents a key value pair, where the first element is the key and the second element is the corresponding value. The syntax is d.items function. Here d is the dictionary. Revise these examples here. In Python, the keys method is a dictionary method that returns a view object containing the keys of the dictionary. Note that keys returns a list of the key values in a dictionary. Lists are enclosed in square brackets. Syntax is d.keys function. Here, d is the dictionary. Revise these examples here. In Python, the values method is a dictionary method that returns a view object containing only the values of the dictionary. The syntax is d.values function. Here, d is the dictionary. Revise these examples here. In Python, the copy function is used to create a shallow copy of a dictionary. It returns a new dictionary object that contains the same key value pairs as the original dictionary. We cannot copy a dictionary by using assignment equal to operator, as it will create a reference to the same dictionary variable and modifications will also be reflected in both dictionaries. We can use built-in function copy to create a new dictionary and modifications done on base dictionary will not be reflected. The syntax is dict_new equals dict_old.copy function. Revise these examples given here. Let's learn about fromKeys method in dictionary. In Python, the fromKeys method is a built-in method available for dictionaries. It is used to create a new dictionary with specified keys and a default value for all the keys. The syntax is new_dict equals dict.fromKeys of keys, value. Here, keys is an iterable, such as a list or tuple, containing the keys for the new dictionary. Value is the default value assigned to each key. The fromKeys method returns a new dictionary with the specified keys and default value. Revise these examples given here. The setDefault method is used to retrieve the value of a specified key from a dictionary. If the key exists in the dictionary, the method returns its corresponding value. If the key does not exist, the method creates a new key value pair with the specified key and a default value, and then returns the default value. The syntax is dictionary.setDefault of key, default_value. Here, key is the key to be searched in the dictionary. Default_value is the value to be set as the default if the key is not found. None if key is not in the dictionary and default_value is specified. Revise these examples given here. Review of Python Basics, Part 5. In this video, we are going to have a quick revision on sorting techniques bubble sort and insertion sort. So let's dive in and get started. Let's revise sorting. Sorting is to arrange the list in an ascending or descending order. Sorting algorithms specifies the way to arrange data in a particular order. The importance of sorting lies in the fact that data searching can be optimized to a very high level if data is stored in a sorted manner. Sorting is also used to represent data in more readable formats. There are various sorting techniques that can be used to sort the list in ascending or descending order. Let's recall the two sort techniques: bubble sort and insertion sort. Bubble sort is one of the simplest sorting techniques where it traverses the whole list by comparing its adjacent elements, sorting them and swapping the elements until the whole list is sorted. In simple words, bubble sort is a simple sorting algorithm that repeatedly steps through a list, compares adjacent elements, and swaps them if they are in the wrong order. The pass through the list is repeated until the list is sorted. How does bubble sort work? Let's see an example. Example 1. Sorting in ascending order using bubble sort. Suppose an array of elements of a list is 75, 30, 95, 80, 10 are given as input by the user. Let us understand the working of bubble sort with the help of the following illustration. The elements in a list are given in this box. In bubble sort algorithm in Python, the first pass refers to the initial iteration over the list that is being sorted. Bubble sort works by repeatedly swapping adjacent elements if they are in the wrong order. In each pass, the largest element bubbles up to its correct position at the end of the list. After the first pass, the largest element will be at the end of the list. During the first pass, the algorithm compares each pair of adjacent elements from the beginning of the list and swaps them if they are in the wrong order. This process continues until it reaches the end of the list. Now, come on, let's look at the first pass on the screen. The first pass refers to the initial iteration over the list that is being sorted. Now look at step 1. Bubble sort starts by comparing the first two elements in the list. Here the first element 75 is compared with the second element 30. It will swap since 30 is less than 75. Swap refers to the exchange or interchange of values between two variables or elements. Here values 75 and 30 are swapped, that is, exchanged. Now you can see on the right side box. Here the greater value 75 is on the second position. So the numbers displayed are 30, 75, 95, 80, 10. Now come to step 2. Now, the second element 75 is compared with the third element 95. Here, no swapping is done, as 75 is less than 95. So, now look at the right side box, the numbers displayed are 30, 75, 95, 80, 10. Now come to step 3. Now the third element, 95 is compared with the fourth element 80. It will swap since 80 is less than 95. Here values 95 and 80 are swapped, that is, exchanged. Now you can see on the right side box. Here the greater value 95 is on the fourth position. So the numbers displayed are 30, 75, 80, 95, 10. Now come to step 4. Now the fourth element 95 is compared with the fifth element 10. It will swap, since 10 is less than 95. Here values 95 and 10 are swapped, that is, exchanged. Now you can see on the right side box. Here the greater value 95 is on the last position. So the numbers displayed are 30, 75, 80, 10, 95. The largest element, 95, is settled at its correct place, that is, at the end. I have highlighted 95 in blue color. So the first four elements 30, 75, 80, 10, form the unsorted part while the last element, 95, forms the sorted part and will be compared for the next pass. In the bubble sort algorithm in Python, the term second pass refers to the second iteration or traversal of the list during the sorting process. After completing the first pass, the largest element, 95, is in its correct position at the end of the list. However, there may still be other elements 30, 75, 80, 10 out of order. So, a second pass is performed to repeat the process, but this time excluding the last element, 95, since it is already in its correct position. Now, look at step 1 of second pass. Bubble sort starts by comparing the first two elements in the list. Here the first element 30 is compared with the second element 75. Here, no swapping is done, as 30 is less than 75. So, now look at the right side box, the numbers displayed are 30, 75, 80, 10, 95. Now come to step 2. Here the second element 75 is compared with the third element 80. Here also, no swapping is done, as 75 is less than 80. So, now look at the right side box, the numbers displayed are 30, 75, 80, 10, 95. Now come to step 3. Here the third element 80 is compared with the fourth element 10. It will swap since 10 is less than 80. Here values 80 and 10 are swapped, that is, exchanged. Now you can see on the right side box. Here the greater value 80 is on the second position from the end. So the numbers displayed are 30, 75, 10, 80, 95. The next largest element 80 is settled at its correct place. I have highlighted both 80 and 95 in blue color. So the first three elements 30, 75, 10, form the unsorted part while the last two elements 80 and 95 forms the sorted part and will be compared for the next pass. In the bubble sort algorithm in Python, the term third pass refers to the third iteration or traversal of the list during the sorting process. After completing the second pass, the largest element, 80 and 95, are in its correct position at the end of the list. However, there may still be other elements 30, 75, 10 out of order. So, a third pass is performed to repeat the process, but this time excluding the last two elements, 80 and 95, since both are already in its correct position. Now, look at step 1 of third pass. Bubble sort starts by comparing the first two elements in the list. Here the first element 30 is compared with the second element 75. Here, no swapping is done, as 30 is less than 75. So, now look at the right side box, the numbers displayed are 30, 75, 10, 80, 95. Now come to step 2. Here the second element 75 is compared with the third element 10. It will swap since 10 is less than 75. Here values 75 and 10 are swapped, that is, exchanged. Now you can see on the right side box. Here the greater value 75 is on the third position from the end. So the numbers displayed are 30, 10, 75, 80, 95. The next largest element, 75, is settled at its correct place. I have highlighted the three numbers 75, 80, and 95 in blue color. So the first two elements 30, 10, form the unsorted part while the last three elements 75, 80, and 95 forms the sorted part and will be compared for the next pass. In the bubble sort algorithm in Python, the term fourth pass refers to the fourth iteration or traversal of the list during the sorting process. After completing the third pass, the largest elements, 75, 80, and 95, are in its correct position at the end of the list. However, there may still be other elements 30 and 10 out of order. So, a fourth pass is performed to repeat the process, but this time excluding the last three elements, 75, 80, and 95, since all these three elements are already in its correct position. Now, look at step 1 of fourth pass. Bubble sort starts by comparing the first two elements in the list. Here the first element 30 is compared with the second element 10. Here, it will swap, since 10 is less than 30. So, now look at the right side box, the numbers displayed are 10, 30, 75, 80, 95. The next largest element, 30, is settled at its correct place. I have highlighted the four numbers 30, 75, 80, and 95 in blue color. And finally the list is sorted. Here, the total number of items is 5, so outer loop will be executed n-1 times. That is, 4 times. There will be 4 passes through the list. Let's see the steps of bubble sort. Let's see how it works. Step 1. Get the total number of items or elements in the given list. Step 2. Determine the number of outer passes, n-1, to be done. Its length is list-1. Step 3. Perform inner passes, n-1, times for outer pass 1. Get the first element value and compare it with the second value. If the second value is less than the first value, then swap the positions. Step 4. Repeat step 3 passes until you reach the outer pass, n-1. Get the next element in the list, then repeat the process that was performed in step 3 until all the values have been placed in their correct ascending order. Step 5. Return the result when all passes have been done. Return the results of the sorted list. Step 6. Optimize algorithm. Avoid unnecessary inner passes if the list or adjacent values are already sorted. For example, if the provided list already contains elements that have been sorted in ascending order, then we can break the loop early. Let's see an example for bubble sort. Now, look at the red arrow. In this example, the input list, 5, 2, 9, 1, 6, is passed to the bubble_sort function. The function then performs the bubble sort algorithm on the list. Now, look at the for loop iteration. The outer loop iterates from I equals 0 to n-1, where n is the length of the list. This controls the number of passes performed. In each pass, the inner loop iterates from j equals 0 to n-i-1, comparing adjacent elements and swapping them if they are in the wrong order. After completing the sorting process, the sorted list is returned from the function using return ARR. Finally, the sorted list, 1, 2, 5, 6, 9, is printed as the output. This demonstrates the usage of the bubble sort algorithm to sort a list of numbers in ascending order. Let's see the detailed explanation in the next screen. Let's see the algorithm of bubble sort. Let's see how it works. Step 1. Start with an input list of elements to be sorted. Step 2. Get the length of the list and assign it to the variable n. Step 3. Iterate through the list using an outer loop from index 0 to n-1. Within the outer loop, use an inner loop to iterate from index 0 to n-i-1. Compare the element at the current index with the element at the next index. If the current element is greater than the next element, swap them. Step 4. Return the sorted list. Let's see how it works. First, create an input list of elements 5, 2, 9, 1, 6. Then, call the bubble_sort function with the input list. The function performs the following iterations. Pass 1. Compare 5 and 2. Swap them. Compare 5 and 9. No swap. Compare 9 and 1. Swap them. Compare 9 and 6. Swap them. The list after pass 1 is 2, 5, 1, 6, 9. Next iteration, pass 2. Compare 2 and 5. No swap. Compare 5 and 1. Swap them. Compare 5 and 6. No swap. The list after pass 2 is 2, 1, 5, 6, 9. Next iteration, pass 3. Compare 2 and 1. Swap them. Compare 2 and 5. No swap. The list after pass 3 is 1, 2, 5, 6, 9. Next iteration, pass 4. Compare 1 and 2. No swap. The list after pass 4 is 1, 2, 5, 6, 9. Now, return the sorted list 1, 2, 5, 6, 9. Let's discuss about insertion sort. An insertion sort is an efficient algorithm for sorting a small number of elements. In insertion pass, for each pass, the correct position for the current element is found by comparing adjacent elements before the current position and sliding larger elements up until an element less than the current element is found. Insertion sort is an in-place sorting algorithm. In insertion sort, an element gets compared and inserted into the correct position in the list. Let's see some examples where insertion sort is used. Example 1. Insertion sort works the same way as sorting a hand of playing cards, that is, starting with an empty left hand and the cards face down on the table. One card at a time is then removed from the table and inserted into the correct position in the left hand. To find the correct position for a card, it is compared with each of the cards already in the hand, from right to left. Example 2. To sort the report card of n number of students according to the roll number. Let's see how insertion sort works. Example 1. Sorting in ascending order using insertion sort. A list containing an array of elements, 55, 30, 10, 82, 45 are given by the user, which is the initial list. Let us understand the working of insertion sort with the help of the following illustration. The insertion sort algorithm works by considering one element at a time and inserting it into its correct position within the already sorted subarray. In insertion sort algorithm in Python, the first pass refers to the initial iteration over the list that is being sorted. Now, come on, let's look at the first pass on the screen. The first pass refers to the initial iteration over the list that is being sorted. Now look at step 1. Here, the key element is 30. Insertion sort starts by comparing the first two elements in the list. Here the first element 55 is compared with the second element 30. It will swap since 30 is less than 55. Swap refers to the exchange or interchange of values between two variables or elements. Here values 55 and 30 are swapped, that is, exchanged. Now you can see on the right side box. Here the greater value 55 is on the second position. So the numbers displayed are 30, 55, 10, 82, 45. As the elements haven't reached the proper position in the sorted manner, the second pass continues. In the insertion sort algorithm in Python, the term second pass refers to the second iteration or traversal of the list during the sorting process. Now, look at step 1 of second pass. Here, the key element is 10. Insertion sort starts by comparing the second and third elements in the list. Here the second element 55 is compared with the third element 10. It will swap, since 10 is less than 55. So, now look at the right side box, the elements displayed are 30, 10, 55, 82, 45. Now come to step 2. As 10 is smaller element than 30, element 10 has not found its right position. Hence, the first element 30 is compared with the second element 10. Here swapping is done, since 10 is less than 30. So, now look at the right side box, the elements displayed are 10, 30, 55, 82, 45. Here, elements 10 and 30 have reached the proper position in the sorted subarray on the left. As the other elements haven't reached the proper position in the sorted manner, the third pass continues. In the insertion sort algorithm in Python, the term third pass refers to the third iteration or traversal of the list during the sorting process. Now, look at step 1 of third pass. Here, the key element is 82. The third element 55 is compared with the fourth element 82. No swapping is done, as 55 is less than 82. So, now look at the right side box, the elements displayed are 10, 30, 55, 82, 45. As the elements 55, 82 and 45 haven't reached the proper position in the sorted manner, the fourth pass continues. In the insertion sort algorithm in Python, the term fourth pass refers to the fourth iteration or traversal of the list during the sorting process. Now, look at step 1 of fourth pass. Here, the key element is 45. The fourth element 82 is compared with the fifth element 45. Here, swapping is done, since 45 is less than 82. So, now look at the right side box, the elements displayed are 10, 30, 55, 45, 82. Now look at step 2. Here the key element is 45. The third element 55 is compared with fourth element 45. It will swap, since 45 is less than 55. So, now look at the right side box, the elements displayed are 10, 30, 45, 55, 82. Now the list is sorted. The total number of items, say n, is 5, so outer loop will be executed n-1 times, that is 4 times. So there will be 4 passes through the list. For each pass, it not only compares adjacent items and swaps, but also slides up each larger element until it gets to the correct location in the sorted part of the array. Let's see the steps for insertion sort. Step 1. If the element is the first one, it is already sorted. Step 2. Move to the next element of the list. Step 3. Compare the current element with all elements in the sorted list. Step 4. If the element in the sorted list is smaller than the current element, iterate to the next element. Otherwise, shift all the greater element in the list by 1 position towards the right. Step 5. Insert the value at the correct position. Step 6. Repeat until the complete list is sorted. Let's see an example for insertion sort. Now, look at the first white box. The code defines a function insertion_sort that takes an input list ARR and sorts it in ascending order using the insertion sort algorithm. In the insertion_sort function, we iterate through the elements starting from the second element, index 1, to the end of the list. For each element, we assign it to the variable key and set the variable j to the index of the element before it. Now, look at the second white box. We then enter a while loop that compares the element at index j with the key value. If the element at index j is greater than the key, we shift it 1 position to the right. We continue this process until we find the correct position for the key element or reach the beginning of the list. Finally, we insert the key value at the correct position and move to the next element in the iteration. After the sorting process is complete, the sorted list is returned. Now look at the red arrow. In this example usage, we have a list 8, 3, 1, 5, 2 that we want to sort. We call the insertion_sort function with this list, and the sorted list, 1, 2, 3, 5, 8, is printed as the output. Let's see the algorithm and how it works. Step 1. Start with an input list of elements to be sorted. Step 2. Iterate through the list starting from the second element. Assign the current element to the variable key. Set the variable j to the index of the element before the current element. While j is greater than or equal to 0 and the element at index j is greater than the key. Shift the element at index j 1 position to the right. Decrement j by 1. Insert the key at index j plus 1. Step 3. Return the sorted list. Let's see how it works. First, create an input list 8, 3, 1, 5, 2. Then, call the insertion sort function with the input list. Next, the function iterates through the list as follows. When key equals 3, j equals 0, the list becomes 3, 8, 1, 5, 2. When key equals 1, j equals 1, the list becomes 1, 3, 8, 5, 2. When key equals 5, j equals 2, the list becomes 1, 3, 5, 8, 2. When key equals 2, j equals 3, the list becomes 1, 2, 3, 5, 8. Now, return the sorted list 1, 2, 3, 5, 8. Let's see the applications of bubble sort. Bubble sort is simple, fastest and easiest sorting algorithm. Education. Bubble sort is commonly used for teaching sorting algorithms in programming courses due to its simplicity. Small datasets. It is the fastest sorting method for an extremely small lists or arrays with few elements. Partially sorted data. Bubble sort performs well when the data is already partially sorted. Algorithm analysis. It can be used as a reference for analyzing and comparing the performance of other sorting algorithms. Let's see the applications of insertion sort. Small datasets, insertion sort is efficient for sorting small lists or arrays with a limited number of elements. Its simplicity and low overhead make it an appropriate choice for small datasets. Partially sorted data, insertion sort performs particularly well when the input data is already partially sorted. It minimizes the number of comparisons and swaps, making it an efficient choice for data that is nearly sorted or has a small number of misplaced elements. Online sorting, insertion sort is suitable for scenarios where elements are continuously added to a sorted list in real time. It allows for efficient insertion of new elements into the correct position while maintaining the sorted order. Adaptive sorting, insertion sort is an adaptive sorting algorithm, meaning that it performs well on data that is already partially sorted. As the input becomes increasingly sorted, the number of comparisons and swaps decreases, resulting in improved efficiency. Stable sorting, insertion sort is a stable sorting algorithm, meaning it maintains the relative order of elements with equal keys. This property can be crucial in certain applications where preserving the original order is important. Functions in Python Part 1. In this video, we are going to learn functions in Python, advantages, and built-in functions. So let's dive in and get started. When writing programs, we should avoid long, repetitive code. Functions help to keep our programs simple and short. So what is a function? A function is a small section of a program that performs a specific task that can be used repeatedly throughout a program, but the task is usually a calculation. Functions perform the task and return a value to the main program. Why do we use functions? Program code is easier to read and understand when it is broken up into smaller sections. Functions can make code shorter, simpler, and easier to write. Benefits of using functions. If something needs to be changed in a function, it only needs to be changed once, within the function code. This change will then appear wherever the function is used in the program. If functions weren't used, the code would have to be amended at every point that it appears in the program. Let's consider a real-life example of a dishwasher to understand how functions could be utilized in Python. Imagine you want to create a program that simulates the operation of a dishwasher. Now, look at the left side of the screen. This program is one long, complex sequence of statements. Now look at the right side. Here's how you could use functions to achieve this. In this program, the task is divided into smaller tasks. Each task is performed by a separate function. Step 1. Start the dishwasher. Define a function called start_dishwasher that turns on the dishwasher, fills it with water, and starts the cleaning cycle. This function can handle any necessary setup steps before starting the actual cleaning process. Step 2. Load the dishes. Create a function called load_dishes that takes a list of dishes as a parameter and loads them into the dishwasher. You can include checks to ensure the dishwasher isn't overloaded and handle any specific requirements for loading certain types of dishes. Step 3. Set the cleaning mode. Define a function called set_cleaning_mode that allows the user to select the cleaning mode for the dishwasher. This function can take parameters such as the cleaning intensity, temperature, and duration. It can also include validation checks to ensure valid input. Step 4. Run the cleaning cycle. Create a function called run_cleaning_cycle that performs the actual cleaning process. This function can control the flow of water, adjust temperature as per the cleaning mode, and run the cleaning cycle for the specified duration. Step 5. Unload the dishes. Define a function called unload_dishes that unloads the clean dishes from the dishwasher. This function can handle the process of removing the dishes, checking their cleanliness, and placing them in the appropriate storage areas. By breaking down the dishwasher operation into these functions, you can create a modular and reusable code structure. Each function is responsible for a specific task, making the code more organized and easier to maintain. You can call these functions in a specific sequence to simulate the complete dishwasher operation. Moreover, you can also add additional functions to handle error handling, user input validation, or even create a user interface to interact with the program. Python functions is a block of statements that return the specific task. The idea is to put some commonly or repeatedly done tasks together and make a function so that instead of writing the same code again and again for different inputs, we can do the function calls to reuse code contained in it over and over again. Functions are the most important building blocks for any application in Python and work on the divide and conquer approach. Advantages of using functions. Easy updation. Functions divide code into smaller, self-contained units. When you need to make an update, you can focus on the specific function related to the change, rather than navigating through a large, monolithic codebase. Code reusability. Functions can be reused throughout the program or in different programs, saving time and effort by avoiding code repetition. Program handling becomes easier, only a small part of the program is dealt with at a time. Compact code. While working with functions, a common set of code is written only once and can be called from any part of the program, which reduces lines of code and programming overheads. Maintainability. Functions make code easier to maintain and debug by isolating specific tasks, allowing for targeted modifications and bug fixes. Readability. Functions improve code readability by encapsulating logic and providing clear and descriptive names for specific operations. Testing. Functions facilitate testing since they allow you to test smaller units of code independently, aiding in identifying and fixing issues. Functions in Python can be categorized into three types: built-in functions, modules, and user-defined functions. The built-in library provides a wide range of functionalities that can be readily used in Python programs without requiring any additional installations or imports. It includes modules and functions for tasks such as mathematical operations, file handling, string manipulation, data structures, networking, and more. In Python, built-in functions are predefined functions that are available as part of the Python programming language. These functions are included in the Python standard library and can be used directly without requiring any additional imports or installations. Built-in functions provide a wide range of functionality and are designed to perform common tasks or operations. We can discuss about these functions one by one. Type conversion functions in Python are built-in functions that allow you to convert values from one data type to another. These functions provide a convenient way to change the type of data in your programs. Here are some commonly used type conversion functions. Int function converts a value to an integer. Let's look at some examples. Look at the Python code. Line 1. Converts the float arguments 3.14 to integer 3. Line 2. Converts the string arguments 112 to integer 112. Line 3. Int function can convert the floating point values to integers, but it doesn't round off. It chops off the fraction part. So minus 32.4 becomes minus 32. Line 4. If no argument is passed, it function returns 0. Line 5. Generates an error if the argument is a string value. str function converts a value to a string. For example, str of 42 would return the string 42. Float function converts a value to a floating point number. Let's see some examples. Look at the Python code. Line 1. It converts the integer arguments 314 to float value 314.0. Line 2. Converts the string arguments to float. Line 3. Addition of integer values results in float value. Line 4. If the argument is an expression, the expression is evaluated and float function returns float value. Line 5. Converts a string value to float value. Line 6. If no argument is passed, float function returns 0.0. In line 7. If the string argument contains any character other than leading plus or minus sign and floating point number in the current format, then float function results in an error. The input function in Python is used to interact with the user by accepting input from them. It allows you to prompt the user with a message or a question and waits for the user to enter a response. The response entered by the user is then returned as a string. Prompt is an optional parameter that represents the message or question you want to display to the user. It is used as a prompt to inform the user about what kind of input is expected. If no prompt is provided, the function will simply wait for the user to enter input without displaying any message. The input function reads the user's input as a string. Look at this example. Here the input function prompts the user to enter their name, and the entered name is stored in the name variable, and the program displays a greeting message with the entered name, as hello followed by their name with exclamatory point. If you want to perform numerical operations on the input, you need to convert it to the appropriate data type using functions like int or float. Now, look at the example. The input function prompts the user to enter their age, and the entered age is stored as a string in the age variable. Since we want to perform arithmetic operations on the age, we use the int function to convert it to an integer. Finally, the program calculates the age of the user in the next year. The input function can be used without any arguments. In that case, it simply waits for the user to enter input without displaying any message or prompt. Now, look at this example. When the program executes the input function without any arguments, it waits for the user to input something. You can see the cursor waiting for the user to input something. Once the user enters a value welcome to Sallyann Bytes and presses the enter key, the entered value is stored in the value variable. The program then proceeds to print the entered value using the print function. Using input without any arguments can be useful when you want to give the user a chance to provide input without providing any specific instructions or prompts. The eval function in Python is a built-in function that evaluates a string containing a Python expression or statement. It allows you to dynamically execute code that is represented as a string, enclosed in quotation marks. If the given argument is not a string, or if it cannot be evaluated as a number, then eval function results in an error. Look at these examples. In line 1, the eval function takes the string 30 plus 45 foot as the valid mathematical expression to be evaluated, that adds the numbers 30 and 45 together and returns the result, 75, on the console. In line 2, the eval function takes the string 30.5 plus 45 foot as the mathematical expression to be evaluated, that adds the floating point number 30.5 and the integer 45 together and returns the result, 75.5 on the console. In line 3, since the expression is not provided as a string, it results in type error. Illustrating eval using input function. The eval function evaluates the string like a Python expression and returns the result as an integer. Now, look at this example. In this code, the eval function is used to evaluate the user's input as a Python expression. The expression is obtained using input function, and then eval function evaluates it. The evaluated result is stored in the eval variable, which is printed using print function. Finally, the type of the evaluated value is printed. It's an integer. The max function returns the largest item in the provided arguments. The min function returns the smallest item in the provided arguments. In case of string-type argument, ASCII values of characters are compared for retrieving highest to lowest values using max and min functions. Now, look at the examples. In line 1, the max function is called with the arguments 45, 25, 33, and 83. The max function compares the values and returns the largest value among them, which is 83, and is printed. In line 2, the min function is called with the arguments 45, 25, 33, and 83. The min function compares the values and returns the smallest value among them, which is 25, and is printed. In line 3, the max function compares the strings using ASCII values and returns the largest string among them, which is Singapore. The ASCII value of uppercase S is 83. In line 4, the min function compares the strings using ASCII values and returns the smallest string among them, which is Delhi. The ASCII value of the uppercase letter D is 68. The abs function in Python is used to return the absolute value of a single number. It takes an integer or float number as argument and always returns a positive value. It returns a floating or integer number depending upon an argument. Syntax is abs of number. The number parameter can be any numeric value, such as an integer or a floating point number. Let's see some examples. In all these examples, the abs function is used to calculate the absolute value of the given numbers. The function returns the positive magnitude of the number, regardless of its original sign. The type function in Python is used to determine the data type of a variable or an object. It returns the class or type of the object that is passed as an argument. Syntax is type of object. The object parameter can be any value or variable whose type you want to determine. In each of these examples, the type function is used to determine the type of the given object. The function returns a class object that represents the type of the object. The Boolean argument given to type function should have T capital letter for true and F capital letter for false, otherwise it will generate an error. The len function in Python is used to determine the length or the number of elements in a sequence or collection such as a string, list, tuple, or dictionary. Syntax is len of sequence. The sequence parameter can be any sequence or collection for which you want to find the length. Let's see some examples. In each of these examples, the len function is used to determine the length of the given sequence. The function returns an integer value representing the number of elements in the sequence. The round function in Python is used to round a given number to a specified number of decimal places or to the nearest whole number. Syntax is round of number, comma, and digits. The number parameter is the value that you want to round. The n digits parameter, optional, specifies the number of decimal places to which you want to round. Let's see some examples. When n digits is not specified. Look at line 4. This call rounds the number 3.14159 to the nearest whole number, which is 3. In line 5, the number 3.64159 is rounded to the nearest whole number, which is 4. When n digits is 0. In line 8, the number 3.14159 is rounded to 0 decimal places. Since n digits is 0, the result is a whole number represented as a float, 3.0. In line 9, the number 3.64159 is rounded to 0 decimal places, resulting in 4.0. When n digits is positive integer. In line 12, in this case, the number 3.4559 is rounded to one decimal place. The rounding rule dictates rounding to the nearest even number, so the result is 3.5. In line 13, the number 3.532 is rounded to two decimal places, resulting in 3.53. In line 16, when n digits is negative, rounding is performed on the left side of the decimal point. In this example, 1234.56 is rounded to the nearest tens place, because -1 is passed as digits. The result is 1230.0. In line 17, 1258.42 is rounded to the nearest hundreds place, since -2 is provided as n digits. The result is 1300.0. The range function in Python is used to generate a sequence of numbers. It creates an iterable object that represents a sequence of numbers from a starting value to an ending value, with an optional step size. Syntax is range of start, stop, step. The start parameter is the starting value of the sequence, inclusive, which is optional. If not provided, it defaults to 0. The stop parameter is the ending value of the sequence, exclusive. The sequence will include numbers up to, but not including, this value. The step parameter is the increment or step size between each number in the sequence. It is optional and defaults to 1 if not provided. Let's see some examples. In the first example, range of 5 generates a sequence of numbers from 0 to 4. In the second example, range of 1, 6 generates a sequence of numbers from 1 to 5. In the third example, range of 2, 10, 2 generates a sequence of even numbers from 2 to 8, incrementing by 2. In each example, invoking the list, we will see the sequence of numbers. Functions in Python, Part 2. In this video, we are going to learn modules, importing modules in a Python program, math module, and random modules. So let's dive in and get started. In Python, a module is a file containing Python code that defines functions, classes, and variables that can be used in other programs. The set of functions stored in a file is called module, and this approach is known as modularization. Modules help organize code and promote code reusability. They allow you to break your program into smaller, more manageable parts. There are some commonly used modules in Python that are used for certain predefined tasks, and they are called libraries. Let's discuss about module creation. You can create your own modules by writing Python code in a .py file. Each file represents a module, and its name is usually the same as the file name, excluding the .py extension. A module in Python is a file that contains a collection of related functions. To use a module in your program, you need to import it. Python provides import keyword to import modules in a program. You can import the whole module or specific parts of it. The import statement is used for importing modules. There are two methods to import modules: importing entire module and importing selective methods from a module. Let's see one by one in detail. Importing entire module. To import an entire module in Python, you can use the import statement followed by the name of the module. Syntax is import module_name. For example, let's say you have a module called math.py that contains various mathematical operations. To import the entire module, you would use import math. It gives access to all the functions of math module. Next is to import multiple modules in a program. Syntax is import module_name1, module_name2, and so on. Example: import math time. This will import two modules in a program. Next is, we can access any function of the imported module by using dot notation. Example: math.sqrt function. Importing the entire module may load more code into memory than necessary. If you only need specific functions or variables from a module, you can use the from statement to import them selectively. Now, let's discuss about importing selective methods from a module. To import selective methods or entities from a module in Python, you can use the from statement. This allows you to import all or specific functions, classes, or variables directly into your code without referencing the module name. Syntax is from module name import star. Example: from math import star. It gives access to all the functions of math module. Next is to import a particular function of the module. Syntax is from module name import method name. Example: from math import sqrt. This will import only sqrt function from the math module. Next is to import multiple functions. Syntax is from module name import method 1, method 2, up to method n. Example: from math import sqrt, pow, pi. This will import multiple functions, that is, sqrt, pow and pi functions of math module in a program. Let's see some examples. Line 1 imports the sqrt, pow, and pi entities from the math module. Now you can use these entities directly in your code without referencing the module name, math. In line 2, the sqrt function is imported from the math module, allowing you to calculate the square root of a number. In this line, it calculates the square root of 625, which is 25.0, and printed. In line 3, the pi constant is imported from the math module. It represents the mathematical constant pi. In this line, it is printed after rounding it to 2 decimal places using the round function. The output will be 3.14, which is the rounded value of pi. In line 4, the pow function is imported from the math module, allowing you to calculate the power of a number. In this line, it calculates 3 raised to the power of 3, which is 27, and printed. To import all methods from a module. Syntax is, from module name import star. It imports all the functions and constants from a module. Example. From math import star. This will import all the constants and functions or methods of math module. Let's see some examples. When you use from math import star, it imports all entities from the math module into your code. This includes functions, constants, and other entities defined in the math module. Look at line 1. This line imports all entities from the math module. It allows you to use any function, constant, or other entities for math without explicitly mentioning the module name. In line 2, the pi constant is part of the math module and represents the mathematical constant, pi. Since you imported all entities from the math module, you can directly access pi. The value of pi will be printed, which is approximately 3.141592653589793. In line 3, the factorial function is part of the math module. It calculates the factorial of a number. In this case, factorial of 5 calculates the factorial of 5, which is 120, and printed. In line 4, the sqrt function is also part of the math module. It calculates the square root of a number. In this line, sqrt of 225 calculates the square root of 225, which is 15.0, and printed. Let's see the key points of import statement. Import statement is the simplest and the most common way to use modules in our code. For example, import math. On executing this statement, Python shall perform 3 operations. Search for the file, math.py. Create space where module's definition and variable will be created. Execute the statements in the module. Import statement does not directly import the functions and constants in the program. To access or use any of the functions present in the imported module, we have to specify the name of the module followed by the name of the function, separated by a dot, also known as a period. This format is called dot notation. Let's see this example. Line 1 imports the math module, which is a standard library module in Python that provides various mathematical functions and constants. Line 2, the sqrt function is part of the math module. It calculates the square root of a number. In this line, math.sqrt of 144 calculates the square root of 144, which is 12.0, and printed. Let's discuss about the math module. The math module in Python is a built-in module that provides various mathematical operations and functions. It allows you to perform complex mathematical calculations easily. To use the math module, you need to import it into your Python script using the following line of code. Import math. This is the very first statement to be given. Let's discuss about the given function one by one. The math.ceil of x function in Python returns the smallest integer greater than or equal to the given number x. It rounds the number up to the nearest integer. Let's see these examples. In line 1, the import math statement imports the math module, allowing you to access its functions and constants in your code. In line 2 and 3, the math.ceil function is called with the argument -25.17. This function returns the smallest integer greater than or equal to -25.17, which is -25, and is printed to the console. In line 4 and 5, the math.ceil function is called with the argument -200.12. The function returns the smallest integer greater than or equal to -200.12, which is -200, and is printed to the console. In line 6 and 7, the math.ceil function is called with the argument -200.72. The function returns the smallest integer greater than or equal to -200.72, which is -200, and is printed to the console. In line 8 and 9, in this last example, the math.ceil function is called with the argument 200. Since 200 is an integer, the math.ceil function simply returns the same integer value 200 and is printed to the console. The math.floor of x function in Python returns the largest integer less than or equal to the given number x. It rounds the number down to the nearest integer. Let's see these examples. In line 1, the import math statement imports the math module, allowing you to access its functions and constants in your code. In line 2 and 3, the math.floor function is called with the argument -25.17. This function returns the largest integer less than or equal to -25.17, which is -26, and is printed to the console. In line 4 and 5, the math.floor function is called with the argument -200.12. The function returns the largest integer less than or equal to -200.12, which is -201, and is printed to the console. In line 6 and 7, the math.floor function is called with the argument -200.72. The function returns the largest integer less than or equal to -200.72, which is -201, and is printed to the console. In line 8 and 9, the math.floor function is called with the argument 200. Since 200 is an integer, this function simply returns the same integer value 200 and is printed to the console. The pow function in Python is used to calculate the power of a number. It takes two arguments, the base number and the exponent. It returns the output in floating point number. Syntax is pow of base, exponent. The pow function returns the result of raising the base to the power of the exponent. It is equivalent to using the exponentiation operator. Let's see some examples. In line 1, the import math statement in Python is used to import the math module, which provides a set of mathematical functions and constants. In line 2, this statement calculates 2 raised to the power of 2 using the pow function from the math module. The result is 4, and it is printed to the console. In line 3, this statement calculates 10 raised to the power of -2. The pow function supports both positive and negative exponents. In this case, 10 raised to the power of -2 is equal to 0.01 and is printed. In line 4, this statement calculates 4 raised to the power of 2, resulting in 16.0, and is printed to the console. In line 5, this statement calculates 5 raised to the power of 0. Any number raised to the power of 0 is always 1. Therefore, the result of this expression is 1, which is printed to the console. The fabs function in Python is a built-in function provided by the math module. It is used to return the absolute value, positive value, of the expression or number. It returns a floating point number, even if the argument is an integer. Now, look at this example. In line 1, the import math statement in Python is used to import the math module, which provides a set of mathematical functions and constants. In line 2, math.fabs of number returns the absolute value of the variable number, which is -25. The result is then printed, giving us the output 25.0. Let's see the difference between fabs and abs function. Data types. The fabs function is specifically designed to work with floating point numbers, while the abs function can handle both integers and floating point numbers. Module requirement. The fabs function is part of the math module, so you need to import the module using import math before you can use it. On the other hand, the abs function is a built-in function in Python, so you can use it without any imports. Return type. The fabs function always returns a floating point number, even if the input is an integer. In contrast, the abs function returns an integer if the input is an integer, and a floating point number if the input is a floating point number. The sqrt function in Python is used to calculate the square root of a number. This function accepts a number which is greater than 0, otherwise results in runtime error. It is available in the math module, so you need to import it before using the function. Let's see some examples. In line 1, the import math statement imports the math module, making all its functions and variables accessible in the current script. In line 2 and 3, we use the math.sqrt function to calculate the square root of 16. The output is 4.0. In line 4 and 5, we calculate the square root of 22 using math.sqrt of 22, and the output will be 4.69041575982343. In line 6 and 7, we calculate the square root of 22 using math.sqrt of 22, and then apply the round function to round the result to the nearest integer. The rounded value, which is 5, is printed on the console. In line 8 and 9, when trying to calculate the square root of a negative number, such as -22, an error occurs because the square root of a negative number is not defined in the real number system. This will result in a value error being raised. The log10 function in Python is used to calculate the logarithm base 10 of a number. It is available in the math module, so you need to import it before using the function. Let's see some examples. In line 1, the import math statement imports the math module, making its functions and variables accessible in the current script. In line 2 and 3, we calculate the logarithm base 10 of 100 using math log 10 of 100. The result, which is 2.0, is printed on the console. In line 4 and 5, we calculate the logarithm base 10 of 100.42 using math log 10 of 100.42, and the output is 2.0018202170383228 is printed on the console. In both cases, the math.log10 function takes the argument as the number for which you want to calculate the logarithm base 10. It returns a floating point number representing the logarithm base 10 of the given number. The cos function in Python is used to calculate the cosine of an angle given in radians. It is available in the math module, so you need to import it before using the function. Let's see some examples. In this code, we calculate the cosine of different angles using the math.cos function and print the results. In line 2 and 3, we calculate the cosine of 0 radians, or 0 degrees, using math.cos of 0. The result will be 1.0, as the cosine of 0 degrees is 1. In line 4 and 5, we calculate the cosine of 30 degrees using math.cos of 30. The argument is in degrees, but the math.cos function expects the angle in radians. So, internally, the value is converted to radians. The result will be approximately 0.15425144988758405. In line 6 and 7, we calculate the cosine of minus 3 radians using math.cos of minus 3. The result will be approximately minus 0.98999249660044454. Negative angles are allowed, and the math.cos function will calculate the cosine accordingly. In line 8 and 9, we calculate the cosine of pi radians using math.cos of math.pi. The result will be minus 1.0. The sine function in Python is used to calculate the sine of an angle given in radians. It is available in the math module, so you need to import it before using the function. Let's see some examples. In this code, we calculate the sine of different angles using the math.sine function and print the results. In line 2 and 3, we calculate the sine of 0 radians, or 0 degrees, using math.sine of 0. The result will be 0.0, as the sine of 0 degrees is 0. In line 4 and 5, we calculate the sine of 30 degrees using math.sine of 30. The argument is in degrees, but the math.sine function expects the angle in radians. So, internally, the value is converted to radians. The result will be minus 0.98803162409286118. In line 6 and 7, we calculate the sine of minus 3 radians using math.sine of minus 3. The result will be approximately minus 0.14112000805988672. Negative angles are allowed, and the math.sine function will calculate the sine accordingly. The tan function in Python is used to calculate the tangent of an angle given in radians. It is available in the math module, so you need to import it before using the function. Let's see some examples. In this code, we calculate the tangent of different angles using the math.tan function and print the results. In line 2 and 3, we calculate the tangent of 0 radians, or 0 degrees, using math.tan of 0. The result will be 0.0, as the tangent of 0 degrees is 0. In line 4 and 5, we calculate the tangent of 3 radians using math.tan of 3. The result will be minus 0.14254654307427778. In line 6 and 7, we calculate the tangent of minus 3 radians using math.tan of minus 3. The result will be approximately 0.14254654307427778. The help function in Python is used to access the built-in documentation, docstring, of a particular object, module, function, or class. It displays information about the object and how to use it. Now, look at this example. When you run this code, the documentation for the math.tan function will be displayed in the console or interactive shell. It will provide information about the function's purpose, parameters, and usage. Note that the help function returns the documentation as a string, so you need to use print to display it. Now, let's see about the random module. The random module is like a magical tool that helps us create randomness and surprises in our programs. Generating random numbers. Just like rolling a dice and getting a random number between 1 and 6, the random module helps us generate random numbers in our programs. We can use these numbers to make computer games more exciting or make decisions in our programs. Picking random things. Imagine you have a jar filled with different colored candies. The random module can help us pick a random candy from the jar. We can use this to create surprises in our programs, like picking a random character in a game or a random question in a quiz. Shuffling things. Think of a deck of playing cards. The random module can help us shuffle the cards so that they are in a random order. We can use this to create random sequences or mix up things in our programs. Pseudo-random numbers on lottery scratch cards. ReCAPTCHA, like in login forms, use a random number generator to define which image is to be shown to the user. In Python, random numbers are not enabled implicitly. Therefore, we need to invoke random module or random code library explicitly in order to generate random numbers. The first statement to be given in a program for generating random numbers is import random. Let's see the various functions associated with the random module. The randRange function is a part of the random module in Python. It allows us to generate a random number from a specified range. This method generates an integer between its lower and upper arguments. By default, the lower argument is 0 and upper argument is range -1. The syntax is random.randRange of start, stop, step. The randRange function takes in 3 parameters. Start, optional. It specifies the starting point of the range, inclusive. If not provided, it defaults to 0. Next parameter is stop. It specifies the ending point of the range, exclusive. The function will generate random numbers up to, but not including, this value. Step, optional. It specifies the step size or interval between numbers in the range. If not provided, it defaults to 1. The start, stop, and step values can be integers. Let's see an example. In line 1, the import random is used to bring the random module into our code. By importing the random module, we gain access to various functions and capabilities that allow us to work with random numbers and randomness in our program. In line 4, we are using the randRange function from the random module. The randRange function generates a random number within a specified range. The first parameter, 0, specifies the starting point of the range, inclusive. In this case, we want our range to start at 0. The second parameter, 10, specifies the ending point of the range, exclusive. We want our range to go up to, but not include, 10. The third parameter, 2, is the step size or interval between numbers. It indicates that we want to generate only even numbers within the range, as we are incrementing by 2 at each step. The randRange function will then produce a random even number between 0 and 10, exclusive, based on the specified range and step size. This random even number is assigned to the variable even_number. Finally, we use the print function to display the value stored in the even_number variable. The output will be the randomly generated even number between 0 and 10. Here, you can see the output displayed each time a random number, for the first code 4, for the second code 8, and for the third code 6. Let's see another example. In line 2, the line import random imports the random module into our code. This module provides functions that allow us to work with random numbers, make random selections, and more. In line 3, we define a list called subjects that contains 4 different subjects as elements. Each subject is represented by a string. In line 4 and 5, we use the randRange function from the random module. The randRange function generates a random number within a specified range. The first parameter, 2, specifies the ending point of the range, exclusive. Since we provide only one parameter, the starting point is assumed to be 0. The randRange function will then produce a random number between 0 and 2, exclusive. It could be either 0 or 1. The random number generated by randRange is assigned to the variable ran_index. This number will serve as the index to select a random subject from the subjects list. Finally, we use the print function to display the subject at the randomly chosen index in the subjects list. Since the ran_index variable holds a random number between 0 and 2, it will randomly select one of the subjects from the list. So, the overall code imports the random module, creates a list of subjects, generates a random index using randRange, and then prints the subject corresponding to the randomly chosen index. You can see the output that, each time the code is run, a different subject will be printed, adding an element of randomness to the program. The random function generates a random decimal number between 0 and 1. This function can be used to generate random floating point value in the range 0.1, 1.0. It takes no parameters and returns values uniformly distributed between 0 and 1, including 0, but excluding 1. Let's see some examples. In this code, each time random function generates a different number. Program to calculate the sum of the digits of a random 3-digit number. This code generates a random number n between 100 and 1000, and then separates the digits of n to calculate the sum of its individual digits. Look at line 4. The random function generates a random fractional number from 0 to 1. When a random number generated using random function gets multiplied by 900, a random number is obtained from 0 to 899. When we add 100 to it, we get a number from 100 to 999. Line 7 and 8 converts the random number to an integer. Line 11, 12, and 13 extracts the individual digits from the random number. Line 16 and 17 calculates the sum of individual digits. When you run this code, it will output two numbers. The first number, n, is a random integer between 100 and 1000. The second number is the sum of the individual digits of n, that is, a plus b plus c. In this case, n is 547, and the sum of its digits, 5, 4, and 7, is 16. Next time when you run the code, n is 670, and the sum of its digits, 6, 7, and 0, is 13. The random function generates a random integer between a specified range. It is part of the random module in Python. Now, look at this example. In this code, randint of 1, 10 generates a random integer between 1 and 10, including both endpoints. Each time you run the code, it will output a different random number within the specified range. For example, the output could be 2 and the next time it could be 3 and so on. Let's learn some more functions of the random module. The uniform function is another function provided by the random module in Python. It generates a random floating point number between two specified values. The syntax is random.uniform of x, y. Now, look at this example. In this code, uniform of 0, 1 generates a random floating point number between 0 and 1. The range is inclusive of 0 but exclusive of 1. Each time you run the code, it will output a different random number within the specified range. You can see the output below. The choice function is another useful function provided by the random module in Python. It allows you to randomly select an element from a sequence, such as a list or a string. The syntax is random.choice of sequence. Let's see an example. You can also use the choice function with strings. In this case, choice of my_string selects a random character from the my_string string. The output could be any character from the string, such as R, next time it could be L, and so on. The shuffle function is another useful function provided by the random module in Python. It allows you to randomly shuffle the elements of a sequence, such as a list. The syntax is shuffle of list. Let's see an example. In this code, shuffle of my_list shuffles the elements of the my_list list in place, meaning it modifies the list directly. Each time you run the code, it will output a different order of the elements in the list. For example, the output could be list of elements 4, 3, 5, 1, 2, and next time it could be list of elements 3, 4, 2, 1, 5. The shuffle function is particularly useful when you want to randomize the order of a list or when you need to randomly permute a sequence of elements. It can be handy for implementing algorithms like shuffling a deck of cards, randomizing quiz questions, or generating random permutations. Functions in Python Part 3. In this video, we are going to learn user-defined functions, how to define and call a function in Python, how function returns a value, parameters and arguments in function, types of user-defined functions. So let's dive in and get started. Let's discuss about the user-defined functions. In Python, you can define your own functions to encapsulate a block of reusable code. User-defined functions allow you to modularize your code and improve its readability and maintainability. Let's learn how to define and call a function in Python. To define and call a function in Python, you can follow these steps. Function definition. Start by defining the function using the def keyword, followed by the function name and parentheses. You can also specify any parameters inside the parentheses, which the function may accept, and a colon. Now look at the syntax. Here, def keyword is used to start the function definition. Next is function_name, which is the name you give to your function. Choose a descriptive name that reflects the purpose or action performed by the function. Here, parameters are optional. Parameters are the inputs or arguments that the function can accept. Parameters are enclosed in parentheses and can be separated by commas if there are multiple parameters. If the function doesn't require any parameters, the parentheses can be left empty. Next is function documentation, optional. You can include a doc string within triple quotes right after the function definition. This is used to provide a brief description of the function's purpose, parameters, and return values. Next is function body, where you write the code statements that define the actions or operations to be performed when the function is called. Make sure to indent the function body to indicate that it belongs to the function. Statements must have same indentation level, usually 4 spaces. Next is return statement, optional. If you want your function to return a value, you can use the return statement followed by the expression or variable to be returned. If there is no return statement or it doesn't specify any expression, the function will return none by default. Function can alter only mutable type values. Let's define a simple function, which does not return any value by using the command def greet function : and call the function. You can look at the greet function called. The output will be hello world. Welcome to Python programming. This example displays these messages as output and does not contain a return statement. Such functions are called void functions. Void functions might display something on the screen or have some other effect, but they don't have a return value. If we try to assign the result of such a function to a variable, we get a special value called none. User-defined functions in Python are called using only the function name. Python functions don't have any explicit beginning or end, like curly braces to indicate the start and stop for the function. They have to rely on this indentation, spaces. Now, look at this example. Print function has been declared immediately below def function and hence it shows syntax error. When we leave indent, spacing, in front of print function, it will give expected output. Let's see an example of a user-defined function in Python to print a right-angled triangle. In this function, right_angled_triangle, in line 2, we use a loop to iterate from 1 to the given height plus 1. On each iteration, we print a string of asterisks that corresponds to the current row number. This results in a right-angled triangle pattern being printed. When you call the function with right_angled_triangle of E5, it will print the triangle as shown in this output. In this code, we have given height parameter as 5. You can change the height parameter to any positive integer to adjust the size of the triangle. In Python, a function returns a value using the return statement. When a return statement is encountered in a function, the function execution immediately stops, and the value specified after the return keyword is returned as the result of the function. Function can take input values as parameters, execute them and return output, if required, to the calling function with a return statement. The function returning value to the calling function is termed as fruitful function. Here's an example to illustrate how a function returns a value. A Python program to calculate the area of a rectangle. In this function, compute_rectangle_area, we take the length and width as input parameters. Using these values, we calculate the area by multiplying the length and width, and store it in the area variable. Finally, we return the calculated area. When you run the example code with a length of 5 and a width of 3, it will output, the area of the rectangle is 15. You can substitute different values for length and width to calculate the area of a rectangle with different dimensions. In Python, a function can return multiple values by using a tuple. You can simply separate the values with commas in the return statement, and they will be automatically packed into a tuple. Let's see an example. A Python program to calculate the area and perimeter of a rectangle. In this example, the function calculate_rectangle_properties takes the length and width of a rectangle as input parameters. It calculates both the area and perimeter of the rectangle and returns them as two separate values. When you call the function with length of 5 and width of 3, the function calculates the area, 15, and perimeter, 16, of the rectangle. The return statement packs these two values into a tuple, which is then unpacked into the variables rectangle_area and rectangle_perimeter respectively. The code then prints the area and perimeter separately, resulting in the following output as area 15 and perimeter 16. In Python, the return statement is used in a user-defined function to specify the value that the function should return when it is called. The return statement is typically placed at the end of the function, but it can also appear within conditional statements or loops based on the desired logic of the function. Return without an expression argument is used to return from the middle of a function, in which case the none value is returned. In Python, the return statement without an expression argument can be used to exit a function prematurely and return none. This is useful when you want to stop the execution of the function before reaching the end or when you don't need to explicitly return a value. Let's see an example. In this code, the func function is defined, and it uses the pass statement, which is a placeholder indicating that the function does not have any code to execute. Essentially, the function does nothing. Then, we call the func function and assign the result to the variable a. Since the function doesn't have a return statement, it implicitly returns none. Finally, we print the value of a, which will output none. Here are some key points of return statement in user-defined function. Functions must be defined before they are called. Statements inside the definitions are not executed until the function is called. The order in which statements are executed is called the flow of execution. Statements are executed one at a time in order until a function call is reached. Return statement returns the value of an expression following the return keyword. In the absence of the return statement, the default value none is returned. In Python, parameters and arguments are terms used to describe the variables and values passed into functions. At first, let's discuss about parameters in functions. Parameters are the variables declared in the function definition. They represent the inputs or placeholders that the function expects to receive when it is called. They are defined inside the parentheses after the function name. They are like empty containers waiting to hold values when the function is called. They are also sometimes referred to as formal parameters. In this example, the function greet holds a parameter name, which is called the formal parameter. This name parameter is just a variable declared in the function greet. Arguments are the values passed to a function when calling it. They are the actual values that are assigned to the corresponding parameters inside the function. They are provided in the parentheses when calling the function. They are like the values that fill the empty containers, parameters, when the function is called. They are also sometimes referred to as actual arguments. Let's consider an example. In this example, the function greet has a parameter called name. When we call the greet function and pass the argument Joel, the value Joel gets assigned to the name parameter within the function. So, when the function is executed, it will print hello, Joel. Here are some key points of parameter passing. In Python functions, if you are passing values of immutable types, that is, numbers, strings, etc., to the called functions, then the called function cannot alter their values. But in case parameters passed are mutable in nature, such as lists or dictionaries, then called function would be able to make changes to them. Here are some function definition given. Identify which of these are invalid giving reasons. In example 1, function definition is valid as the parameters defined are valid parameters. In example 2, invalid parameter. Expression, a+1, has been defined as an argument, which is illegal in Python. In example 3, invalid parameter. 5 and b, which are literals, defined as a parameter, which is illegal in Python. Let's see some key points of how arguments work. First key point. Functions may be simple one-to-one mappings, where a single argument is passed to the function, and it returns a corresponding result. Let's consider an example. In this example, we have a function called square that takes a single argument number. The function calculates the square of the number by multiplying it by itself using the exponentiation operator and returns the result. When we call the square function with the argument 5, it performs the square operation and returns the result, which is then assigned to the variable result. Finally, we print the value of result, which outputs 25 as the square of 5. Here, the function square acts as a one-to-one mapping. Each unique input, argument, corresponds to a unique output, result. The argument 5 is passed to the function, and it returns the squared value 25. Second key point. Functions may also contain multiple input and/or output variables as well as return multiple values. Let's consider an example. In this example, the function add_n_subtract takes two input parameters, x and y. Inside the function, it performs addition and subtraction operations on the input values and stores the results in sum_result and difference_result variables, respectively. The return statement is used to return multiple values, separated by commas. In this case, the function returns both sum_result and difference_result. When we call the add_n_subtract function with arguments 10 and 5, it calculates the sum and difference and returns the results. The returned values are then assigned to result 1 and result 2 variables. Finally, we print the values of result 1 and result 2, which output 15 and 5, respectively. Third key point. Functions don't need to contain arguments at all. You can define functions without any parameters if they don't require any inputs to perform their intended tasks. Here's an example. In this example, the function say_hello doesn't have any parameters defined. It simply contains a single statement that prints hello when executed. When we call the say_hello function without any arguments, it executes the code inside the function, which results in printing hello to the console. Fourth key point. The user can set arguments to default values in function definitions. In this example, the f1 function has two parameters x and a, with a having a default value of 1. Inside the function, it calculates the square of x multiplied by a, using the exponentiation operator and returns the result. When we call the f1 function with only the argument 5, it uses the default value of a, which is 1, and calculates 1*5 to the power 2, resulting in 25. Alternatively, when we call the f1 function with both the arguments 5 and 2, it overrides the default value of a, and calculates 2*5 to the power 2, resulting in 50. This example demonstrates how the default value for an argument provides a fallback value when the caller does not provide a specific value, and how it can be overridden by providing a different value explicitly. Let's discuss about the types of user-defined functions. Function with no argument and no return value. These type of functions do not take any value or argument and do not return any value. Let's consider an example. In this example, greeting is the function name. The function greeting doesn't have any parameters defined. It contains a single statement that prints the greeting message hello, welcome, when executed. When we call the greeting function without any arguments, it executes the code inside the function, which prints the greeting message to the console. This function doesn't return any value explicitly using the return statement. It solely focuses on performing a specific action or displaying output without producing a result that needs to be captured or stored. Function with arguments but no return value. In this type of function, parameters are given in the parentheses separated by comma. Also, the values are passed for the parameter at the time of function calling. Here's an example of a function that takes arguments but doesn't return any value. In this example, the sum_n_product function takes two arguments, a and b, inside the function. It calculates the sum of a and b and assigns it to the total variable. It also calculates the product of a and b and assigns it to the product variable. Instead of returning these values, the function directly prints them to the console using the print statements. When we call the sum_n_product function with arguments 3 and 4, it calculates the sum, 3 plus 4 is equal to 7, and the product, 3 * 4 is equal to 12, and then prints the results to the console. Function with no argument but return value. In this type of function, the function may not take any arguments but returns a value in the calling function. Let's consider an example. Step 1, Function definition. In line 1 and 2, the function welcome is defined. It doesn't take any arguments. The function body contains a single line of code, which is the print function call with the message welcome to Sallyann Bytes as the argument. The return statement is used to return the result of the print function call. Step 2, Function call. In line 4, the welcome function is called without any arguments. The function execution reaches the print statement inside the function. As a result, it displays the message welcome to Sallyann Bytes on the console. Step 3, Function call within print function. In line 5, the welcome function is called within the print function. The execution of the welcome function is similar to the previous step, displaying the message welcome to Sallyann Bytes on the console. However, since the print function within welcome doesn't have a specific return value, the welcome function returns none. As a result, when print welcome is executed, it first displays the message welcome to Sallyann Bytes and then prints none, which represents the return value of the welcome function. Overall, the code calls the welcome function twice. The first call displays the message welcome to Sallyann Bytes, and the second call displays the message along with none. Function with arguments and return value. This type of function involves both parameter passing with the returned values. We can return values from function using return keyword. In this example, in line 1 and 2, the function add_numbers takes two arguments, a and b. It adds them together and stores the result in the result variable. Finally, in line 3, it returns the value of result using the return keyword. In line 4 and 5, you can then call the function and store its return value in a variable. In this case, add_numbers 3, 4 returns 7, which is then assigned to the variable sum. The print statement displays the value of sum, which is 7. The return value must be used at the place from where it has been called in different ways, storing return value in a variable. You can store the return value of a function in a variable by assigning it using the assignment operator, equal to. In this example, you can see how the return value is stored in a variable val. Displaying return value using print function. To display the return value of a function using the print function in Python, you can directly pass the function call as an argument to print. You can see in this example how return value is displayed using print function. Using return value in any expression. Line 1 begins the function definition of cube that takes a single parameter number. The function will calculate the cube of this number. Line 2 indicates the return statement of the function. It calculates the cube of number by multiplying it by itself 3 times. The result is then returned as the output of the function. In line 4, prompts the user to enter a number and assigns the entered value to the variable n1. The input function takes input from the user as a string, and int is used to convert it to an integer. Look at line 5 of this code. Val equals n1 plus cube of n1. This line calculates the expression, the the sum of the number n1 and the cube of n1 by calling the cube function with n1 as an argument. The return value of the cube function is added to n1 and stored in the variable val. And in line 6, it is printed. The output is 130 if number 5 given. Difference between parameters and arguments. First point. Parameters are variables defined within the function signature or declaration, serving as placeholders for the data that the function expects to receive. On the other hand, arguments are the actual values or expressions provided to a function when it is called or invoked, supplying the necessary input data. Second point. Parameters establish the structure and expected inputs of a function, acting as local variables within the function's scope. Meanwhile, arguments provide the specific values or variables that the function will process, fulfilling the function's logic. Third point. Parameters are used during the function definition, typically appearing within the parentheses after the function name. Conversely, arguments are employed when calling or invoking the function, appearing within the parentheses after the function name. Fourth point. For example, in the function definition def multiply of a, b, a, and b are parameters that can be used within the function's body. In contrast, when calling the multiply function like multiply of 3, 5, 3 and 5 are arguments passed to the function for processing. Fifth point. Parameters define the names and types of data that a function can accept, whereas arguments supply the actual values that correspond to the parameters. Arguments are bound to the parameters defined in the function. Sixth point. While parameters are typically required when defining a function, Python allows setting default values for parameters, making them optional during function calls. On the other hand, arguments are necessary when calling a function, but default values for parameters allow some arguments to be omitted. Functions in Python, Part 4. In this video, we are going to learn types of arguments, positional arguments, default arguments, keyword arguments, variable length arguments. So let's dive in and get started. Let's discuss about the arguments and types of arguments. In Python, an argument refers to a value that is passed to a function or method when it is called. Arguments provide a way to supply inputs or data to functions, allowing them to perform specific tasks or operations based on those inputs. In this example, a function named f1 with two parameters, x and y, also called formal arguments, are defined. The function body consists of two statements, which could be any valid Python code. These statements will be executed when the function is called. The function is then called with the arguments 10 and 20 using the syntax f1 of 10, 20. When the function is called, the values 10 and 20 are assigned to the parameters x and y, respectively. The statements within the function body will be executed using these values. Python provides different ways of passing the arguments during the function call. Positional arguments, default arguments, keyword arguments, and variable length arguments. Let's discuss about these four types of arguments in Python. Let's discuss about the positional arguments in Python. Positional arguments are arguments passed to the actual arguments of a function based on their position or order. The number of positional arguments must match the number of parameters defined in the function. Let's consider an example. In example 1, Alice and 25 are positional arguments. The function greet expects two arguments, name and age, which are assigned the values Alice and 25, respectively. The number of positional arguments Alice and 25 matches the number of parameters name and age defined in the function. Hence the output displayed is Hello Alice. You are 25 years old. Now, look at example 2. Here 25 and Alice are positional arguments. The function greet expects two arguments, name and age, which are assigned the values 25 and Alice respectively. The number of positional arguments 25 and Alice does not match the number of parameters name and age defined in the function. Hence the output displayed message is wrong. If we change the order, the result will change. If we change the number of arguments passed, it will result in an error. Let's consider another example. In example 1, 500 and 200 are positional arguments. The function subtract expects two arguments, x and y, which are assigned the values 500, 200 respectively. When subtracted 200 from 500, results in 300. But in example 2, the function subtract expects two arguments, x and y, which are assigned the values 200 and 500 respectively. When subtracted 500 from 200, results in minus 300. If we change the order, the result will change. If we change the number of arguments passed, it will result in an error. Python allows function arguments to have default values. If the function is called without the argument gets its default value. In Python, a default argument is a value assigned to a function parameter that is used when the caller does not provide a corresponding argument. To define a default argument in Python, you can specify a default value for a parameter in the function definition. In the function definition, you can assign a default value to one or more parameters by providing an equal sign, followed by the desired default value. When the function is called, if an argument is provided for a parameter, the provided value is used. Otherwise, the default value specified in the function definition is used. The syntax is argument name equals value. Let's consider an example. In line 1, the code defines a function called greet that takes two parameters, name and message. The message parameter has a default value of good morning if no argument is provided. In line 3 to 9, the docstring in the function definition is a multi-line comment that describes the function's purpose and usage. It provides information about the parameters and the default behavior of the function. In line 12, the function greet prints a greeting message, concatenating the name and the message using the print function. Let's analyze the function calls. Now look at line 14. In this function call, only the name argument is provided, and the message argument is not specified. Since message has a default value of good morning, the function will use that default value. The output of this function call will be, "Hello Kate, good morning." Now look at line 15. In this function call, both the name and message arguments are provided explicitly. The value of "How do you do" will be used for the message parameter. The output of this function call will be, "Hello Bruce, how do you do?" In Python, keyword arguments, also known as named arguments, allow you to pass arguments to a function using the parameter names, rather than relying on their position or order. By using keyword arguments, you can provide values for specific parameters while skipping others or changing the order of the arguments. Syntax is function underscore name of, param1 equals value 1, param2 equals value 2, and so on. In the function call, you specify the parameter name, followed by an equals sign, and then the corresponding value you want to assign to that parameter. You can provide values for any number of parameters using this syntax. Let's see an example. In line 1, in the greet function, the name and message parameters are defined. In line 5 and 6, when calling the function, instead of relying on the order of the parameters, we explicitly specify the parameter names followed by the corresponding values. This way, even if the parameters are swapped or omitted in the function call, the correct values will be assigned. So here the output will be, "Hi, Joel." "Hello, Alice." It's important to note that when using keyword arguments, the order of the arguments does not matter as long as you provide the parameter names. However, positional arguments, arguments provided without specifying the parameter names, must come before any keyword arguments. Look at line 4 of this Python code. In this function call, the first argument Kate is passed as a positional argument, meaning it is assigned to the first parameter name based on their respective positions. The second argument, "How are you?" is passed as a keyword argument by explicitly specifying the parameter name message followed by an equals sign and the corresponding value. This is a valid usage of keyword arguments because you are providing a value for a specific parameter by using its name. Here, positional arguments are provided before the keyword arguments. The output of this function call would be, "How are you, Kate?" Now look at line 5. In this function call, the first argument Sam is passed as a keyword argument by explicitly specifying the parameter name followed by an equals sign and the corresponding value. This is a valid usage of keyword arguments. However, the second argument, "Good morning," is provided as a positional argument without specifying the parameter name. This is an invalid usage because a positional argument cannot follow a keyword argument. Python requires that all positional arguments are provided before any keyword arguments. Advantages of writing functions with keyword arguments. Improved code readability. By using keyword arguments, it becomes clear which value corresponds to which parameter, enhancing the readability of your code. Flexibility in argument order. With keyword arguments, you can change the order of the arguments or skip some arguments altogether. This can be especially useful when a function has a large number of parameters, and you only want to provide values for specific ones. Default argument override. If a function has default arguments, you can override those default values by explicitly passing different values using keyword arguments. Let's consider some more examples of keyword arguments. Look at line 1. The code demonstrates a function called func1 that takes 3 arguments, a, b, and c. However, both b and c have default values assigned to them, which means they are optional arguments. If no value is provided for b or c when calling the function, the default values will be used. Let's go through each function call and see how the arguments are passed. Now look at line 4. Func1 of 2. In this case, the value of a is set to 2, while b and c will take their default values. Therefore, the output will be a is 2, b is 4, c is 6. Now, look at line 5, func1 of 3, 5, 7. Here, all three arguments are provided explicitly. A is set to 3, B is set to 5, and C is set to 7. The output will be A is 3, B is 5, C is 7. Now look at line 6, func1 of 25, C equals 20. In this case, the value of A is set to 25, B takes its default value of 4, and C is explicitly set to 20 using the keyword argument. The output will be A is 25, B is 4, C is 20. Now, look at line 7, func1 of C equals 20, A equals 10. Similarly, the values of A and C are explicitly provided using keyword arguments. A is set to 10, B takes its default value of 4, and C is set to 20. The output will be A is 10, B is 4, C is 20. Thus, this function allows you to provide values for A, B, and C, but if any of them are not provided, they will take their default values. The order in which the arguments are provided can be changed by using keyword arguments, as demonstrated in the last two function calls. Note: the function named func1 has three parameters, out of which the first one is without default value and the other two have default values. So, any call to the functions should have at least one argument. Here, we can see some key points of using keyword arguments. An argument list must have any positional arguments followed by any keyword arguments. Keywords in argument list should be from the list of parameters name only. No parameter should receive value more than once. Parameter names corresponding to positional arguments cannot be used as keywords in the same calls. Here are some learning tips of keyword arguments. The default value assigned to the parameter should be a constant only. Only those parameters which are at the end of the list can be given default value. You cannot have a parameter on the left with default argument value without assigning default values to parameters lying on its right side. The default value is evaluated only once at the point of function definition. Consider the given user-defined functions to calculate average of three numbers. Def average of n1, n2, n3 equals 1000. Return of n1 plus n2 plus n3 / 3. Now look at the tabular column. We are checking if each function call is legal or illegal by giving reasons. The first function call, average of n1 equals 20, n2 equals 40, n3 equals 80, is legal, as non-default values provided as named arguments. The second function call, average of n3 equals 10, n2 equals 7, n1 equals 100, is legal, as the keyword argument can be in any order. The third function call, average of 100, n2 equals 10, n3 equals 15, is legal, as the positional argument is before the keyword arguments. The fourth function call, average of n3 equals 70, n1 equals 90, 100, is illegal, as the keyword arguments are before the positional arguments. The fifth function call, average of 100, n1 equals 23, n2 equals 1, is illegal, as multiple values are provided for n1. The sixth function call, average of 20, number equals 9, n3 equals 11, is illegal, as undefined argument number is used. Variable length arguments, also known as varargs, allow a function to accept a varying number of arguments. In Python, you can define the types of variable length arguments. Args, this notation allows a function to accept any number of positional arguments. The syntax is def f1 of *args:*. The asterisk before args unpacks the arguments into a tuple within the function. Note: the asterisk character has to precede a variable identifier in the parameter list. Let's consider an example. In this program, we are defining a function called sum that accepts a variable number of arguments using the *args notation and calculates the sum of the provided numbers, printing the result. Now look at line 1. The code demonstrates a function called sum that accepts a variable number of arguments using the *args notation. This means that you can pass any number of arguments to the function, and they will be treated as a tuple named number within the function. Lines 2 to 5 calculates the sum of the provided numbers. Let's see how the function works for each function call. Now, look at line 7. Sum empty function. In this case, no arguments are passed to the function. Since the *args notation allows for 0 or more arguments, the number tuple will be empty. As a result, the sum will be 0, and the output will be the sum equals 0. Now, look at line 8. Sum of 10. Only one argument, 10, is passed to the function. The number tuple will contain a single element, which is 10. The sum will be 10, and the output will be the sum equals 10. Now, look at line 9, sum of 10, 20. Two arguments, 10 and 20, are passed to the function. The number tuple will contain two elements, 10 and 20. The sum will be 30, and the output will be the sum equals 30. Now, look at line 10. Sum of 20, 30, 40, 50. Four arguments, 20, 30, 40, and 50, are passed to the function. The number tuple will contain all four elements. The sum will be 140, and the output will be the sum equals 140. Thus, the sum function allows you to pass a variable number of arguments, and it calculates the sum of those arguments using a loop. This can be useful when you need to calculate the sum of multiple numbers without knowing the exact number of values in advance. Note: we can call this function by passing any number of arguments, including zero number. Internally, all the values are represented in the form of a tuple. Functions in Python, Part 5. We are going to learn passing mutable and immutable objects to functions, passing arrays or lists to functions, passing strings to a function, passing tuple to a function, passing dictionary to a function. So let's dive in and get started. Understanding how Python sees objects is a key to becoming a better Python programmer. At first, let us know what are Python objects. In Python, everything is an object, including integers, lists, and even functions. This means that every value, variable, function, or data structure you encounter is an instance of a class and has associated attributes and methods. Let's verify using the interpreter. Now look at example 1. Integers as objects. In line 1 of example 1, it assigns the value 5 to the variable x. In Python, integers are objects, so x becomes an object of the int class with the value 5. In line 2, the bit_length method is called on the x object. This method returns the number of bits required to represent the integer value of x. In this case, x has the value 5, which can be represented with 3 bits, 101. So the output displayed is 3. Example 2. Lists as objects. Here, my_list is an object of the list class. It has methods like append, which can be used to modify the list by adding elements. The output displayed is list containing elements 1, 2, 3, 4. Now look at example 3. Functions as objects. In Python, functions are also objects. They can be assigned to variables, passed as arguments, and have attributes. In this example, greet is an object of the function class, and we can call it like any other object. So everything in Python is an object. Let's learn about the use of id and use of is to deepen our understanding of what's happening under the hood when using Python to create and modify objects. Python has a built-in function, id, which returns the address of an object in memory. In this example, we created an object by the name of x and assigned it the value of 2. We then used id of x and discovered that this object is found at the address 139804188311824 in memory. The function id of object returns the address of object in memory. This allows us to check interesting things about Python. Let's say we create two variables in Python, one by the name of x and one by the name of y, and assign them the same value. Now look at this example. Both variable x and y holds the string Python programming. Now, in line 5, we are using the equality operator to verify that they indeed have the same value in Python's eyes. Yes, look at the output, it's true. But are these the same object in memory? In theory, there can be two very different scenarios here. Now, look at picture 1. According to the picture 1, we really have two different objects, one by the name of x and another by the name of y, that just happen to have the same value. Now look at picture 2. Yet, it could also be the case that Python actually stores here only one object, which has two names that reference it, as shown in picture 2. Now, we can use the id function to check this. So as we can see, Python's behavior matches picture 1, described in the previous screen. Even though x is equal to y in this example, that is, x and y have the same values, they are different objects in memory. This is because, look at line 8, id of x not equal to id of y, the output is false. Now, look at line 9 and 10. There is a shorter way to make the comparison given, and that is to use Python's is operator. Checking whether x is y is the same as checking id of x equal to id of y, which means whether x and y are the same object in memory. Here the output is true. We have said that everything in Python is an object, yet there is an important distinction between objects. Some objects are mutable while some are immutable. An object whose internal state can be changed is called mutable. Example, list, set, dictionary. An object whose internal state cannot be changed is called immutable. Example, number, string, tuple. Let's see about immutable objects. An object whose internal state cannot be changed is called immutable. For example, int objects are immutable in Python. Look at example 1. What will happen if we try to change the value of an int object? Well, it seems that we changed x successfully from 53,045 to 53046. What exactly has happened here? Let's use ID to further investigate. Now look at example 2. X is assigned value 53045 and the ID is noted. In line 5 onwards, we can see that by assigning x equals 53,046, we didn't change the value of the object that x had been bound to before. Rather, we created a new object and bound the name x to it. So the ID is different. Now, look at picture 1. So after assigning 53045 to x by using x equals 53,045, we had this state. Now, look at picture 2. And after using x equals 53,046, we created a new object and bound the name x to this new object. The other object with the value of 53,045 is no longer reachable by x, or any other name in this case. Whenever we assign a new value to a name, in this example, x, that is bound to an int object, we actually change the binding of that name to another object. So the IDs are different. The same applies for tuples, strings, str objects, and bools as well. In other words, int and other number types such as float, tuple, bool, and str objects are immutable. An object whose internal state can be changed is called mutable. For example, we know that we can modify the contents of a list object. Now, look at example 1. The first line initializes a list called my_list with 3 elements, 5, 20, and 30. The second line modifies the first element of my_list by assigning the value 10 to my_list of 0. In Python, list indices start from 0, so my_list of 0 refers to the first element of the list. Finally, the third line prints the modified list my_list. Does that mean we actually created a new object when assigning a new value to the first element of my_list? Again, we can use ID to check. Now, look at example 2. Both IDs are same. Look at picture 1. So our first assignment my_list equals 5, 20, and 30 created an object in the address 140167178840256 with the values of 5, 20, and 30. Now, look at the second picture. We then modified the first element of this list object using my_list of 0 equals 10, that is, without creating a new list object. And hence the address is the same, with the values 10, 20, 30. In the previous video, we have passed single constant value to functions either through positional arguments or through keyword arguments. In Python, we can pass multiple values to the function using lists, tuples, dictionary, etc. In Python, objects can be categorized as either mutable or immutable. Immutable objects, such as numbers, strings, and tuples, cannot be modified after creation. When passing an immutable object as an argument to a function, the function receives a copy of the object's value. Modifying an immutable object within a function only affects the local copy and does not impact the original object outside the function. This behavior is known as pass-by-value for immutable objects. Mutable objects, such as lists and dictionaries, can be changed after they are created. When passing a mutable object to a function, the function receives a reference to the original object. Any modifications made to the mutable object within the function will affect the original object outside the function as well. Mutable objects are passed by reference in this case. Now, we are in the topic passing arrays or lists to functions. But before that, let's see the difference between an array and a list. Data type. Lists can store elements of different data types, while arrays typically store elements of the same data type. Mutability. Lists are mutable, allowing for modifications to the elements, whereas arrays can be mutable or immutable depending on the underlying data type. Functionality. Lists provide general-purpose functionality for data manipulation, while arrays are optimized for numerical computations and offer specific mathematical operations. Memory overhead. Lists have a higher memory overhead compared to arrays because of their additional functionality and flexibility. Availability. Lists are a built-in data structure in Python and readily available, while arrays require the array module to be imported. Indexing. Both lists and arrays use zero-based indexing, allowing access to elements by their index position. Dynamic resizing. Lists have dynamic resizing, meaning they can grow or shrink as needed, while arrays can be fixed size or resizable, depending on the implementation. Element types. Lists can store elements of different data types, making them heterogeneous, while arrays typically store elements of the same data type, making them homogeneous. Methods. Lists provide a wide range of built-in methods for general-purpose data manipulation, while arrays offer specialized methods for mathematical computations and operations. When working with arrays or lists in Python, passing them to functions involves some considerations. Let's see the summary of passing arrays or lists to functions. Arrays or lists can be passed as arguments to functions in Python. By default, when an array or list is passed to a function, the function receives a reference to the original object. Any modifications made to the array or list within the function will affect the original object. This behavior is due to the fact that arrays or lists are mutable objects. Modifying the array or list within the function will persist even after the function returns. It is important to understand that the reference to the original array or list is passed, not a copy of the entire object. Consequently, any changes made to the array or list within the function will be reflected in the original object outside the function's scope. You can pass a list as an argument of a Python function the same way as any other type, and it will be the same type inside the function. Let's see an example. In this example, a list named my_list is defined with the values 1, 2, 3. Now, look at line 3. A function called my_func is defined that takes a list as an argument. In line 4 and 5, within the function, there is a for loop that iterates over each element in the list_as_argument and prints each element. In line 7, after defining the function, you call my_func with the my_list as an argument, which means the elements of my_list will be printed by the function as 1, 2, and 3. Finally, in line 8, outside the function, you print the my_list again. This will print the list as it is, without any changes made by the function. The output is list containing 1, 2, and 3. There is a list of 3 numbers. You can pass this list as an argument and display all its elements one by one. If you print a list after the function execution, it will print the same numbers. Because lists are mutable, when you pass a list as an argument, you create a reference to this list and not a copy. Now look at example 2. Look at line 6, the same example, but if you print a list after the function execution, it will print the same numbers. Because lists are mutable, when you pass a list as an argument, you create a reference to this list and not a copy. Check the output displayed on the console. Now, in example 3, in line 4, we are modifying the list. After you modify this list, the modification will apply to the list outside the function because it was a reference and not a copy. Any modifications made to the array or list within the function will affect the original object because lists are mutable objects. Consequently, any changes made to the array or list within the function will be reflected in the original object outside the function's scope. Check the output displayed on the console. Let's see how to create a copy of a list. Look at line 4. If you want to modify the list as a copy of the one inside parameter, you can use the copy function. Look at the output. Now, if you run the code, the modification inside the function doesn't apply to the my_list list, because the function operates on a copy and not on the original object. Let's discuss about passing strings to a function. Strings can be passed to a function as an argument. Since strings are immutable objects in Python, it is used as pass by value. Thus a function can access the value of a string but cannot modify it. If you wish to modify a string, the solution is to create another, new, string and concatenate the modified value of parameter string in the newly created string. Now, in this example, 2 strings are passed as arguments to the user-defined function, my_str, by giving 2 function calls. These string messages are received as a parameter in the function definition and finally printed. Let's see another example. User-defined function to accept a string as input and to count and return total number of vowels present in it. The code defines a function named countVowels that takes a string, str, as an argument. This function counts the number of vowels, both lowercase and uppercase, present in the input string and returns the count. In line 1 and 2, in the countVowels function, a variable count is initialized to 0. In line 3, a for loop iterates over each character, ch, in the input string, str. In line 4, for each character, the code checks if it is present in the string a-e-i-o-u, which contains all the lowercase and uppercase vowels. In line 5, if a character is found to be a vowel, the count variable is incremented by 1. In line 6, finally, the function returns the count value. In line 10, in the main code section, the user is prompted to enter a string using the input function. The entered string is stored in the str_input variable. In line 11, the countVowels function is called with str_input as an argument, and the returned count value is stored in the count variable. In line 12, lastly, the total count of vowels is printed using the print statement. When you run the code, it will prompt you to enter a string. After entering the string, the code will count the number of vowels in it and display the result. You can check the output on the console. The string entered here is we are learning functions in Python. Total number of vowels present in the string are 11. Let's see how to pass tuple to a function. Tuples can be passed to a function as an argument. Since tuples are immutable objects in Python, a function can only access the value of a tuple but cannot modify it. Let's see an example. In line 1, in the given code, there is a function called fun1 that takes a single argument x. In line 2, x equals list of x. The x tuple is converted to a list. This is done to allow modification of its elements since tuples are immutable in Python. Now, look at line 3. In line 3, x of 0 equals x of 0 times 2. Look at the side calculation. I have marked the index 0 and 1 for values 10 and 20. The first element of the x list, 10, is multiplied by 2 and assigned back to the same position. This doubles the value of the first element as 10 times 2 as 20. In line 4, x of 0 equals x of 1 plus 10. The value of the first element, now 20, is updated to be the sum of the second element 20 plus 10. This means the value of the first element becomes 20, which is the original value of the second element plus 10. So value of first element becomes 30. In line 5, the modified list x is printed inside the function. Look at the output, value inside function is list of 30, 20. Outside the function, the following steps are executed. In line 6, tup equals 10, 20. A tuple tup with values 10 and 20 is created. In line 7, print tup. The original tuple tup is printed. It outputs tuple containing 10, 20. In line 8, fun1 of tup. The fun1 function is called with the tup tuple as an argument. This means the x parameter inside the function will reference the same tuple object. In line 8, print tup. The original tuple tup is printed again. This outputs tuple containing 10, 20. The important thing to note is that tuples are immutable in Python, meaning their values cannot be changed once assigned. However, when the tup tuple is converted to a list inside the fun1 function, modifications can be made to the list elements. However, these modifications do not affect the original tuple referenced by tup outside the function, which is why the final output of print tup remains unchanged as tuple holding elements 10 and 20. Example 2. Let's write a Python program to input elements in a tuple and pass it to a function to determine the total number of even and odd numbers in it. Now, look at line 1. The given code defines a function countof of tup that takes a tuple tup as an argument. The function counts the number of even and odd numbers in the tuple and returns a tuple of counteven, countodd with the respective counts. Now, look at line 2 and 3. Counteven equals 0 and countodd equals 0. Two variables are initialized to keep track of the counts of even and odd numbers in the tuple. In line 4, for I in tup. This loop iterates over each element I in the tup tuple. In line 5, if I mod 2 equal to 0. This condition checks if the current element I is divisible by 2 without a remainder, that is, if it is an even number. In line 6, counteven plus equals 1. If the current element is even, the counteven variable is increment by 1. In line 7, else. If the current element is not even, that is, it is odd, this block is executed. In line 8, countodd plus equals 1. If the current element is odd, the countodd variable is increment by 1. In line 9, return counteven, countodd. The function returns a tuple, counteven, countodd, containing the final counts of even and odd numbers. The rest of the code outside the function performs the following steps. In line 10, tup1 equals empty. An empty tuple tup1 is initialized. In line 11, n equals int of input of, enter the total elements in a tuple. The user is prompted to enter the total number of elements in the tuple. In line 12, for I in range of n, this loop iterates n times. In line 13, number equals int of, input of enter the number. The user is prompted to enter a number. In line 14, tup1 equals tup1 plus, number. The entered number is added to the tup1 tuple using tuple concatenation. In line 15, count_stats equals countovenod of, tup1. The countovenod function is called with the tup1 tuple as an argument, and the return tuple, counteven, countodd, is assigned to the count_stats variable. In line 16, print, even numbers are, count_stats of index 0. The count of even numbers is printed. In line 17, print, odd numbers are, count_stats of index 1. The count of odd numbers is printed. Overall, this code allows the user to enter a tuple of numbers and then counts the number of even and odd numbers in that tuple, displaying the results accordingly. Let's discuss about passing dictionary in a function. Dictionary can be passed to a function as an argument. Since dictionaries are mutable objects in Python, a function can alter the values of dictionary in place. Let's see an example. Now, look at line 1. In the code, the marks_increase function takes a student dictionary, stud, and an increment value, p. In line 2 and 3, inside the function, it accesses the marks and status values of the dictionary and modifies them accordingly. In line 5 and 6. After defining the function, two student dictionaries, student1 and student2, are created with different initial values for the marks and status keys. In line 7 and 8, the marks_increase function is then called twice, passing student1 with an increment of 50 and student2 with an increment of 60. This updates the marks and status values in the respective dictionaries. Finally, in line 9 and 10, the updated student1 and student2 dictionaries are printed, displaying the modified values for marks and status keys. The output will be as shown on the console. Functions in Python Part 6. In this video, we are going to learn scope of variables. Global scope, local scope, using global keyword and LEGB rule. So let's dive in and get started. We already know what's a variable. Let's recall what's a variable. Sometimes we need computers to remember the information we give it and that it calculates during programs. A variable can be thought of as a box that the computer can use to store a value. The value held in that box can change or vary. In Python, variables are used to store values, such as numbers, strings, or other data types. Through a variable we store the value in the memory of a computer. Variable is a named unit of storage. A program manipulates its value. Every variable has a type, and this type defines the format and behavior of the variable. Let's see about variables, working with numbers. A variable is a name that refers to a value. You can assign a value to a variable using the equal sign operator. Here's an example: x equals 5. In this example, x is the variable name, and 5 is the value that is being assigned to it. Whenever a variable name occurs in an expression, the interpreter replaces it with the value of that particular variable. A variable is an identifier or placeholder that holds a value. In other words, a variable is a reference to a computer memory location where the value is stored. In Python, every element is termed as an object. Hence, a variable is also an object in Python. What does variable scope in Python mean? In Python, the scope of a variable defines where the variable is accessible and can be referenced within your code. The scope determines the visibility and lifetime of a variable. The scope of a name or variable depends on the place in your code where you create that variable. The Python scope concept is generally presented using a rule known as the LEGB rule. The letters in the acronym LEGB stand for local, enclosing, global, and built-in scopes. This summarizes not only the Python scope levels but also the sequence of steps that Python follows when resolving names in a program. Let's see the scope of variables in detail. All variables in a program may not be accessible at all locations in that program. This depends on where you have declared a variable. Scope of variables refers to the part of the program where it is visible. That is, area where you can refer, use it. We can say that scope holds the current set of variables and their values. Here we will study two types of scope of variables: global scope and local scope. Global scope means the names that you define in this scope are available to all your code. Local scope means the names that you define in this scope are only available or visible to the code within the scope. Let's learn how to create variables with local scope in Python. Variables defined inside a function's body have local scope, which means they are accessible only within that particular function. In other words, they are local to that function. The local scope or function scope is a Python scope created at function calls. Every time you call a function, you're also creating a new local scope. The local scopes are names assigned inside a function definition or loop. They cannot be accessed outside the function. Let's see an example. Line 1. This code defines a function called my_function. Line 2. Inside the function, there is a local variable named local_variable which is assigned the value 5. In line 3, the function then prints the value of local_variable, which is 5. In line 5, when you call my_function as my_function, it executes the code inside the function and prints the value of local_variable, which is 5. So the output of my_function is 5. In line 6. However, when you try to print local_variable outside the function using print local_variable, it raises a name error with the message name local_variable is not defined. This error occurs because local_variable is a local variable that is only accessible within the scope of the my_function function. It is not accessible outside of the function. Variables with local scope are limited to the block or function where they are defined. Once the execution flow exits the block or function, the local variables are destroyed, and you can no longer access them. If you want to use the value of local underscore variable outside the function, you would need to either return the value from the function and store it in a different variable, or define the variable outside the function in a broader scope, such as the global scope. You can only access a local variable by calling the function. Let's see another example. Look at line 1. The code defines a function called learn_to_code. Line 3, inside the function, there is a local variable named coding_tutorial which is assigned the string value Sallyann bytes. In line 4, the function then prints a message that includes the value of coding_tutorial using an f string. In line 7, when you call learn_to_code as learn_to_code, it executes the code inside the function. It assigns the value Sallyann bytes to the coding_tutorial variable and then prints the message the best place to learn to Python code is with Sallyann bytes. The local variable coding_tutorial is limited in scope to the learn_to_code function, and it cannot be accessed or referenced outside of that function. What happens when we try to access that variable with a local scope from outside the function's body? It raises a name error because it is not visible in the rest of the program. It is only visible within the function where it was defined. Let's see another example. In this code, the function learn_to_code defines a local variable coding_tutorial and prints a message using that variable. However, when you try to print coding_tutorial outside the function, it will result in a name error because the variable coding_tutorial is local to the function and not accessible outside of it. Variables with local scope are only accessible within the block or function where they are defined. Once the execution flow exits the block or function, the local variables are destroyed and cannot be accessed from outside. If you want to use the value of coding_tutorial outside the function, you would need to either return the value from the function and store it in a different variable, or define the variable in a broader scope such as the global scope. Let's learn how to create variables with global scope in Python. When you define a variable outside a function, like at the top of the file, it has a global scope and it is known as a global variable. A global variable is accessed from anywhere in the program. You can use it inside a function's body, as well as access it from outside a function. They are names declared with global keyword in a function. Let's see an example. In this code, in line 1, a global variable named global_variable is defined and assigned the value 10. The global_variable is declared outside any function, making it accessible from anywhere in the code, including inside functions. In line 3, the my_function is defined, which does not explicitly declare the global_variable as a local variable. Therefore, when my_function is called, it can access and reference the global variable. In line 4, inside the my_function, the statement print, global_variable, is executed, which prints the value of the global_variable. Since global_variable is a global variable, it can be accessed and printed from within the function without any issues. In line 6, when you call my_function, using my_function, it executes the code inside the function, which includes printing the value of global_variable. As a result, the output of my_function will be 10. You can use a global variable inside a function's body, as well as access it from outside a function. Let's see an example. In this code, in line 2, a global variable named coding_tutorial is defined and assigned the value Sallyann bytes outside any function. Being a global variable, it is accessible from anywhere in the code. In line 4, the function learn_to_code is defined. In line 6, inside the function, the variable coding_tutorial is accessed using its name directly. Since coding_tutorial is a global variable, it can be accessed and referenced within the function without any issues. The function then prints a message that includes the value of coding_tutorial using an f string. In line 9, when you call learn_to_code, using learn_to_code, it executes the code inside the function. It accesses the global variable coding_tutorial and prints the message the best place to learn to code is with Sallyann bytes. In line 12, after that, you access the global variable coding_tutorial from outside the function using print, coding_tutorial. It prints the value of coding_tutorial, which is Sallyann bytes, because the global variable is accessible throughout the code. We can access global variable in the absence of local variable with the same name. Let's see an example. In this code, there are 3 variables, a, x, and y. In line 1, a is assigned the value 2 outside of any function, so it is a global variable. Global variables are accessible from anywhere in the code, including inside functions. In line 2, the function f of x is defined with a parameter x, which is a local variable. Local variables are specific to the scope of the function and can only be accessed within the function. In line 3, inside the function f of x, there is a statement y equals x plus a. Here, x is the function's parameter, so it refers to the value passed to the function when it is called. Since a is not defined as a local variable within the function, Python looks for its value in the global scope. Therefore, the value of a is accessible inside the function, and y is assigned the result of adding x and a. In line 4, the function returns the value of y, which is a local variable defined within the function. In line 6, outside the function, the variable p is assigned the result of calling f of 5. This will pass the value 5 as an argument to the function, and the function will return the sum of 5 and the global variable, a2, which is 7. In line 7, finally, the value of p is printed, which will output 7 since p holds the returned value of the function. We can use the same names in different scopes, but the priority is given to the local variable. Let's consider an example. Look at line 1. The line a equals 2 initializes the global variable a with the value 2. In line 2 and 3, the function func defines a local variable a with the value 10. This local variable a is distinct from the global a and does not affect it. In line 6, the line prints the value of the global a, which is 2. In line 7, the line func calls the function func, which prints the value of its local a variable, which is 10. The local variable is deleted as soon as the function stops running. So, the lifetime of a local variable gets over early in comparison to a global variable. Local variables are temporary and exist only within the function's execution context. They are created when the function is called and cease to exist when the function returns or completes its execution. On the other hand, global variables have a longer lifetime and exist throughout the entire duration of the program. They are defined outside of any function and can be accessed from any part of the code, including within functions. Now, look at this example, line 1. We initialize the global variable global_var with the value I am a global variable. In line 3, we define a function named my_function. In line 4, 5, and 6, within the my_function function, we create a local variable local_var and assign it the value I am a local variable. We print the value of the local variable local_var. We print the value of the global variable global_var. In line 8, we call the my_function function. This will execute the code within the function. The function will print the value of the local variable local_var, which is I am a local variable. The function will print the value of the global variable global_var, which is I am a global variable. You can check the output on the console. In line 10, we print the value of the global variable global_var outside the function. This statement is outside the function and refers to the global_var variable. It outputs I am a global variable because it uses the value of the global_var variable. In line 11, the line print, local_var, is commented out because it will result in an error. This line tries to print the value of the local variable local_var outside the function. However, local variables are not accessible outside the function's scope, so it will raise an error. What happens when there is a global and local variable, and they both have the same name? Let's see an example. Look at line 2, the line city equals Denmark initializes the global variable city with the value Denmark. In line 4 and 6, the function travel_plans defines a local variable city with the value London. This local variable city is distinct from the global city and does not affect it. The line 7, the print statement, within the function travel_plans prints the value of the local city variable, which is London. In line 10, when the function is called with travel_plans, it executes the print statement within the function, resulting in the output I want to visit London next year. In line 13, after the function call, the print statement, outside the function refers to the global variable city, resulting in the output I want to visit Denmark next year. This line uses the global variable city because there is no local variable with the same name within the current scope, outside the function. How to use global keyword in Python. What if you have a global variable but want to change its value inside a function? Now, look at this example. In line 2, the line city equals Denmark initializes the global variable city with the value Denmark. In line 4, 5, inside the travel_plans function, the code tries to access the global variable city in the first print statement. First, this is like when we tried to access the global variable defined outside the function. This works fine on its own, as we saw earlier on. In line 7, however, when the code reaches the line city equals London, it assumes that city is a local variable because of the assignment statement within the function. Since the variable city is assumed to be local, the attempt to print its value earlier leads to an error because the local variable city is referenced before it is assigned a value. The error message unbound local error, local variable city referenced before assignment indicates that the variable city is being treated as a local variable but is referenced before it is assigned a value within the function. By default, Python thinks you want to use a local variable inside a function. So, when we first try to print the value of the variable and then reassign a value to the variable we are trying to access, Python gets confused. The way to change the value of a global variable inside a function is by using the global keyword. Using global keyword in Python. Let's see the modified example. In line 2, there is a global variable named city assigned the value Denmark. In line 5, the code then prints the value of the global variable city using an f-string. The output will be, I want to visit Denmark next year. In line 7, after that, there is a function named travel_plans, defined, and inside this function, in line 8, the global keyword is used to indicate that city is a global variable. Let's see, within the travel_plans function. In line 10, the initial value of the global variable city is printed using an f-string. So the output is, I want to visit Denmark next year. In line 12, a new value of London is assigned to the global variable city from within the function. In line 14, the new value of the global variable city is printed using an f-string. The output will be, I want to visit London next year. In line 17, after defining the function, it is called with travel_plans. This executes the code within the function. In line 20, finally, the value of the global variable city is printed again outside the function using an f-string. The output will be I want to visit London next year. Value of global variable can be modified using global keyword. Now, look at this example. In line 1, the line a equals 2 initializes the global variable a with the value 2. In line 2 and 3, the function func uses the global keyword to indicate that a is a global variable. In line 4, inside the function, the value of the global variable a is incremented by 5 using the expression a equals a plus 5. In line 5, the updated value of a is then returned by the function. In line 7, when print a is called, it prints the initial value of a, which is 2. In line 8, when print func is called, it calls the func function, which updates the value of a and returns the updated value of 7. This value is printed. In line 9, finally, when print a is called again, it prints the final value of a, which is also 7 after the increment. Note that the global keyword is used within the func function to indicate that a refers to the global variable, allowing us to modify its value within the function. Changing a global name used in a function definition changes the function. Let's see an example. In line 1, a equals 5 initializes the global variable a with the value 5. In line 2 and 3, the function func of x takes an argument x and returns the sum of x and the global variable a. In line 5, when print of func of 7 is called, the func function is invoked with the argument 7. Inside the function, it adds the value of x, which is 7, to the value of the global variable a, which is 5, resulting in 12. This value is printed. In line 6, then, the value of the global variable a is changed to 1. In line 7, when print of func of 7 is called again, the func function is invoked with the argument 7. Inside the function, it adds the value of x, which is 7, to the updated value of the global variable a, which is 1, resulting in 8. This value is printed. Thus, the global variable a is accessed by the func function, and any changes made to the global variable will affect its behavior when the function is called. Unlike other languages, Python function arguments are not modified by default. Let's see an example. In line 1, the line a equals 5 initializes the global variable a with the value 5. In line 2 and 3, the function func of x takes an argument x and returns the sum of x and the global variable a. In line 5, the line x equals 4 assigns the value 4 to the variable x. In line 6, when print of func of x is called, the func function is invoked with the value of x, which is 4, as the argument. Inside the function, it adds the value of x, which is 4, to the value of the global variable a, which is 5, resulting in 9. This value is printed. In line 7, finally, when print of x is called, it prints the value of the variable x, which is still 4. The value of the global variable a does not affect the value of the variable x outside the function. In this case, the global variable a is accessed within the func function, but any changes made to the global variable do not affect the value of the variable x outside the function. Let's see the difference between local and global variable. Scope. Local variables are declared within a specific function or block and are only accessible within that particular function or block. Global variables are defined outside any function or block, making them accessible from anywhere within the entire Python program. Accessibility. Local variables can be accessed and used only within the function or block where they are defined. Global variables can be accessed and utilized from any part of the code, including inside functions. Lifetime. Local variables are created when the function is called and are destroyed once the function completes its execution. Global variables last from the start of the program until the program finishes its execution. Modification inside functions. Local variables can be modified inside the function or block where they are declared. Global variables can be modified inside functions, but you need to explicitly declare them as global using the global keyword. Best practice. It is generally considered good practice to use local variables whenever possible to limit their scope, reduce side effects, and improve code maintainability. Global variables should be used sparingly and only when necessary to avoid code complexity and potential issues with unintended modifications. The Python scope concept is commonly explained using the LEGB rule, which stands for local, enclosing, global, and built-in. This rule defines the order in which Python searches for a variable name during execution. When you reference a variable in your code, Python follows this order to determine which variable with that name to use. In LEGB rule, L stands for local. Local scope refers to the innermost scope, which is the scope of the current function or block of code. If a variable is defined inside the function or block, Python first looks for the variable in this local scope. In LEGB rule, E stands for enclosing. Enclosing scope refers to any enclosing or surrounding functions, moving outward from the current function. If the variable is not found in the local scope, Python checks the enclosing scopes, if any, one by one, in the order they are nested. In LEGB rule, G stands for global. Global scope refers to the module-level scope, which means variables defined at the top level of a module. If the variable is not found in the local or enclosing scopes, Python looks for it in the global scope. In LEGB rule, B stands for built-in. Built-in scope refers to the built-in namespace containing Python's predefined names, for example, print, len, range, etc. If the variable is not found in any of the previous scopes, Python searches for it in the built-in scope. The LEGB rule helps Python determine the correct variable to use, ensuring that names don't conflict and that each variable is taken from the appropriate scope. If Python cannot find the variable in any of the above scopes, it will raise a name error indicating that the variable is not defined. Let's see this example. In line 2, we start in the global scope, where the global underscore variable is defined with the value I am global. In line 4, we then encounter the outer underscore function, call in the global scope. So, we enter the outer underscore function. In line 6, inside the outer underscore function, we define the enclosing underscore variable with the value I am enclosing. This becomes part of the enclosing scope. In line 8, now, we encounter the inner underscore function, call within the outer underscore function. So, we enter the inner underscore function. In line 10, inside the inner underscore function, we define the local underscore variable with the value I am local. This becomes part of the local scope. In line 11, the first print, local underscore variable, statement looks for local underscore variable in the local scope and prints its value, which is I am local. In line 12, the second print, enclosing underscore variable, statement looks for enclosing underscore variable in the enclosing scope since it's not in the local scope. It finds the variable there and prints its value, which is I am enclosing. In line 13, the third print, global underscore variable, statement looks for global underscore variable in the global scope since it's not found in the local or enclosing scopes. It finds the variable there and prints its value, which is I am global. In line 15, 17, after executing the inner underscore function, we return to the outer underscore function. The outer underscore function has no more statements to execute, so it returns to the global scope. We reach the end of the code, and the program finishes its execution. In this example, the LEGB rule determines the scope of each variable. Local underscore variable is in the local scope of inner underscore function. Enclosing underscore variable is in the enclosing scope of inner underscore function, which includes the outer underscore function. Global underscore variable is in the global scope, accessible from all functions and blocks. By following the LEGB rule, Python successfully finds the appropriate variable in each case and prints their respective values. Now, look at this example. You can see the yellow box represents local scope, blue box represents enclosing scope, red box represents global scope, and green box represents built-in scope. Now, look at the yellow box, the inner function. Do you remember the rule of local scope? If a variable is defined inside the function or block, Python first looks for the variable in this local scope. So look at the output, the value 18 is printed. Now, look at this example. In the yellow box, which represents the local scope, line 6, e equals 18, is not given. So do you remember the next rule? Enclosing scope refers to any enclosing or surrounding functions, moving outward from the current function. If the variable is not found in the local scope, Python checks the enclosing scopes, if any, one by one, in the order they are nested. So the blue box containing the outer function, the enclosing scope is evaluated and the output is 12. Now, look at this example. In both the yellow box and blue box, which represents the local scope and the enclosing scope, line 6, e equals 18, and line 4, e equals 12 are not given. So do you remember the next rule? If the variable is not found in the local or enclosing scopes, Python looks for it in the global scope. So the red box containing the global scope is evaluated and the output is 6. Now, look at this example. In the yellow box, blue box, and the red box, which represents the local scope, enclosing scope and global scope, the variables are not given. Line 6, e equals 18, line 4, e equals 12, and line 2, e equals 6 are not given. So do you remember the next rule? If the variable is not found in any of the previous scopes, Python searches for it in the built-in scope. So the green box containing the built-in scope is evaluated and the output is 2.71828182845945. Now, look at this example. The LEGB rule helps Python determine the correct variable to use, ensuring that names don't conflict and that each variable is taken from the appropriate scope. Here, the first line is also blocked. If Python cannot find the variable in any of the above scopes, it will raise a name error indicating that the variable is not defined. Hope you had a clear understanding of the LEGB rule. Functions in Python, Part 7. In this video, we are going to learn flow of execution of program using main function as a function, flow of execution containing function call with visualization and practical implementation. So let's dive in and get started. At first, let's know what's flow of execution in Python program means. The flow of execution basically refers to the order in which statements are executed. That is to say, execution always starts at the first statement of the program. Moreover, statements execute one at a time. It happens in order, from top to bottom. Now, look at the second box. Let's discuss about the function definition. Function definitions do not alter the flow of execution of the program. However, it remembers the statements inside the function. They do not execute until the functions is called. Now, look at the third box. Let's discuss about the function calls. Function calls are similar to a bypass in the flow of execution. Thus, in place of going to the next statement, the flow will jump to the first line of the called function. Then, it will execute all the statements there. After that, it will come back to pick up where it left off. Look at the fourth box. It is essential to remember that when reading a program, do not read it from top to bottom. Instead, keep following the flow of execution. This will ensure that one reads the def statements as they are scanning from top to bottom. However, one must skip the statements of the function definition until they reach a point where that function is called. Now, let's discuss about the flow of execution of Python program using main function as a function. Come on, now, where does the flow of execution start in Python? Here is the answer: the main function is like the entry point of a program. But, the Python interpreter runs the code right from the first line. Thus, the execution of the code begins from the starting line, proceeds line by line. Including a main function is not mandatory in Python. It can structure our Python programs in a logical way that puts the most important components of the program. It can also make our programs easier for non-Python programmers to read. Let's see an example for flow of execution of Python program using main function, so that you can understand it better. In this Python program, let's see the flow of execution. When the script is executed, the Python interpreter starts from the top of the script and encounters the main function call on the 7th line. Now, look at line 7. You can see the main function called. So, the main function in line 4 is then executed. It prints this as the main function to the console. Next, the hello function in line 6 is called from within the main function. So the hello function in line 1 is executed, and it prints hello, world, to the console. Now, look at line 7, the main function is called, and in line 4, 5, 6, within the main function definition, the hello function was also called. The flow of execution followed the path from the main function to the hello function, and then it returned to the main function after the hello function completed its execution. Instead of directly calling the main function at the end of the script, you can add a conditional check. Look at the syntax below. If 2_name, 2_ equal to, 2_ main, 2_ inside the main function itself. This way, the main function will only be executed if the script is run as the main program, not when it's imported as a module. Let's try to understand this syntax. Every Python module has a built-in variable called 2_name, 2_, that is, 2_ places before and after name, containing the name of the module. Now, look at the first box in Python, 2_name, 2_ is a built-in variable that stores the name of the current module. When a Python script is run, the value of 2_name, 2_ is set to 2_main, 2_ if it is the main program being executed. Now, look at the second box. 2_main, 2_ is a string literal that represents the name of the main module in Python. When you run a Python script directly, for example, using the Python command or running the script from an IDE, the module name is set to 2_main, 2_. Now look at the third box. If 2_name, 2_ equal to 2_main, 2_, this line is a conditional check that evaluates whether the script is being run as the main program. If the condition is true, the code block following this line will be executed. If the condition is false, for example, when the script is imported as a module, the code block will be skipped. Look at the fourth block. Main function. Inside the conditional block, there is a call to the main function. This is where you typically put the code that you want to execute when the script is run as the main program. Let's see an example. Write a Python program to compute the area of a rectangle on the basis of length and breadth inputted by the user as the arguments to this function. Now, look at line 1, 2, and 3 of this code. We define a function rectangle_area of length, breadth that takes two arguments length and breadth and computes the area of the rectangle by multiplying these two values. In line 5, in the main function, we use a try-except block to handle any potential input errors. In line 7 and 8, the user is prompted to enter the length and breadth of the rectangle as floating point numbers. In line 9, we check if the input values are positive, greater than 0, using a conditional check. In line 10, if they are not positive, we print an error message. In line 12 and 13, if the input values are positive, we call the rectangle_area function with the provided length and breadth and print the result. In line 17 and 18, the main function is called only when the script is run as the main program, not when imported as a module. Let's discuss about the flow of execution of Python program containing function call. Some key points to remember. Execution of a program starts from the first line of the code, executes one line at a time from top to bottom. The function definition never changes the sequence of execution of a program, but the statements inside the function are only executed when the function is called. A function can be called from inside of another function. A function can be declared inside of another function declaration. This idea is similar to recursion. Don't read the program from top to bottom, but read the execution flow. As we know that any function, in order to work, has to be called with proper arguments. So we are going to look into how a function works, starting from the function call till result generation. We will consider a very simple addition program that adds two numbers. This code takes 5 steps to be executed. Step 1. Now, look at line 1 of the Python code. The flow of execution is from top to bottom. Line 1 gets executed, but as it contains the def keyword, which I have highlighted def keyword, in yellow box, the interpreter gets aware that it is a function declaration, so it jumps over it. This shows that a function never gets executed unless called. Right side you can see the visualization, where frames and objects are allocated. Now, in step 2, the execution jumps to line 4. Look at line 4. This is the point where the function add is called inside the print function and a global frame is created that stores the function add, and its execution will start. You can look at the visualization on the right side of the screen, how an global frame is created that stores the function add. Step 3. The execution control jumps to line 1 and the stack frame, memory block, for add is created along with the values that are passed as arguments in the function call. Now, look at the visualization, how stack frame, memory block is created for function add with the values, a equals 10 and b equals 20. Step 4. Now the return statement is encountered in line 2. In step 5, the sum operation is executed and the result is generated. Also, look at the visualization, the return value is displayed 30, which is the output. Done running 5 steps. Now the stack frame is destroyed and the value is returned to the calling function. Hence we get the output of 30. Look at the visualization for reference. Python is good at keeping track of the execution so that each time a function completes, the program picks up from the place where it left off, until it gets to the end of the program where it terminates. Now, look at example 2. Addition and subtraction program of two numbers. Look at line 1. Execution begins from line 1. Here, the interpreter encounters a function definition, which will not be executed till the function is called. Then the interpreter's control reaches line 4, where the second function definition is encountered, which gets skipped. After this, the control reaches line 11 and 12 and gets executed. Then, in succession, line 13 is executed, where the interpreter encounters a function call and jumps to the function header and starts executing line 1, 2, and 3. Line 3 is the return statement, which shall return the value back to the function call statement. Thus, the returned value is received by the variable add in line 13, from where it was called, and gets printed upon the execution of line 14. Now, the interpreter executes line 15 in succession, which is again a function call. The control then jumps to line 4 and executes lines 5, 6, 7, 8, and 9 respectively. The control goes back to line 15 with returning value and finally executes line 16 and terminates the program. Hope you can understand the flow of execution containing function calls. Functions in Python Part 8. In this video, we are going to learn recursion, how recursion works. Recursive function to implement the power function, sum of n natural numbers using recursion, Fibonacci series using recursion, factorial of a number using recursion, binary search in arrays or lists using recursion, recursion versus iteration, visualization and practical implementation. So, let's dive in and get started. The statement, in order to understand recursion, one must first understand recursion, is a playful and somewhat paradoxical phrase often used humorously to describe the self-referential nature of recursion. In its simplest form, a recursive function is one that calls itself. Let me try to explain with an example. Let's use a fun and relatable example of counting the number of chocolates in a box using recursion, chocolate and recursion, the magical box puzzle. Imagine you have a box of chocolates, but you don't know how many chocolates are inside. You want to find out the total number of chocolates, but you can't count them all at once because there are too many. So, you decide to use recursion to figure it out. Now, look at this picture. Step 1. Open the big box, which I have highlighted in red box, under Step 1, and you see there are smaller boxes of chocolates inside. Boxes inside of boxes. Each small box might have chocolates in it, too. Step 2. Take the first small box and open it. Now you have a new box in your hand. Open this new box, and you find more small boxes inside. Each of these boxes might have chocolates too. Keep doing this until you find the smallest box that you can open, and inside, you see the chocolates directly. In Step 4, you opened the tiny box. You can see, I have highlighted in red box and the smiley is pointing to it. Now, count the chocolates in the tiniest box. That's easy. Now, close the tiniest box and add up the number of chocolates you counted with the chocolates in the small box you opened just before it, in Step 3. Close that small box and add up the chocolates inside it with the chocolates in the bigger box you opened earlier, in Step 2. Keep closing the boxes and adding the chocolates until you've reached the first box you opened, in Step 1. Ta-da! Now you know the total number of chocolates in the big box. This is recursion in action. By breaking down the problem into smaller boxes and counting the chocolates in the tiniest box first, you were able to figure out the total number of chocolates without counting them all at once. It's like solving a puzzle step by step, making the task much more fun and manageable. Now look at the pseudocode. In line 1, this pseudocode represents a recursive function count chocolates in box that takes a box as input and calculates the total number of chocolates in that box. In line 2 and 3, it checks if the box is a tiny box, base case, with chocolates directly, in which case it returns the count of chocolates in that tiny box. In line 4, 5, 6, 7, 8, and 9. If the box contains smaller boxes, recursive case, it iterates through each smaller box, calling the count chocolates in box function recursively on each of them and adding the counts together to get the total number of chocolates in the big box. Line 12, 13, and 14 is the example usage, which demonstrates how to find the total number of chocolates in the big box using recursion and then prints the result. Please note that this pseudocode is a conceptual representation and not a specific implementation in any particular programming language. It aims to demonstrate the logic and structure of the recursive solution to the chocolates and nested boxes problem. I hope this description helps you visualize the recursion example with the box of chocolates. So, what is recursion in Python programming? Recursion is one of the most powerful tools in a programming language. It is a function calling itself again and again. Recursion is a programming technique in which a function calls itself to solve a problem. In other words, it is a method in which a function calls itself one or more times in its body. This picture shows the working of a recursive function called recurse. It is a function calling itself again and again. Let's see the conditions for implementing recursion. Base case recursion requires a stopping point, called the base case, which represents the simplest form of the problem that can be solved directly without further recursion. Recursive case. In the recursive case, the function calls itself with modified parameters, allowing it to break down the problem into smaller subproblems to be solved. Convergence towards base case. The modified parameters in each recursive call should move the problem closer to the base case, ensuring that the recursion eventually stops. Repeated subproblems. Recursion is effective when the problem can be divided into smaller instances of itself, allowing the function to solve these repeated subproblems efficiently. Proper function invocation. To achieve the desired outcome, the recursive function must be called with the appropriate parameters for solving each subproblem accurately. No infinite recursion. Care should be taken to avoid infinite recursion, where the base case is never reached, as it can lead to program crashes and errors. Efficiency considerations. While recursion can provide elegant solutions, it may not always be the most efficient approach due to redundant function calls. In some cases, using iteration might be more efficient. Advantages of recursion. Recursive functions make the code look clean and elegant. A complex task can be broken down into simpler subproblems using recursion. Sequence generation is easier with recursion than using some nested iteration. Disadvantages of recursion. Sometimes the logic behind recursion is hard to follow through. Recursive calls are expensive, inefficient, as they take up a lot of memory and time. Recursive functions are hard to debug. Let's learn how recursion works. Recursion is implemented by dividing the recursive problem into two parts. Termination part or stopping point, that is the base case, for the smallest possible problem, when the function returns a value directly. Recursive part, that is the recursive case, which contains one of the more recursive calls on smaller parts of the problem. Let us write a recursive function to implement the power function. The power function is used to raise a base number to a specified exponent. For example, power of 2, 3 should return 8, because 2 raised to the power of 3 is 8. We can implement the power function recursively using the following logic. Base case, if the exponent is 0, the result is always 1. Recursive case, for any other positive exponent n, the result is obtained by multiplying the base with the result of the power function called with the base and n minus 1 as the new exponent. Let's see an example for the recursive Python function to implement the power function. In line 2, the function power takes two parameters, base and exponent, representing the base number and the power to which the base is raised, respectively. In line 3, in the function, we have a base case to handle the scenario when the exponent is 0. When the exponent is 0, any number raised to the power of 0 is always 1. So, if the exponent is 0, the function returns 1. In line 6, the recursive case handles the situation when the exponent is not 0. In this case, we return the result of multiplying the base with the result of calling the power function again with the same base and exponent minus 1 as the new exponent. In the recursive case, the function keeps calling itself with a reduced exponent until the base case is reached, that is, when the exponent becomes 0. The output of 2 power 5 is 32 and 2 power of 10 is 1024. Let's see the example to understand how the recursive power function works. Example, power of 2, 5. The function is called with base equals 2 and exponent equals 5. Since exponent is not 0, the recursive case is executed. We return 2 asterisk power of 2, 5 minus 1, which is equivalent to 2 asterisk power of 2, 4. The function is called again with base equals 2 and exponent equals 4. Again, the recursive case is executed, and we return 2 asterisk power of 2, 4 minus 1, which is 2 asterisk power of 2, 3. The function is called again with base equals 2 and exponent equals 3. Again, the recursive case is executed, and we return 2 asterisk power of 2, 3 minus 1, which is 2 asterisk power of 2, 2. The function is called again with base equals 2 and exponent equals 2. Again, the recursive case is executed, and we return 2 asterisk power of 2, 2 minus 1, which is 2 asterisk power of 2, 1. Once more, the recursive case is executed, and we return 2 asterisk power of 2, 1 minus 1, which is 2 asterisk power of 2, 0. Now, the function is called with base equals 2 and exponent equals 0. Since the exponent is 0, we hit the base case, and the function returns 1. As the recursive calls unwind, the function evaluates the multiplication operations. 2 times of, 2 times of, 2 times of, 2 times of, 2 times 1. And finally, the result is 32, which is the correct value of 2 power 5. This is the beauty of recursion. By breaking down the problem into smaller subproblems and leveraging the return values from recursive calls, we arrive at the final result. However, it's important to ensure that there is a proper base case to terminate the recursion and prevent infinite loops. Let's see some more examples of recursion. Example 2. Write a function to calculate the sum of n natural numbers using recursion. Let's understand how this function works. In line 2, the function sum of natural numbers takes an integer n as input, representing the number of natural numbers to sum. In line 3 and 4, if n is less than or equal to 1, return n. This is the base case, that means the termination part, when the function returns a value directly. In this function, when n is less than or equal to 1. If n is 1 or less, it means we have reached the smallest natural number. In this case, the function simply returns n, which will be either 0 or 1, depending on the input value. In line 6, the recursive case handles the situation when n is greater than 1. In this case, we return n plus sum of natural numbers of n minus 1. In the recursive case, the function keeps calling itself with a reduced value of n until the base case is reached, that is, when n becomes 1 or less. So when you enter a number 5, the output will be 15. Let's see how sum of n natural numbers using recursion works. The function call sum of natural numbers of 5 is made with n equals 5. Since n is greater than 1, the recursive case is executed, and we return 5 plus sum of natural numbers of 5 minus 1. A new recursive call sum of natural numbers of 4 with n equals 4 is made. Again, n is greater than 1, so the recursive case is executed, and we return 4 plus sum of natural numbers of 4 minus 1. Now, another recursive call sum of natural numbers of 3 with n equals 3 is made. The recursive case is executed again, and we return 3 plus sum of natural numbers of 3 minus 1. A new recursive call sum of natural numbers of 2 with n equals 2 is made. The recursive case is executed again, and we return 2 plus sum of natural numbers of 2 minus 1. A final recursive call sum of natural numbers of 1 with n equals 1 is made. This time, the base case is triggered as n is equal to 1. The base case simply returns n, which is 1. The recursive call chain starts to unwind, and each returned value is added up along the way. 1 plus 2 plus 3 plus 4 plus 5 is equal to 15. Now, you can enter a different number and work out this code. Example 3. Write a function to display Fibonacci series using recursion. A Fibonacci sequence is the integer sequence of 0, 1, 1, 2, 3, 5, 8, and so on. The first two terms are 0 and 1. All other terms are obtained by adding the preceding two terms. This means to say the nth term is the sum of n-1, th and n-2, th term. Base case: if n less than or equal to 1, return n. We have two base cases. Fib of 0 equals 0 and fib of 1 equals 1. These base cases handle the scenario when n is 0 or 1, and they directly return the corresponding Fibonacci numbers 0 and 1, respectively. Write a function to display Fibonacci series using recursion. Now, look at the code. In line 2, the function recur_fibo takes an integer n as input, which represents the position of the term in the Fibonacci series that we want to find. In line 3, in the function, we have a base case to handle when n is less than or equal to 1. If n is 0 or 1, it means we have reached the base case, and the function returns n itself. In line 6, the recursive case is executed when n is greater than 1. In this case, the function returns the sum of two recursive calls, recur_fibo of n-1 and recur_fibo of n-2. These recursive calls are used to find the two preceding terms in the Fibonacci sequence. By repeatedly applying the recursive formula, the function calculates the Fibonacci number at position n in the series. In line 8, the user is prompted to enter the number of terms required in the Fibonacci series using the input function. In line 10, the program then uses a for loop to iterate from I equals 0 to I equals terms -1, inclusive. At each iteration, the recur_fibo function is called with the value of I. This calculates and prints the Fibonacci number at the ith position in the series. The loop continues until it reaches the last term specified by terms. For example, if the user enters terms equals 10, the code will generate the first 10 Fibonacci numbers and print them as 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. The Fibonacci series starts with 0 and 1, and each subsequent number is the sum of the two preceding ones. The function recur_fibo is called for each index position in the Fibonacci series, from 0 to 9, inclusive. When recur_fibo of 0 is called, it directly returns 0, which is the first term of the Fibonacci series. When recur_Fibo of 1 is called, it directly returns 1, which is the second term of the Fibonacci series. For recur_Fibo of 2, it reaches the recursive case and returns the sum of recur_Fibo of 1 and recur_Fibo of 0, that is, 1 plus 0 is equal to 1. For recur_Fibo of 3, it returns the sum of recur_Fibo of 2 and recur_Fibo of 1, that is, 1 plus 1 is equal to 2. In the next step, 2 plus 1 is equal to 3. In the next step, 3 plus 2 is equal to 5. In the next step, 5 plus 3 is equal to 8. In the next step, 8 plus 5 is equal to 13. In the next step, 13 plus 8 is equal to 21. In the last step, 21 plus 13 is equal to 34. The sequence of function calls, following the recursion logic, calculates each Fibonacci number iteratively by summing the two preceding terms until the desired position is reached, giving us the Fibonacci series from 0 to 34. What do you mean by factorial of a number? The factorial function, symbol of factorial looks like exclamatory mark, says to multiply all whole numbers from our chosen number down to 1. Examples: for factorial is equal to 4 times 3 times 2 times 1 is equal to 24. 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 5040. 1 factorial equals 1. Factorial is not defined for negative numbers, and the factorial of 0 is 1. 0 factorial equals 1. The factorial of a non-negative integer n is the product of all positive integers less than or equal to n. It is denoted by n factorial and is defined as n factorial equals n times n minus 1 times n minus 2 times goes on times 3 times 2 times 1. Example 4. Write a recursive function to calculate the factorial of a number. Let's look at the Python code. The code defines a recursive function called recur_factorial of n that takes an integer n as input and returns its factorial. Here's an explanation of how the code works. In line 2, the function recur_factorial of n is defined with a single parameter n, which represents the number whose factorial is to be calculated. In line 3, inside the function, there's a base case that checks if n is equal to 1. If n is 1, it means we have reached the smallest possible factorial, and the function returns 1. In line 5, 6, if n is not equal to 1, it means the factorial needs to be calculated recursively. The function returns n multiplied by the factorial of n minus 1, which is calculated by calling recur_factorial of n minus 1. In line 8, the user is prompted to enter a number through the input function, and the input is stored in the variable num. In line 11 and 12, the code checks if the entered number num is negative. If num is negative, it prints a message indicating that the factorial does not exist for negative numbers. In line 13 and 14, if num is not negative, the code then checks if num is equal to 0. If num is 0, it prints a message indicating that the factorial of 0 is 1, as per the factorial definition. In line 15 and 16, if num is positive and not equal to 0, it calls the recur_factorial of num function to calculate the factorial of num and prints the result. Recursion in this code works by repeatedly breaking down the problem into smaller, simpler subproblems until it reaches the base case, n equal to 1, where it can directly return a value without making further recursive calls. The intermediate results are then multiplied together to obtain the final factorial. The factorial of 5 is represented as 5 factorial and is calculated as 5 factorial equals 5 times 4 times 3 times 2 times 1 is equal to 120. Now, let's visualize the recursive calls and calculations step by step. Recur_factorial of 5. Since 5 is not equal to 1, we proceed to the else block. We return 5 times recur_factorial of 4. Next step, recur_factorial of 4. Since 4 is not equal to 1, we proceed to the else block. We return 4 times recur_factorial of 3. Next step, recur_factorial of 3. Since 3 is not equal to 1, we proceed to the else block. We return 3 times recur_factorial of 2. Next step, recur_factorial of 2. Since 2 is not equal to 1, we proceed to the else block. We return 2 times recur_factorial of 1. Next step, recur_factorial of 1. Now, we have reached the base case where n is equal to 1. We return 1. Now, let's substitute the values back in reverse order to get the final result. Recur_factorial of 1 returns 1. Recur_factorial of 2 returns 2 times 1 is equal to 2. Recur_factorial of 3 returns 3 times 2 is equal to 6. Recur_factorial of 4 returns 4 times 6 is equal to 24. Recur underscore factorial of 5 returns 5 times 24 is equal to 120. So, the final result is 120, which is the factorial of 5. This visualization demonstrates how the recursive function repeatedly breaks down the problem into smaller subproblems until it reaches the base case and then combines the results to get the final factorial. Let's learn about binary search. Binary search is an efficient and fast algorithm for finding an element in a sorted list of elements. An example is finding your best friend's number in your contact list of 1,000 numbers. Binary search algorithms are also known as half-interval search. It finds elements by repeatedly dividing the array in half and then compare the middle of the division to identify in which division the element could be present. In order to implement binary search, we need 3 pointers, namely lower bound, upper bound, and a middle pointer. The division of a subarray is defined by lower bound and upper bound, whereas the mid-pointer value is compared to the value of the element that needs to be located. Binary search algorithm can be implemented in recursion method. The recursive method follows the divide and conquer approach to find the value's position. Let's see how binary search works. The binary search algorithm takes advantage of a collection of elements that is already sorted by ignoring half of the elements after just one comparison. These are the steps to implement binary search. To search an element, say val in a sorted array, suppose in ascending order, the val is compared with the middle element first. If the searched value, val, is equal to the middle value, then the index number and position number of this element is returned. Else if val is greater than the middle element, the second half of the array becomes the new segment to be traversed. Else if val is less than the middle element, the first half becomes the new segment to be scanned. The same process is repeated until val is found or the segment is reduced to the single element and still val is not found, in case of an unsuccessful search. This picture clearly explains how binary search works. If searched value is not found in the middle, and if the value is greater than the middle value, the second half becomes the new segment to be traversed. If the value is less than the middle value, the first half becomes the new segment to be traversed. For binary search, we have the following conditions. Condition 1. If the searched value, val, is equal to the middle value, then the index number and position number of this element is returned. Let's see an example. Val is the item to be searched. Val is the variable which holds the element to be searched. Val equals 40. Look at the first picture. A sorted array consists of elements 20, 30, 40, 50, 60, with index marked from 0 to 4. First index equals 0, last index equals 4, middle element equals first index plus last index divided by 2. Middle element equals first index 0 plus last index 4 divided by 2 equals 2. We found that the middle element is an index 2. Index 2 holds the value or element 40. Hence val 40 appears at index 2, which is highlighted in the second picture. So the search is terminated and the output is the position 40 occupies in the list, index 2. Condition 2. Else if val is greater than the middle element, the second half of the array becomes the new segment to be traversed. Let's see an example. Val is the item to be searched. Val is the variable which holds the element to be searched. Val equals 60. Look at the first picture. A sorted array consists of elements 20, 30, 40, 50, 60, and 70 with index marked from 0 to 5. First, we have to find the middle element of the whole array. Look at the left side middle red box. First index equals 0. Last index equals 5. Middle element equals first index plus last index divided by 2. Middle element equals 0 plus 5 divided by 2 is equal to 5 divided by 2 is equal to 2.5 equals 2. Middle element is an index 2. Index 2 is equal to 40. Hence val 40 appears at index 2. Value 40 is not the value to be searched. The value to be searched 60 is greater than the middle element 40. Hence we move right side to the second half of the array. Now look at the calculations on the right side of the middle red box. New search begins in the second half. Search starts at index 3 and takes the value from index 3 onwards. New first index equals 3. New last index equals 5. New middle element equals new first index plus new last index divided by 2. New middle element equals 3 plus 5 divided by 2 is equal to 8 divided by 2 is equal to 4. New middle element is an index 4. Index 4 is equal to 60. Hence val 60 appears at index 4, which is the value to be searched. So the search is terminated and the output is the position 60 occupies in the list, index 4. Condition 3. Else if val is less than the middle element, the first half becomes the new segment to be scanned. Let's see an example. Val is the item to be searched. Val is the variable which holds the element to be searched. Val equals 20. Look at the first picture. A sorted array consists of elements 20, 30, 40, 50, 60 and 70 with index marked from 0 to 5. First, we have to find the middle element of the whole array. Look at the left side middle red box. First index equals 0. Last index equals 5. Middle element equals first index plus last index divided by 2. Middle element equals 0 plus 5 divided by 2 is equal to 5 divided by 2 is equal to 2.5 equals 2. Middle element is an index 2. Index 2 is equal to 40. Hence val 40 appears at index 2. Value 40 is not the value to be searched. The value to be searched 20 is less than the middle element 40. Hence we move left side to the first half of the array. Now look at the calculations on the right side of the middle red box. New search begins in the first half. Search starts at index 0 and takes the value from index 0 and 1. New first index equals 0. New last index equals 1. New middle element equals new first index plus new last index divided by 2. New middle element equals 0 plus 1 divided by 2 is equal to 1 divided by 2 is equal to 0.5 equals 0. New middle element is an index 0. Index 0 is equal to 20. Hence val 20 appears at index 0, which is the value to be searched. So the search is terminated and the output is the position 20 occupies in the list, index 0. Let's see an example to write a recursive program to implement binary search in arrays/lists. Now, look at the Python code. Line 1. Define the binary underscore search function with parameters lst, the sorted list, low, the index of the lower bound, high, the index of the upper bound, and val, the target value to find. In line 2 and 3, check the base case. If high is less than low, it means the target element cannot exist in the list segment. In this case, return none to indicate that the element is not found. In line 5, calculate the middle index of the current list segment, mid-val, by finding the average of low and high and using integer division to get an integer result. In line 7, compare the element at the middle index, lst of, mid-val, with the target value, val. In line 8, if lst of, mid-val, is greater than val, it means the target value is in the left half of the list. So, perform a recursive call to binary underscore search with low unchanged, high updated to mid-val -1, and the same target value val. In line 9, if lst of, mid-val, is less than val, it means the target value is in the right half of the list. So, perform a recursive call to binary underscore search with low updated to mid-val +1, high unchanged, and the same target value val. In line 12, if lst of, mid-val, is equal to val, we have found the target element. Return mid-val, which is the index of the target element in the list. If the function hasn't returned yet, it means the target element is not found in the current list segment. Continue the recursion with the narrowed list segment until the base case is reached. When the recursion ends, the function will either return the index of the target element or none if the element is not present in the list. In the example provided, in line 14, we call the binary underscore search function with a list, 8, 11, 23, 49, 96, 100, and two different target values, 49 and 101. In line 15, the first call to binary underscore search with the target value 49 returns 3, which is the index of the element 49 in the list. In line 16, the second call to binary underscore search with the target value 101 returns none since 101 is not present in the list. Let's see the difference between recursion and iteration. Recursion is a programming technique where a function calls itself, whereas iteration is a programming technique where a loop repeatedly executes a set of statements. Recursion involves solving a problem by breaking it down into smaller subproblems, whereas iteration involves solving a problem by repeatedly executing a set of instructions until a specific condition is met. Recursion is often used when the problem can be naturally divided into subproblems of the same type, whereas iteration is often used when a sequence of instructions needs to be repeated multiple times. Recursion generally requires more memory space due to multiple function calls being stored on the call stack, whereas iteration generally requires less memory space as it doesn't involve creating multiple function calls. Recursion may lead to a large number of function calls, resulting in potential stack overflow if not optimized, whereas in iteration, no risk of stack overflow, as it doesn't involve function calls and less nested within other functions. Recursive solutions are typically shorter and more elegant for certain types of problems, whereas iterative solutions can be longer, but they may be more efficient for certain problems. Recursion may be slower due to the overhead of function calls and stack operations, whereas iteration is generally faster due to fewer overheads and direct control over loop execution. Recursion examples: binary search, calculating factorial, traversing tree structures. Iteration examples: for loop, while loop, iterating through arrays or lists. Some problems are inherently suited to recursive solutions, whereas iteration is often the default choice for many programming tasks. In recursion, base case is essential to avoid infinite recursion, whereas in iteration, loop termination condition must be carefully defined to prevent an infinite loop. Python libraries, Part 1. In this video, we are going to learn introduction of modules, package and library, module in Python, importing Python modules, name resolution, module aliasing with practical implementation. So, let's dive in and get started. Let's discuss about using Python libraries. Normally, a general library, you can see in the first picture, is a collection of books or is a room or place where many books are stored to be used later. Similarly, in the programming world, a library is a collection of precompiled codes that can be used later on in a program for some specific well-defined operations. Other than precompiled codes, a library may contain documentation, configuration data, message templates, classes, and values, etc. So, what are Python libraries? Python libraries are collections of precompiled code modules that offer specific functionalities. They simplify programming by providing ready-to-use code, saving developers from writing repetitive tasks, as we don't need to write the same code again and again for different programs. Python libraries play a very vital role in fields of machine learning, data science, data visualization, etc. Let's see the relation between module, package, and library in Python. Module. A module is a file containing Python code that can define functions, classes, and variables and statements with .py extension related to a particular task. A module allows us to organize our code by grouping related code, which makes the code easier to understand and use. Package. A package is a directory of Python modules. It is a namespace that contains multiple packages or modules. It is a directory which contains a special file $init::.py through which Python interpreter interprets it as a package. Library. A library refers to a collection of modules that together cater to specific needs or applications. For example, Math Library of Python caters to mathematical computations, NumPy library deals with scientific computing, etc. First, we can discuss about modules. A module is a single file containing Python code that defines variables, functions, and classes. Let me explain this with an example. If the content of a book is not indexed or categorized into individual chapters, the book will become boring and complicated. Hence, dividing the book into chapters makes it easy to understand. In the same way, Python modules are files which have a similar code. Thus, a module simplifies a Python code where classes, functions, and variables are defined. Now look at the second point. It serves as a way to organize code and make it reusable by allowing you to import its contents into other Python scripts. Modules can be small, containing just a few functions, or larger, encompassing several related functions and classes. Examples of modules in Python include math, random, and datetime. Look at the first box. How to create a module. To create a module, just save the code you want in a file with the file extension .py. Example, save this code in a file named mymodule.py. Def greeting of name, : print, hello, plus name. Now look at the right side box. How to use a module. Now we can use the module we just created by using the import statement. Example, import the module named mymodule and call the greeting function. Import mymodule. Mymodule.greeting of Sam. There are several built-in modules in Python, which you can import whenever you like. Advantages of Python modules. Code organization. Modules organize code into separate files for better project management. Group related functions and classes in a single module for improved readability. Code reusability. Write functions or classes once, reuse them in multiple parts of the project. Saves time and effort by avoiding redundant code. Namespace management. Modules create separate namespaces, preventing naming conflicts. Use the same names in different modules without issues. Modularity. Break code into smaller modules for easier development and maintenance. Work on individual components separately. Standard library. Python's extensive standard library provides pre-built modules for various tasks. Reduces the need for external dependencies and speeds up development. Platform independence. Python modules run on any platform supporting Python. Simplifies cross-platform development. Let's discuss about Python module names. A module name is the file name with the .py extension. When we have a file named empty.py, empty is the module name, the _name _ is a variable that holds the name of the module being referenced. Let's see this example. Import random. This line imports the random module from the Python standard library. After this line executes, you can use functions and classes from the random module in your code. In line 2, random.double_name double_. This line accesses the double_name double_ attribute of the random module. In Python, modules have several attributes, and double_name double_ is one of them. The double_name double_ attribute is a built-in variable that holds the name of the module as a string. Output of example 1 is random. The reason for this output is that the double_name double_ attribute of the random module is set to random. In other words, the value of random.double_name double_ is the string random. Look at the second example, line 6. The double_name double_ attribute is particularly useful when you want to determine whether a Python script is being run as the main program or being imported as a module into another script. When a Python script is executed directly, its double_name double_ attribute is set to double_main double_. If the script is imported as a module in another script, the double_name double_ attribute will be set to the name of the module, in this case, random. Look at the code of example 2. If you have the following code in a script called example.py and if you run example.py directly, Python example.py, it will print. Now look at the output. This script is being executed directly. This is some_ function in example.py will be printed. However, if you import example.py in another script, the if double_name double_ equals double_main double_ block will not be executed, and only the functions and classes defined in the module will be available for use. Key points of module names. A module's file name should end in .py. If the module's file name does not end with .py as the extension, we will not be able to import it into other programs. A module's name cannot be the same as the Python keyword. Naming a module as for, while, etc. would result in an error. The name of a module is stored inside a constant double_name double_. Importing Python modules. In Python, importing modules is a way to bring the functionalities defined in one module, Python file, into another module or script, making them accessible for use. It allows you to reuse code, organize your codebase, and avoid redundancy. There are several ways to import Python modules. First point, using the import statement. The import statement is the most common way to import a module. It allows you to access all the functions, classes, and variables defined in the module. The syntax is import module_name. Example to generate a random integer between 1 and 10. Let's look at the code. In line 1 we import random module and printing the random integers between 1 and 10 in the second line. The output will be 10, next time 6, next time, any random number between 1 and 10 and so on. To import multiple modules, it can be done as import module_name1, module_name2 and so on. To access particular methods from any module, the statement shall be modulename.functionName. Here, you have to note that, to use or access or invoke a function, we specify the module name and function name separated by a dot. This format is also known as dot notation. Second point is using the from import statement. The from import statement allows you to selectively import specific items, functions, classes, or variables from a module directly into your current namespace. The syntax is from module_name import item_name1, item_name2, and so on. Let's see an example. In line 1, from math. This specifies that we are importing functions from the math module. Import sqrt, pi. This imports the sqrt and pi functions from the math module directly into the current namespace. Now you can use these functions without referencing the math module. In line 2, sqrt, of 16 this calls the sqrt function that was imported from the math module. It takes the argument 16 and returns the square root of 16, which is 4.0. This directly accesses the pi constant from the math module. The value of pi is approximately 3.141592653589793. Third point. Using wildcard import, not recommended. You can use the star symbol wildcard to import all items from a module into the current calling namespace program. However, this practice is generally discouraged as it can lead to namespace pollution and make it harder to identify the source of functions or variables. The syntax is from module_name import star called wildcard. In this example, from math module the sign function is accessed. So sign of 0 is equal to 0.0. It is recommended to use explicit imports, import module or from module import item, to make your code more readable and avoid potential naming conflicts. Also, try to avoid wildcard imports from module import star to maintain a clean namespace and improve code maintainability. Note that, while importing using from keyword, do not refer to the module name when referring to the methods or functions. Let's see an example. In line 1, we import the pow and factorial functions from the math module using from math import pow, factorial. Then, in line 2, we use these functions to perform calculations. Pow of 2, 3. This calculates 2 raised to the power of 3, which is 8. In line 3, name error, from math we have imported factorial, in the first line. So need not use math.factorial. Let's see some examples. Now look at the first code. Let's say we have a Python file called area.py which has a few functions in it for calculating the area of a circle, square and rectangle. Let's use those functions again in some other programs. Now look at the first code. We have created the area module, which is a user-created module, not from the Python library. However, this program uses the standard math module for using py, function that belongs to it. Now, we shall call these modules in another program named math1.py. You can see in the second code below. Note: always remember that the module area.py should be in the same default root folder where math1.py also resides. In the second code below, the import statement gives access to all attributes and methods present in the module. Methods in a module are accessed using syntax module.method function. When we run this program, the submodules, namely circle_area, square_area, and rectangle_area, shall be called from module area using the statements area.circle_area, area.square_area, area.rectangle_area. They shall generate the output as shown on the right side of the screen. Retrieving objects from a module. There is another function dir, which, when applied to a module, gives you the names of all that is defined inside the module. Let's see an example. When you pass an object as an argument to dir, it lists the attributes and methods available for that object. Here, area is passed as amObject as an argument to dir function. You can see the output, how it has listed the attributes and methods available for area module. Let's see an example. To calculate the area of the circle only, can be done using the from statement, along with the name of the submodule to be called specifically. The left-hand side code is the modification of right-side code, area.py. Here, we are modifying using from statement along with the name of the submodule to be called specifically. The syntax is from module_name import function_names is used to import a particular attribute, subroutine, from a module. In case you do not want whole of the module to be imported, then you can use from module_name import function_name statement as we have done in this example. Look at the left-hand side code. In order to calculate area of the circle_area, function is being called from module area. Note that, for modules having a large number of functions, it is recommended to use from instead of import. Point 4. Importing a module using from module name import star. This statement allows the user to import everything from the specified module. This construct will import all Python definitions into the namespace of another module. However, the use of this construct is not recommended much as it may result in namespace pollution. We may have several objects of the same name and the definitions can be overridden. Let's see an example. Import star gives access to all functions in area module. You can use all the functions in area module directly. From the previous examples, we have observed that import statement in Python can be represented in any of the following for importing module in some other program. Let's recall. Point 1. Import test. Imports the module test and creates a reference to that module in the current calling program, or namespace. After executing this statement, you can use test.name to refer to the objects defined in module test. Point 2. Import test1, test2, test3. This statement shall import 3 modules, namely test1, test2 and test3 in current namespace. As a result, all the definitions of these modules are available and can be used as module_name, name. Name represents the submodule or any object. Point 3. From test import star. When you use import start statement, it shall import all the submodules or objects defined in the module test into the current namespace. So, after executing this statement, you are required to simply give the name of the object to be referred to, defined in the module test. In other words, name would now be used as name only, without specifying module's name, that is, test.name is not required to be given. If name was already defined, it is replaced by the new version, the one imported from the module. Point 4. From test import T1, T2, T3. This statement shall import the module test and create references in the current namespace to the given objects. In other words, you can now use T1, T2, and T3 in your program without specifying their module's name along with them. Note: whenever we are using a module in our program, for that module, its compiled file will be generated and stored in the hard disk permanently. Let's discuss about the name resolution, resolving scope of a name. Python name. A Python name is an identifier, that is something we use to access a Python object. And, in Python everything is an object. A name can hold any kind of value. Namespace is a collection of names. It maps names to corresponding objects. When different namespaces contain objects with the same names, this avoids any name collisions. Internally, a namespace is implemented as a Python dictionary. When Python interpreter starts up, the namespace containing the built-in names is created and is never deleted until the interpreter quits. We have three namespaces. Local namespace. Local namespaces are created whenever a function is called, and they hold the names of variables defined inside that function. These names are only accessible within the function's scope. Next is global namespace. The global namespace is associated with the main module or the module at the top level of the program. It contains names defined at the top level of a script or a module. These names can be accessed throughout the module. However, to modify them inside a function, you must explicitly declare them as global using the global keyword. And the last one is a built-in namespace. This namespace contains all the names of Python's built-in functions, keywords, and exceptions. These names are available by default and do not require any explicit import. Examples include print, len, input, etc. Python resolves the scope of a name using LEGB rule, that is, it checks environments in the order, local, enclosing, global, and built-in. For every name reference, Python does the following to resolve it. Step 1. It checks within its local environment, LEGB, or local namespace, if it has a variable with the same name. If yes, Python uses its value. If not, then it moves to step 2. In step 2, Python now checks the enclosing environment, LEGB, if there is a variable with the same name. If yes, Python uses its value. If not, then it moves to step 3. In step 3, Python now checks the global environment, LEGB. If there is a variable with the same name. If yes, Python uses its value. If not, then it moves to step 4. In step 4, Python now checks the built-in environment, LEGB. If there is a variable with the same name. If yes, Python uses its value. If not, Python would generate the error. Name variable is not defined. Thus, LEGB rule means checking in the order of local, enclosing, global, built-in environments, namespaces, to resolve a name reference. Let's learn about module aliasing. Module aliasing in Python refers to the practice of giving a shorter or more convenient name, alias, to a module when importing it. This can be helpful when working with modules with long or complex names, or when there is a possibility of name conflicts. It allows you to use a shorter name to refer to the module's contents without affecting its actual name in the Python standard library or file system. Module aliasing is achieved using the import statement. Syntax is import module _name as alias _name. Here's an example of importing the math module and giving it an alias m. In this example, we can use m instead of math to access the functions and constants provided by the math module. Similarly, you can also use aliasing when importing specific items from a module using the from module _name import item _name as alias, which is the syntax. In this example, square _root is an alias for the sqrt function from the math module. Remember that while aliasing can improve code readability, it is essential to use meaningful aliases that convey the purpose of the module or item being imported. Very short or cryptic aliases may make the code harder to understand for others and yourself in the future. Python Libraries Part 2. In this video, we are going to learn package and library, locating modules, Python standard library functions and modules, Python's built-in mathematical functions, Python's built-in string functions, and practical implementation. So, let's dive in and get started. We usually organize our files in different folders and subfolders based on some criteria, so that they can be managed easily and efficiently. For example, we keep all our games in a games folder, and we can even subcategorize according to the genre of the game or something like this, given in the picture. Even you can add more subfolders to the game folder. The same analogy is followed by the packages in Python. So what is a package in Python? A package is a collection of multiple Python modules organized in a directory hierarchy. Package in Python is a folder that contains various modules as files. The main purpose of a package is to create a namespace for modules, avoiding naming conflicts and providing a clear structure. A package is defined by the presence of a special file called _init_.py in its directory. The _init_.py file can be empty or contain initialization code for the package. Packages allow developers to create a logical grouping of related modules. Examples of packages in Python include NumPy, Pandas, and Matplotlib. Let's see how to create a package. Point 1. Create the directory structure. Decide on a name for your package, and then create a directory with that name. Inside the package directory, you'll have other subdirectories and Python modules. A simple package structure could look like this. Look at the right side box. Second point, add the _init_.py files. The _init_.py file is required in each directory to make it a package. You can leave it empty or add package-level initialization code if needed. This file is executed when the package or its modules are imported. Point 3. Define the modules. In this example, you have module1.py, module2.py, submodule1.py, submodule2.py, submodule3.py, and submodule4.py. Each of these files represents a Python module and can contain functions, classes, or variables that you want to expose as part of your package. Point 4. Writing code in the modules. Open each module file and write the necessary Python code for the functions, classes, or variables you want to include in your package. For example, in module1.py, you might have def function _in _module1. Return function from module 1. Point 5. Usage. To use your package in another Python script or project, you can import the functions or classes you defined in your modules. For example, look at the right side box. Importing functions from your package. From my package.module1 import function _in _module1. Result equals function _in _module1, print, result. Remember, to access modules within subpackages, you use a similar import statement but specifying the full path to the module. That's it. You've created a basic Python package. As your package evolves, you might want to add more modules or subpackages to organize your code effectively. A package is simply a collection of similar modules, subpackages, etc. A package and a library are technically the same. Let's see an example. Let's say we have two modules named area.py, calculating area of a circle, square and rectangle, and volume.py, which has a few functions to compute volumes of the various shapes. Hence these two modules are both related to each other and should be bundled in a package. Thus, we are going to create a package geometry, which will have both modules, area.py and volume.py. Steps to create and import a package. Create a directory named geometry and add both modules area.py and volume.py in it. Also, create a file _init_.py in directory geometry. The _init_.py file is required to make Python treat the directories as containing packages. Import the package and use the attributes contained inside the package. What is _init_.py file? _init_.py is a special file in Python that is used to mark a directory as a Python package. When you create a directory and place in _init_.py file inside it, Python treats the directory as a package, allowing you to organize your code into modules within that package. Some key points of _init_.py. Package initialization. The primary purpose of _init_.py is to initialize a Python package. It can be an empty file or can contain Python code to be executed when the package is imported. Marking directories. If a directory contains an _init_.py file, Python treats that directory as a package. This means you can use the package's modules and subpackages within your code. Namespace package. In Python 3.3 and later, _init_.py is not required for regular packages and is optional. If a directory doesn't contain an _init_.py file, it will be treated as a namespace package, and its subpackages can be spread across multiple directories. Package level code. The _init_.py file allows you to define package level code, including variable definitions, function definitions, or any other initializations that you want to be executed when the package is imported. Importing modules. When you import a module from a package, Python looks for the _init_.py files in the package directories to properly initialize and set up the package namespace. What's a library? A library, in the context of programming, is a collection of code resources that provides specific functionalities. It can consist of modules and packages, along with other resources like documentation, configuration files, and data files. Libraries are designed to be reusable and are often created to solve particular problems or provide specific tools for developers. Python libraries are usually distributed in a way that allows users to import and utilize their modules and packages in their own projects. Examples of Python libraries include the standard library that comes with Python, example, math, deals with mathematical operations, OS, JSON, and external libraries like NumPy, deals with scientific computing, pandas, and requests. A package is a collection of modules, a library is a collection of packages. Multiple interrelated modules are stored in a library. And whenever we need to use a module, we import it from its library. In Python, it's a very simple job to do due to its easy syntax. We just need to use import. Importing math library. Import math x equals 16. Print of math.sqrt of x. Output will be 4.0. Here, we imported the math library and used one of its methods, that is, sqrt, square root, without writing the actual code to calculate the square root of a number. That's how a library makes the programmer's job easier. But here we needed only the sqrt method of math library, but we imported the whole library. Instead of this, we can also import specific items from a library module. Importing specific items from a library module. From math import sqrt, sign. X equals 16, y equals 3.14, print of, sqrt of, x, printoff, sign of, y. We can see that we imported only sqrt and sign methods from the math library. Note that math library contains trigonometric functions, representation functions, logarithmic functions, angle conversion functions, etc. Advantages of libraries and packages. Reusability, save time by using pre-built code. Enhanced functionality, access a wide range of features and tools, rapid development, speed up the coding process. Community support, benefit from active user communities. Reliable solutions, well-tested and proven code. Cross-platform compatibility, works on different systems. Modularity, encourages a modular approach to programming. Extensibility, easily expand functionality with plugins. Industry standards, follow best practices for better code quality. Let's discuss about locating modules. When you import a module, the Python interpreter searches for the module in the following sequence. Current directory. Python looks for modules in the current working directory of your script or interactive session. This allows you to create and import your own modules easily. If the module isn't found, Python then searches each directory in the shell variable Python path. So, what is Python path environment variable? The Python path environment variable can be used to add custom directories to the module search path. By setting this variable, you can tell Python to search for modules in specific directories not included in the default sys.path. Finally, if all else fails, Python checks the default path, which is the location where Python has been installed on your computer screen. Python standard library functions and modules. The Python standard library is a collection of modules and packages that come bundled with the Python programming language. It provides a wide range of functionalities for tasks such as math operations, file handling, date and time manipulation, regular expressions, and more. The standard library is well documented, allowing developers to explore the available modules and functions with ease. Some of these important modules are explicitly designed to encourage and enhance the portability of Python programs, such as Math module for mathematical functions, Random module for pseudorandom number generation, and String module for string or text-related functions. Python's built-in mathematical functions. Let's discuss about the two mathematical constants pi and Euler's number. In Python, you can access two commonly used mathematical constants, pi and Euler's number, through the math module in the Python standard library. Pi is a well-known mathematical constant, which is defined as the ratio of the circumference to the diameter of a circle, and its value is 3.141592653589793. Look at example 1. To import this single object pi from the math module, let's see the code. Line 1, import math. We are importing the math module. In line 3 and 4, we are importing a single object pi from the math module and storing in a variable pi underscore value and finally printed. Now, look at example 2. Alternatively, it can be done without prefixing the module name and writing the name of the object directly after keyword import. From math import pi. Print pi. The output will be the same as example 1. Similarly, another well-known mathematical constant defined in the math module is e. It is called Euler's number. And it is a base of the natural logarithm. Its value is 2.71828182845945. Look at example 3. These constants can be directly called and used from math module. Note that we should remember not to use module name with imported object. If imported through from module import command, because now the imported object is part of your program's environment. In Python, the math module provides functions to work with angles expressed in degrees and radians. You can use these functions to convert between degrees and radians or perform trigonometric operations. Math.radians of degrees. This function converts an angle from degrees to radians. It takes an angle in degrees as input and returns the corresponding angle in radians. The formula to convert an angle from degrees to radians for mathematical calculations are given on the right side of the screen for your reference. Now look at example 4. Line 1, import math. This line imports the math module, allowing you to use its functions later in the code. In line 3, degrees equals 45, this line creates a variable degrees and assigns it the value of 45. It represents the angle in degrees that you want to convert to radians. Line 4. Radians equals math.radians of degrees. This line uses the math.radians function from the math module to convert the angle given in degrees to radians. The math.radians function takes the angle in degrees as input and returns the corresponding angle in radians. In this case, degrees is 45, so the output radians will be approximately 0.78539816339744483 radians and finally gets printed. So, the code demonstrates how to use the math.radians function to convert an angle from degrees to radians in Python. Math.degrees of radians. This function converts an angle from radians to degrees. It takes an angle in radians as input and returns the corresponding angle in degrees. The formula to convert an angle from radians to degrees for mathematical calculations are given on the right side of the screen for your reference. Now look at example 5. Line 1, import math. This line imports the math module, making all the functions and constants from the math module accessible in your script. In line 3, radians equals 2. This line creates a variable radians and assigns it the value of 2. The value 2 represents an angle given in radians, which you want to convert to degrees. In line 4, degrees equals math.degrees of radians. This line uses the math.degrees function from the math module to convert the angle given in radians, stored in the radians variable, to degrees. The math.degrees function takes an angle in radians as input and returns the corresponding angle in degrees. In this case, radians is 2, so the output degrees will be approximately 114.591559026164665 degrees and finally printed. So, the code demonstrates how to use the math.degrees function to convert an angle from radians to degrees in Python. By importing the math module, you can access the degrees function and many other mathematical functions provided by Python's standard library. Python provides a wide range of built-in string functions that allow you to manipulate and work with strings effectively. Let's now see some practical implementation of most commonly used inbuilt string functions. Now, look at example 1. Write a Python function to add ing at the end of a given string, length should be at least 3. Now, in line 4, define the function add_string of s with the parameter s, which represents the input string. In line 5, check if the length of the input string s is greater than or equal to 3 using the if len of s greater than 3 condition. If the length is at least 3, proceed to the next step. Otherwise, if the length is less than 3, return the original string s without any changes. In line 6, if the length is at least 3, check if the last 3 characters of the string s are ing using the slicing notation s of index of -3:. In line 7, if the last 3 characters are ing, it means the string already ends with ing, so we add ly instead. Return the modified string s plus ly. In line 9, if the last 3 characters are not ing, it means the string does not end with ing, so we add ing to the end of the string. Return the modified string s plus ing. In line 11, the function has now completed, and it returns the modified string if the length of the input string was at least 3. If the length was less than 3, it returns the original string. Let's see the test cases. In line 14, add _string of go. The input string is go, which has a length of 2, so it does not satisfy the condition len of s greater than equal to 3. The function returns the original string go unchanged. You can check the output go on the console. In line 15, add _string of read. The input string is read, which has a length of 4, satisfying the condition len of s greater than 3. The last 3 characters of the string are ead, not ing, so we add ing to the end of the string. The function returns the modified string reading. In line 16, add _string of exciting. The input string is exciting, which has a length of 8, satisfying the condition len of s greater than 3. The last 3 characters of the string are ing, so we add ly instead. The function returns the modified string excitingly. Example 2. Write a Python function to get a string from a given string where all occurrences of its first character char have been changed to $, except the first character char itself. Now, look at the Python code. Line 9. Change _ char of restart. Now, look at line 5. The input string is restart. Char equals s of index 0 sets char to r, the first character of the string restart. In line 6. S equals s dot replace of char comma $, replaces all occurrences of r with $, so s becomes $est$t. In line 7. S equals char plus s of 1 : concatenates r with the rest of the modified string est$t. The function returns the modified string and gets printed as check the output rest$t. Now, look at line 10. Change _ of char of madam. The input string is madam. Now, look at line 5. Char equals s of index 0 sets char to m, the first character of the string. In line 6. S equals s dot replace of char comma $, replaces all occurrences of m with $, so s becomes $ada$. In line 7, s equals char plus s of index 1 : concatenates m with the rest of the modified string ada$. In line 8. The function returns the modified string mada$, and is printed on the console. Same way, try to work out for the string express given here. Thus, the change _ char of is function replaces all occurrences of the first character of the input string s, except the first character itself, with $, and returns the modified string. Data file handling, part 1. In this video, we are going to learn Introduction of Data File Handling. What is a file? File I/O, input and output, why use files, data file operations, file types, text files, binary files, CSV files, difference between text files, binary files, CSV files. So, let's dive in and get started. Let's learn about data file handling. Look at the first box. Programs are transient, running for a short time and generating temporary output. Data entered and processed in these programs reside in primary memory, RAM, random access memory. Primary memory, RAM, is volatile, meaning it is temporary and gets cleared when the program ends. When the program is rerun, it starts with no previous data since it was temporary and is no longer available. Now, look at the second box. Some programs are persistent, running continuously or for a long time. Persistent programs store at least some data in permanent storage, such as a hard drive. When these programs shut down or restart, they resume execution from the same point. Examples of persistent programs include operating systems that run whenever a computer is switched on and web servers that run continuously, waiting for network requests. One of the simplest ways for programs to maintain their data is by reading and writing text files. The third box says about how business operations efficiently manage data with file handling. Programs used in day-to-day business operations heavily rely on file handling to manage data efficiently. Many business applications, such as accounting software, inventory management systems, and customer relationship management (CRM) tools, use files to store and retrieve information. Accounting software uses files to store financial records, transaction details, and reports. Inventory management systems store product information, stock levels, and purchase orders in files. CRM tools use files to keep customer data, sales history, and communication records organized. Files enable these applications to access and manipulate data even after the program execution ends, ensuring data persistence and reusability. So, what is a file? A file is a named location on secondary storage where data is permanently stored for later access. A file is a document or the data stored on a permanent storage device which can be read, written, or rewritten according to requirement. Data is packaged up on the storage device as data structures called files. All files are assigned a name that is used for identification purposes by the operating system and the user. What's the need for a data file? To store data in organized manner. To store data permanently. To access data faster. To search data faster. To easily modify data later on. So, what is file input and output? File I/O, input-output, is the process of reading data from files and writing data to files in computer programs, enabling permanent data storage and retrieval. File input-output means transfer of data from secondary memory, hard disk, to main memory or vice versa. Now, look at this picture. When we are working on a computer system, the file or the document stored on the hard disk is brought into RAM, random access memory for execution and vice versa. The arrow shows the flow of data. So, the data is read from external files using file input, file I/O. The program processes and manipulates the data as needed. Finally, the processed data is written back to external files using file output, file I/O. File handling in Python allows us to interact with files to store data permanently and read from them later. Data used in variables is temporary in nature. Once the application is closed, all the variables and data are lost. So, there comes the concept of files. In order to save our data on some secondary storage device, we have to use files. Files are used to store data permanently on disk or to read data from external sources. Now, look at the picture. Data maintained inside the files is termed as persistent data, that is, it is permanent in nature. Python allows us to read data from and save data to the external text files permanently on secondary storage media. Apart from this, we permanently store the program data as Python scripts, with .py extension also. We usually use the files to store data permanently while working and storing data in word processing applications, spreadsheets, presentation applications, etc. All of these operations require data to be stored in files so that it may be used later. A file in itself is a bunch of bytes stored on some storage devices like hard disk, pen drive, etc. A file or data file is a stream or sequence of characters or data occupying named space on the disk where a sequence of related data is stored. It contains data pertaining to a specific application for later use. Let's discuss about data file operations. Data file operations refer to the actions and procedures performed on data stored in files using a computer program. These operations typically involve reading data from files, writing data to files, updating file content, and deleting files. Data file operations are essential in various applications where data needs to be persisted or retrieved from files. Data file handling in Python enables us to create, update, read, and delete the files stored on the file system through our Python program. The following operations can be performed on a file. In Python, file handling consists of following 3 steps. Open a file. Process data, that is, performing operations like read, write, append, insert, delete, etc. Close the file. Let's discuss about the file types before we discuss about the file operations. Computers store every file as a collection of zeros and ones that is in binary form. Therefore, every file is basically just a series of bytes stored one after the other. Python allows us to create and manage 3 types of file: text files, binary files, and CSV files. Let's discuss one by one in detail. Let's learn about the text files. Text file definition. A text file is a type of computer file that stores plain text characters without any special formatting or binary data. Let's see some key points of text files. Human readable. Text files contain data that can be easily read and understood by humans as it consists of readable text. Encoding. Text files are often encoded using a ASCII, Unicode character. Line termination. Each line of text in a text file is typically terminated by a special character, known as end of line, EOL. By default, this EOL character is the new line character, \n. Next is creation and editing. Text files can be created and edited using simple text editors like Notepad, Windows, TextEdit, macOS, Nano, or VI, Unix-like systems. Common uses. Text files are widely used for storing configuration settings, program source code, log files, data for data processing tasks, and more. Read and write in Python. In Python, you can use the built-in open function to read from and write to text files. Reading uses R mode, while writing uses W mode, and appending uses A mode. File handling. It's a good practice to use the with statement in Python for file handling, as it automatically handles file closing and ensures proper cleanup even if an exception occurs. Universality. Text files are platform independent, making them easily exchangeable between different operating systems and applications. Examples of text files include document files such as .txt, .rtf, .pdf, tabular files such as .csv, .tsv, source code files such as .py, .js, .c, .app, .java. Web standard files such as .html, .xml, .css, .json. Configuration files such as .ini, .cfg, .reg. Text files play a fundamental role in computing and are essential for data storage, communication, and data exchange between different systems. Let's learn about the binary files. Binary files are a type of computer file that stores data in a non-human readable format. Unlike text files, binary files contain encoded data that is not directly interpretable by humans. Let's see some key points of binary files. Non-human readable. Binary files store data in binary format, consisting of sequences of zeros and ones, making them not human readable. Encoding. Binary files can store any type of data, including images, audio, video, executables, and more. The data is represented using binary code. No line termination. Unlike text files, binary files do not use line termination characters like \n, new line character. File size. Binary files are generally more compact and efficient in terms of storage as they represent data in a more compressed manner. Reading and writing. Reading and writing binary files involve using the appropriate mode, RB for reading, WB for writing, and dealing with bytes or byte arrays. Examples of binary files include image files such as .png, .jpg, audio files such as .mp3, .wav, video files such as .mp4, .avi, compiled executable files such as .exe, .dll. Content interpretation. To interpret the data in binary files, specific file formats and knowledge of the data structure are required. Each file type has its unique format and decoding process. Read and write in Python. In Python, you can use the open function with binary mode to read and write binary files. Reading uses RB mode, while writing uses WB mode. Safety. Due to their non-human readable nature, binary files should be handled with caution to avoid accidental data corruption. Binary files are essential for storing and processing complex data that requires precise encoding, such as multimedia files, databases, and compiled software. When working with binary files, it's crucial to understand the file format specifications to properly read and interpret the data. Let's learn about the CSV files. CSV, comma-separated values, files are a popular file format for storing tabular data. In CSV files, each line represents a row of data, and each value within the row is separated by a comma, or another delimiter character, such as a tab or semicolon. Let's see some key points of CSV files. Structure. CSV files are plain text files that organize data in a table-like format, with rows and columns. Each row represents a record, and each column represents a field or attribute. Next is the delimiter. The values in CSV files are separated by a delimiter character, typically a comma, hence the name comma-separated values. However, other delimiters like tabs, \t, or semicolons are also commonly used. Next is human readable. CSV files are human readable, making them easy to create, edit, and view in a text editor or spreadsheet software. Next is the common use. CSV files are widely used for data exchange between different applications and platforms due to their simplicity and versatility. No data types. CSV files do not store data types, all values are treated as strings. Any data type conversions must be performed during data processing. Header row. CSV files often include a header row at the beginning, which provides the names or labels for each column. Handling special characters. Special characters, such as the delimiter itself or new lines within a field, need to be properly escaped or enclosed in quotes to maintain data integrity. File extension. CSV files typically have a .csv file extension. Salient features of CSV files are, each record consists of fields separated by comma, delimiter. It is the most preferred import and export format for databases and spreadsheets. Each line in a CSV file is treated as a record. Let's see the difference between text file, binary file, and CSV file. Representation. Text file contains human-readable text characters. Binary file stores data in non-human readable binary format, whereas CSV file contains tabular data with comma-separated values. Next is file contents. Text file is a plain text, for example, letters, words, sentences. Binary file is any data type, example, images, audio, video, executables. CSV files are structured data in rows and columns. Next is delimiters. In text file, no specific delimiters, new line character separates lines. In binary file, no specific delimiters, data is represented in binary code. In CSV file, comma, tab, or other custom delimiters are used. Next is structure. Text file. Textual data without a defined structure. Binary file. Data is represented as a sequence of zeros and ones. CSV file. Table-like structure with rows and columns. Next is size. Text file. Larger in size compared to binary files. Binary file. often more compact and efficient in storage. CSV file. Larger in size than plain text due to separators. Next is human readability. Text file, easily readable and editable by humans. Binary file. Not human readable, requires special software to interpret. CSV file. Human readable, but values need proper parsing. Next is platform dependent. Text file. Platform independent, new line handling may vary. Binary file. May have portability issues due to different binary representations. CSV file. Platform independent, widely used for data exchange. Next is file extension. Text file. Commonly has .txt or other text-specific extensions. Binary file. File extensions vary based on the file type, example, .jpg, .mp3, .exe. CSV file. Commonly has .csv or other delimiter-specific extensions. Next we can see the examples. Text file. Hello, this is a text file, binary file. Binary file, non-human readable. CSV file. Name, age, email. Last difference is usage. Text file. Used for storing configuration settings, program source code, etc. Binary file. Suitable for multimedia files, databases, and compiled software. CSV file. Ideal for data exchange and tabular data storage. Data file handling, part 2. In this video, we are going to learn opening a file, methods to open a file, using open function, using with statement, file open modes, advantages of using with statement, closing a file and various properties of file objects with practical implementation. So, let's dive in and get started. Python has a well-defined methodology for opening, reading, and writing files. In Python, you can work with files to read data from them, write data to them, or perform various file operations. To handle data files in Python, we need to have a file variable or file object or file handle. The process of accessing and manipulating files in Python is done using the open function. Open function is the most extensively used function in handling files in Python. The open function allows you to open a file in different modes, such as reading, writing, or appending. It provides a straightforward way to interact with the file system and handle data stored in files. Now, look at this picture. When we want to read or write a file, let's say on the hard drive, we must first open the file. Opening the file communicates with the operating system, which knows where the data for each file is stored. When we open a file, we are asking the operating system to find the file by name and make sure the file exists. There are two methods to open a file. Using open function. Using with statement. Let's see one by one in detail. Open function takes the name of the file as the first argument. The second argument indicates the mode of accessing the file. The syntax for open function is file variable or file object or file handle equals open of file name, access mode. Here the first argument with open function is the name of the file to be opened, the path to a file, and the second argument describes the mode, that is, how the file will be used throughout the program, whether read mode or write mode or append mode. This is an optional parameter as the default mode is the read mode, reading. The file underscore object establishes a link between the program and the data file stored in the permanent storage. The access modes define the location of the file pointer, that is, from where the data has to be read and written to the file. Modes for opening a file are read, R, mode, to read the file, write, W, mode, to write to the file. Append, A, mode, to write at the end of the file. Let's learn how to manipulate data with Python's file handling. Files reside in the computer's secondary memory. Secondary memory is persistent, which means that data is not erased when a computer is powered off. Once you make changes to a file and save it, the changes are permanently written and saved in the secondary memory. To work with files, we need to load them into the main memory first. Main memory is the temporary cache memory that holds requested data for a brief interval. The data is lost when the computer is powered off. Now, look at this picture. Files are loaded from secondary memory to the main memory and then processed by the CPU. Once the processing is done, the data is written back to the secondary memory. Let's see in detail. Now, look at the second picture. When opening a file in Python using open function, it returns an object of the file type, enabling file manipulation in the program. Python automatically associates a buffer with the file during its opening. This buffer acts as a temporary memory area to store data before writing it to the file. When writing content to the file, data is first placed in the buffer. Once the buffer is full or when flush is explicitly called, the data is written from the buffer to the file on the hard disk. To ensure data integrity, Python automatically transfers any unsaved data from the buffer to the file when we close it. If needed, the flush method of the file object can be used to force an immediate transfer of data from the buffer to the file before closing, guaranteeing that all data is properly written. Let's learn how file handlers work. Python interacts with files loaded in the main memory through file handlers. When we want to read or write a file, we must open it first. Opening a file signals to the operating system to search for the file by its name and ensure that it exists. The operating system, OS, returns a file handler if open is successful. Then we can interact with our file through the file handler. The file handler does not contain the data itself, it just provides an interface for handling the file operations. Let's look at file handlers in detail. Look at the picture. In your Python code, if opening is successful, the operating system returns us a file handle. The file handle is not the actual data contained in the file, instead, it is a handle that we can use to read the data. It is the object that gets associated with a particular file to perform read or write operations at a particular time. We are given a handle if the requested file exists and with no proper permission to read the file. Let's learn how to open a file. I am using online GDB for data file handling. First, you should remember the syntax to open a file. File_object equals open of file_name, access_mode. So, now look at the code. F equals open of myfile.txt, R. Here myfile.txt is the file name, R is the access mode, R represents read mode. When F, the file object or file variable or the file handle gets printed, Python will raise file not found error. Because myfile.txt file name does not exist. So open function will fail a traceback and we will not get a handle to access the contents of the file, as shown in this picture. How to open a file. Step 1. Click the new file to open a new file. You get a dialog box like this, untitled. So you type the new name for your new file. Here, we have typed myfile.txt. Press OK. Tada! Did you find the new file name, myfile.txt? Step 2. Now let's type the text here. Welcome to Sallyann Bytes. Text file is opened successfully. Now, come on, let's run this code. What can you see on the output of this file handle? In the output, we have received a file handle where myfile.txt is the file name and mode is the permission, which is R, stands for read mode, in our case. Encoding is the encoding mechanism for the Unicode character set, UTF-8. When we open a file, it opens in read mode by default and F as the file object or file variable or file handle, whatever we may say, shall be returned as the output by the operating system. Key points to remember. Always create the file in the same default folder where your Python has been installed. When you open a file in read mode, the given file must exist in the folder, otherwise Python will raise file not found error. The first line of code is a common way to open a file in Python and assign a file object to a variable named f. The open function is a built-in Python function used to open files. It takes two arguments. The first argument is the name of the file you want to open, and the second argument is the mode in which you want to open the file. Myfile.txt is the name of the file you want to open. Replace myfile.txt with the actual name of the file you want to work with. If the file is in the same directory as your Python script, you can simply provide the file name. If the file is in a different directory, you can specify the file's full path. R is the second argument to open, is the mode in which you want to open the file. In this case, R stands for read mode. This means you are opening the file for reading, and you can only read data from the file, not write to it. F equals this part of the code assigns the file object returned by the open function to the variable f. The variable f now becomes a file handle, which you can use to interact with the opened file. After executing this line of code, you can use the file object f to read data from the file and perform various operations on it. For example, you can use methods like read, readline, or readlines to read the contents of the file. Now, look at the second line of code. This is similar to the previous one, but with a specific file path provided in the name of the file. As explained earlier, the open function is used to open files in Python. In this case, the function is opening a file with the path d:/myfile.txt in read mode, R. d:/myfile.txt is the file path of the file you want to open. The file is located on the D drive, and the file name is myfile.txt. The double slash is used to escape the backslash character since it has a special meaning in strings, it is used to escape other characters. Now, let's look at the third line of code. Here f is a variable that will hold the file object after the file is opened. You can choose any valid variable name you prefer. Open function is a built-in Python function used to open files. It takes two main arguments, the file path and the mode. R is a string literal prefix that indicates the following string should be treated as a raw string. This means that backslashes won't be treated as escape characters, which is useful when dealing with file paths. d:\myfile.txt is the file path. It specifies the directory, d:, and the file name, myfile.txt, that you want to open. Finally, R is the mode in which the file is opened. R stands for read mode, which means you are opening the file for reading its contents. Let's learn about the file modes. Mode R opens a file for reading only. The file pointer is placed at the beginning of the file. This is the default mode. If the specified file does not exist, it will generate file not found error. Mode RB opens a file for reading only in binary format. The file pointer is placed at the beginning of the file. This is the default mode. Mode R+ opens a file for both reading and writing. Plus, the file pointer will be at the beginning of the file. Mode RB+ opens a file for both reading and writing in binary format. The file pointer will be at the beginning of the file. Mode W opens a file for writing only. Overwrites the file if the file exists. If the file does not exist, it creates a new file for writing. Mode WB opens a file for writing only in binary format. Overwrites the file if the file exists. If the file does not exist, creates a new file for writing. Mode W+ opens a file for both writing and reading. Overwrites the existing file if the file exists. If the file does not exist, creates a new file for both reading and writing. Mode WB+ opens a file for both writing and reading in binary format. Overwrites the existing file if the file exists. If the file does not exist, creates a new file for reading and writing. Mode A opens a file for appending. The file pointer is at the end of the file if the file exists. That is, the file is in the append mode. If the file does not exist, it creates a new file for writing. Mode A B opens a file for appending in binary format. The file pointer is at the end of the file if the file exists. That is, the file is in the append mode. If the file does not exist, it creates a new file for writing. Mode A+ opens a file for both appending and reading. The file pointer is at the end of the file if the file exists. The file opens in the append mode. If the file does not exist, it creates a new file for reading and writing. Mode A B+ opens a file for both appending and reading in binary format. The file pointer is at the end of the file if the file exists. The file opens in the append mode. If the file does not exist, it creates a new file for reading and writing. Key point to remember. The default file open mode is read mode. If you do not provide any file open mode, Python will open it in read mode, R. Let's see an example. This line of code will open the file myfile.txt for reading and writing purpose. Here, the name of the file specified is constant. If it already exists, then it has to be in the same folder where we are working now, otherwise we have to specify the complete path. Note: it is not mandatory to have file name with extension. In this example, .txt extension is used for convenience of identification as it is easy to identify the file as a text file. For binary file, we will use .dat extension. Apart from using open, function for creation of file, with, statement can also be used for the same purpose. With statement groups file operations for compact and readable code. It is useful for related operations executed as pairs. Resources are automatically managed and deallocated. Ensures proper resource release when done. No need to explicitly close files using with statement. Enhances code organization and exception handling. Syntax of with statement is, with open of file name, mosd as file object : file manipulation statements. Let's see an example. We are writing a program to illustrate with statement. Now, look at the code. In line 2. With open of samplefile.txt, w, as f, opens the file named samplefile.txt in write mode, w. The with statement ensures that the file is properly opened and managed. The file object is assigned to the variable f. Now look at line 3, 4, and 5, inside the indented block, f.writeof, learning \n, f.writeof, Python files \n, and f.writeof is interesting \n. These lines write the given text to the file, each on a new line. Print statement in line 6 prints whether the file is closed or not. f.closed is a Boolean attribute of the file object that indicates if the file is closed, true, or open, false. In line 7, outside the with block, after exiting the indented block, the with statement automatically closes the file. The file is properly closed and resources are released. The final print statement prints whether the file is closed at this point. Since the with block has already exited, the file should be closed, true. So, the output of the code would be something like, is file closed, false. Is file closed now, true. Here, you can see that the file is open, false, inside the with block but closed, true, once the block is exited, confirming that the with statement automatically takes care of proper resource management. Advantages of using with statement. Any file that is opened using with statement is closed automatically, once the control comes outside the with statement. In case the user forgets to close the file explicitly or if an exception occurs, the file is closed automatically. Once we are done with the read/write operations on a file, it is a good practice to close the file. Python provides a close method to do so. While closing a file, the system frees the memory allocated to it. The syntax of close function is fileObject.close function. Note that a close function breaks the link between file object and the file on the disk. After closing a file, using close function, no tasks can be performed on that file through the file object. In this example, we have used name property of the file object f along with print statement, which will return the name of the currently used file, which is samplefile.txt in this case. Now, look down at the first red box. The same program can be alternatively performed in case the file is not present in the Python root directory. Let's assume that the text file is present in the D drive. Then the open function method shall be defined as f equals open of d:/samplefile.txt, r. Here, you have to note that accessing file with / if stored on some other drive. In the next line print statement, read function is used for reading the data present in the file. Note that a file always gets opened in read mode and is text file by default. Let's see the various properties of file object. Once open is successful and file object gets created, we can retrieve various details related to that file using its associated properties. Name. Name of the opened file. Mode. Mode in which the file gets opened. Closed. Returns Boolean value, which indicates whether the file is closed or not. Encoding. Returns the encoding format of the file. The various properties of file object are seen in this example. You can check this one by one. Data file handling, part 3. In this video, we are going to learn reading data from a file, read function, read of n function, readline function, readlines function with practical implementation. So, let's dive in and get started. The Python programming language provides the ability to work with files using open function. Python programming treats some files as text files, where lines are separated by new line characters \n. You can open regular files with the parameter r. Now we are going to learn how to read data from a file. Python provides various methods associated with a file object for reading data from a file. We can read character data from text file by using the read methods given here. Read function, read of n function, readline function, and readlines function. Let's see the methods of reading data from a text file in Python. Read function. To read the entire data from the file, starts reading from the cursor, from the beginning of the file, up to the end of the file. Read of n function. To read in characters from the file, starting from the cursor, if file holds fewer than n characters, it will read until the end of the file. Also, if the size is missing or has a negative value, then the entire file is read. Readline function. To read only one line from the file, starts reading from the cursor up to, and including, the end of line character. Readlines function. To read all lines from the file into a list, starts reading from the cursor up to the end of the file and returns a list of strings, separated by new line character \n. Let's learn about the read function in detail. We have read function and read of size function. Read function can be used to read entire data, while read of size can be used to read specific size strings from a file. This function also returns a string read from the file. At the end of the file, again an empty string will be returned. The syntax of read function is a file object.read function or file object.read of size. Here the size specifies the number of bytes to read from the file. So, the function may be used to read a specific number of characters from the file. If the value of size is not provided or a negative value is specified as size, then the entire file will be read. Let's see some examples. To illustrate read function by reading the entire data from a file, myfile.txt. Now look at the main.py Python code. Line 1. F equals open of myfile.txt, r. This line opens the file myfile.txt in read mode, R. The open function returns a file object that you can use to interact with the file. In line 2, data equals f.read function. Here, you use the read method of the file object, f, to read the entire content of the file and store it in the variable data. This method reads the entire content of the file as a single string. In line 3, it prints the content of the file, which is stored in the data variable. This will output the entire content of the file to the console. In line 4, finally, you use the close method to close the file. It's important to close the file after you're done with it to free up system resources and ensure that the file is properly closed. Now look at the right side text file named myfile.txt. You can type any text to read. The content of the file myfile.txt seems to be as follows. Hello everyone. Welcome to Sallyann Bytes. Now, you are working with Python files. So, when you run the main code, it will read the content of myfile.txt and print it to the console. You can check the output here, how the entire data from the text file is read and displayed. Let's see another example. Example 2. To illustrate read of n by reading only the first 10 characters from the file, myfile.txt. Now, look at the main code, main.py line 2, data equals f.read of 10. Here, you use the read method of the file object, f, with an argument of 10. This means you're reading the next 10 characters, or bytes, from the file and storing them in the variable data. In line 3, it prints the content stored in the data variable, which are the first 10 characters from the file. When you run the provided code, it will read the first 10 characters from the file and print them to the console as hello ever. In this case, only the first 10 characters of the file are read and printed. This demonstrates that you can read a specific number of characters, or bytes, from a file using the read method with an argument. Keep in mind that the argument specifies the maximum number of characters to read, so if the file content is shorter than that, it will read the entire content. Now look at example 3. To illustrate read of n by reading only the first 150 characters from the file, myfile.txt. Here the file content is shorter than the data to be read 150 characters, so it will read the entire data as shown in the output. It reads the entire data, as the text file content is shorter than the data to be read. Always remember, read function returns a string read from the file. Here, when we find the type of data, it displays type equals class str. That is the data is of string type. Let's learn about readLine function. ReadLine function is used to read only one line from the file, starts reading from the cursor up to, and including, the end of line character. ReadLine function will return a line read, as a string from the file. First call to function will return the first line, second call return the next line, and so on. We must remember that file object keeps track from where reading or writing of data should happen. Now, come to the second point. For readLine function, a line is terminated by \n, that is, new line character. The new line character is also read from the file and postfixed in the string. When end of file is reached, readLine function will return an empty string. The syntax for readLine function is fileObject.readLine function. Here, fileObject is the file object that has been opened using the open function. It represents the file you want to read from. The readLine function reads characters from the file until it reaches a new line character, \n, or until the end of the file, whichever comes first. It then returns the content it has read as a string. Since the method returns a string, it should be returned and stored using a variable as shown here in the first box. X variable equals file.readLine function or print of file.readLine function. For reading an entire file using readLine function, we will have to loop over the file object. This is a memory-efficient, simple, and fast way of reading the file, as shown in the second box. For line in x:, print of line. Example 5. To read data line by line using readLine method. In the main code, main.py, look at line 2. F equals open of myfile.txt, r. This line opens the file myfile.txt in read mode, r, and assigns the file object to the variable f. This allows us to interact with the file's contents. In line 3, line 1 equals f.readLine function. This line reads the first line from the file using the readLine method. It reads until it encounters a new line character, \n, and assigns the content hello everyone to the variable line 1. Thus, you can see the output displayed only the first line, hello everyone. Example 6. To read data line by line using readLine method. In the main code, main.py, look at line 2. F equals open of myfile.txt, r. This line opens the file myfile.txt in read mode, r, and assigns the file object to the variable f. This allows us to interact with the file's contents. In line 3, line 1 equals f.readLine function. This line reads the first line from the file using the readLine method. It reads until it encounters a new line character, \n, and assigns the content hello everyone to the variable line 1. In line 4, it prints the content of line 1 to the console. The end equals argument is used to prevent adding an extra new line character after the content is printed. So, it prints hello everyone to the console. In line 5, line 2 equals f.readLine function reads the second line from the file and assigns the content welcome to Sallyann Bytes to the variable line 2. In line 6, it prints the content of line 2 to the console, resulting in welcome to Sallyann Bytes being printed. In line 7, line 3 equals f.readLine function reads the third line from the file and assigns the content now you are working with to the variable line 3. In line 8, it prints the content of line 3 to the console, resulting in now you are working with being printed. In line 9, line 4 equals f.readLine function reads the fourth line from the file and assigns the content Python files to the variable line 4. In line 10, it prints the content of line 4 to the console, resulting in Python files being printed. In line 11, f.close function, the line closes the file after reading and printing its contents. Closing the file is important to release system resources. Now, the text file is seen on the right side, holding the text. The output is, data is read line by line using readLine method. 4 lines are displayed in the output. Always remember that the readLine function returns a string read from the file. Here, when we find the type of data, it displays type equals class str. That is the data is of string type. Let's learn about readLine's function. readLine's function is used to read all lines from the file into a list. It starts reading from the cursor up to the end of the file and returns a list of strings, separated by new line character \n. readLine's function can be used to read the entire data content of the file. This method will print all the lines present in the file. It will start reading the data line-wise from the beginning of the file and shall display the contents of the file till the end of file character. The syntax of readLine's function is file object.readLine's function. Here, file object is the file object that has been opened using the open function. It represents the file you want to read from. readLine's function reads all lines from the file and returns them as a list of strings. Each string in the list represents a line from the file. Let's see an example for readLine's function. To read all the lines from the file into list. Now, look at the code. In line 2, it opens the file myfile.txt in read mode, R. In line 3, it uses the readLine's function to read all lines from the file and store them in a list in a variable data, and in line 4, it gets printed, and finally, in line 5, it closes the file after reading. Now look at the output. Each line of the file is stored as a separate string element in the list that is in square brackets, including new line characters, \n. Keep in mind that the new line characters are present because the readLine's function retains the line breaks from the file. Now, look line 6, in the main code, you are finding the type of the data. Now look at the output, type equals class list. So, here, we have to remember that readLine's function reads all lines from the file and returns them as a list of strings. Each string in the list represents a line from the file. Let's see another example for readLine's function using for loop. To read all the lines from the file into list. Now, look at the main code, line 2, f equals open myfile.txt, r. This line opens the file myfile.txt in read mode, r, and assigns the file object to the variable f. This file object is used to interact with the file's contents. In line 3, lines equals f.readLine's function. This line reads all lines from the file using the readLine's method. It returns a list of strings where each string represents a line from the file, including the new line characters, \n, at the end of each line. The list of lines is assigned to the variable lines. In line 4, we use the for loop. For line in lines : this loop iterates through each element, line, in the lines list. In line 5, inside the loop, this line prints the content of the current line to the console using the print function. The end equals empty string argument is used to prevent the addition of an extra new line character after the content of the line is printed. This effectively prints each line without additional new lines. Finally, in line 6, f.close function, after the loop completes, this line closes the file. It's important to close the file to release system resources and ensure proper handling of the file. Now look at the output. The lines are printed exactly as they appear in the text file, without any additional formatting like list, square brackets, or \n, etc. Data file handling, part 4. In this video, we are going to learn writing data to file, write function, write line function, appending data to file with practical implementation. So, let's dive in and get started. Let's learn about writing data to file in Python. It is pretty standard that large chunks of data need to store in the files. Python is widely used in data analytics and comes with some inbuilt functions to write data into files. We can open a file and do different operations on it, such as write new contents into it or modify a file for appending content at the end of a file. Now, look at this picture. A file is a collection of data stored on a storage device. It can be a text file containing human-readable characters or a binary file containing non-textual data like images, audio, video, etc. Let's see about the write operation. A write operation refers to the process of saving data to a file in the external file, secondary storage. In Python, you can perform write operations to create, update, or modify the contents of a file. There are two things we need to remember while writing to a file. If we try to open a file that doesn't exist, a new file is created. If a file already exists, its content is erased, and new content is added to the file. In order to write into a file in Python, we need to open it in write mode by passing w inside open as a second argument. The Python programming language provides the ability to work with files using open function. Python programming treats some files as text files, where lines are separated by new line characters \n. You can open regular files with the parameter r. Now we are going to learn how to write data to a file. Python provides various methods associated with a file object for writing data to a file. We can write character data into a file in Python by using the following two file object methods: write of string function and write lines of sequence of lines function. Let's learn about write of string method. Write of string method takes a string as parameter and writes it in the text file in a single line. For storing data with end of line character, we will have to add \n character to the end of the string. Notice the addition of \n at the end of every sentence while talking of data.txt. \n is treated as special characters of 2 bytes. As the argument to the function has to be string for storing numeric value, we have to convert it to string. Here, file object is the file object that you've opened using the open function. String is the string you want to write to the file. Note that the write method actually writes data onto a buffer, temporary storage. When the close method is executed, the contents from this buffer are moved to the file located on the permanent storage. Let's see some examples for write of string method. Now, look at the main code, main.py. In line 2, f equals open of myfile.txt, w. This line opens the file named myfile.txt in write w mode. The file object is assigned to the variable f. If the file doesn't exist, it will be created new. If the file does exist, its previous content will be erased. But, here, in this example, we don't have a file named myfile.txt, which is not yet created. In line 3, this line writes the string hello, this is some data followed by a new line character, \n, to the file. The new line character adds a line break, ensuring that the next write will start on a new line. In line 4, this line writes the string to write to the text file, followed by a new line character to the file. Again, the new line character ensures that the subsequent write will be on a new line. In line 5, this line prints a message to the console, indicating that the data has been successfully written to the file. In line 6, this line closes the file. It's important to close the file when you're done writing to it to ensure that the changes are saved and to free up system resources. Now, click the Run button on the main code. You can see the red arrow pointing the Run button. Ta-da! What a surprise! After running this code, you'll find a file named myfile.txt in the same directory as your Python script, containing the 2 lines of text that you've written. Now you can see the new text file, myfile.txt, created. And you can see the 2 lines of text, hello, this is some data to write to the text file. So, if the file doesn't exist, it will be created new. Let's see another example. If the file exists, data present in the file shall be overridden, or overwritten, every time we run this program. Here, a new myfile2.txt file is created and this file will have contents specified inside the write method. Now, we can see how to create a new text file. Come on. Now, look at this picture, we are clicking to the new file to create. Immediately, a dialog box appears, showing untitled. Now let us add a text file name, myfile2.txt, and press OK. Now, in the first screen, we can see a new file created, named myfile2.txt. Now, look at the second screen. You can type the 2 lines of text, hello, this is some data to write to the text file. Now, look at the third screen. Here, we are typing the main code in main.py location. Now, look at the main code, main.py. In line 2. This line opens the file named myfile2.txt in write w mode. As before, if the file doesn't exist, it will be created. If the file does exist, its previous content will be overwritten. The file object is assigned to the variable f. In line 3, this line writes the string Python files followed by a new line character, \n to the file. The new line character ensures that the next write operation will start on a new line. In line 4, this line writes the string are interesting to work with, followed by a new line character to the file. Again, the new line character ensures that the subsequent write will be on a new line. In line 5, this line prints a message to the console, indicating that the data has been successfully written to the file. In line 6, this line closes the file. After running this code, you'll find a file named myfile2.txt in the same directory as your Python script will be overwritten. You can see the text overwritten as Python files are interesting to work with in the text file, myfile2.txt. In order to avoid this situation, we should add new text, append, to already existing text using append mode, which we shall discuss in the same video at the end. Let's see an example. For storing numeric data value in a text file, conversion to string is required. Now, look at the main code, main.py. This code is about writing text to a file named num.txt in Python. Now, look at line 2. This line opens the file named num.txt in write mode, w. It creates a file object f that allows you to interact with the file. If the file doesn't exist, it will be created. If it already exists, its content will be replaced. Line 3. X equals 45, this line assigns the numeric value 45 to the variable x. In line 4. This line writes the string learning files in Python followed by a new line character, \n to the file. This text will be the first line of the file. Line 5. This line converts the numeric value stored in the variable x, which is 45, into a string using the str function. Then, it writes this string representation of the number to the file. In line 6, this line simply prints the message write operation to the file done successfully to the console after the file write operation has been completed. This serves as a confirmation that the code has executed successfully and that the data has been written to the file as intended. It's a good practice to include such messages to keep track of the execution flow and provide feedback to the user or the programmer during the development process. In line 7. This line closes the file that was opened using the open function. It's important to close the file after you're done writing to it to make sure that all the data is properly flushed and saved. So, when you run this code, a file named num.txt will be created, or overwritten if it already exists. You can check this file on the right side, which has the content, learning files in Python, in the first line and 45 on the next line. Thus, the code demonstrates how to convert a numeric value into a string using the str function and then write both strings and converted values to a text file. Note that, while working data to a file using the write method, we must provide line separator, \n, new line feed, otherwise the entire data shall be written in a single line. Let's see another example. Python program to perform addition of two numbers in a file. This code will generate an error and no values are written to the file, newfile.txt. You can check the file empty on the right side. This is because writing numbers is not permitted to a file. Thus it is required to be converted into a string first. You need to convert num1 and num2 to a string using str function, before writing it to the file. To perform addition of two numbers in a file, modification of example 4. In line 2, this line opens the file named newfile.txt in write mode, w, and creates a file object f for writing. In line 3, this line prompts the user to enter the first number. The input function reads the input as a string, and int converts it to an integer. In line 4. Similar to the previous line, this one prompts the user to enter the second number. In line 5, this line calculates the sum of num1 and num2 and stores it in the variable sum. In line 6, this line writes the string \n number1, followed by the string representation of number1 to the file. The str function is used to convert number1 to a string before concatenating it with the rest of the text. In line 7, similarly, this line writes the string \n number2, followed by the string representation of num2 to the file. In line 8, this line writes the string \n sum of two numbers, followed by the string representation of sum to the file. In line 9, finally, this line closes the file after writing all the necessary information. This code collects two numbers from the user, calculates their sum, and then writes a series of lines to the newfile.txt file, each containing information about the numbers and their sum. Each line starts with \n to create a new line, and then the corresponding text is added using string concatenation. This creates a structured output in the file. You can check the output in the text file, named newFile.txt on the right side. In this program, the plus operator will concatenate the two strings and str method is used for type conversion from an integer to a string. Let's learn about the WriteLines method. WriteLines method is the sequence data type such as list, tuple, etc., including multiple strings, that can be written at the same time using WriteLines method in the text file. The syntax is file object, WriteLines of sequence. Here, file object is the file object that you've opened using the open function. Sequence _of strings is an iterable, like a list or a generator, containing the strings you want to write to the file. Let's see an example. Program to add list items to a file using WriteLines method. Let's see the main code, main.py. In line 2, it opens the file named myfile.txt in write mode, W. The file will be created if it doesn't exist, and if it does exist, its previous content will be cleared. In line 3, it defines a list containing 3 strings, each representing a line of text. The \n at the end of each string represents a new line character, ensuring that each line is written on a new line in the file. In line 4, it writes the contents of the list to the file using the WriteLines method. Each string in the list is written as a separate line in the file. In line 5, it displays a message indicating that the lines have been written to the file successfully. In line 6, it closes the file. It's important to close the file after writing to ensure that all data is properly flushed and resources are released. This code will work as expected, creating a file named myfile.txt with the following content, as shown on the right side, myfile.txt file, including the contents, computer science, information technology and artificial intelligence, each displayed one below the other. Note that while reading from or writing to the file, the cursor always starts from the beginning of the file. WriteLines method accepts any type of sequence as an argument. \n, new line character, is explicitly passed to WriteLines method. We have to use the \n, new line character, in the program, after the end of each list item or string. You must have noticed that till now we have used close method in all the programs to close the file in the end. Just remember that in Python, it's recommended to use a with statement when working with files to ensure proper file handling, which automatically closes the file when you're done with it. Here's how you can modify your code to use the with statement. Now look at the main code, main.py. In line 4, we have used with statement to open the file. We have already learned about the with statement in detail in Data File Handling, Part 2, Methods to Open File Using With Statement. This way, you don't need to explicitly call f.close method, because the file will be automatically closed when the with block is exited. Key points to remember. For storing data with EOL character, we have to add a new line character, \n, at the end of every sentence to mark the end of file. In case of storing numeric value, we have to either convert it into a string using str method or write it in quotes. We cannot write numeric data directly into the file. If we don't use the close method, it will not write anything into the file, as without closing the file, the resources are not released. If we write more data to an existing file, it will overwrite the previous data. Thus, the entire file will be overwritten. Therefore, in order to add data to already existing data, append mode is to be used. Let's discuss about appending data to a file. Append means to add to. So, if we want to add more data to a file which already has some data in it, we will be appending data. In such a case, use the access mode, which means open for writing, and if exists, then append data to the end of the file. In Python, we can use the mode to open an output file in append mode. This means that if the file already exists, it will not be erased. If the file does not exist, it will be created. When data is written to the file, it will be written at the end of the file's current contents. The syntax is file_object equals open of filename, a. Here, file_object is a variable that will hold the reference to the opened file. You can choose any valid variable name you like. File name should be replaced with the name of the file you want to open. A is the mode in which you want to open the file. A stands for append mode. Let's see an example. Program to add data to an existing data in the file. The given code accomplishes the task of appending data to an existing file. Now, look at the main code, main.py. It opens the file myfile.txt in append mode, writes the specified data to it, and then closes the file. Now, look at the right side text code, myfile.txt. Here the existing data "Hello everyone, welcome to Sallyann Bytes" are inside this file. Now when we append or add extra data, we are learning how to append data to an existing data in the file. This is also added with the previous text, without overwriting. You can see in the right side text box, second box. Let's see another example. Program that asks the user to input their name and age and store data in a text file. Now, look at the main code, main.py. In line 2 and 3, in these lines, the program uses the input function to prompt the user to input their name and age. The values entered by the user are stored in the name and age variables, respectively. In line 4, here, the program opens the file named user_details.txt in append mode A. This means that the program will add new content to the file without overwriting its existing content. In line 5, the program writes the user's name and age to the file, separated by a comma, and followed by a new line character, \n. The new line character ensures that the next entry will be written on a new line in the file. In line 6, after writing the user's data to the file, the program prints a success message to the console, indicating that the data has been stored in the text file. In line 7, finally, the program closes the file using the close method. It's important to close the file when you're done writing to it to ensure that the changes are properly saved and resources are freed. You can see below the user_details.txt file, where the program asks the user to input their name and age, and finally the given data is stored in the text file, one below the other. Data file handling, part 5. In this video, we are going to learn relative and absolute path and standard file streams. So, let's dive in and get started. Let's discuss about files in a computer system. Files in a computer system are typically organized into directories, also known as folders. So, what is a directory? Directories provide a way to group related files together and create a hierarchical structure for better organization and management of files. Every running program has a current directory, which is the default directory for most operations. For example, while opening a file for reading, Python looks for it in the current working directory. In Python, you can use the OS operating system module to work with files and directories. os.getCwd returns the name of the current working directory. Files are always stored in the current folder or directory by default. The OS operating system module of Python provides various methods to work with file and folder or directories. For using these functions, we have to import OS module in our program. CWD stands for current working directory. Let's learn about the file path in data file handling. In Python, a path is a string that specifies the location of a file or directory on the file system. Now, look at this picture. Here, I am working with Python IDLE to teach you the file path clearly, step by step. Now, the Python code written is saved in the directory c:\Sallyann bytes/python/file handling/files. Now, look at this Python code in the green box in line 1, import OS. This line imports the OS module, which stands for operating system. The OS module provides a way to interact with various operating system functionalities, such as file and directory manipulation. Second line, cwd equals os.getCwd function. Here, os.getCwd is a function provided by the OS module. GetCwd stands for Get Current Working Directory. When you call this function, it returns a string that represents the current working directory of your Python script or program. The current working directory is the directory or folder where your script is currently running. The returned value is assigned to the variable cwd. Finally, printf cwd, this line prints the value stored in the cwd variable. The value represents the current working directory, which is the location where your Python script is currently being executed. So, when you run this code, it will import the OS module, retrieve the current working directory using os.getCwd, and then print that directory's path to the console. This can be useful to understand where your Python script is operating and can be particularly helpful when dealing with file and directory paths in your code. You can see the output in the below box. The current working directory is c:\Sallyann bytes/python/file handling. File paths in data file handling can be either relative path or absolute path. A relative path is a path that specifies the location of a file or directory relative to the current working directory. For example, if the current working directory is c:\Sallyann bytes/python/file handling, a relative path to the myfile.txt file in the same directory would be myfile.txt. Relative paths are useful when you need to specify a file or directory location that is relative to the current working directory. Now, we will see about absolute path. An absolute path is a path that specifies the complete location of a file or directory on the file system, starting from the root directory. For example, the absolute path of c:\Sallyann bytes/python/file handling/myfile.txt file would be c:\Sallyann bytes/python/file handling/myfile.txt. Absolute paths are useful when you need to specify a file or directory location that is not relative to the current working directory. Now, look at this picture. A text file named myfile.txt is saved in a Windows path, C drive, C:/Sallyann bytes/python/file handling/myfile.txt. The green arrow marks the path. When we right-click myfile.txt and then click the properties, we can find the location of the file myfile.txt as shown below. Now, you can see the contents of myfile.txt file. Hello, everyone. Welcome to Sallyann Bytes. Today, we are learning relative and absolute path in Python. Now, we are entering into Python IDLE environment. If Python is already installed in your computer, you can work with it. Or else, install Python in your computer. In the video titled Getting Started with Python for Class 11 Computer Science, you'll find a tutorial on how to install Python on your system. Feel free to access the link provided in the description box below to watch the video. Now, look at the below picture. This is the interactive mode with the command prompt. Now to enter into script mode, click File menu. It's highlighted in red box. Now, click New File. You will enter into the script mode, where you can type data and save it and run the code, and the output displays in interactive mode. Now, we are typing the Python code in the script mode. Look at line 1. F equals open of C:/Sallyann bytes/python/file handling/myfile.txt, R. This line of code opens the file located at the specified absolute path and assigns the file object to the variable f. The path points to myfile.txt within the directory structure C:/Sallyann bytes/python/file handling. So this is the absolute file path we have given. This is the completer location of the file, starting from the root directory, C drive. In line 2. Data equals f.read function. This line reads the entire contents of the file using the read method and stores it in the variable data. Line 3, print of data. This line prints the contents of the data variable to the console, which is the text inside myfile.txt. Line 4, f.close. This line closes the file object associated with the variable f. Now, look at the output displayed. You can see the contents of myfile.txt file displayed over here. Now, look at the Python code. In line 1, f equals open of myfile.txt, R. This line of code opens the file named myfile.txt in read mode, R, and assigns the file object to the variable f. This is the relative path of the current working directory. In line 2, data equals f.read. This line reads the entire contents of the file using the read method and stores it in the variable data. In line 3, print of data. This line prints the contents of the data variable to the console, which is the text inside myfile.txt. In line 4, f.close. This line closes the file object associated with the variable f. It's good practice to close files after you're done with them to free up system resources and prevent potential issues. Now, look at the output displayed. You can see the contents of myfile.txt file displayed over here. So finally, we are thorough with the absolute path, which is a path that specifies the complete location of a file or directory on the file system, starting from the root directory, in this project, from C drive. And relative path is a path that specifies the location of a file or directory relative to the current working directory. Both gives the same output of the contents of the text file, myfile.txt, as they are in the same directory. Remember, they are in the same directory. Note that the Python program and external file must be in the same directory, else we will need to enter the file path. Here the Python program is in the directory C:/Sallyann bytes/python/file handling/file1, and the external file is in the directory C:/Sallyann bytes/python/file handling/myfile.txt. Let's discuss about the standard file streams in Python. If someone asks us to give input to a program interactive or through typing, we know what devices we need for it, like the keyboard, mouse. Similarly, in case someone states that the output that to be displayed, we know which device it will display, right? Undoubtedly that will be on the monitor. So, we can reliably say that the keyboard does the standard input device and the monitor does the standard output device. Similarly, any error if happens then determines and also displayed on the monitor. So, the monitor is also a standard error device. We use file objects to work with data file. Similarly, input or output from standard I/O devices is also performed using standard I/O stream object. We can reliably say that the keyboard does the standard input device and the monitor does the standard output device. Since we use high-level functions for performing input or output through keyboard and monitor, such as eval function, input function, and print statement, we are not required to explicitly use I/O stream object. In Python, standard file streams refer to three default streams that are used for input and output operations. They are standard input stream, standard output stream, and standard error stream. These standard streams are nothing but file objects, which get automatically connected to your program's standard devices when we start Python. In order to work with standard I/O stream, we need to import sys module. The methods which are available for I/O operations in it are read function, for reading a byte at a time from keyboard. Write function, for writing data on console, that is, monitor. The three standard streams are described as follows. Standard input, sys.stdin. This stream is used for reading input from the user or from another program. By default, it is connected to the keyboard, but you can redirect it to read from a file or another source. Standard output, sys.stdout. This stream is used for displaying output to the user or sending data to another program. By default, it is connected to the console or terminal, but you can redirect it to write to a file or another destination. Standard error, sys.stderr. This stream is used for displaying error messages or warnings to the user or another program. Like sys.stdout, it is also connected to the console by default but can be redirected. In Python, these streams are represented as file-like objects, which means you can use file operations like read and write with them. The standard way to access these streams is through the sys module, which provides access to various system-related functionality, including the standard streams. You need to import the sys module to use them. Let's see how you can interact with these standard file streams. In order to work with standard I/O stream, input-output stream, we need to import sys module. For standard input stream, we use sys.stdin.read function, or you can use readline function also. For standard output stream, we use sys.stdout.write function, and for standard error stream, we use sys.stderr.write function. Let's see an example. Program to check if division is possible using standard file streams. Now, look at the Python code. In line 1, import sys. This statement imports the sys module, allowing you to use its functionalities. In line 2, sys.stdout.writeOf, enter the first number. This line uses the write method of the stdout stream to display the message enter the first number, without adding a new line character at the end. In line 3, n1 equals int of sys.stdin.readline function. This line reads a line from the stdin stream, standard input, using the readline method, converts it to an integer using the int function, and assigns the result to the variable n1. In line 4, sys.stdout.writeOf, enter the second number. This line similarly uses the write method of the stdout stream to display the message enter the second number. In line 5, n2 equals int of sys.stdin.readline function. This line reads another line from the stdin stream, converts it to an integer, and assigns the result to the variable n2. In line 6, if n2 equal to 0. This line checks if the value of n2 divisor is equal to 0. In line 7, sys.stderr.writeOf can't be divided. If n2 is equal to 0, this line uses the write method of the stderr stream to display the message can't be divided. The stderr stream is typically used for error messages and highlighted in red color in the output. In line 8 and 9, else. If n2 is not equal to 0, this line starts the else block. sys.stdout.writeOf, division is possible. Inside the else block, this line uses the write method of the stdout stream to display the message division is possible. You can see the output. We enter the first number as 54 and the second number is 6. As the number is divisible, the message displays division is possible. Now look at the right side output. We enter the first number as 54 and the second number as 0. As it can't be divided by 0, error message in red color is highlighted as can't be divided. Let's see another Python code. Program to open a text file and read a content using standard file streams. In line 1, the import sys statement is used to import the sys module in Python, which provides access to system-specific parameters and functions. In this code, the sys module is used to interact with the standard input and output streams, as well as the standard error stream. In line 2, sys.stdout.writeOf, enter the text file to be opened. This line uses the write method of the stdout stream to display the message enter the text file to be opened, without adding a new line character at the end. This prompts the user to enter the name of the text file they want to open. In line 3, fname equals sys.stdin.readline. This line reads a line from the stdin stream, standard input, using the readline method and assigns it to the variable fname. The user's input is expected to be the name of the text file. In line 4, f equals open of fname.strip function, r. This line opens the file specified by the user's input, stored in the variable name in read mode, R. The strip method is used to remove any leading or trailing white space characters from the file name. In line 5, while true : this initiates an infinite loop, which will keep reading characters from the file until the loop is explicitly broken. In line 6, ch equals f.read of 1. Inside the loop, this line reads one character from the file using the read method with an argument of 1. The read character is stored in the variable ch. In line 7, if ch equal to empty string. This line checks if the value of ch is an empty string. If it is, it means that the end of the file has been reached, and there are no more characters to read. In line 8, sys.std_error.write of end of file reached. If the end of the file is reached, this line uses the write method of the std airstream to display the message end of file reached. The std airstream is used for error messages. In line 9, break. This keyword breaks out of the loop when the end of the file is reached. In line 10, else. If the condition in step 6 is not met, this else block is executed. In line 11, sys.stdout.write of ch. Inside the else block, this line uses the write method of the stdout stream to write the character ch to the standard output. This effectively prints the contents of the file character by character. In line 12, f.close function. After the loop, this line closes the file that was opened earlier. Now look at the output. The user enters the file name as myfile.txt. The contents in myfile.txt is completely displayed in the output. Hello everyone. Welcome to Sallyann Bytes. We are working with standard file streams in Python. Finally, the error message is displayed in red color. The message is end of file reached. Data file handling, part 6. In this video, we are going to learn binary files. What is a binary file? Reading and writing data from and into binary file, serialization, pickling, unpickling, Python pickle module, pickle.dump method, pickle.load method, and practical implementation. So, let's dive in and get started. Let's discuss about binary files. What is a binary file? A binary file is a computer file that holds special codes instead of words or pictures we can understand. These codes are like a secret language only computers know, and they're used to do important computer tasks, like showing images or playing music. Now, look at the first point. A binary file in Python is a type of file used to store non-textual data. This means that a binary file is not designed to hold human-readable text like sentences or paragraphs. Instead, it's intended to store data that doesn't have a natural textual representation, such as images, audio, video, or program code. It contains data in its raw form, represented as sequences of bytes. This means binary files are like data blueprints. They're made up of tiny building blocks called bytes, each representing a number from 0 to 255. These bytes hold important secrets, like pictures, sounds, and computer instructions. Understanding them can be like reading a secret code and might need special tools or knowledge. Third point. Binary files are used to store various types of data, such as images, audio, video, executables, and serialized objects. Most of the files that we see in our computer system are called binary files. For example, document files, image files, video files, audio files, database files, archive files, executable files. Unlike text files, binary files do not use character encoding and store data as is, without transformation. In text files, characters are encoded using a specific character encoding like UTF-8, which allows humans to read and understand the content. Binary files, on the other hand, do not involve encoding characters. They store the actual bytes of data without any attempt to interpret or transform them into human-readable characters. The data in binary files might represent things like color values, sound waveforms, or machine instructions. These bytes might not make sense when viewed as text. Now, come to the next point. Python's built-in open function is used to work with binary files. Binary files are opened in either read mode, RB, for reading, or write mode, WB, for writing. Reading from a binary file involves using the read method to retrieve bytes from the file. Writing to a binary file involves using the write method to store bytes in the file. Let's discuss about reading and writing data from or into binary file. To write a structure such as list or dictionary to a binary file and read it subsequently, we need to use the Python module pickle. The module pickle is used for serializing and deserializing any Python object structure. So, what is serialization? Serialization is the process of converting complex data structures into a format that can be easily stored, transmitted, or shared. Serialization is like turning your favorite toy into a picture so you can put it in a box, send it to a friend, and they can use the picture to make the toy look exactly the same again. So, serialization is the process of transforming data or an object in memory, RAM random access memory, to a stream of bytes called byte streams. These byte streams in a binary file can be stored in a disk or in a database or sent through a network. Serialization is commonly used in programming to save the state of objects, lists, dictionaries, and other data structures. Serialization is also called pickling. So, what is meant by pickling? Pickling in Python refers to the process of converting a Python object into a binary representation. It means the process to convert any kind of Python objects such as list, dictionary, etc., which is human-readable form, into byte streams, that is, zeros and ones, machine-readable form is called pickling. It's like putting the object into a jar so you can save it or send it somewhere else. The pickle module in Python is used for pickling. Pickling is used to save complex data structures, like lists, dictionaries, and even custom objects, in a way that they can be stored or transmitted. The resulting pickled file is binary and not human-readable. Why it is called so? The name pickle comes from the concept of pickling in cooking, which refers to the process of preserving food by storing it in a container. In the same way, the Python pickle module preserves and stores objects by converting them into a byte stream. Now, look at this picture. Pickling refers to the process of converting the Python objects or structure to a byte stream, machine-readable, before writing to a binary file. Unpickling is the process of taking a pickled binary file and converting it back into a Python object. That means, we can convert the byte stream, zeros and ones, generated through pickling, back into Python objects by a process called unpickling. It's like opening the jar and getting the object out. The pickle module is also used for unpickling. Unpickling restores the original data structure, including all the values and relationships. This is useful when you want to use or manipulate the saved data in your program again. However, be cautious when unpickling data from untrusted sources, as malicious code could be hidden in pickled objects. In short, pickling and unpickling are ways to store and retrieve complex Python data structures using a binary format. Now, look at this picture. Unpickling refers to a reverse process where the byte stream, zeros and ones, machine-readable, is converted to the original structure, human-readable. We know that the methods provided in Python for writing or reading a file work with string parameters. So, when we want to work on a binary file, conversion of data at the time of reading as well as writing is required. Pickle module can be used to store any kind of object in a binary file as it allows us to store Python objects with their structure. So, for storing data in a binary format, we will use pickle module. The steps to perform read and write operations on a binary file are: Step 1. Import the pickle module using import pickle statement. It provides two main methods, dump and load. Step 2. Open a binary file with the required access mode. For creation of a binary file, we will use pickle.dump method to write the object in file, which is opened in binary access mode. The syntax of dump method is dump of object, file object. Step 3. For reading data from a file, we have to use pickle.load method to read the object from pickled file. The syntax of load method is object equals load of file object. Note that we need to call load method each time dump method is called. Step 4. Once all required operations are done on a binary file, it is to be closed using close method. Python pickle module is used for implementing the binary file structure. Dump and load functions are used for pickling and unpickling the binary files, respectively. Let's see a program to write structure, list in the binary file. Now, look at the main code, main.py. In line 2, the f operation function is defined. This function is responsible for writing a list of numbers to a binary file using the pickle module. In line 3, the pickle module is imported. This module provides a way to serialize and deserialize Python objects, allowing them to be saved to files and read back later. In line 4, a list named list1 containing numbers 10, 20, 30, 40, 50 is created. In line 5, the program opens a binary file named list.dat in write binary mode, WB. This mode allows you to write binary data to the file. In line 6, the pickle.dump function is used to serialize and write the contents of list1 to the binary file f. This function takes two arguments, the object you want to serialize and the file object to write to. In line 7, a message list added to binary file is printed to indicate that the list has been successfully written to the binary file. In line 8, the file is closed using f.close method to ensure that all data is properly written and resources are released. In line 9, finally, the f operation function is called to execute the operations defined within it. When you run the program, the operations defined within the f operation function are executed. As a result, the list 10, 20, and 30, 40, 50 is serialized using the pickle module and written to the binary file list.dat. The message list added to binary file is printed to the console to indicate that the operation was successful. Now look at the right side of the screen. If you were to examine the contents of the list.dat file after running the program, you would find the binary representation of the serialized list. This binary data wouldn't be directly human readable, as it's meant to be interpreted and deserialized using the pickle module in a Python program. Example 2. Python program to write structure, dictionary to the binary file. Now, look at the main code, main.py. In line 2, the pickle module is imported. This module provides a way to serialize and deserialize Python objects, which allows them to be saved to files and read back later. In line 3, a dictionary named dict1 is created. This dictionary contains key-value pairs representing subjects and corresponding scores. In line 4, the program opens a binary file named bin_file.dat in write binary mode, WB. This mode allows you to write binary data to the file. In line 5, the pickle.dump function is used to serialize and write the contents of dict1 to the binary file f. This function takes two arguments, the object you want to serialize, in this case, the dictionary dict1, and the file object to write to. In line 6, a message dictionary added to binary file is printed to indicate that the dictionary has been successfully written to the binary file. In line 7, the file is closed using f.close to ensure that all data is properly written and resources are released. The program essentially writes the dictionary dict1 into a binary file named bin_file.dat using the pickle module for serialization. The data is stored in binary format, which can be used later to deserialize and reconstruct the original dictionary using the pickle.load function. After running the program, you should see the printed message dictionary added to binary file on the console, indicating that the dictionary has been successfully written to the binary file. If you were to examine the contents of the bin_file.dat file after running the program, you wouldn't see the actual dictionary content in a human-readable form. You can check the contents below of the screen. Instead, you would see the serialized binary data that represents the dictionary, which is not much in human-readable form. This binary data is meant to be interpreted and deserialized using the pickle module in a Python program to retrieve the original dictionary. Let's see how to write a Python program to read dictionary items from the binary file. Now, look at the main code, main.py. The given code is a Python program that demonstrates how to read the contents of a Python dictionary from a binary file using the pickle module. Now, look at line 2, import pickle. This line imports the pickle module, which provides a way to serialize and deserialize Python objects, allowing you to save and load complex data structures like dictionaries. In line 3, f equals open of bin_file.dat, rb. This line opens a binary file named bin_file.dat in read binary mode, rb. The rb mode is used because pickle deals with binary data. The file should contain serialized dictionary data. In line 4, dict1 equals pickle.load of f. This line uses the pickle.load function to deserialize the content of the binary file and load it into the variable dict1. This assumes that the content of the file is a serialized Python dictionary. In line 5, f.close function. After reading the dictionary content, the file is closed using the close method to free up system resources. In line 6, printf dict1. Finally, the code prints the content of the deserialized dictionary, dict1, to the console. This will display the key-value pairs stored in the dictionary. You can see the output displayed in human-readable format. Data file handling, part 7. In this video, we are going to learn binary operations, inserting or appending a record in a binary file, reading a record from a binary file, searching a record in a binary file, updating a record in a binary file, and practical implementation. So, let's dive in and get started. We already learned in the previous video about Python pickle module. Pickle module can be used to store any kind of object in a binary file as it allows us to store Python objects with their structure. For storing data in a binary format, we will use pickle module. We also learned the steps to perform read and write operations on a binary file. Mainly we learned about importing pickle module using import pickle statement. It provides two main methods, dump and load. The syntax of dump method is dump, object, file object. Syntax of load method is object equals load of, file object. Binary files store data in a format that is not human-readable and is optimized for efficiency. Here are 4 major operations that can be performed using binary files in programming. Inserting or appending a record in a binary file, reading a record from a binary file, searching a record in a binary file, and updating a record in a binary file. let's see one by one in detail. Let's see about inserting or appending a record into a binary file. Inserting or appending a record into a binary file requires importing pickle module into your program followed by dump method to write onto the file. Let's see an example. Now, look at the Python code. In line 2, it starts by importing the pickle module, which allows for easy serialization and deserialization of Python objects. In line 3, an empty list called record is created to store the student records. In line 4, 5, 6, 7, a loop is used to repeatedly take input from the user for roll number, name, and marks of the student. In line 8, this data is then packed into a list called data. In line 9, the data list is appended to the record list, creating a list of lists containing all the student records. In line 10, 11, 12, the user is asked whether they want to add more records. If the user enters n, case insensitive, the loop breaks. In line 13, the file student is opened in binary write mode, WB. This creates or overwrites the file if it already exists. In line 14, the pickle.dump function is used to serialize the record list and write it to the file. In line 15, a message is printed to indicate that the record has been added. In line 16, finally, the file is closed using f.close to ensure proper resource management. So now look at the right side of the screen. The input is accepted from the user. The user is prompted to enter the roll number, name, marks. If the user wished to add more records, the user presses Y for yes and adds some more records. If he pressed N for no, the message displays record added. So, where is the record added? The record is now added into the student file. So now, look at the below screen. When we open the student file, you can see the contents of the student details which we have entered in binary write mode, where the contents are in binary form, which is not human readable. It is difficult to read and understand, but it is directly used and understood by the computer. So, once again, I summarize this example of inserting or appending a record into a binary file. In this code, inserting and adding a record in student file begins with importing pickle module. Then, treating for the number of records to be added is done using while loop. Input is accepted from the user for roll number, name and marks. These fetched values are saved as a list to be appended. Once the record is created, it is appended to the binary file student using the dump method, which writes the object onto the opened file. Finally, the file is closed explicitly and the record is added into the student.dat file as shown below the screen, in the output, which is in binary form, unreadable characters, but understood by the computer. Now, let's see about reading a record from a binary file. That is, how a record is read from a binary file. This Python program demonstrates how to read records from a binary file named student.dat using the pickle module. The student.dat file contains serialized objects that represent student records, each containing information like roll number, name, and marks. Now, look at the Python code. In line 2, import the pickle module, which is used for serializing and deserializing Python objects. In line 3, open the binary file student in read mode, RB. The RB mode stands for read binary, which is used to read binary files. In line 4, use pickle.load of f to deserialize the object stored in the binary file. This line reads the serialized data from the file and reconstructs the original Python object. In this case, the serialized object represents a list of student records. In line 5, print a message indicating the contents of the student file are going to be displayed. In line 7, 8, 9, 10, loop through each record in the student_record list. Inside the loop, extract the roll number, name, and marks from the current record, R, by indexing the list. The roll number is at index 0, the name is at index 1, and the marks are at index 2. In line 11, print the extracted roll number, name, and marks using the print function. In line 12, close the file using the f.close statement to free up system resources. Now, once again, I summarize this example of reading a record from the binary file student.dat. This program deals with reading the contents from binary file student using load method of pickle module. It is used to read the object from the opened file. The syntax for this is given by the statement, object equals pickle.load of file. Once the contents are read, it gets stored inside the object, student_record. All the data of the respective fields from this object is held in the respective variables, roll_number, name, and marks and are finally displayed as the output. You can check the output displayed on the console. Now, let's see about searching a record in a binary file. Program to search a record from the binary file student.dat in the basis of roll number. Now, look at the Python code. This Python code is a program that reads records from a binary file named student.dat and searches for a specific student's information based on their roll number. The program uses the pickle module to serialize and deserialize Python objects for storing and retrieving data from the binary file. Now, look at line 2. The import pickle statement imports the pickle module, which provides functionality for serializing and deserializing Python objects. In line 3, the f equals open, student, rb, line opens the file named student in binary read mode, rb. This means that the file is opened for reading as binary data. In line 4, the student_record equals pickle.load, f, line reads the object stored in the binary file using the pickle.load function. This object is expected to be a list of student records. The contents of the binary file are deserialized into the student_record variable. In line 5, it sets the found variable to 0. In line 6, the program then prompts the user to enter a roll number to search for using the RNO equals int of input of enter the roll number to search line. The user is expected to input an integer roll number. In line 7, the code enters a loop using for r in student_record to iterate through each student record in the student_record list. In line 8, inside the loop, the program checks if the roll number, r of 0, of the current record matches the roll number entered by the user, or no. In line 9, if a match is found, it prints a message indicating a successful search and displays the student's name, r of 1. In line 10, it then sets the found variable to 1 to indicate that the record was found, and breaks out of the loop using break. In line 12, after the loop completes, the program checks if the found variable is still 0. If found is 0, it means that no record with the specified roll number was found, so, in line 13, it prints a record not found message. In line 14, finally, the code closes the binary file using f.close to release the resources associated with the file. Let's recall. This code reads a list of student records from a binary file, allows the user to input a roll number, and searches for a matching student record. If a matching record is found, it prints the student's name. If no matching record is found, it prints an error message. Now, look at the contents of the student file in the right side of the screen for your reference. Now, look at the output. When the roll number is entered as 1111, the output is successful search Alice found. When roll number is given as 1118, which is not in the student file, the message displayed is sorry, record not found. Now, let's see about updating a record in a binary file. Program to update the name of the student from the binary file. This program requires roll number to be fetched from the user whose name is to be update. This Python code is a program that allows you to update the name of a student in a binary file containing student records. The program uses the pickle module for reading and writing data in a serialized format. Now, look at line 2. The code begins by importing the pickle module with the line import pickle. In line 3, the f equals open, student, rb plus, line opens the file named student in binary read and write mode, rb plus. This means the file is opened for both reading and writing binary data. In line 4, the student_record equals pickle.load of f, line reads the object stored in the binary file using the pickle.load function. The object is expected to be a list of student records. The contents of the binary file are deserialized into the student_record variable. In line 5, it is set 0 to the variable found. In line 6, the program then prompts the user to enter a roll number to search for using the RNO equals int of input of enter the roll number to search line. The user is expected to input an integer roll number. In line 7, the code enters a loop using for r in student_record to iterate through each student record in the student_record list. In line 8, inside the loop, the program extracts the roll number from the current student record with our number equals r of 0. In line 9, the code then checks if the extracted roll number, RNO, matches the roll number entered by the user, RNO. In line 10, if a match is found, it prints the current name of the student, r of 1, then in line 11, it prompts the user for a new name with r of 1 equals input of new name. In line 12, after updating the name, the found variable is set to 1 to indicate that the record was found, and the loop is broken using break in line 13. In line 14 and 15, if a record was found, that is, found equals 1, the program seeks the beginning of the file using f.seek of 0 to ensure that the file pointer is positioned at the start of the file. In line 16, the updated student_record list is then written back into the binary file using pickle.dump of student_record, f to overwrite the existing data with the updated student record. Finally, in line 17, the program prints a message indicating that the name has been updated, and in line 18, the file is closed using f.close method to release the resources associated with the file. In line 19, after updating the student record in the binary file, the code reopens the same binary file in read mode using f equals open, student, rb. In line 20, the line student_record equals pickle.load, f, reads the updated object from the binary file, which now contains the modified student records after the name update. In line 21, the file is then closed again using f.close to release its resources. In line 22, finally, the print student_record line prints the entire student_record list, showing the updated records. This part of the code is intended to display the modified student records after updating the name. It's a way to confirm that the name update was successful and that the changes were saved in the binary file. In summary, the entire code reads student records, allows the user to update a student's name based on a roll number, writes the updated records back to the binary file, and then reopens and prints the updated records to verify the changes. Let's check the output on the console. The roll number to be searched is given as 1110. Current name is Sam. We update the new name Alex. So now, you can see in roll number 1110, new name Alex is updated. Data file handling, part 8. In this video, we are going to learn random access in file using tell and seek methods with practical implementation and visualization of how the cursor pointer moves through the code. So, let's dive in and get started. Let's learn about random access in files using tell and seek methods. Random access in files refers to the ability to read or write data at any location within a file, rather than just sequentially from the beginning to the end. In real-world scenarios, files can be large, and it's often necessary to read or write data at specific positions within the file. In many programming languages, including Python, you can achieve random access in files using the tell and seek functions. When we open a file to perform read or write operation, there is a cursor, a blinking cursor, which move inside the file. Whatever the operation, read or write, we perform, that operation will be done at the cursor position. Within a file, we can get the current position of cursor and move the cursor. To do this, Python gives us two functions, tell and seek methods. Let's learn about the seek method. Seek function is used to change the position of the file handle, file pointer, to a given specific position. That means, seek method is used to move the file pointer to a specified position within the file. File pointer is like a cursor, a blinking cursor, which defines from where the data has to be read or written in the file. Seek method can be done in two ways: absolute positioning and relative positioning. Absolute positioning or referencing using seek method gives the file number on which the file pointer has to position itself. That means, an absolute offset prescribes the exact point where the file pointer should reside. The syntax of seek method is f.seek of file_location, where f is the file pointer. Example, f.seek of 20. This will give the position or file number where the file pointer has been placed. This statement shall move the file pointer to 20th byte in the file no matter where you are. Relative positioning or referencing using seek method has two arguments. Offset, the number of bytes to move the file pointer. Second argument is the position from which it has to traverse. Syntax of seek method is f.seek of offset, from_what method, where f is the file pointer. The reference point is defined by the from_what argument. It can have any of the three values. 0 value sets the reference point at the beginning of the file by default. 1 value sets the reference point at the current file position. 2 value sets the reference point at the end of the file position. Let's see some examples. f.seek of -10, 1. From current position, move 10 bytes backward. f.seek of 10, 1. From current position, move 10 bytes forward. f.seek of -20, 1. From current position, move 20 bytes backward. f.seek of 10, 0. From beginning of file, move 10 bytes forward. Let's discuss about the tell method. Tell method returns the current position of the file read or write pointer within the file. If we have moved our file pointer through seek method, tell method is used to tell the position where file pointer is currently pointing to. Syntax of tell method is f.tell method, where f is the file pointer. When you open a file in reading or writing mode, the file pointer rests at 0th byte. When you open a file in append mode, the file pointer rests at the last byte. Key points to remember. It must be remembered that Python 3.x only supports text file seeks from the beginning of the file. Seek method with negative offset only works when the file is opened in binary mode. Let's see some examples. Here, explanation is done clearly for this example, and you can see the visualization of how the cursor pointer moves through the code in the next screen. So listen carefully. First, let's create a text file named filenew.txt. You can see the first box holding contents. Welcome to Sallyann Bytes. Now look at the next box. It contains the main code. The given code demonstrates the usage of the seek and tell methods for file handling in Python. Let's break down what each part of the code does. Now look at line 1. F equals open of filenew.txt, comma, r. This line opens the file filenew.txt in read mode, r, and assigns the file object to the variable f. In line 2, print of initial cursor position, comma, f.tell method. The tell method returns the current position of the file pointer in terms of the number of characters. Initially, when the file is opened, the file pointer is at the beginning of the file. So, this line will print the initial position of the file pointer, which is 0. In line 3, f.seek of 5. The seek method is used to move the file pointer to a specific position within the file. In this case, it moves the file pointer to the 5th character in the file. Since the file pointer was initially at the beginning, this operation moves it to the 5th byte after O in welcome. In line 4, print of reading data, comma, f.read method. The read method, without specifying a character limit, reads from the current file pointer position to the end of the file. In this case, it reads and prints everything from the character m in welcome to the end of the file. In line 5, print of final cursor position, comma, f.tell method. After the read operation, the file pointer is at the end of the file. This line will print the final position of the file pointer, which is after the number of characters in the file, that is 27. Let's see the output. The initial position of the file pointer is 0. After seek of 5, the file pointer is at position 5. Read method reads and prints the content from the em in welcome to the end of the file, so it outputs me to Sallyann bytes. After the read operation, the file pointer is at the end of the file, so it's positioned at the 27th byte. Now, let's visualize how the cursor pointer moves through the code. Let's see how it works. You can see the initial cursor position within the file is at 0th byte. After moving the file pointer to the 5th byte using seek of 5, the content is read from me to Sallyann bytes. You can also see the final cursor position within the file is at 27th byte. Let's see another example to illustrate seek and tell functions. Here, explanation is done clearly for this example, and you can see the visualization of how the cursor pointer moves through the code in the next screen. So listen carefully. In a text file named filenew.txt, you can see it holding contents. Welcome to Sallyann bytes in the first box. Now look at the next box. It contains the main code. The given code demonstrates the usage of the seek and tell methods for file handling in Python. Let's break down what each part of the code does. In line 1, f equals open of filenew.txt, comma, r. This line opens the file filenew.txt in read mode, r, and assigns the file object to the variable f. In line 2, print of initial cursor position, comma, f.tell method. The initial position of the cursor pointer is 0, so it prints initial cursor position 0. In line 3, f.seek of 5. The cursor pointer moves to the 5th byte after character O in welcome, so it sets the cursor pointer to position 5. In line 4, print of current cursor position, comma, f.tell method. The cursor pointer is now at position 5, so it prints current cursor position is 5. In line 5, f.seek of 10. The cursor pointer moves to the 10th byte, which is the space before Sallyann. In line 6, print reading data, comma, f.read of 6. It reads 6 characters starting from the current cursor pointer position, which is at the space before Sallyann, so it reads and prints space S-A-L-L-Y. Totally 6 characters, including the space. In line 7, print of final cursor position, comma, f.tell method. After the read of 6 operation, the cursor pointer is at the position right after space Sally, so it prints final cursor position as 16. Starting from space before Sallyann and until the end of the file. In line 8, f.close method. This line closes the file, releasing any resources associated with it. You can see the output displayed as initial cursor position 0. Current cursor position 5, reading data, space Sally, final cursor position 16. Now, let's visualize how the cursor pointer moves through the code. The initial cursor position within the file is 0th byte. Current cursor position after seek of 5 is after letter O in welcome. Current cursor position after seek of 10 is before space of Sallyann, reading data f.read of 6 is space Sally. Totally 6 characters, including the space, in front of letter S in Sally. Final cursor position within the file is at 16th byte. The cursor starts from space before Sallyann and ends at the end of the file, that is 16th byte. Let's see another example. Program to read byte by byte from a file using seek and tell functions. A text file named filenew.txt is already created. You can see the first box holding contents, "Welcome to Sallyann Bytes." Now look at the next box. It contains the main code. In line 1, f equals open of filenew.txt, r. This line opens a file named filenew.txt in read mode, r, and assigns the file object to the variable f. In line 2, print of, before reading, f.tell method. The tell method returns the current file pointer position, which is the byte offset from the beginning of the file. This line prints the current position before any reading is done. In line 3, s equals f.read method. The read method is used to read the entire contents of the file. Here, it reads the entire file content, "Welcome to Sallyann Bytes," and assigns it to the variable s. In line 4, print, after reading, f.tell method. After reading the entire file, the file pointer is now at the end of the file. This line prints the file pointer's position to show that it has moved. In line 5, f.seek of 0. The seek method is used to move the file pointer to a specified position within the file. Here, it moves the file pointer to the beginning 0th byte of the file. In line 8, print of from the beginning again, f.tell method. After using seek of 0 to move the file pointer, this line prints the file pointer's position to confirm that it's at the beginning of the file again. In line 9, s equals f.read of 4. The read method can also take an argument that specifies the number of bytes to read from the file. This line reads the first 4 bytes from the file and assigns them to the variable s. Here it prints first 4 bytes WELC. In line 11, print of f.tell method. After reading 4 bytes, the file pointer has moved to the 4th byte position. This line prints the updated file pointer position. Here you can check the output for on the console. In line 12, s equals f.read of 3. This line reads the next 3 bytes from the file and assigns them to the variable s. In line 13, it prints the data read from the file as OME. In line 14, print of f.tell method. After reading 3 more bytes, the file pointer has moved to the 7th byte position. This line prints the updated file pointer position. You can check the output displayed 7 on the console. In line 15, f.close method. Finally, the close method is used to close the file. This is an important step to release system resources associated with the file. Let's visualize how the cursor pointer moves through the code. In line 2, print of, before reading, f.tell method. The tell method returns the current file pointer position, which is the byte offset from the beginning of the file. This line prints the current position before any reading is done. You can also check the output on the console before reading 0. In line 3, s equals f.read method. The read method is used to read the entire contents of the file. Here, it reads the entire file content, "Welcome to Sallyann Bytes," and assigns it to the variable s. In line 4, print, after reading, f.tell method. After reading the entire file, the file pointer is now at the end of the file. This line prints the file pointer's position to show that it has moved. You can also check the output on the console after reading 27. In line 5, f.seek of 0. The seek method is used to move the file pointer to a specified position within the file. Here, it moves the file pointer to the beginning 0th byte of the file. In line 8, print of from the beginning again, f.tell method. After using seek of 0 to move the file pointer, this line prints the file pointer's position to confirm that it's at the beginning of the file again. You can also check the output on the console from the beginning again 0. In line 9, s equals f.read of 4. The read method can also take an argument that specifies the number of bytes to read from the file. This line reads the first 4 bytes from the file and assigns them to the variable s. Here it prints first 4 bytes WELC. You can check the output, first 4 bytes are WELC, on the console. In line 11, print of f.tell method. After reading 4 bytes, the file pointer has moved to the 4th byte position. This line 11 prints the updated file pointer position. Here it prints 4, you can check the output for on the console. In line 12, s equals f.read of 3. This line reads the next 3 bytes from the file and assigns them to the variable s. In line 13, it prints the next 3 bytes, OME. You can check the output displayed OME on the console. In line 14, print of f.tell method. After reading 3 more bytes, the file pointer has moved to the 7th byte position. This line prints the updated file pointer position. You can check the output displayed 7 on the console. Data file handling, part 9. In this video, we are going to learn Introduction to CSV files, why use CSV file handling in Python, reading from a CSV file with practical implementation. So, let's dive in and get started. In data file handling, there are three types of files: text file, binary file, and CSV file. We have already learned about text file and binary files in the previous video's data file handling part 1 to part 8. Now we are learning CSV files. Sharing data is a big deal in workplaces today, and people often use spreadsheets or databases to do it. A simple way to share data is through something called a CSV file, which stands for comma-separated values. CSV files are like lists of information organized in rows and columns, kind of like a table. Each row in a CSV file is like a piece of information, and the values in each row are separated by commas. CSV files are easy to read because they're like plain text that humans can understand. They're great for keeping tabular data, which means stuff like numbers and text in a table. Programs like Microsoft Excel or OpenOffice Calc can use CSV files to put data in tables and take data out of them. So, when people want to share data in a simple way, they use CSV files because they work with programs we use a lot. CSV stands for comma-separated values. Thus, we can say that a comma-separated file is a delimited text file that uses a comma to separate values. What is a CSV file? CSV, comma-separated values, is a plain text file format that represents tabular data, with values separated by a delimiter, usually a comma, and each line corresponding to a record. It's commonly used for storing and exchanging structured data between different applications and platforms. Let's see the features of a CSV file. CSV file stands for comma-separated values. It is used for storing tabular data in spreadsheet or database. Each line of the file is known as a data or record. Each record consists of one or more fields, separated by commas, also known as delimiters, that is, each of the records is also a part of this file. Tabular data is stored as text in a CSV file. The use of comma as a field separator is the source of the name for the file format. It stores our data into a spreadsheet or a database. Note, the most commonly used delimiter in a CSV file is usually a comma. Why use CSV file? Advantages of CSV files. CSV files are simple, small in size, faster and easy to work with. CSV files are universally supported for data interchange. It's easy to generate and import onto a spreadsheet or database. It's compatible with Python's built-in libraries. It's ideal for data analysis with popular libraries like Pandas and NumPy. It's human-readable, lightweight, and easy to edit manually. It's platform-agnostic and suitable for version control. That is, CSV files are processed by almost all existing applications. Let's discuss about the CSV file handling in Python. CSV is an inbuilt module used to read and write tabular data in CSV format. Therefore, to perform read and write operations with CSV file, we must import CSV module. CSV module can handle CSV files correctly regardless of the operating system on which the files were created. Along with the module, open function is used to open a CSV file and return file object. We load the module in the usual way using import. Import CSV. Like other files, text file and binary files, in Python, there are two basic operations that can be carried out on a CSV file. First one is reading from a CSV file, and the second one is writing to a CSV file. Let's discuss reading from a CSV file. Let's discuss about reading from a CSV file. Reading from a CSV file using the csv.reader object in Python. First, we have to open CSV file. To read from a CSV file, use Python's built-in open function to open the file in our read mode, obtaining a file object. Next point is to create CSV reader object. Utilize the csv.reader function to create a CSV reader object, passing the file object as an argument. This reader object is used to interact with the CSV data. Third point is to iterate over rows. The CSV reader object is an iterable that allows you to access each line of the CSV file as a list of fields. You can loop through the reader object to iterate over each row in the CSV file. Each row is returned as a list of strings. Next point is to use next function for advancing. You can use the next function directly on the reader object to read the next line of the CSV file. This is useful for skipping header rows or reading specific rows. Next point is to for loop to read all rows. Alternatively, you can treat the CSV reader object like a list in a for loop to read all the lines of the file, with each line represented as a list of fields. In essence, the reader object simplifies the process of reading CSV data by providing an iterable interface for accessing and processing each row in the file as a list of fields. Before reading from a CSV file, at first, enter the student details in Excel spreadsheet and select File, Save as option. Type the name of the file as student and select CSV, delimited.csv, format from Save as type option. Click Save button. You can see the Excel spreadsheet containing the details of the 10 students, saved in file name, student.xls. Next step is to open the notepad and open student.csv file that contains equivalent data for student.xls in comma-separated values. You can see the notepad here, containing the same contents of student details. In student.csv, notepad file, you can see the file line in the header and remaining lines are the data or records. The fields are separated by comma, or we may say the separator character. In general, the separator character is called a delimiter, and the comma is not the only one used. Other popular delimiters include the tab, \t, colon, and semicolon characters. Let's see an example. Write a Python program to read the contents of student.csv files. Now, look at the Python code. I have worked in Python IDLE. So now, let's look at the Python code. This Python program reads the contents of a CSV file named student.csv using the CSV module. Here's a step-by-step explanation of the code. In line 2, import CSV. This line imports the CSV module, which provides functionality for working with CSV files. In line 3, f equals open student.csv, r. This line opens the student.csv file in read mode, r, and assigns it to the variable f. This creates a file object that you can use to interact with the file. In line 4, csv_reader equals csv.reader of f. Here, the csv.reader function is used to create a CSV reader object called csv_reader. This object is specifically designed to read and parse CSV data from the file. In line 7, for row in csv_reader : This for loop iterates through each row in the CSV file using the csv_reader object. In each iteration, row represents a single row of data from the CSV file as a list of strings. Each element in the list corresponds to a field in that row. In line 8, print of a row. Inside the loop, this line prints the current row. You can replace this line with any code to process or manipulate the data as needed. In line 9, f.close. Finally, after reading the CSV file, the program explicitly closes the file using the close method. It's good practice to close files when you're done with them to free up system resources. So, this program opens the student.csv file, creates a CSV reader object to parse its contents, iterates through each row, and prints each row to the console. It's a basic example of reading CSV data from a file in Python. As seen in this output, every record is stored in reader object in the form of list. List is enclosed in square brackets. Thus all the records are displayed as lists separated by comma. Example 2. Write a Python program to read the contents of student.csv file using with open method. Now, look at the Python code. This Python program reads the contents of a CSV file named student.csv using the with open method along with the CSV module. Here's a step-by-step explanation of the code. In line 2, import CSV. This line imports the CSV module, which provides functionality for working with CSV files. In line 3, with open of student.csv, r as csv_file. This line uses the with open statement to open the student.csv file in read mode, r. The with statement is used here to ensure that the file is properly closed when you're done with it. The file object is assigned to the variable csv_file. In line 4, reader equals csv.reader of csv_file. This line creates a CSV reader object named reader using the csv.reader function. This object is specifically designed to read and parse CSV data from the file specified by csv_file. In line 5, rows equals empty square bracket. This line initializes an empty list named rows. This list will be used to store the data from the CSV file. In line 6, for rec in reader. This for loop iterates through each row or record in the CSV file using the reader object. In each iteration, rec represents a single row of data from the CSV file as a list of strings. Each element in the list corresponds to a field in that row or record. In line 7, rows.append of rec. Inside the loop, this line appends the current row to the rows list. This effectively collects all the rows from the CSV file into the rows list. In line 8, print rows. After the loop completes, this line prints the entire rows list, which now contains all the data from the CSV file. So, this program opens the student.csv file, creates a CSV reader object to parse its contents, iterates through each row, appends each row to a list, and finally prints the entire list of rows, effectively displaying the contents of the CSV file. You can see the output displayed here. The output will be a list of lists, where each inner list represents a row from the CSV file, and the elements of the inner lists are the individual fields, columns, of the CSV data. This output represents the contents of the student.csv file, where each inner list corresponds to a row in the CSV file, and the elements within each inner list represent the values in that row's columns. Example 3. Write a Python program to count the number of records present in student.csv file. The provided program counts the number of records, rows, present in the student.csv file using the CSV module in Python. Here's a step-by-step explanation of the code. Now, look at line 2, import CSV. This line imports the CSV module, which provides functionality for working with CSV files. In line 3, f equals open of student.csv, r. This line opens the student.csv file in read mode, r, using the open function and assigns the file object to the variable f. This creates a file object that you can use to interact with the file. In line 4, csv_reader equals csv.reader of f. Here, the csv.reader function is used to create a CSV reader object named csv_reader. This object is specifically designed to read and parse CSV data from the file specified by f. In line 5, c equals 0. This line initializes a variable c to 0. This variable will be used to count the number of records, rows, in the CSV file. In line 7, for row in csv_reader. This for loop iterates through each row in the CSV file using the csv_reader object. In each iteration, row represents a single row of data from the CSV file as a list of strings. Each element in the list corresponds to a field in that row. In line 8, c equals c plus 1. Inside the loop, this line increments the c variable by 1 for each row read. This effectively counts the number of rows in the CSV file. In line 9, print, number of records are c. After the loop completes, this line prints the value of c, which is the count of records, rows, in the CSV file. It displays the total number of records. In line 10, f.close. Finally, after counting the records, the program explicitly closes the file using the close method. It's good practice to close files when you're done with them to free up system resources. So, when you run this program, it will open the student.csv file, iterate through its rows, count the records, print the count, and then close the file. The output will be something like this shown in the screen. This output indicates that there are 11 records, rows, in the student.csv file. One of the important observations from the output is the number of records which is being displayed as 11 instead of 10. This is so because the header, first line, in the student.csv.file is also treated as a record only. This limitation is overcome in the next example. Example 4. Write a Python program to count the exact number of records present in student.csv file excluding the header. Now, look at the Python code. In line 2, import CSV. This line imports the CSV module, which provides functionality for working with CSV files. In line 3, f equals open student.csv, r. This line opens the student.csv file in read mode, r, using the open function and assigns the file object to the variable f. This creates a file object that you can use to interact with the file. In line 4, csv_reader equals csv.reader of f. Here, the csv.reader function is used to create a CSV reader object named csv_reader. This object is specifically designed to read and parse CSV data from the file specified by f. In line 5, csv rows equals empty square brackets. This line initializes an empty list named csv rows. This list will be used to store the data rows from the CSV file, excluding the header row. In line 6, value is assigned to 0. In line 7, for row in csv_reader:. This for loop iterates through each row in the CSV file using the csv_reader object. In each iteration, row represents a single row of data from the CSV file as a list of strings. Each element in the list corresponds to a field in that row. In line 8 and 9, if csv_reader.line_number equal to 0:. Here, we have used line_number object of CSV file. Our csv_reader_ object has a method called line_number that returns the number of lines in our CSV. Then if statement in line 8 checks if the line is the first line or not. If the condition is true, that is, if it is the header line, then it is ignored using continue statement and the counting of records is resumed from the second line onwards. In line 10, csvrows.append of row. Inside the loop, for rows other than the header, this line appends the current row to the CSV rows list. This effectively collects all the data rows from the CSV file, excluding the header row. In line 11, after the loop completes, the code calculates the number of data rows, records, by using len of list of CSV_reader. The len function counts the number of elements, rows, in the CSV rows list. In line 12, print, number of records are, value. Finally, the program prints the count of records, excluding the header, to the console. The count is stored in the value variable. In line 13, f.close. After counting the records, the program explicitly closes the file using the close method. This is good practice to free up system resources. You can check the output now, as 10 records. Line_number object always stores the current line in consideration, and hence the correct output for 10 records is so obtained. Example 5. Write a Python program to print the records in the form of comma-separated values, instead of lists. Now, look at the Python code. In line 2, import CSV. This line imports the CSV module, which provides functionality for working with CSV files. In line 3, f=open student.csv, r. This line opens the student.csv file in read mode, r, using the open function and assigns the file object to the variable f. This creates a file object that you can use to interact with the file. In line 4, csv_reader equals csv.reader of f. Here, the csv.reader function is used to create a CSV reader object named csv_reader. This object is specifically designed to read and parse CSV data from the file specified by f. In line 5, for row in csv_reader:. This for loop iterates through each row in the CSV file using the csv_reader object. In each iteration, row represents a single row of data from the CSV file as a list of strings. Each element in the list corresponds to a field in that row. In line 6, print, .join of a row. Inside the loop, this line joins the elements of the row list using a comma as the separator. This effectively converts the list of fields into a single string with comma-separated values, CSV format, and prints it to the console. We have used a new function join. Join function is a string method that joins the string by a string separator. Here the separator is comma. In line 7, f.close. After printing all the records, the program explicitly closes the file using the close method. It's good practice to close files when you're done with them to free up system resources. So, when you run this program, it will open the student.csv file, iterate through its rows, convert each row into a comma-separated string, and print each record in CSV format to the console. The output will look something like this, shown on the screen. Thus, all records are displayed as a string separated by a comma separator and not as a list, and hence the output is so obtained. Example 6. Write a Python program to search the record of a particular student from student.csv file on the basis of inputted name. Now, look at the Python code. The provided Python program reads a CSV file named student.csv and searches for a student's record based on the entered name. Here's a breakdown of the code. In line 2, import CSV. This line imports the CSV module, which is necessary for reading and writing CSV files. In line 3, f=open student.csv, r. This line opens the CSV file student.csv in read mode, r, and assigns it to the file object f. In line 4, csv_reader equals csv.reader of f. This line creates a CSV reader object csv_reader using the csv.reader function. The CSV reader is used to iterate through the lines of the CSV file. In line 5, name equals input, enter the name of the student to be searched. This line prompts the user to enter the name of the student they want to search for and stores it in the variable name. In line 6, for row in csv_reader:. This line starts a loop to iterate through each row in the CSV file. In line 7, if row of 0 equal to name, : Inside the loop, it checks if the value in the first column index 0, of the current row matches the entered name. In line 8, print of a row. If a match is found, it prints the entire row, student's record, to the console. Here's how the program works. It opens the CSV file and reads its contents line by line. For each line, it checks if the first column, presumably the student's name, matches the entered name. If a match is found, it prints the entire row, which likely contains additional information about the student. You can check the output. Here we have entered the name of the student to be searched as Caleb. So Caleb's details are displayed with name, class, and marks. Data file handling, part 10. In this video, we are going to learn writing to a CSV file with practical implementation. So, let's dive in and get started. Like other files, text file and binary files, in Python, there are two basic operations that can be carried out on a CSV file. First one is reading from a CSV file, and the second one is writing to a CSV file. We have already discussed about reading from a CSV file in the previous video data file handling part 9. Now in this video, let's discuss about how to write to a CSV file. Let's discuss about the writing to a CSV file. CSV module. The key points about writing to a CSV file in Python using CSV.writer function in a concise format are: the first key point is the CSV module. Python provides a CSV module for working with comma-separated values, CSV, files. Second key point. Create writer object. To write to a CSV file, you first create a writer object using the CSV.writer function. This writer object is used to convert data into a delimited string suitable for CSV format. Third key point is write row method. The write row method of the writer object allows you to write a list of fields to the CSV file. These fields can be strings, numbers, or a mix of both. Fourth key point is automated line endings, that is no EOL, end of line, needed. You don't need to manually add a new line character, or other end of line indicators, to indicate the end of a line when using write row. The method takes care of this for you, ensuring each row ends correctly. Fifth key point is the delimiter. By default, the CSV writer uses a comma symbol as the delimiter to separate values in the CSV file. You can specify a different delimiter by providing the delimiter parameter when creating the writer object. Let's see an example. Write a Python program to write data onto student.csv file using the write row method. Now, look at the Python code. This Python code is used to write student data into a CSV, comma-separated values, file. The CSV file will contain information about students, such as their name, class, year, and percentage. Here's an explanation of each part of the code. Now, look at line 3, importing the CSV module. This line imports the Python CSV module, which provides functionality for working with CSV files. In line 5, we are defining the fields list. This list contains the column headings or field names for the CSV file. In this case, it includes name, class, year, and percent. In line 7 to 11, we are defining the rows list. This list contains the data to be written to the CSV file. Each element of this list is a list itself, representing a row of data. Each inner list contains the student's information, including name, class, year, and percentage. In line 13, we are specifying the file name. This variable stores the name of the CSV file you want to create or write to. In this case, it's set to studentmarks.csv. In line 15, we are opening the CSV file for writing. The with open, file name, W, new line equals space, as F:. This line opens the CSV file specified by file name in write mode, W. The new line equals space argument ensures that the file uses the default new line character for your operating system. In line 18, we are creating a CSV writer object. The CSV.writer function is used to create a CSV writer object named CSV_W. It specifies the file object F and sets the delimiter to a comma. In line 20, we are writing the field names. The CSV_W.write row of fields line writes the field names, column headings, to the CSV file. In line 21 and 23, we are writing data rows. The for loop iterates through the rows list and writes each row of student data to the CSV file using CSV_W.write row, I. In line 24, we are printing a confirmation message. Finally, the code prints file created to indicate that the CSV file has been successfully created and populated with student data. After running this code, you will have a CSV file named studentmarks.csv in the same directory as your Python script containing the student data in a structured format that can be easily read and processed using spreadsheet software. Now, you can look at the output. In the Python output, you can see file created message. Now, to view the contents of studentmarks.csv, you have to open the Excel sheet with the name studentmarks, which is created new. You can see the student details displayed here. To be more clear, the Python script as well as the content created on the Excel spreadsheet are displayed here. You can check the contents of student marks of the spreadsheet given as per the code. Data structures in Python, Stack Part 1. In this video, we are going to learn Introduction to Data Structures in Python, Stack, implementation of stack using list, creating a stack, push operation or adding elements to a stack, checking the status of stack, pop operation or deleting elements from a stack, traversal or displaying a stack, applications of stack. So, let's dive in and get started. We are going to learn about data structures in Python. Are you ready? We have learned about different data types in Python for handling values in class 11. Recall that string, list, set, tuple, etc. are the sequence data types that can be used to represent collection of elements either of the same type or different types. Multiple data elements are grouped in a particular way for faster accessibility and efficient storage of data. That is why we have used different data types in Python for storing data values. Such grouping is referred as a data structure. So now, look at the introduction of data structures in Python. Definition. A data structure is a fundamental concept in computer science that defines a specific way to organize and store data efficiently in a computer's memory or storage system. Purpose. Data structures are essential for performing various operations on data, such as insertion, retrieval, deletion, and searching, in an effective and optimized manner. Types. There are various types of data structures, including arrays, lists, stacks, queues, trees, graphs, hash tables, and more, each with its own rules and operations. Role in programming. Data structures are crucial for algorithm design and software development, allowing programmers to choose the most appropriate data structure for a particular task or problem. How data structures varies from data type in Python. Definition of data type. Specifies the type of data a variable can hold. Definition of data structures. Organizes and stores data efficiently in a program. Homogeneity. In data type, homogeneous, variables of the same type store the same kind of data. In data structure, it can be homogeneous or heterogeneous, may store different data types within the same structure. Examples of data type are int, integer, float, floating point number, str, string, bool, boolean, etc. Examples of data structure are lists, arrays, dictionaries, sets, stacks, queues, trees, graphs, etc. Purpose of data type defines the nature of individual variables and the kind of data they can hold. Purpose of data structure provides efficient methods for organizing, managing, and manipulating collections of data. Custom implementation of data type, typically predefined in the programming language and cannot be easily customized. Custom implementation of data structure, developers can create custom data structures using classes and objects to suit specific needs. Let's see the data structure definition clearly. A data structure defines a mechanism to store, organize, and access data along with operations, processing, that can be efficiently performed on the data. For example, a string is a data structure that contains a sequence of elements, with each element being a character. In contrast, a list is a sequence data structure where each element may have different data types. Both lists and strings support various operations like reversal, slicing, and element counting. Data structures are designed to organize multiple elements in a way that allows easy execution of operations on individual elements and the entire data unit. There are different types of data structures that build on one another, including simple and compound data structures. Simple data structure. It's built on primitive data types to create higher-level data structures. Primitive data types are the basic building blocks of simple and compound data structures: integers, floats and doubles, characters, strings, and boolean. The most common simple data structures are arrays and linked lists. Next is the compound data structure. Builds on primitive and simple data structures, and may be linear or nonlinear. Again, the compound data structures are further divided into linear data structures and nonlinear data structures. Linear data structure forms a linear sequence with unique predecessors and successors. Example: stack and queue. Nonlinear data structure does not form linear sequences. The nonlinear tree structure is built from hierarchical relationships. They are multi-leveled and non-sequential. Example: tree, hash, graph. Stack and queue are two other popular data structures used in programming. In this video, we are going to learn about a linear sequence structure called the stack, and in further upcoming videos, we will learn about queue. You can see the picture, how things are stacked or arranged one above the other. Let's explore the concept of stack. A stack is like a pile of books. You put one book on top of another, and when you want to take a book, you always take the one on the top. It's like a last in, first out game, where the last book you put in is the first book you take out. Stacks are used in computers to keep track of things in a similar way, like when you undo an action in a game or program, it's like taking a book off the top of the pile. It's quite interesting. So, what is a stack in Python? A stack is a fundamental linear data structure. Linear data structures form sequences. It is visualized as a logical entity resembling a physical stack or pile of objects. In a stack, elements are inserted and deleted at one end, known as the stack's top. Programmers typically implement a stack using two common data structures, arrays and linked lists. Stack is a linear structure implemented in LIFO, last in, first out, manner where insertions and deletions take place only at one end, that is, the stack's top. Here, you can see the applications of stack in real life. Stack of coins, stack of plates, can of tennis balls, stack of books, stack of pebbles, multiple chairs in a vertical pile. Take an example, stack of plates. You can only add or remove plates from the top of the stack. The most recently added plate is the first one to be removed. So stack is implemented in last in first out. Last plate in is the first plate out. Let's learn about the features of stack. A stack is a linear data structure that provides only one end for entry and exit of data. No element can be accessed from the middle. It works on the last in first out (LIFO) principle. The element entering last into the stack will be retrieved first from it. Now, look at the picture. Stack is a collection of elements with two primary operations. Push and pop push. This operation adds an element to the top of the stack. Pop. This operation removes and returns the element from the top of the stack. An insertion in a stack is called pushing. A deletion in a stack is called popping. Top is the variable that points to the top of the stack. Let's discuss about the stack operations using push and pop operations. To perform push and pop, we need to declare a variable that points to the top of the stack, that is top, and acts as a storage location or a container to store elements of the stack. Now look at the step 1 picture. Top variable is empty as the stack remains empty. In step 2, an element, bottom, is pushed or inserted or added on top of the stack. You can see in step 2, the top variable points to bottom element. In step 3, an element, D, is pushed or inserted or added on top of the stack. You can see in step 3, the top variable points to D element. And D element is above the bottom element. In step 4, an element, C, is pushed or inserted or added on top of the stack. You can see in step 4, the top variable points to C element. And C element is above the D element. In step 5, an element, B, is pushed or inserted or added on top of the stack. You can see in step 5, the top variable points to B element. And B element is above the C element. In step 6, an element, A, is pushed or inserted or added on top of the stack. You can see in step 6, the top variable points to A element. And A element is above the B element. Now, it's time for the pop operation. In step 7, A element is deleted or removed from the top of the stack. Now, the top points to B element. In step 8, B element is deleted or removed from the top of the stack. Now, the top points to C element. In step 9, C element is deleted or removed from the top of the stack. Now, the top points to D element. In step 10, D element is deleted or removed from the top of the stack. Now, the top points to bottom element. In step 11, bottom element is deleted or removed from the top of the stack. Now, the top points to none. Stack is empty again. You did it. From these operations of push and pop, you can see the two stack operations are performed through the top elements are inserted as well as deleted from the top only. The stack is a dynamic data structure as it grows, with increase in number of elements, or shrinks, with a decrease in the number of elements. A static data structure, on the other hand, is one that has a fixed size. Implementation of stack using list in Python is the easiest of all programming languages. The basic operations performed on the stack are creating a stack, push operation, adding elements to a stack, checking the status of stack, pop operation, deleting elements from a stack, and traversal, displaying a stack. Let's discuss one by one in detail. Let's learn how to create a stack. Python provides a built-in data structure called a list, which is flexible and can hold a variable number of elements of different types. Lists in Python are implemented in memory, and they can store a mix of different data types. To create an empty stack in Python using a list, you can simply use the built-in list function or square brackets to initialize an empty list. Syntax is stack equals list function, which represents an empty stack list. Here, stack is a variable of list type and is created using list function. Or it can be written as stack equals empty square brackets, which also represents an empty stack list. Here, stack variable is created by assigning an empty pair of square brackets. Like lists, in order to access the elements in a stack, index values are used. Thus, the first element in the stack will be stack 0, the second will be stack 1, and so on. Unlike lists, random access is not allowed for the objects contained in the stack. Let's discuss about the push operation or adding elements to a stack. Push elements onto the stack, adding or inserting a new element to the stack list is called push operation. To add elements to the stack, use the append method of the list. Pushing an element onto the stack means adding it to the end of the list. Syntax is stack.append of x. Here, x is the element to be inserted into the stack and is inserted at the end of the list implemented as a stack. If stack is empty list, it simply appends this first element to the stack. Note: Attempts to insert an element into a full stack, that is, top equals n-1, where n is the size of the stack, is called the stack overflow. Algorithm for push operation. The steps to be performed for carrying out the push operation on the stack are as follows. Step 1. Start. This step marks the beginning of the algorithm. Next, to initialize an empty stack using a list in Python. Step 2. Stack equals list function or stack equals empty square bracket. Next, to input the value to be added to the stack from the user. Step 3. Element equals input of, enter the value to be added in the stack. We come to the main steps now. Append the entered element to the top of the stack. Step 4. Stack.append of element. Next, the element has been successfully pushed onto the stack, and the stack now contains the user input element at its top. Step 5. End. This step marks the end of the algorithm. While we perform push operation into the stack, we push the element onto the stack using append function. To use stack efficiently, we need to check the status of stack as well. So, the following functions are added to stack. Peek operation. The peek operation allows you to examine the top element of the stack without removing it. It's useful for inspecting the top element before making decisions based on its value. It will throw an exception if the stack is empty or null. Overflow. Overflow occurs when you attempt to push an element onto a stack that is already full, relevant in fixed-size stacks. In Python using lists, overflow is typically not a concern because lists can dynamically resize to accommodate elements. Underflow. Underflow occurs when you try to pop an element from an empty stack. It represents an attempt to remove an element from a stack that has no elements. To avoid underflow in Python, check whether the stack is empty before attempting a pop operation and handle it gracefully to prevent errors. Algorithm to display top elements without deleting it using peek function. Steps to count the total number of elements in a stack and handle underflow conditions. Step 1. Start. This step marks the beginning of the algorithm. Step 2. Count the total number of elements in the stack by using the len function and store the result in st_len. Step 3. Check if st_len is empty, indicating an empty stack. Handle underflow condition, example, return an error message. Go to step 5, it exits the program. Step 4. If the stack is not empty, calculate the index of the top element, last element in the stack, and store it in top. Print the value of top if needed. Step 5. End. This step marks the end of the algorithm. Let's recall. The algorithm starts by counting the total number of elements in the stack using len function. It then checks if the stack is empty, underflow, and handles the underflow condition by printing a message or taking other appropriate actions. If the stack is not empty, it calculates and prints the index of the top element. Algorithm to check if stack is empty. To count the total number of elements in a stack and handle the underflow condition if the stack is empty. Step 1. Start. This step marks the beginning of the algorithm. Step 2. Count the total number of elements in the stack by using the len function and store the result in st_len. Step 3. Check if st_len is 0, indicating an empty stack. Handle underflow condition, example, return an error message. Step 4. End. This step marks the end of the algorithm. Let's recall. The algorithm starts by counting the total number of elements in the stack using len function. It then checks if the stack is empty, underflow, and handles the underflow condition by printing a message. Pop operation or deleting elements from a stack. Pop operation refers to the process of removing the top element from a stack. Syntax is stack.pop function. Here, the function pop function removes the last element which is on the top of the stack. It also returns the popped or deleted elements from the list. Note: in order to delete an element from the stack, no subscript or index value is required to be passed to the function pop. If the user tries to delete an element from the empty stack, it is called underflow of stack. Let's see a basic algorithm for performing the pop operation on a stack and handling cases where the stack is empty. That is, an algorithm to delete an element from a stack. Step 1. Start. This step marks the beginning of the algorithm. Step 2. st_len equals len of stack. Calculate the total number of elements in the stack and store it in the variable st_len. Step 3. If st_len equals empty square brackets or if not stack or if not len of stack. This step checks if the stack is empty using various methods. First method, st_len equals empty square brackets. Here it compares st_len to an empty list to check for an empty stack. Second method, if not stack, here it checks if the stack itself evaluates to false, which would work correctly if stack is an empty list. Third method, if not len of stack. Here it checks if the length of the stack is 0, which is a valid way to check for an empty stack. Step 4. Element equals stack.pop function. If the stack is not empty, this step removes the last element, top element, from the stack using the pop method and stores it in the variable element. Step 5. Print element. Print the element that was removed from the stack in the previous step. Step 6. End. This step marks the end of the algorithm. In this algorithm, the if condition shall check whether the stack is empty or not. In case of non-empty stack only, the element shall be removed from the stack using the built-in function pop function that removes the last element. Once an element is popped, the stack automatically reduces one index position. Traversing or displaying a stack refers to the process of iterating through the elements stored in a stack data structure to access and view each element, typically starting from the top, most recently added element, and working your way down to the bottom, the earliest added element. Let's see the algorithm for traversing stack elements. Step 1. Start. This step marks the beginning of the algorithm. Step 2. L equals len of stack. Calculate the total number of elements in the stack and store it in the variable L. Step 3. For I in range of L -1, -1, -1. This step uses a for loop to iterate through the elements of the stack in reverse order, starting from the top element, index L -1, and moving towards the bottom, index 0. Inside the loop, it prints each element in the stack using stack of I. Step 4. End. This step marks the end of the algorithm. Applications of stack. Reversing a word or line. Stacks can reverse the characters or words in a sentence or string by pushing each element onto the stack and then popping them in reverse order. Evaluation of arithmetic expressions. Stacks are used to convert infix expressions, like 2 plus 3, to postfix notation, like 2, 3, plus, and then evaluate them efficiently using postfix evaluation algorithms. We can learn about this in detail in the upcoming videos. Processing function calls. Stacks manage function call information, including local variables and return addresses, in programming languages, allowing for proper function execution and return. Backtracking. Stacks are crucial in backtracking algorithms, like depth-first search, as they store and manage the current path or state, enabling efficient exploration of possible solutions. Undo mechanism in text editors. Text editors utilize stacks to implement undo and redo functionality by storing the changes made to the text and allowing users to reverse or redo those actions. Data structures in Python Stack Part 2. In this video, we are going to see the implementation of stack using list and practical implementation. Let's dive in and get started. Let's look at example 1. Write a Python program to implement all basic operations of a stack, such as adding element, push operation, removing element, pop operation, and displaying the stack elements, traversal operation using lists. Now, look at the code. In line 1, stack equals empty square brackets. This line initializes an empty list called stack, which will be used to represent the stack data structure. Initially, the stack is empty. In line 3, while true. This starts an infinite loop. The code inside this loop will keep running until a break statement is encountered. In this case, it allows the program to keep executing stack operations until the user chooses to quit. In line 4, print stack operations. This line prints a message indicating the start of the menu for stack operations. The \n is used to print a new line character, creating a line break for better readability. In line 5 to line 8, the next 4 lines, print 1. Push, print 2. Pop, print 3. Display, and print 4. Quit, print out the menu options for the user to choose from. These options include push, pop, display, and quit. In line 10. Choice equals int of, input of, enter your choice. This line prompts the user to enter their choice by displaying enter your choice, and reads the input as a string using input function. Then, it converts the input to an integer using int function and stores it in the variable choice. In line 12, the if statement checks the value of choice to determine which operation the user has selected. If choice equals 1. If the user chose 1, push, the code inside this block is executed. In line 13, item equals input of enter element to push. It prompts the user to enter an element to push onto the stack and stores the input in the variable item. In line 14, stack.append of item. It adds the item to the top of the stack by appending it to the stack list. In line 15, print f item pushed onto the stack. It prints a message confirming that the element has been pushed onto the stack. In line 17, the elif statement checks if choice is equal to 2, pop. If so, it performs the following. In line 18, if stack. It checks if the stack is not empty. If the stack is not empty, that is, it contains elements, it executes the code inside this block. In line 19, popped_item equals stack.pop function. It pops the top element from the stack using pop function and assigns it to the variable popped_item. In line 20, print f popped element popped_item. It prints the element that was popped from the stack. In line 21, if the stack is empty, the else block. In line 22, it prints a message indicating that the stack is empty and a pop operation cannot be performed. In line 24, the elif statement checks if choice is equal to 3, display. If so, it displays the stack elements as follows. In line 25, if stack. It checks if the stack is not empty. If it's not empty, it executes the code inside this block. In line 26, print stack elements. It prints a message to indicate that the following lines will display the stack elements. In line 27, L equals len of stack. It calculates the length of the stack and assigns it to the variable L. In line 28, for item in range of L-1, -1, -1. This for loop iterates over the stack in reverse order, starting from the top, index L-1, down to the bottom, index 0, and moving in reverse, -1, direction. In line 29, print of stack of item. It prints each element of the stack as it iterates through the loop, effectively displaying the stack elements from top to bottom. In line 33, if the stack is empty, the else block, it prints a message indicating that the stack is empty. In line 33, the elif statement checks if choice is equal to 4, quit. In line 34, if so, it breaks out of the infinite loop using the break statement, ending the program. In line 36 and 37, if none of the above conditions are met, that is, the user enters an invalid choice, it executes the else block and prints a message telling the user that their choice is invalid and to try again. The code continues to loop, allowing the user to perform stack operations until they choose to quit by selecting option 4. Now, let's see the output. Look at the first column. When we run the program, the menu displays the list of stack operations: 1, push. 2, pop. 3, display. 4, quit. Now the user enters the choice as 1. Enter element to push. 22 is typed by the user. So it is printed as 22 pushed onto the stack. Now the menu is displayed with the 4 options. Enter your choice, 1 is typed again. Enter element to push, 11 is typed. So, it is printed as 11 pushed onto the stack. Now the menu is displayed with the 4 options. Now the user enters the choice, 1 again. Enter element to push, 33 is typed. So, it is printed as 33 pushed onto the stack. Now, look at the second column. The menu is displayed with the 4 options. Now, the user enters the choice, 3. Stack elements displayed are 33, 11, 22. As 33 is the last in element, it is displayed on the top. Now again the menu displays the 4 options. The user enters choice 2. Popped element is 33. Do you remember the LIFO principle for stack? Last in first out. The last element pushed in is 33 and the first element popped out is 33. Now look at the first column. Now again the menu displays the 4 options. The user enters choice 2 again. Popped element is 11. Now the second element 11 gets popped out. Now again the menu displays the 4 options. The user enters choice 2 again. Popped element is 22. Now the bottom element 22 gets popped out. Now, look at the second column. Now again the menu displays the 4 options. The user enters choice 3 to display the elements. Now, the stack is empty. The stack elements 22, 11 and 33 popped out one after the other and now the stack remains empty. Now again the menu displays the 4 options. The user enters choice 4 to quit. Program ends with quit option. Example 2. Write a Python program to display unique vowels present in the given word using stack. Now, look at the Python code. In line 1, this line prompts the user to enter a word and stores the input in the variable word. The input function is used to get input from the user, and the provided message, enter a word, is displayed as a prompt. In line 3, this line creates a list named vowels that contains all lowercase and uppercase vowels. These are the characters that the program will consider as vowels when checking the word. In line 4, here, an empty list named unique_vowels is initialized. This list will be used to store the unique vowels found in the user's input word. In line 6, this line starts a for loop that iterates over each character, char, in the user's input word, word. In line 7, inside the loop, this line checks whether the current character, char, is in the vowels list, that is, whether it's a vowel, and whether it's not already in the unique_vowels list. In line 8, if the conditions in the previous line are met, the current vowel is appended to the unique_vowels list. This ensures that only unique vowels are added to the list. In line 10, after the loop completes, this line prints the unique_vowels list, which contains all the unique vowels found in the input word. In line 11, finally, this line prints a message that includes the number of different, unique, vowels present in the input word. It uses the len function to calculate the length of the unique_vowels list, which gives the count of unique vowels. Now, let's look at the first output. The input entered is data structures in Python. It correctly identified the unique vowels as lowercase a, u, e, I, and o and displayed them in the unique_vowels list. Additionally, it correctly calculated and displayed that there are 5 different vowels present in the input word. Second time, we run the code and type uppercase letters. For the input stacks in Python, in uppercase letters, it correctly identified the unique vowels as uppercase a, I, and o and displayed them in the unique_vowels list. The program also correctly calculated and displayed that there are 3 different vowels present in the input word. Example 3. Write a Python program to create a stack called employee to perform the basic operations on stack using list. The list contains the 2 values, employee number and employee name. The program should include the options for addition, deletion, and display of employee details. Let's look at the code now. Line 1, this line initializes an empty list called employee_stack. This list will be used to store employee details, where each employee is represented as a tuple containing their employee number and employee name. Line 3. This line starts an infinite loop using while true. This loop will continue running until the user chooses to exit the program. Lines 4 to 8. These lines print a menu of options for the user to choose from. It displays options to add an employee, delete an employee, display employee details, or exit the program. Line 10. This line prompts the user to enter their choice and stores the input as an integer in the variable choice. Line 12. This line checks if the user's choice is equal to 1, which corresponds to the option to add an employee. In line 13 to 16, if the user chooses to add an employee, choice 1, the program prompts the user to enter the employee number and name. It then appends a tuple containing these details to the employee_stack list and confirms the addition. In line 18, this line checks if the user's choice is equal to 2, which corresponds to the option to delete an employee. In line 19, this line checks if there are any employees in the employee_stack list. In line 20, 21. If there are employees in the stack, it removes the last employee, last tuple, from the employee_stack list using the pop method. It then prints a message confirming the deletion, including the deleted employee's details. In line 22, 23. If there are no employees in the stack, it prints a message indicating that there are no employees to delete. In line 25, this line checks if the user's choice is equal to 3, which corresponds to the option to display employee details. In line 26, this line checks if there are any employees in the employee_stack list. In line 27, 28, 29. If there are employees in the stack, it prints the header employee details, and then iterates through the employee_stack list, printing the employee number and name for each employee. In line 31, if there are no employees in the stack, it prints a message indicating that there are no employee details to display. In line 33. This line checks if the user's choice is equal to 4, which corresponds to the option to exit the program. In line 34, 35. If the user chooses to exit the program, it prints exiting program and exits the infinite loop by using the break statement, effectively terminating the program. In line 37. If the user enters a choice that is not 1, 2, 3, or 4, this line starts an else block, indicating that the choice is invalid. In line 38. Inside the else block, it prints a message indicating that the choice is invalid and prompts the user to select a valid option. This program provides a menu-driven interface for managing employee details using a list-based stack and handles various user choices appropriately. Now, let's look at the output. Now, look at the first column. The program starts by displaying a menu of options. 1. Add employee. 2. Delete employee. 3. Display employees. 4. Exit. The user chooses option 1 to add an employee. The user enters the employee number as 2450 and the employee name is Sam. The program adds this employee to the stack and confirms. Employee Sam added successfully. Again, the menu gets displayed. The user chooses option 1 again and adds another employee with number 2452 and name Alice. The program adds this employee to the stack and confirms. Employee Alice added successfully. The user chooses option 1 once more and adds another employee with number 2454 and name Alex. The program adds this employee to the stack and confirms. Employee Alex added successfully. Now, look at the second column. The user chooses option 3 to display the employees the user has added. The program prints the details of all the employees currently in the stack. Employee number 2450. Employee name Sam. Employee number 2452. Employee name Alice. Employee number 2454. Employee name Alex. Next, the user chooses option 2 to delete an employee. The program removes the last employee, which is Alex with employee number 2454, and confirms the deletion. Employee Alex with employee number 2454 deleted. The user chooses option 3 again to display the updated list of employees. The program prints the details of the remaining employees. Employee number 2450. Employee name Sam. Employee number 2452. Employee name Alice. Now, look at the first column. The user chooses option 2 again to delete an employee. The program removes Alice with employee number 2452 and confirms the deletion. Employee Alice with employee number 2452 deleted. The user chooses option 2 once more to delete another employee. The program removes Sam with employee number 2450 and confirms the deletion. Employee Sam with employee number 2450 deleted. The user chooses option 2 again, but this time, there are no more employees in the stack, so the program informs you that there are no employees to delete. No employees to delete. Now, look at the second column. The user chooses option 3 once more to display the current list of employees, and the program confirms that there are no employee details to display. No employee details to display. Finally, the user chooses option 4 to exit the program, and the program displays exiting program before terminating. Data structures in Python Stack Part 3. Today, I am here to teach Data Structures in Python, Part 3, Algebraic or Arithmetic Expressions, Infix, Prefix and Postfix Notations. Conversion from infix to postfix notation with algorithm and visualization using stack method. Let's start with an interesting topic in data structures using stack. Before getting into that, first we should know what's an algebraic or arithmetic expressions. Algebraic expression is a valid combination of operators and operands. Operand is the quantity upon which a mathematical operation is performed. It can be a variable. For example, x, y, z, or a constant, for example, 5, 4, 6. Next is the operator, which is a symbol that represents a mathematical or logical operation between operands. Examples of operators. Common operators include plus, addition, minus, subtraction, asterisk, multiplication, slash, division, and raised to the power, exponentiation. Let's discuss about the notations for algebraic or arithmetic expressions. Algebraic expressions can be represented in 3 notations: infix, prefix, and postfix. In infix notation, arithmetic expressions are written with operators placed between operands, such as x plus y, 2 minus 3 asterisk y, etc. You can see the highlighted operators between operands here, representing operators placed between operands. Parentheses are used to specify the order of operations in complex expressions. The BODMAS, brackets, orders, division and multiplication, addition and subtraction, rule is applied to evaluate expressions in infix notation. Polish notation or prefix notation. This was introduced by Polish mathematician Jan Lukasiewicz in the 1920s. In prefix notation, operators are written before their operands. The order of operations and operands determines the result, eliminating the need for parentheses. For example, x plus y in prefix notation is written as plus xy. You can see the highlighted operator plus before the operands x and y, pre means before. Reverse Polish notation, postfix notation. In postfix notation, operators are written after their operands. It is the reverse of prefix notation. For example, x plus y in postfix notation is written as xy plus. You can see the highlighted operator plus after the operands x and y, post means after. Let's recall the 3 notations with examples. In infix notation, operators are placed in between the operands. For example, x asterisk y plus z. You can see the operators asterisk and plus are between the operands x, y, and z. Likewise, look at the second example. 3 asterisk, 4 plus 5, and the third example, x plus y, slash, z asterisk 5. In prefix or Polish notation, operators are placed before the corresponding operands. So, x asterisk y plus z is written as plus z asterisk xy. 3 asterisk 4 plus 5 is written as asterisk 3 plus 4 5 and x plus y slash z asterisk 5 is written as slash plus xy asterisk z5. Now, let's see the postfix or reverse Polish notation. Operators are placed after the corresponding operands. So, x asterisk y plus z is written as xy asterisk z plus. 3 asterisk 4 plus 5 is written as 3 4 5 plus asterisk. X plus y slash z asterisk 5 is written as xy plus z5 asterisk slash. You can gain a clearer understanding by learning how to convert these notations. So, simply follow the concept. Now let's learn about the conversion from infix to postfix notation. First, let's learn about the basic concepts of these conversions. Infix expressions. Infix expressions are the most common way humans write arithmetic expressions, where operators are placed between operands, for example, x plus y slash z. Humans can evaluate infix expressions by following the order of precedence, Bodmer's rule, to determine which operations to perform first. Conversion to postfix. Converting an infix expression to postfix notation involves rearranging the operators so that they follow their order of evaluation. This conversion process uses a stack data structure to keep track of operators encountered in the infix expression. Single traversal for evaluation. Prefix and postfix expressions allow for straightforward evaluation with a single left-to-right traversal. Operators in these notations are already in the correct order, simplifying the evaluation process. Stack usage. During the conversion of infix to postfix, a stack is employed to manage operators and ensure they are placed in the correct order. Postfix expression storage. A string variable is used to store the equivalent postfix expression during the conversion process. Here are the 3 important features of postfix expressions. Operand order. Postfix expressions maintain the same order of operands as in the equivalent infix expression. Parentheses unnecessary. Postfix expressions do not require parentheses to clarify the expression's meaning or resolve ambiguity or uncertainty. Operator priority irrelevant. When evaluating a postfix expression, the priority of operators, such as multiplication or addition, is no longer a concern, as the order of operations is inherently clear in postfix notation. We consider some binary operations like exponentiation, multiplication, division, addition, and subtraction and its precedence. Exponentiation has the highest precedence with value 3. Multiplication and division has the next highest precedence with value 2. Addition and subtraction has the lowest precedence with value 1. Now, let's write an algorithm for infix to postfix conversion. Pay close attention, as each step holds significant importance. Step 1. Initialize an empty stack operator stack to hold operators. Empty stack named operator stack, which holds the operators like addition, subtraction, multiplication, division, etc. Step 2. Initialize an empty string postfix expression to store the postfix expression. Empty string named postfix expression stores the postfix expression, like variables x, y, z, or constants like 5, 4, 6, etc. Step 3. Scan the infix expression from left to right, one symbol at a time. For example, it scans the infix expression given, one symbol at a time, from open parenthesis on the left to the close parenthesis, the last symbol on the right. For each symbol in infix expression, if it's an operand, a number, or a variable, add it to the postfix expression. So, look at the infix expression given here. If it's an operand, that is a number or a variable, append or add it to the postfix expression. Now come to the second part. If it's an operator, do the following. There are 2 subdivision. Subdivision A. While operator stack is not empty and the precedence of the current operator is less than or equal to the precedence of the operator at the top of operator stack, pop the operator from operator stack and add it to the postfix expression. You can see the operator and precedence value box given below for your reference. Subdivision B. Push the current operator onto operator stack. Step 4. If the symbol is an opening parenthesis left parenthesis, push it onto operator stack. You can see the left parenthesis, which is highlighted here, just push it onto operator stack. Step 5. If the symbol is a closing parenthesis right parenthesis, pop operators from operator stack and add them to the postfix expression until a matching opening parenthesis left parenthesis is encountered. Discard left parenthesis. Remember, postfix expressions do not require parentheses, so just discard the left parenthesis. Step 6. Continue scanning and processing symbols until you reach the end of the infix expression. Step 7. After processing all symbols in the infix expression, pop any remaining operators from operator stack and add them to the postfix expression. Step 8. The postfix expression now contains the postfix notation of the original infix expression. Now, let's see the visualization for infix to postfix conversion. Pay close attention, as each step holds significant importance. The infix expression given is open parenthesis x plus y close parenthesis, slash, open parenthesis z asterisk 8 close parenthesis. Step 1. First, the action done is that we are initializing. In the third column, you can see the operator stack. Initialize an empty stack named operator stack to hold operators. Empty stack named operator stack, which holds the operators like addition, subtraction, multiplication, division, etc. Step 2. You can see the fourth column, initialize an empty string postfix expression to store the postfix expression. Empty string named postfix expression stores the postfix expression. Step 3. Scan the infix expression from left to right, one symbol at a time. It scans the infix expression given, one symbol at a time, from open parenthesis on the left to the close parenthesis, the last symbol on the right. Step 4. Now the symbol scanned is left parenthesis. Action done is push in operator stack. You can see the operator stack contains the left parenthesis. Postfix expression column is still empty. Now, we have to continue scanning and processing symbols until you reach the end of the infix expression. So, symbol scanned is x, action done is append to postfix string postfix expression. Operator stack holds the left parenthesis. Postfix expression stores x. Symbol scanned is plus. Action done is push in operator stack. Operator stack holds the left parenthesis and plus. Postfix expression stores x. Symbol scanned is y, action done is append to postfix string postfix expression. Operator stack holds the left parenthesis and plus. Postfix expression stores x, y. Here, the next symbol scanned is close parenthesis. In step 5 of the algorithm, we have learned that, if the symbol is a closing parenthesis right parenthesis, pop operators from operator stack and add them to the postfix expression until a matching opening parenthesis left parenthesis is encountered. Discard left parenthesis. Remember, postfix expressions do not require parentheses, so just discard the left parenthesis. Now, the operator stack remains empty. Postfix expression stores x, y plus. Now, the symbol scanned is slash. Action done is push in operator stack. Operator stack holds slash. Postfix expression stores x, y plus. Now, the symbol scanned is open parenthesis. Action done is push in operator stack. Operator stack holds slash and open parenthesis. Postfix expression stores x, y plus. Now, the symbol scanned is z, action done is append to postfix string postfix expression. Operator stack holds slash and open parenthesis. Postfix expression stores x, y plus z. Now, the symbol scanned is asterisk. Action done is push in operator stack. Operator stack holds slash, open parenthesis, asterisk. Postfix expression stores x, y plus z. Now, the symbol scanned is 8. Action done is append to postfix string postfix expression. Operator stack holds slash, open parenthesis, asterisk. Postfix expression stores x, y plus z8. Now, the symbol scanned is close parenthesis. Action done is pop operators from operator stack till open parenthesis is encountered and append the popped operators in postfix expression. Discard the left parenthesis. Now, the operator stack holds slash. The postfix expression stores x, y plus z8 asterisk. Now, we came to the end of input expression. Action done is pop all operators from operator stack and append the popped operators in postfix expression. Operator stack remains empty. Postfix expression shows the final output as x, y plus z8 asterisk slash. Let's see another example. Convert the following infix notation to postfix notation, showing stack and string contents at each step. Infix expression is a plus b minus c asterisk d. Let's look at the steps. Symbol scanned is a. Action done is append to postfix expression. Operator stack, initially stack is empty. Postfix expression holds a. Come to the second step. Symbol scanned is plus. Action done is push plus in operator stack. Operator stack holds plus. Postfix expression has a. Third step. Symbol scanned is b, append to postfix expression. Operator stack holds plus. Postfix expression stores a, b. In the next step, symbol scanned is minus. Minus have equal precedence to plus. You can check the precedence table given on the right side of the screen for your reference. So, in the operator stack, first pop plus, then push minus. Now operator stack holds minus. Plus is popped out of the stack and hence postfix expression now stores A, B plus. In the next step, symbol scanned is C, action done is append to postfix expression. Operator stack holds minus. Postfix expression stores A, B plus C. In the next step, symbol scanned is asterisk. Asterisk have higher precedence than minus. You can check the precedence table for reference. Now, push asterisk in operator stack. So, operator stack holds minus, asterisk. Postfix expression stores A, B plus C. In the next step, symbol scanned is D, action done is append to postfix expression. Operator stack holds minus, asterisk. Now, postfix expression stores A, B plus C, D. Next we came to the end of input expression. Action done is pop all operators from operator stack and append the popped operators in postfix expression. So asterisk and minus are popped one by one out of the stack. Now operator stack is empty. The final output is A, B plus C, D asterisk minus. I hope it's clear to you. Data structures in Python stack part 4. Today, I am here to teach Data Structures in Python, Part 4, Evaluation of Postfix Expression using Stack with Algorithm and Visualization using Stack method. Let's discuss about the evaluation of postfix expression using Stack. Some key points about postfix expressions are: stacks can be employed to evaluate expressions in postfix notation. This approach assumes that the operators within the expressions are binary operators. Postfix notation, also known as reverse Polish notation, RPN, places operators after their operands. The stack helps in processing the postfix expression sequentially. When encountering an operand, it's pushed onto the stack. When an operator is encountered, it's used to operate on the top elements of the stack. The result is then pushed back onto the stack. The process continues until the entire postfix expression is evaluated, and the final result is left on the stack. Now, we are going to write an algorithm to evaluate postfix expression. Step 1. Initialize an empty stack named operand stack to hold operands. Step 2. Start iterating through each character in the postfix expression named postfix expression from left to right. Step 3. For each character in postfix expression. Subdivision A. If the character is an operand, a number, convert it to a numeric value and push it onto operand stack, subdivision B. If the character is an operator, plus, minus, asterisk, slash, etc., do the following. Number 1. Pop the top two values from operand stack. These are the operands. Number 2. Perform the operation indicated by the character on the two operands. Number 3. Push the result back onto operand stack. Step 4. Continue this process until you have processed all characters in postfix expression. Step 5. After processing all characters, the operand stack should contain only one value, which is the result of the expression. Step 6. Pop this value from operand stack to obtain the final result, which is the evaluated value of the postfix expression. So the postfix expression 862 asterisk for slash plus is evaluated to 11. Are you curious about how it operates? Let's take a look at a visualization. Here's the visualization to evaluate postfix expression. Postfix expression given is 862 asterisk for slash plus. Step 1. We are initializing an empty stack named operand stack. In step 2, start iterating through the postfix expression. 862 asterisk 4 slash plus. First symbol scanned is 8. Action done is that element 8 is pushed in operand stack. So, operand stack holds element 8. In the next step, symbol scanned is 6. Action done is that element 6 is pushed in operand stack. So, operand stack holds elements 8 and 6. In the next step, symbol scanned is 2. Action done is that element 2 is pushed in operand stack. So, operand stack holds elements 8, 6 and 2. In the next step, symbol scanned is asterisk. Action done is that pop 2 elements 2 and 6, apply the operator asterisk and push back the result 12. So, operand stack holds elements 8 and 12, output will be 6 multiplied by 2 is 12. In the next step, symbol scanned is 4. Action done is that push 4 in operand stack. So, operand stack holds elements 8, 12 and 4. In the next step, symbol scanned is slash. Action done is that pop two elements 4 and 12, apply the operator slash and push back the result 3. So, operand stack holds elements 8 and 3, output will be 12 divided by 4 is 3. In the next step, symbol scanned is plus. Action done is that pop two elements 3 and 8, apply the operator plus and push back the result 11. So, operand stack holds element 11, output will be 8 added to 3 is 11. It's the end of input expression. Action done is that pop 11 from operand stack. So, operand stack is empty. The final output will be 11. We did it. Let's see another example. Evaluate following postfix expressions while showing status of stack after each operation given: A equals 3, B equals 5, C equals 1, D equals 4. The postfix expression given is A, B asterisk C slash D asterisk. Now let's see the solution. Replacing literals with values. The postfix expression after substitution becomes 3 5 asterisk 1 slash 4 asterisk. So now, look at the tabular column. In the first step, we are initializing an empty stack named operand stack. In step 2, start iterating through the postfix expression. 3 5 asterisk 1 slash 4 asterisk. First symbol scanned is 3. Action done is that element 3 is pushed in operand stack. So, operand stack holds element 3. In the next step, symbol scanned is 5. Action done is that element 5 is pushed in operand stack. So, operand stack holds elements 3 and 5. In the next step, symbol scanned is asterisk. Action done is that pop two elements 3 and 5, apply the operator asterisk and push back the result 15. So, operand stack holds element 15, output will be 3 multiplied by 5 is 15. In the next step, symbol scanned is 1. Action done is that element 1 is pushed in operand stack. So, operand stack holds elements 15 and 1. In the next step, symbol scanned is slash. Action done is that pop two elements 1 and 15, apply the operator slash and push back the result 15. Now, operand stack holds the element 15. The output will be 15 slash 1 is equal to 15. In the next step, symbol scanned is 4. Action done is that element 4 is pushed in operand stack. So, operand stack holds elements 15 and 4. In the next step, symbol scanned is asterisk. Action done is that pop two elements 4 and 15, apply the operator asterisk and push back the result 60. Now, operand stack holds the element 60. The output will be 15 multiplied by 4 is equal to 60. Thus we came to the end of input expression. Action done is pop 60 from operand stack. Now, the operand stack is empty. The final output is 60. We reached our objective. Try to work out by yourself. Data structures in Python, Q, Part 5. Today, I am here to teach Data Structures in Python, Part 5, Q, Implementation of Q as List, creating a queue using list, inserting an element into a queue, yen queue, checking the queue status, deleting elements from a queue, dq, traversal of queue elements. In our previous videos, we delved into the implementation of stacks. Now, let's embark on the journey of implementing queues using Python lists. Similar to stacks, queues involve a sequence of items, a linear list, but they come with specific rules governing how items can be added and removed from this list. In a queue, deletions occur at one end of the list, while insertions happen at the other end. Now, look at the definition. A queue is a linear data structure used in computer science and data management. Queues follow the first in, first out (FIFO) principle, meaning that the element that has been in the queue the longest is the first to be removed. It is a linear collection of elements, arranged in a sequential order. The operations performed are yen queue. New elements are added at the rear or tail of the queue. dq. Elements are removed from the front or head of the queue. Let's see queues in our day-to-day life at various places such as waiting in line at a supermarket checkout, passengers at the bus stop, vehicles in queue for filling gas at the gas station, people waiting to use ATM, etc. In all of these cases, the first person in queue is served first and others can enter the queue only at the end. Thus, a queue is called FIFO, first in, first out data structure, where the item first inserted is the first to get removed. Queue is known as FIFO first in first out approach or FCFS first come first served approach. Look at the example picture. First yellow car into the gas station is the first car out from the gas station. Remember, queue is a linear data structure that follows FIFO policy. Let's discuss about queue in Python. A queue consists of two open ends, front and rear. You can see the front and rear ends in this picture. Data can only be removed from the front end. That is, the element at the front end of the queue. A new data element can only be added to the rear end of the queue. In Python, an empty list is created using the list function. This empty list can be used as a queue data structure. When using a list as a queue, the rear and front of the queue are initially both set to the 0th position in the list. This configuration represents an empty queue with index values starting from 0 and no elements present. In this queue representation, elements are inserted at the rear end. Deletion of an element is performed from the front end of the queue. Similar to a stack, a queue can hold data objects of heterogeneous, multiple types. You can see here the list containing values of different data type. A queue is a specialized list data structure which performs only two operations, that is insertion and deletion. Elements are always added from the rear end of the queue and removed from the front end of the queue. Now, we are going to discuss about the basic operation carried out by a queue as a list are. Creating a queue using list. Inserting an element in a queue, yen queue, checking the status of queue. Deleting elements from a queue, DQ, traversal or displaying queue items. Before entering into the basic operations, some key points to remember. In Python, there's no need to implement overflow operations for queues. This is because Python is a dynamic language, and it doesn't require creating lists with a fixed size. As a result, you will never encounter a situation where the queue is full, eliminating the need to handle overflow scenarios. In Python, creating a list allocates memory and can store a variety of elements, regardless of their data types. Similar to how you can create a stack using the Python list function, you can create a queue in the same manner. The syntax is queue equals list function. That is, an empty queue is created as a variable of list data type. The syntax can also be written as queue equals empty list. It means queue variable is an empty queue as it does not contain any element. Initially, when you create an empty queue using these methods, it doesn't contain any elements. When you add the first element to the queue, it is placed at queue of index 0, and both the front and rear positions are at 0. Subsequent elements are added incrementally, with the front position remaining at 0 and the rear position increasing by 1 for each new element added. This linear structure of a queue can be implemented using a Python list. Now, we're going to discuss about inserting an element in a queue. Enqueue. Let's learn about inserting an element in a queue, that is, enqueue. Enqueue operation adds a new element to the rear end of a queue. Elements can be inserted into the queue as long as there is available space. Attempting to insert elements beyond the queue's capacity leads to an exception called overflow. To insert an element into a queue, the rear position is increment to accommodate the new value. In Python, the append function is used to add elements to a list, which can simulate a queue. Let's see an example. If we want to insert 5 elements, 27, x, 3.6, 89, y, into a queue using a list. Step 1. Initially, the queue is empty, with both front and rear at the same position. Step 2. Insert the first element, 27, into the queue with front equals 0 and rear equals 0. Queue becomes list containing element, 27. Step 3. Next element x is inserted into the queue with front equals 0 and rear equals 1. Rear is increment by 1 and the queue becomes list containing 27x. In step 4. Insert another element, 3.6, into the queue with front equals 0, rear equals 2. So rear is increment again and the queue becomes a list containing elements, 27x, 3.6. In step 5. Insert another element, 89, into the queue with front equals 0, rear equals 3. So rear is increment again and the queue becomes a list containing elements, 27x, 3.6, 89. In step 6. Insert another element, y, into the queue with front equals 0, rear equals 4. So rear is increment again and the queue becomes a list containing elements, 27x, 3.6, 89, y. Have you noticed that, in these 6 steps of inserting elements into a queue, all insertions occur at the rear end? And also, the index value for the rear position changes with each element insertion. In contrast, the index value for the front position remains constant at 0. When the last element is inserted, front stays at the 0th position, while rear reaches the 4th position of the queue. This process of inserting an element into a queue is called enqueue. The position of rear changes with each insertion, allowing elements to be added at the end of the queue. In Python, list function append is used to add elements to the queue. The syntax is queue.append of x. Here, x is the element to be inserted at the rear end position in the queue. If the queue is initially empty, adding element x places it at both the front and rear positions, where front equals 0 and rear equals 0. Let's see an algorithm to insert an element into a list queue. Step 1, start. This step serves as the starting point of the algorithm. It indicates the beginning of the execution of your program. Step 2. Q equals list, function or Q equals empty list. In this step, we initialize an empty queue using a Python list. We have two options to achieve this. Q equals list, function. This line creates an empty list using the list function constructor. Q equals empty list. Alternatively, you can create an empty list using square brackets. The purpose of this step is to create an empty data structure that will represent your queue. Step 3, element equals input of, enter the element to be added to the queue. In this step, we prompt the user to enter an element to be added to the queue. Input of, enter the element to be added to the queue, is used to display a user-friendly message and collect input from the user. The element entered by the user is stored in the variable element. Step 4. Q.append of, element. In this step, we add the element entered by the user to the end of the queue. Q.append of, element, is the command responsible for adding the element to the list, Q, represented by the variable Q. This operation simulates the process of enqueuing, adding an element to the rear of the queue in a typical queue data structure. Step 5. Stop. This step marks the end of the algorithm's execution. It signifies that the task of adding an element to the queue has been completed. Note that the built-in list function append is used to insert elements at the rear end in the queue. Now, we're going to discuss about checking the status of queue. We are going to learn about how to check the status of queue. The constructs which are used to monitor the queue's status when adding or removing elements from it are underflow, peak function, and overflow. Underflow. It checks if the queue contains any elements. That is, it's employed to verify if the queue is empty. This verification is crucial to prevent errors when attempting to remove elements, DQ, from an empty queue. It helps ensure that DQ operations are performed safely without trying to remove elements from an empty queue. Let's see the algorithm to check an empty queue. Step 1. Start. This step marks the beginning of the algorithm's execution. Step 2. If Q equal to empty list. Or if not Q or if not len of Q. In this step, you are checking if the queue is empty using different conditions. Any of these conditions will be true if the queue is indeed empty. Here's what each condition does. If Q equal to empty. This condition checks if the queue is an empty list. If not Q. This condition checks if the queue evaluates to false, which happens when it's empty. If not len of Q. This condition checks if the length of the queue is 0, which indicates an empty queue. If any of these conditions is true, it means that the queue is empty, and the program proceeds to the next step. Step 3. Stop. This step signifies the end of the algorithm's execution. Next construct, which is used to monitor the queue's status when adding or removing elements from it, is the peak function. Peak operation is used to view elements at the front end of the queue, allowing us to see them without actually removing them out of the queue. Let's see the algorithm to display first element without deleting it using peak function. Step 1. Start. This step marks the beginning of the algorithm's execution. Step 2. If Q equal to empty list. In this step, we first check if the queue is empty using the condition Q equal to empty square brackets. If it's true, the queue is empty, we proceed to the next substep. Substep A. Print of Q is empty. If the queue is empty, this substep prints the message Q is empty to indicate that there are no elements in the queue. Substep B. Go to step 4. This substep directs the program to skip the next step, step 3, and proceed directly to step 4. Step 3. Print of Q of 0. In this step, if the queue is not empty, meaning it contains elements, you print the first element of the queue. Q of 0 accesses the element at the front of the queue without removing it. This simulates the behavior of a peak operation. Step 4. Stop. This step signifies the end of the algorithm's execution. Next construct, which is used to monitor the queue's status when adding or removing elements from it, is the overflow. Overflow checking serves the purpose of verifying whether there is enough space in the queue to add more elements. Its primary goal is to prevent situations where the queue becomes too full, which could lead to errors or problems when trying to add elements using in-queue operations. By performing overflow checks, you ensure that the queue's capacity is not exceeded, thereby avoiding potential issues during the addition of new elements. Now, we're going to discuss about deleting elements from a queue, DQ. Let's learn about deleting elements from a queue, DQ. It is mandatory to check whether the queue is empty before deleting an element. Deleting elements from a non-empty queue is done from the front end of the queue. The process of removing an element from a queue is called dequeue. Dequeue operation removes one element at a time from the front of the queue. Elements can be deleted from a queue until it becomes empty. Attempting to delete an element from an empty queue results in an exception known as underflow. In Python, you can use the built-in list function del or pop to remove elements from a queue. Syntax is queue.pop of 0. It deletes the element at the front end, index 0, of the queue. It returns the deleted element. It allows you to remove and retrieve the front element simultaneously. Another syntax is del queue of 0. It deletes the element at the front end, index 0, of the queue. It does not return the deleted element. It only removes the element from the queue without providing its value. To delete an element from the front end of a queue, use the pop of 0 function in Python. The 0th position represents the front of the queue, so pop of 0 removes the element at the front. After removal, all elements following the deleted element are shifted to fill the gap. Pop of 0 returns the value of the removed element. This operation maintains the order of elements in the queue, effectively simulating queue behavior in Python. Let's see the algorithm to delete an element from a list queue. Step 1. Start. This step indicates the beginning of the algorithm, where the execution starts. Step 2. If queue equals empty list. This is a conditional statement that checks whether the queue is empty or not. The square brackets typically represent an empty list. Step 2. Continued. Print queue is empty. If the queue is empty, this line of code prints the message queue is empty to indicate that the queue does not contain any elements. Step 2. Continued. Go to step 4. If the queue is empty, the algorithm jumps to step 4, which means it will skip step 3 and proceed to the final step, step 5. Now, look at step 3. Element equals queue.pop of 0, or del queue of 0. This step assumes that the queue is not empty because it follows the conditional check in step 2. It involves removing an element from the front of the queue. Depending on the programming language used, you might use either the pop of 0 method if queue is implemented as a list, or the del queue of 0 statement to achieve this. The removed element is stored in the variable element. Step 4. Print element. After removing an element from the queue in step 3, this step prints the removed element to the output. Step 5. Stop. This step marks the end of the algorithm. The execution terminates here. Note that a queue is a data structure that follows the FIFO, first in first out, principle, allowing insertions at the rear and deletions at the front. Let's see an example. The list queue, which we created, holds 5 elements, 27, x, 3.6, 89, y. To remove these elements one by one from the queue front, the following steps have to be done along with the value changed for front and rear position. Now, look at step 1. A queue consists of 5 elements as shown here. Step 2. Execute pop of 0, or pop front function to delete or remove front element, which is 27. After deleting the front element, that is 27 from the queue list, the new queue automatically fills the gap and the list is shifted one position towards the left. You can see in the last picture how the new queue has filled the gap and the list is shifted to one position towards the left. Step 3. Look at the first picture. Use pop of 0, or pop of front to remove front element, that is x, from the queue list. After deleting the front element, that is x, from the queue list, the new queue automatically fills the gap and the list is shifted one position towards the left. Now, look at the second picture, how the new queue has filled the gap and the list is shifted to one position towards the left. Step 4. Look at the first picture. Use pop 0, or pop front to remove front element, that is 3.6, from the queue list. After deleting the front element, that is 3.6, from the queue list, the new queue automatically fills the gap and the list is shifted one position towards the left. Now, look at the second picture, how the new queue has filled the gap and the list is shifted to one position towards the left. Step 5. Look at the first picture. Use pop 0, or pop front to remove front element, that is 89 foot, from the queue list. After deleting the front element, that is 89 foot, from the queue list, the new queue automatically fills the gap and the list is shifted one position towards the left. Now, look at the second picture. Here front end and rear end is 0, holding element y. Step 6. Look at the first picture. Use pop 0, or pop front to remove front element, which is also the last element, that is y, from the queue list. After deleting the front element, that is y, from the queue list, the queue becomes an empty queue. Now, look at the second picture. It's an empty queue. So, we have performed 5 deletion operations, also called as dequeue, which results in an empty queue. Now, we're going to discuss about traversal or displaying queue items. Let's learn about the traversal or displaying queue items. Queue traversal is a method for accessing and displaying elements in a queue data structure. To traverse a queue, first, calculate its length using the built-in function len, and store it in a variable, for example, length. Use a for loop that starts from index 0 and continues until the length of the queue. In each iteration of the loop, display the element at the current index in the queue. Let's see the algorithm. Step 1. Start. This step marks the beginning of the algorithm, where the execution begins. Step 2. Length equals len of queue. In this step, the algorithm calculates the length of the queue, which is the number of elements it contains. The len of the queue function is used to determine the length, and the result is stored in the variable length. Step 3. For I in range of 0, length. This step sets up a loop that iterates through the queue's elements. It uses a for loop that starts from I equals 0 and continues until I reaches the value of length 1. Essentially, it goes through each index in the queue. Step 3, continued. Print queue of I. Within the loop, this line of code prints the element at the current index I in the queue. It retrieves and displays each element one by one as the loop iterates. Step 5. Stop. This step marks the end of the algorithm, indicating that the execution has completed. In the upcoming video, we will demonstrate how to write a comprehensive Python program that encompasses all the queue operations. Be sure not to miss it. Data Structures in Python Queue Part 6. Today, I am here to teach Data Structures in Python, Part 6, Queue, Implementation of Queue as List, Practical Implementation, Applications of Queues, Similarities and Differences between Stack and Queue. In our previous videos, we delved into the foundational principles of a queue, a data structure that mimics a line of people, where the first one to join is the first to depart. Let's recall the basic concepts of queue. Queues are a type of linear data structure that follows the first in first out, FIFO, principle, meaning that the first element added to the queue will be the first one to be removed. In Python, yen queue and dequeue are terms commonly associated with data structures called queues. Yen queue. Yen queue refers to the process of adding an element to the end, rear, of a queue. In Python, you can yen queue an element by using the append method for a list, as lists can be used to implement a simple queue. Let's see an example. In this code, first queue is empty list. After that we append the values 1, 2, 3, and print. When you run this code, it will display the output shown here. This output shows the queue after performing the yen queue operations, and you can see that the elements 1, 2, and 3 have been added to the queue in that order. Dequeue. Dequeue refers to the process of removing the element from the front of the queue. In Python, you can dequeue an element by using the pop of a 0 method for a list, which removes the first element. Let's see an example. Here in this code the queue is empty at first, then elements 1, 2, 3 are added in the queue list. If condition len of queue is greater than 0, front underscore element is removed using pop of 0. Then it gets printed. After deleting all the elements queue is empty. After running this code, front underscore element will contain the value that was at the front of the queue, in this case, 1, and the queue will be list containing 2, 3. Now, let's delve into their practical implementation. Example 1. Write a program in Python to add, delete and display elements from a queue using list. Adding is yen queue. Deleting is dequeue. Now, look at line 1 of this Python code. We are initializing an empty list called queue to represent our queue data structure. This program is a menu-driven program. Before that we are defining the functions, yen queue of item, dequeue function, display function and is underscore empty function. In line 3, we are define a function yen queue to add an item to the queue. In line 4, we are using the append method to add the item to the end of the queue list. In line 5, we are print a message to confirm the addition. Next, we are define a function dequeue to remove an item from the queue. In line 8, check if the queue is not empty. In line 9, we use the pop of 0 to remove the item at the front of the queue list. In line 10, we print a message to confirm the removal. In line 11, 12, else, we are printing a message if the queue is empty. Cannot dequeue. In line 14, we are defining a function display to show the current elements in the queue. In line 15, we are checking if the queue is not empty. In line 16, we are printing the contents of the queue list. In line 17, 18, else, we are printing a message if the queue is empty. In line 20, we are defining a function is underscore empty to check if the queue is empty. In line 21, we are returning true if the length of the queue list is 0, otherwise, returning false. In line 23 to line 28, we are starting an interactive menu-driven loop, including the queue operations, yen queue, DQ, display, quit. In line 29, we are prompting the user for their choice. In line 31, if choice is equal to 1. In line 32, we are prompting the user to enter an element to yen queue. In line 33, we are calling the yen queue function to add the item to the queue. In line 34, 35, if choice equals 2, we are calling the DQ function to remove an item from the queue. In line 36, 37, if choice equals 3, we are calling the display function to show the current elements in the queue. In line 38, 39, if choice equals 4, we are printing a message to indicate program exit. In line 40, break statement. It exits the loop and ends the program. In line 41, 42, we are printing a message for an invalid menu choice. Now, let's look at the output. Look at the left column. When choice equals 1, it's yen queue, so element 22 is added. Again, when choice equals 1, it's yen queue, so element 46.5 is added. Now, look at the second column. Again, when choice equals 1, it's yen queue, so element X is added. Now, the choice is 3, so it displays the queue list as 22, 46.5, X. Look at the left column. Now the choice is 2, you get the message removed 22 from the queue. The front element 22 is deleted from the queue. Now the choice is 3. It displays the queue list as 46.5, X. Now the choice is 2. You get the message removed 46.5 from the queue. The front element 46.5 is deleted from the queue. Now the choice is 3. It displays the queue list as X. Now the choice is 2. You get the message, removed X from the queue. Now the choice is 3. It displays, queue is empty, as we have deleted all the elements one by one using the DQ operation. Now, look at the right side. Choice is 4, you get the message exiting the program. Program completed. Try to work it by yourself. Let's see the applications of queue. Printer queue. It manages and prioritizes print jobs in multi-user environments. Let me explain. Queues are vital for handling multiple print requests in a network printer. When the printer is busy, new print requests are queued on the hard disk. The queued jobs wait until the printer becomes available. Queues maintain order in a multi-user printing environment. Second point is single-user systems. Task scheduling and orderly task execution. Let me explain. Queues are utilized in single processor systems with one user at a time. Users requesting system access are placed in a queue. The queue ensures fairness and order for user access in a single-user environment. Third application is real-time systems. Handling interrupts in the order they occur. Let me explain. Real-time systems face interrupts that need immediate handling. For sequential and timely interrupt processing, FIFO queues are used. FIFO queues maintain the order of interrupt handling in real-time systems. Fourth point is simulating wait, demonstrating orderly execution in scenarios involving waiting. Call center phone systems use a queue to hold people in line until a customer representation gets free. Fifth point is playlist ordering. Managing the order of songs in playlists. Buffers on MP3 players and portable CD players, iPad playlists, etc., and songs to the end and play from the front OD the list. Let's see the similarities and differences of queues and stacks. Similarities. Linear data structures. Both queues and stacks are linear data structures, meaning they organize elements in a linear or sequential manner. Addition and removal of elements. Both data structures support operations to add and remove elements, although with different rules for these operations. Let's see the differences between queue and stack. Queue follows first in first out, FIFO, principle, whereas stack follows last in first out, LIFO. In queue, the primary operations are yen queue, add to rear, DQ, remove from front. In stack, the primary operations are push means add to top and pop means remove from top. Use cases. Queue. Maintaining order, process items in the order they arrive, for example, print job management, BFS breadth first traversal. In stack. Managing function calls, evaluating expressions, for example, programming function call stack. In real-world analogy, in queue, queue of people waiting in line at a ticket counter. In stack, stack of plates, where you add and remove from the top. Implementation options. In queue, arrays, linked lists, circular queues are used. In stack, arrays, linked lists are more flexible for resizing. Python exception handling, part 1. In this video, we can learn about the errors in Python and debugging, syntax error, runtime error, logical error, what is exceptional handling with practical implementation. Let's dive in and get started. The computer programs we develop, exceptions, errors, or unusual circumstances can also arise in our everyday experiences. Let's consider a real-life scenario. You leave your house for a picnic by car. On the way, the tire bursts and you are forced to stop the car and replace the tire. In this scenario, the punctured tire is the exception that has occurred unexpectedly. In such a situation, we are required to carry along a spare tire, so that we can change the punctured tire then and there and continue with our journey. This concept is similar to exception handling in computer programming. Many times, when people write code for making applications, they make errors in it. So, when your app suddenly stops working out of the blue, it's usually because of one of these mistakes or errors. But, we all know that fixing these errors is just something we have to do when we're making apps. The process of finding errors in a program is termed as debugging. Errors in a program can cause it to not work properly or give incorrect results. That's why it's important to identify and fix these errors to ensure the program runs correctly. Errors in Python are classified mainly into three types: syntax error, runtime error, logical error. Syntax means the arrangement of letters and symbols in code. So if you get a syntax error, it usually means you've misplaced a symbol or letter somewhere in your code. Python will usually tell you which line and where in the line the problem is. It is completely normal for beginners to make syntax errors all the time. The only thing that helps is practice. What is a syntax error? A syntax error is an error in the syntax of a sequence of characters or tokens that is intended to be written in a particular programming language. Syntax errors occur when the structure of code violates the rules of a programming language. Syntax errors are the most common types of errors and are easily traceable. They occur while the statement is being translated to machine language and before being executed. Example: incorrect indentation, misspelling a keyword. Learning out a symbol such as colon, comma, or parentheses. They can be corrected by the user as the reason for the error and an appropriate message about what is wrong in the program is displayed. Let's see some examples. One of the syntax error is incorrect indentation. What is indentation? Indentation in programming refers to the spaces or tabs placed at the beginning of a line of code to visually represent the structure or hierarchy of the code. In many programming languages, including Python, indentation is not just a matter of style but is syntactically significant. What is incorrect indentation? Now look at this example. In this example, the print statement is incorrectly indented. That is without spaces, white spaces. In Python, the standard convention for indentation is to use 4 spaces for each level of indentation. In Python, indentation is crucial for defining the structure of code blocks, such as functions, loops, and conditional statements. Below you can see the correct indentation of the print statement. So we can correct the syntax error when the errors are displayed. Next syntax error is misspelling a keyword. In this example, the keyword while is misspelled as while. Python is case sensitive, so even a small typo like this can lead to a syntax error. Below you can see while spelled correctly. Next syntax error is missing colon. In this example, the colon is missing at the end of the if statement. It's a syntax error. Colons are used to denote the beginning of an indented code block for constructs like if, for, while, and function definitions. Below you can see the colon included. Next syntax error is missing comma. In this example, commas are missing between the elements of the list, 1, 2, 3, 4, 5. Below, you can see the commas included between elements of the list. Next syntax error is missing parentheses. In this example, the closing parenthesis is missing at the end of the print statement. All open parentheses must be matched with a closing parenthesis in Python. You can see the closing parentheses done and the output scene is hello world. These are common mistakes that can result in syntax errors in Python code. Always double-check your code for these kinds of errors, and pay attention to error messages provided by Python, as they often indicate the location and nature of the syntax problem. In Python, print function is a built-in function used to display output. It's important to note that Python is case-sensitive, so print function with lowercase p is the correct syntax, while print function with uppercase p would result in a syntax error. So when print function with lowercase p is typed, it prints welcome to Sallyann bytes. Next error in Python is the runtime error. A runtime error in Python refers to an error that occurs during program execution rather than during compilation, indicating an issue that prevents the program from running correctly. That means a runtime error occurs after Python interpreter interprets the code you write and the computer begins to execute it. Runtime errors come in different types and some are hard to find. Errors are exceptional, unusual, and unexpected situations and they are never part of the normal flow of a program. You have a runtime error when the application suddenly stops running and displays an error exception dialog box, or when the user complains about erroneous output. It usually results in abnormal program termination during execution. Note: Python is an interpreted language, which means that Python code is executed line by an interpreter without the need for a separate compilation step. The Python interpreter translates the code into machine code at runtime, executing it immediately. This is why Python runtime errors occur during program execution rather than during a separate compilation phase. In Python, such unusual situations are termed as exceptions. Exceptions are usually runtime errors. Let's see some examples of runtime error. Division by 0. Look at the yellow box. Result equals 10/0. This will raise a zero division error because dividing by 0 is not allowed in arithmetic operations. Zero division error is a built-in Python exception that occurs when attempting to divide a number by 0. This error typically happens when you attempt to perform division where the divisor, the number you're dividing by, is 0, which is mathematically undefined. Next runtime error. Performing an operation on incompatible types. Look at the yellow box. The statement result equals hello plus 5 attempts to concatenate a string, hello, with an integer, 5. However, in Python, concatenating a string with a non-string, such as an integer, using the plus operator raises a type error. In Python, the plus operator is used for both addition, when applied to numbers, and concatenation, when applied to strings. When you use plus with a string and another non-string type, Python expects both operands to be strings to perform concatenation. If one of the operands is not a string, Python doesn't know how to concatenate them, hence raising a type error. Next runtime error. Using an undefined identifier. Look at the yellow box. In the statement print, undefined underscore variable, you're attempting to print the value of a variable named undefined underscore variable. However, if undefined underscore variable has not been previously defined or assigned a value in the code, Python will raise a name error. A name error occurs when you try to use a variable or identifier that hasn't been defined in the current scope or namespace. Python requires that variables be defined before they are used, either by assigning them a value or declaring them as part of the program's structure. Next runtime error. Accessing list elements. Look at the yellow box. In the statement my_list equals list containing elements 1, 2, 3, you're creating a list named my_list containing 3 elements, 1, 2, and 3. Lists in Python are 0 indexed, meaning the index of the first element is 0, the second element is 1, and so on. However, in the subsequent statement print, my_list of 3, you're attempting to access the element at index 3 of the list my_list. Since lists are 0 indexed and my_list contains only 3 elements, the valid indices for my_list are 0, 1, and 2. Therefore, trying to access my_list 3 is beyond the bounds of the list and will result in an index error. Next runtime error. Accessing dictionary values. Now, look at the yellow box. In the statement, look at the first line, you're creating a dictionary named my_dict with 2 key value pairs, A:1 and B:2. Dictionaries in Python are collections of key value pairs, where each key must be unique. However, in the subsequent statement print of my_dict is C, you're trying to access the value associated with the key C in the dictionary my_dict. Since the key C does not exist in the dictionary my_dict, attempting to access it will result in a key error. Next runtime error. Accessing object attributes that don't exist. Look at the yellow box. Here, we define a class myClass with a constructor __init___ method that initializes an instance variable attribute with the value 42 for any instance created from this class. Then, we create an object of type myClass using the constructor myClass function. This object has an attribute named attribute initialized to 42. However, in the subsequent line print, obj.nonexistent_attribute, we're attempting to access an attribute named nonexistent_attribute of the object obj. Since nonexistent_attribute was never defined for instances of myClass, attempting to access it will result in an attribute error. So how should the code be to print the value 42? We access the existing attribute of the object obj and print its value. This will correctly print 42 without raising any attribute error because attribute is defined for instances of myClass. You can see the corrected code on the right side highlighted in blue color. Corrections done for the previous example and it outputs the value 42. Next runtime error, trying to access a file that doesn't exist. Look at the yellow box. Here we're attempting to open a file named nonexistent_file.txt in read mode, R, using a with statement. This with statement is commonly used in Python for handling files because it automatically closes the file after the block of code inside it is executed. However, if the file non-existent_file.txt does not exist in the specified location, Python will raise a file not found error when attempting to open it. This exception occurs when Python tries to access a file that doesn't exist in the file system. Let's learn about logical errors. A logical error in programming, also known as a bug, called semantic error, occurs in Python when the code runs without any syntax or runtime errors but produces incorrect results due to flawed logic in the code. These types of errors are often caused by incorrect assumptions, an incomplete understanding of the problem, or the incorrect use of algorithms or formulas. Identifying and fixing logical errors can be challenging because the code may run without raising any errors, making it harder to pinpoint the issue. The error is caused by a mistake in the program's logic. You won't get an error message because no syntax or runtime error has occurred. Debugging techniques such as code inspection, printing intermediate values, and using a debugger are often employed to locate and rectify logical errors. Let's see some examples of logical errors. Using the wrong variable name for calculations. Look at the yellow box. The mistake here is that the variable pi is used without being defined anywhere in the code. It seems like the intention is to use the mathematical constant pi to calculate the area of the circle. However, in Python, the constant pi is not built in, you need to import it from the math module. The correct way to use the pi constant is by importing it from the math module and referencing it as math.pi. So, the corrected version of the code would be, you can see on the right side of the screen, highlighted in yellow color. Import math, radius equals 5. Area equals math.pi star radius raised to the power 2. Print the area of the circle, area. Next logical error. Using integer division instead of the division operator. The intention here is to calculate the average speed in miles per hour, mph, by dividing the distance in miles by the time in hours. However, the code uses the integer division operator, // instead of the regular division operator, /. Integer division returns the quotient of the division, discarding any fractional part, so the result will always be an integer rounded down towards -infinity if necessary. Using integer division in this context is incorrect because it rounds down the result to the nearest integer, which does not accurately represent the average speed in mph. Instead, the regular division operator should be used to get the correct average speed with decimal precision. Next logical error. Using modulus operator instead of the division operator. The intention here is to calculate the total number of pages required to display all the items, given the total number of items, total_items, and the number of items per page, items_per_page. However, the code uses the modulus operator, %, instead of the regular division operator, /. The modulus operator returns the remainder of the division operation, not the quotient, which makes it unsuitable for calculating the total number of pages. However, using the modulus operator in this context is incorrect because it provides the remainder of the division operation, not the total number of pages required. Instead, the regular division operator, /, should be used to get the correct total number of pages. Next logical error. Giving wrong operator precedence. Look at the blue box. In this example, the code intends to calculate the result of adding 5 to the product of 3 and 2. However, due to incorrect operator precedence, the multiplication, 3 multiplied by 2, is evaluated first before the addition, 5+. As a result, the multiplication is performed before the addition, and the result becomes 5 plus 6, which equals 11. To fix this error, parentheses should be used to enforce the correct order of operations. Now, look at the yellow box. With the corrected precedence, the addition, 5 plus 3, is performed first, which is enclosed in brackets, Bodmer's rule, brackets first, resulting in 8, and then the multiplication, 8 multiplied by 2, is performed, resulting in the correct answer, which is 16. What is the meaning of exception? An exception is an unexpected problem that can occur while a computer program is running. An exception is like a surprise problem that happens when you're playing a game or doing something fun on the computer. Imagine you're playing a game and suddenly your character gets stuck in a place it's not supposed to be. That's an exception. It's like a little bug in the game that makes something unexpected happen. But don't worry. Just like how you ask a grown-up for help when you're stuck in a game, programmers have ways to fix these surprises in their computer programs too. They use special tricks called exception handling to catch these surprises and make sure the game keeps running smoothly. Now, what is exception handling? Exception handling is the process of managing and dealing with unexpected problems or errors that arise during the execution of a computer program to prevent crashes and ensure smooth operation. An exception can be described as an interrupt or an event triggered during the normal flow of the execution of a program, which is to be handled carefully. Now listen. It's a situation where something unexpected happens that disrupts the regular flow of the program. This interruption could arise due to various reasons such as invalid user input, hardware malfunctions, network issues, or even logical errors within the program itself. come to the blue point. When an exception is raised on account of some error, the program must contain code to catch this exception and handle it properly. Let me explain. Imagine you're following a recipe to bake a cake. Suddenly, you realize you're out of eggs. This is like an exception, something unexpected happened that could mess up your cake. So, what do? You handle it. You might have a plan for when things go wrong. Maybe you remember you can use applesauce as an egg substitute. That's your way of catching the problem and solving it. In programming, it's the same idea. When something unexpected happens, like dividing by zero or trying to open a file that doesn't exist, the program raises an exception. Your code needs to be ready to catch these exceptions and deal with them gracefully. It's all about being prepared for surprises and making sure your program can keep running smoothly, just like making sure your cake turns out okay even if you're out of eggs. Exceptions are often used with network and file operations. Important terms related to exception handling. Traceback. Let me explain. Think of traceback like a map that shows the path your program took before it got stuck because of an error. Imagine you're following a trail in the woods, and suddenly you hit a big tree blocking your way. The traceback is like a map that helps you trace back the steps you took before you reached that tree. It tells you which paths you followed, where you turned, and how you ended up at the tree. In programming, when there's an error, the traceback shows the steps the program took before it ran into the problem. It tells the programmer which parts of the code were running, where the error happened, and what functions were involved. This helps programmers figure out what went wrong and how to fix it. Now come to the point. When an exception occurs in a program, the traceback is a detailed report that shows the sequence of function calls leading up to the point where the exception was raised. It provides information about the file names, line numbers, and specific functions involved in the execution path, helping developers diagnose and troubleshoot errors. Next is try block. Let me explain. Imagine you're building a sandcastle on the beach, but you know that sometimes big waves can come and knock it down. The try block is like putting a protective barrier around your sandcastle. It's a special area where you know things might go wrong, so you're ready for it. You put all the important parts of your sandcastle inside this protected area. Now, if a big wave, an exception, comes and hits your sandcastle, your code, the try block acts like a shield. It tries to catch the problem before it causes too much damage. If something goes wrong inside the try block, instead of crashing your whole program, the try block helps keep things under control. So, in simple terms, a try block is like a safety net for your code. It's where you put the parts of your program that might have problems, so if anything goes wrong, you can handle it without everything falling apart. Now come to the point. A try block is a section of code where potential exceptions are anticipated and monitored. It encloses the code that might raise an exception. If an exception occurs within the try block, the program attempts to handle it according to the associated catch blocks. Except block or catch block. Let me explain. Let's imagine you're playing a game where you're trying to catch different types of animals. Sometimes you might catch a bird, sometimes a fish, and sometimes a rabbit. Now, when you catch each of these animals, you want to handle them differently, right? The except block is like having special cages for each type of animal you catch. When you catch a bird, you put it in the bird cage. When you catch a fish, you put it in the fish tank. And when you catch a rabbit, you put it in the rabbit hutch. Similarly, in programming, the except block is where you handle different types of problems that might occur in your code. Each except block is like a cage that's designed to catch a specific type of problem or exception that could happen in your program. For example, you might have one except block to catch errors related to not finding a file, another for dividing by zero, and so on. So, when a problem happens inside the try block, the program looks at all the except blocks to see if there's one that matches the type of problem. If it finds a match, it knows how to handle that specific problem using the code inside that except block. It's like having a plan for each type of problem your program might encounter, so you can deal with them in the best way possible. Now come to the point. An except block, or catch block in some languages, is used to catch and handle specific types of exceptions that occur within the corresponding try block. Each except block typically specifies the type of exception it can handle and contains code to respond to the exception appropriately. Let's imagine you're playing a game of hot potato. The goal is to pass the potato around, but if someone drops it, they have to shout oops and throw it to someone else. In programming, when something unexpected happens in your code, you can use a throw block, or raise block in some languages, to shout oops, and pass the problem to another part of your program. Here's how it works. Imagine you're writing a program to count apples, but suddenly you find a rotten one. Instead of dealing with the rotten apple right where you found it, you throw it, or raise it, to a different part of your program that knows how to handle rotten apples. So, when you encounter a problem in your code and you want to make sure it's handled properly, you use a throw or raise statement. This tells the program that something unexpected happened, and it needs to pass the problem to another part of the code that knows how to deal with it. Then, like passing the hot potato, the problem gets passed up through the different parts of your program until it reaches a place where it can be handled, like an except block we talked about earlier. This helps keep your program organized and ensures that problems are dealt with in the right way. Now come to the point. The throw block, or raise block in some languages, is used to explicitly raise an exception at a particular point in the code. When a throw or raise statement is encountered, the specified exception is generated and propagated up the call stack until it is caught and handled by an appropriate except block. Unhandled, uncaught, exception. Let me explain. Imagine you're playing a game of Pass the Parcel, where everyone sits in a circle and passes a parcel around while music plays. When the music stops, whoever is holding the parcel unwraps one layer. Now, imagine if the parcel is accidentally dropped by someone, and nobody catches it. The parcel hitting the ground represents an unhandled exception. In programming, it's like having a problem occur in your code, but you haven't written any instructions on what to do if that problem happens. So, when an unhandled exception occurs in a program, it's like dropping the parcel and not knowing what to do next. The program doesn't have any instructions on how to deal with the problem, so it can't continue running smoothly. In most cases, the program will stop running altogether, and an error message or traceback will appear, showing where the problem occurred and why. This helps the programmer understand what went wrong so they can fix it. Now come to the point. An unhandled exception refers to an exception that is not caught and handled by any except block within the program. If an exception remains unhandled, it typically results in the termination of the program and may produce an error message or traceback indicating the cause of the exception. Python Exception Handling Part 2. Today, I am here to teach Exception Handling Part 2, Standard Exceptions in Python, Common Python Exceptions with Practical Implementation. Let's discuss about the standard exceptions in Python. So let's recall what we learned in the previous video. What is an exception? Irregular, unexpected situations occurring during runtime are called exceptions. Exceptions may occur even if the program is free from all types of errors. What is exception handling in Python? Python provides us a way to handle exceptions so that the script does not terminate but executes some specific code when an exception occurs. This concept is called exception handling. Note: an exception can be addressed by its name. Python has some built-in exception names for common exceptions. If required, a programmer can also define his or her own exceptions. When an exception occurs in a program, we say that exception was raised or thrown. Next we deal with it and say it is handled or caught. And the code written to handle it is known as exception handler. For handling exceptional situations, Python provides raise statement to raise exception in the program. Assert statement. An assert statement in Python is used to test an expression in the program code. And try except statement for catching and handling errors. Try except statement will be covered in the next video, Exception Handling Part 3. So now, let's learn about the raise statement. Python raises an exception whenever it tries to execute invalid code. The raise statement can be used to throw an exception. It interrupts the normal flow of the program and passes control to the exception handling mechanism. It allows you to throw an exception at any time. Let me explain in detail. Raise statement allows the program to force a specified exception to occur at runtime. Python automatically raises an exception when it encounters an error during the program execution. Once an exception is raised or thrown, it is up to caller function to either handle it using try except statement or let it propagate further. The syntax is raise of exception name of message or argument of traceback. Here, exception name is the type of error, which can be string, class, or object. It is an instance of exception class. Argument is the value or parameter passed to the class. It is a short message that describes the error. You can also give your own message for notifying error to the user. As the argument is optional, its default value none is used in case the argument is not provided. Traceback section succeeds the argument when any exception is raised or thrown. Let's see an example for raising or throwing an exception. Look at the yellow box. Line 1 assigns the value 100 to the variable x, line 2. This line starts an if statement that checks if the value of x is greater than 50. Line 3. If the condition in the if statement, x greater than 50, evaluates to true, this line raises an exception. An exception is a signal that indicates that an error or unexpected event has occurred during the execution of the program. In this case, the exception being raised is of type exception, and it includes the message x should not exceed 50. Let's see the output. Traceback, most recent call last. This line indicates that Python is displaying the traceback, which includes information about the sequence of function calls that led to the exception being raised. It starts with the most recent call and goes back through the call stack. The next line provides information about the location of the error. It tells you that the error occurred in a file named raiseexception1.py at line 3. Next line is the code that raised the exception. It tells you that an exception was raised with the message x should not exceed 50. Last line shows the type of exception that was raised, exception, and the message associated with it, x should not exceed 50. You can see line that raised the exception, exception, and descriptive message typed boldly in yellow boxes for your reference. Let's learn about the assert statement. An assert statement in Python is used to test an expression in the program code. If the result after testing comes false, then the exception is raised. This statement is generally used in the beginning of the function or after a function call to check for valid input. The syntax is assert expression of arguments. On encountering an assert statement, Python evaluates the expression given immediately after the assert keyword. If this expression is false, an assertion error exception is raised which can be handled like any other exception. Let's see an example of assert statement. Look at the yellow box for the Python code. Line 1. This line simply prints the message use of assert statement to the console. Line 2. Defines a function named -check which takes a single parameter number. Line 3. This line contains an assert statement. It checks if the number passed to the function is greater than or equal to 0. If it's not, it raises an assertion error with the message oops negative number. Line 4. If the assert statement passes, that is, number is non-negative, this line calculates the square of the number and prints it. Line 5. Calls the -check function with the argument 100. Since 100 is non-negative, the assert statement within the function passes, and it prints the square of 100, which is 10,000. The output will be the result of this calculation. Line 6. Calls the -check function with the argument -350. Since -350 is negative, the assert statement within the function fails, and it raises an assertion error with the message oops negative number. The program terminates at this point, and nothing is printed as a result. Let's see the output. Look at the pink box for the output. You can see 10,000 displayed. This value is printed because the function -check of 100 is called, and 100 is a non-negative number. The assert statement within the function passes, allowing the function to compute and print the square of 100, which is 10,000. You can see none displayed below 10,000. This is printed because the function -check of -350 is called, and -350 is a negative number. When the assert statement within the function fails, an assertion error is raised, causing the function to terminate abruptly without reaching the print statement that calculates the square. Since the function does not explicitly return any value in this case, the default return value of a Python function, which is none, is printed. Now look at the traceback. This is a Python error message that shows the sequence of function calls and file names leading up to the error. It indicates that an assertion error occurred in the -check function at line 3 of the file assert.py when the input -350 was provided, as expected due to the assert statement failing. The message assertion error, oops negative number specifies the reason for the assertion error, indicating that a negative number was encountered. Let's see some standard built-in exceptions available in Python. Name error. Raised when an identifier is not found in the local or global namespace. Type error. Raised when an operation or function is attempted that is invalid for the specified data type. Value error. Raised when a built-in operation or function receives an argument that has the right type but an inappropriate value. Zero division error. Raised when division or module by zero takes place for all numeric types. Attribute error. Raised when an object does not find an attribute. Key error. Raised when a mapping, dictionary, key is not found in the set of existing keys. Indentation error. Raised due to incorrect indentation. I/O error. Raised if the file requested cannot be opened, or failure of input or output operation. Index error. Raised when an index is not found in a sequence. That is, out of range or out of bounds. Import error. Raised if Python cannot find the module requested for in a program. EOF error. Raised when one of the file methods, that is, read function, readline function, or readlines function tries to read beyond the file. Syntax error. Raised when there is an error in Python syntax. Runtime error. Raised when an error does not fall under any specific exception category defined above. All the above predefined exceptions can be used with raise statement. Let's discuss these exceptions in detail with example. Name error. A name error in programming typically occurs when you try to use a variable or a function that hasn't been defined yet. It means Python doesn't recognize the name you're trying to use. It is raised when a function name or variable name is not found in the local or global namespace. If you get a name error, check if the variable name or function name has been typed correctly or not, has been given in quotes or defined somewhere else where it is not required. Note: local variables are local. You cannot refer to them from outside the module or function where they are defined. Let's see an example. When writing a function with a name, we often miss calling the exact function name in the future, which will lead to a name error. Now, look at the code. In this Python code, there's a function named calc_sum defined, which takes two parameters x and y. Within the function, it calculates the sum of x and y and stores the result in a variable op. Then, the function returns this result using the return statement. After defining the function calc_sum, the code calls this function with arguments 5 and 10. Here is the name error. It was initially built to conduct some operation between two numbers and named calc_sum, but when we called it, we used the name calc_su, therefore, it had not previously been defined, and it would throw us a name error. The error in this code is likely due to the misspelling of the function name calc_su instead of calc_sum. The function call calc_su of 5, 10 doesn't match the function name calc_sum. Hence the corrected code, S1 equals calc_sum of 5, 10. So the output will be 15. Now, let's see the description of the name error. Look at the red box. Traceback. It describes a list of the functions which were running and displayed at the time of occurrence of the exception. The second line defines the path. I have highlighted in a yellow box. It defines the path where in the program the exception has occurred. That is the name of the program, which is nameerror1.py in the given example alone with the line number 6. The third line shows the actual place of error, that is the statement in which the error has occurred, which is print method. The fourth and the last line explains that the exception has been raised because of the undefined variable calc_su. Thus, from this example, we can say that the exception name error usually contributes as a result of undefined variable. A mistyped variable or function name, the name was to be enclosed within the quotes. Type error. Type error is raised when an operation or function is attempted that is invalid for the specified data type. For example, if we are trying to do the square root of a number but we are passing a list instead of int, then type error will be generated by the Python. Reasons for type errors. When you are trying to use a value improperly, a type error in Python may arise. For example, indexing a string, list, or tuple with something other than an integer. Second reason. There is a mismatch between the items in a format string and the items passed for conversion. This can happen if either the number of items does not match or an invalid conversion is called for. Third reason. You are passing the wrong number of arguments to a function or method. For methods, look at the method definition and check that the first parameter is self. Then look at the method invocation, make sure you are invoking the method on an object with the right type and providing the other arguments correctly. Let's see an example. Look at the Python code. In this example, you can see that we have created two variables, x and y. Variable x is holding a string hello and the other variable y is holding an integer value 4. Now we are trying to perform division between these variables and hold the result into the third variable, result, and printing the result. But Python will throw type error because an integer cannot be divided by string or character. The Python was expecting integer value, so it throws type error. So you can check the output below as type error on line 3. Value error is raised when a built-in operation or function receives an argument that has the right type but an inappropriate value. Let's see an example. Look at the Python code. This code prompts the user to input their age using the input function, which accepts user input as a string. The int function then converts this input string into an integer and assigns it to the variable age. Finally, the value stored in age is printed to the console using the print function. Now, look at the yellow box to see the output. The output begins with the prompt, enter your age. The user is expected to input their age. However, instead of providing a valid integer input, the user entered 20, which is not a valid integer representation due to the presence of the character O. As a result, the int function encounters a value error because it cannot convert the input string, 20, into an integer. Therefore, the program raises a traceback error, indicating that there was an invalid literal for conversion to an integer, that is the value error. Zero division error. Zero division error is raised when division or module by zero takes place for all numeric types. It occurs when in division operation, denominator is inputted as 0. Let's see an example. Look at the yellow box. Result equals 10/0. This will raise a zero division error because dividing by 0 is not allowed in arithmetic operations. Zero division error is a built-in Python exception that occurs when attempting to divide a number by 0. This error typically happens when you attempt to perform division where the divisor, the number you're dividing by, is 0, which is mathematically undefined. You can check the output here, zero division error, division by 0. Attribute error. Attribute error is raised when an object does not find an attribute. Causes for attribute error. Attribute error indicates that an object has a none type, meaning it is none. Forgetting to return a value from a function often leads to this error, as Python automatically returns none in such cases. Using list methods like sort, which return none, without assigning the result, can also trigger this error. Attempting to use a method not associated with a particular object, such as using append, on an integer list, can raise this exception. Let's see an example. Look at the Python code. X equals 10, x.append of 6. In Python, an attribute error is raised when you try to access or modify an attribute of an object that doesn't exist or isn't applicable to that object's type. In this code, you're trying to use the append method on an integer object, x, which will raise an attribute error because integers in Python do not have an append method. Here, you're trying to call the append method on x, thinking that x is a list. However, x is an integer, and integers do not have an append method, hence raising an attribute error. So the code should be like this. To fix this error, you need to make x a list if you intend to use the append method on it. So the output looks like list of elements containing 10, 6. 6 is appended or added to the list. Key error. Key error is raised when a mapping dictionary key is not found in the set of existing keys. Let's see an example. Accessing dictionary values. Now, look at the yellow box. In the statement, look at the first line. You're creating a dictionary named my_dict with two key value pairs, a:1 and b:2. Dictionaries in Python are collections of key value pairs, where each key must be unique. However, in the subsequent statement print of my_dict is c, you're trying to access the value associated with the key c in the dictionary my_dict. Since the key c does not exist in the dictionary my_dict, attempting to access it will result in a key error. You can check the output of key error here. Index error. Index error is raised when an index is not found in a sequence. That is, out of range or out of bounds. The index you are using to access a list, string, or tuple is greater than its length -1. This exception is raised when an index is not found in a sequence. In other words, it occurs whenever we try to access an index that is out of a valid range. Let's see an example. Accessing list elements. Look at the yellow box. In the statement my_list equals list containing elements 1, 2, 3, you're creating a list named my_list containing 3 elements, 1, 2, and 3. Lists in Python are 0 indexed, meaning the index of the first element is 0, the second element is 1, and so on. However, in the subsequent statement print, my_list of 3, you're attempting to access the element at index 3 of the list my_list. Since lists are 0 indexed and my_list contains only 3 elements, the valid indices for my_list are 0, 1, and 2. Therefore, trying to access my_list of index 3 is beyond the bounds of the list and will result in an index error. I/O error. Input-output error. I/O error is raised if the file requested cannot be opened, or failure of input or output operation, such as opening a file that does not exist, trying to delete a file in use, removing USB while read or write operation is going on. In all these situations, where some interrupt occurs in input or output operation, I/O error exception is raised. Let's see an example. Trying to access a file that doesn't exist. Look at the yellow box. Here we're attempting to open a file named non-existent_file.txt in read mode, R, using with statement. This with statement is commonly used in Python for handling files because it automatically closes the file after the block of code inside it is executed. However, if the file non-existent_file.txt does not exist in the specified location, Python will raise a file not found error when attempting to open it. This exception occurs when Python tries to access a file that doesn't exist in the file system. You can check the output here, file not found error. Indentation error. Indentation error is raised due to incorrect indentation. Now look at this example. In this example, the print statement is incorrectly indented. That is without spaces, white spaces. In Python, the standard convention for indentation is to use 4 spaces for each level of indentation. In Python, indentation is crucial for defining the structure of code blocks, such as functions, loops, and conditional statements. Below you can see the correct indentation of the print statement. So we can correct the syntax error when the errors are displayed. Python Exception Handling, Part 3. Today, I am here to teach Exception Handling Part 3, Handling Exceptions in Python, Try Except Statement with Practical Implementation. Let's discuss about handling exceptions in Python. What is exception handling? Exception handling is vital for preventing program crashes. It involves writing code to handle each exception, providing appropriate messages or instructions to the user. Need for exceptional handling. Exception handling is a widely employed technique across various programming languages, including Python, C++, Java, and Ruby. It aids in capturing and managing runtime errors to prevent program crashes, enhancing program reliability and user experience. Let's see the key points regarding exceptions and their handling, that is the need for exception handling. Python categorizes exceptions for specific handling. Exception handlers isolate error detection and correction from main program logic. Errors are tracked by the compiler or interpreter to locate their exact position. Exception handling applies to both user-defined and built-in exceptions. Let's learn about the process of handling exception. Exception object creation. When an error occurs, Python creates an object known as the exception object. This object holds details about the error, including its type, file name, and the position in the program where it occurred. Handover to runtime system. The exception object is then passed to the runtime system. The runtime system looks for appropriate code to handle the specific exception. Throwing an exception. This process of creating the exception object and passing it to the runtime system is termed as throwing an exception. Control transfer. Upon encountering an exception, control shifts to an exception handler. This interrupts the execution of the remaining program statements. Search for exception handler. The runtime system scans the entire program for an exception handler. Initially looks in the method where the error occurred. If not found, it traverses up the call stack to find a suitable handler. Call stack. The sequence of methods being executed is called the call stack. The runtime system searches this call stack in reverse order to locate an exception handler. Catching the exception. When a suitable handler is found, it's executed by the runtime process. This action of executing the appropriate handler is termed as catching the exception. End of program execution. If no suitable exception handler is found after searching the entire call stack, program execution halts. Now, you can see the flowchart describing the exception handling process. First, an error is encountered in a method. Exception object is created. Exception is raised. This is throwing an exception. Then runtime system searches for exception handler in the current method. If found, it executes the code, that is, catching an exception. If not found, it searches for methods in call stack in reverse sequence. Finally, if not found, program terminates. That is the end of program execution. These are the steps of handling exception. Let's discuss about the catching exceptions. Catching exceptions. An exception is considered caught when code designed to handle it is executed. Exceptions are captured within a try block and managed in an except block. Implementation. Suspicious code prone to exceptions is enclosed within a try block. Each try block is followed by an except block where exception handling code is written. Execution flow. If an exception occurs during execution of the try block, further execution halts. Control shifts to the corresponding except block to manage the exception. You can use the try except statement to gracefully handle exceptions. Here are the different methods for handling exceptions in Python. Method 1. Try and except block. Method 2. Try except with else block. Method 3. Try with multiple except blocks. Method 4. Try except with finally block. Method 1. Try and except block. Purpose of try and except block. Used in Python to catch and handle exceptions during program execution. Try block execution. Code within the try block is executed normally as part of the program. Handling exceptions. Code following the except statement responds to any exceptions raised in the preceding try block. Defending against exceptions. Suspicious code that may raise an exception is enclosed within a try block to defend the program against errors. Execution flow. If an error occurs within the try block, execution is transferred to the corresponding except block. This prevents program termination and allows for controlled handling of errors. Here, you can see the format. The try except block runs specified code and executes alternate code if an exception occurs. The syntax of try except statement is try : you do your operations here, except : if there is an exception, then execute this block. Let's see an example. Look at the yellow box for the Python code addition of two numbers, exception handling with try and except block. Line 1. This line is a comment indicating the purpose of the code block, which is to perform addition. Line 2. This line initiates a try block, indicating that the following code will be attempted, and any errors that occur will be caught by the except block. Line 3 and 4. These lines initialize two variables, n1 with the value 50 and n2 with the value 60. Line 5. Here, we have a printing statement which tries to print the sum of n1 and n3. However, there's a mistake. First is the syntax error. The print statement is incorrectly formatted. In this case, it should be print, sum of two numbers equals n1 plus n2, instead of n1 plus n3. And also we have the logical error. n3 is not defined anywhere in the code. It should be n2 to match the variable initialized earlier. Line 6. This line starts the except block, which handles any errors that occur within the try block. Line 7. This line prints a message indicating an error. However, it should be noted that it's inside the except block, meaning it will only execute if an error occurs in the try block. So the corrected code should be in line 5. Print sum of two numbers equals n1 plus n2. Now look at the output. Look at the red box. An error has occurred, indicates that an error occurred during the execution of the code, triggering the except block to be executed. When an exception occurs within the try block, Python jumps to the except block to handle the exception. In the except block, the code simply prints the message an error has occurred. Let's see another example, exception handling with try except block. Now, look at the yellow box for the Python code dividing two numbers. Line 1. This is a comment indicating the purpose of the code block, which is to perform division. Line 2. This line initializes a variable n1 with the value 0. Line 3. This initiates a while loop that will continue executing the following block of code as long as the value of n1 is not equal to 100. Line 4. This line initiates a try block. The code inside the try block will be executed, and if any errors occur, they will be handled in the except block. Line 5. This line prompts the user to enter a value for the dividend n1 using the input function. The eval function is then used to evaluate the user input as a Python expression. Let me explain the eval function used here. In this line of code, the input function prompts the user to enter a value for the dividend. Whatever the user enters will be treated as a string. For example, if the user enters 50, it will be a string, not an integer. Then, the eval function takes this string input and evaluates it as a Python expression. If the user enters 50, eval 50 will evaluate to the integer 50. Similarly, if the user enters 10 multiplied by 5, eval of 10 multiplied by 5 will evaluate to 50. Line 6. This line prompts the user to enter a value for the divisor, n2, using the input function, similar to the previous line. Line 7. This line calculates the quotient of the division operation between n1, dividend, and n2, divisor, using the floor division operator, and assigns the result to n3. The floor division operator in Python is used to perform division where the result is rounded down to the nearest whole number, integer, towards negative infinity. It divides the left operand by the right operand and returns the largest integer less than or equal to the quotient. Line 8. This line prints the calculated quotient to the console. Line 9. This initiates an except block, which catches any exceptions that occur within the try block. Line 10. This line prints a message indicating that an error has occurred if any exception is raised within the try block. Now let's see the output. The user is prompted to enter the dividend, and they input 50. Then, the user is prompted to enter the divisor, and they input 5. The code calculates the quotient of 50 divided by 5, which is 10. It prints the message the quotient is equals 10. Next, the user is prompted to enter the dividend, but they input ABC, which is not a valid numeric input. The code attempts to evaluate ABC using eval function, which raises a name error because ABC is not a defined variable or valid expression. The except block catches the exception raised by the invalid input, and it prints the message an error has occurred. Next, the user is prompted to enter the dividend, and they input 10. Then, the user is prompted to enter the divisor, and they input 0. The code attempts to calculate the quotient of 10 divided by 0, but division by 0 is undefined in mathematics and leads to a zero division error. The except block catches the zero division error raised by the division by 0, and it prints the message an error has occurred. Next, the user is prompted to enter the dividend again because the loop continues until the dividend n1 becomes equal to 100. Since the code snippet provided does not include any code to break out of the loop or terminate the program, it continues prompting the user for input. Note: when we use try except clause in the script and an error is encountered, a try block code execution is stopped and transferred down to the except block. Let's see the second method. Try except with else block. An optional else clause can accompany the try except block. If no exception is raised in the try block, the code in the else block is executed. The except block is executed only if an exception occurs within the try block. The else block allows for specific actions when no exceptions are encountered. Here, you can see the format. The try block runs specified code, the except block executes if an exception occurs, and the else block runs if no exception is encountered. The syntax of try except with else block is, try : you do your operations here, except : if there is an exception, then execute this block. Else : if there is no exception, then execute this block. The code in else block is executed only if there is no exception. Let's see an example exception handling using try except else block. As you saw earlier, in syntax errors topic, when syntactically correct code runs into an error, Python will throw an exception error. This exception error will crash the program if it is unhandled. The except block determines how your program responds to exceptions. Now, look at the yellow box. This Python code is meant to illustrate how to handle exceptions when dividing two numbers. Now, look at line 1. This is a comment indicating the purpose of the code block, which is to perform division. Line 2 initializes the variable n1 with a value of 0. Line 3. This initiates a while loop that continues until n1 becomes equal to 100. Line 4. Try: the code inside the try block is executed. If an error occurs during this execution, it is caught by one of the except blocks. Line 5. It prompts the user to enter the dividend, the number to be divided. Line 6. It prompts the user to enter the divisor, the number by which to divide. Line 7. It performs integer division of n1 by n2 and assigns the result to n3. Line 8. It prints the result of the division. Line 9. If a name error occurs, typically when eval cannot evaluate the user's input, it prints an error has occurred. Line 10. If a zero division error occurs, when attempting to divide by 0, it prints division by 0 not defined. Line 11. If a syntax error occurs, typically when the user's input is not a valid Python expression, it prints syntax error. Line 12. If a type error occurs, when the data types of operands are inappropriate for the operation, it prints data types do not match. Line 13. Else: this block is executed if no exceptions occur within the try block. Line 14. It prints execution is normal. Done after successful execution of the try block. Now, let's see the output. The user enters 10 as the dividend and 2 as the divisor. Since 10 divided by 2 equals 5, the quotient is correctly calculated and printed. Since there are no exceptions raised during the execution of the try block, the else block is executed, printing execution is normal. Done. Next, the user enters 8 as the dividend and 0 as the divisor, leading to a division by 0 error. The code catches the 0 division error exception and prints division by 0 not defined. Next, the user enters XYZ, which cannot be evaluated as a number, leading to a name error exception. The code catches the name error exception and prints an error has occurred. Next, the user enters 10+, which is not a valid expression, leading to a syntax error exception. The code catches the syntax error exception and prints syntax error. Next, the user enters strings hello and world as the dividend and divisor respectively, which are not compatible for division. This results in a type error exception. The code catches the type error exception and prints data types do not match. Next, the user enters 100 as the dividend and 2 as the divisor. The quotient is correctly calculated as 50. Since there are no exceptions raised during the execution of the try block, the else block is executed, printing execution is normal. Done. Let's discuss about method 3. Try with multiple except blocks. The try statement can include multiple except blocks with specific exception names. Each except block handles a particular exception. Exception names can be specified after the except keyword to catch specific errors. Try with multiple except block. At the occurrence of an exception, the script follows these steps. Control is directed to the corresponding except block for the specific exception encountered. If the exception isn't specified in any except block, control goes to the except block without any exception name. If neither case is met and there's no except block, the script terminates abruptly, akin to not using a try statement. In this structure, try with multiple except blocks, the code within each except block is executed based on the specific exception encountered, and if none match, the code following the except without an exception name is executed. The syntax of try with multiple except blocks is try: you do your operations here, except exception name 1: if there is exception 1, then execute this block. Except exception name 2: if there is exception 2, then execute this block. Except exception name 3: if there is exception 3, then execute this block. Except: if there is no exceptions with the specified name given above, then execute this block. The code in except block, without any name, is executed only if there is no exception. Let's see an example. Look at the yellow box. Line 1. This is a comment indicating the purpose of the code block, which is to perform division. Line 2. It initializes a variable n1 and assigns it the value 0. Line 3. It initiates a while loop that continues until the value of n1 is not equal to 100. Line 4. Try: it begins a try block, indicating that this portion of the code may raise exceptions, and it needs to be handled. Line 5. It prompts the user to input a value for the dividend, converts the input into a Python expression, and evaluates it. The result is assigned to the variable n1. Line 6. It prompts the user to input a value for the divisor, converts the input into a Python expression, and evaluates it. The result is assigned to the variable n2. Line 7. It calculates the integer division of n1 by n2 and assigns the result to the variable n3. Line 8. It prints the calculated quotient. Line 9. It catches a name error exception, which occurs if a variable is referenced before it is assigned a value, and prints a corresponding error message. Line 10. It catches a zero division error exception, which occurs if the user attempts to divide by 0, and prints a corresponding error message. Line 11. This except block catches any other exceptions that may occur during the execution of the try block. It prints out the message an error has occurred. The code essentially repeatedly prompts the user to enter a dividend and a divisor until the dividend becomes 100. It then performs the division operation, handling potential errors such as invalid input or division by 0 gracefully. So, multiple except blocks are used to handle different types of exceptions separately, allowing for targeted error messages and graceful error handling without program termination. Let's look at the output. The program prompts the user to input the dividend. The user inputs 80. The program prompts the user to input the divisor. The user inputs 2. The program calculates the quotient by dividing the dividend, 80, by the divisor, 2, resulting in 40. It then prints out the quotient is equals 40. Next, the user inputs ABC, which is not a valid numerical value. Variable not present, since the user input cannot be evaluated as a numerical value, a name error occurs, and the program catches this error, printing out variable not present. Next, the program prompts the user for the dividend again. The user inputs 50. The program prompts the user for the divisor. This time, the user inputs 0. Since dividing by 0 is undefined and results in a zero division error, the program catches this error and prints out division by 0 not defined. Next, the user inputs 10 plus, which is not a valid numerical value. An error has occurred. Since the input 10 plus cannot be evaluated as a numerical value, the program catches the error, generic except, block, and prints out an error has occurred. Next, the program prompts the user for the dividend once more. The user inputs 100. The program prompts for the divisor. This time, the user inputs 10. The program calculates the quotient by dividing the dividend, 100, by the divisor, 10, resulting in 10. It then prints out the quotient is equals 10. The program repeatedly asks the user for dividends and divisors, performing division operations and handling various types of errors, such as invalid input or division by 0, as the user provides input. Let's learn about the method for try, except with finally block. The finally block is termed as a cleanup or termination clause. It executes regardless of whether an exception occurred in the try block or not. Python allows implementing cleanup actions after executing code using the finally clause. In this structure, try except with finally block, the code within the try block runs, the except block executes if there's an exception, the else block runs if no exception occurs, and the finally block always executes. The syntax of try except with finally block is, try : you do your operations here, except exception 1 : if there is an exception 1, then execute this block. Except exception 2 : if there is an exception 2, then execute this block. And goes on, else : if there is no exception, then execute this block. Finally, : always executed. The code in finally block is always executed, no matter what. Let's see an example. Line 1. This is a comment indicating the purpose of the code block, which is to perform division. Line 2. It initializes a variable n1 and assigns it the value 0. Line 3. It initiates a while loop that continues until the value of n1 is not equal to 100. Line 4. Try : it begins a try block, indicating that this portion of the code may raise exceptions, and it needs to be handled. Line 5. It prompts the user to input a value for the dividend, converts the input into a Python expression, and evaluates it. The result is assigned to the variable n1. Line 6. It prompts the user to input a value for the divisor, converts the input into a Python expression, and evaluates it. The result is assigned to the variable n2. Line 7. It calculates the integer division of n1 by n2 and assigns the result to the variable n3. Line 8. It prints the calculated quotient. Line 9. It catches a name error exception, which occurs if a variable is referenced before it is assigned a value, and prints a corresponding error message. Line 10. It catches a zero division error exception, which occurs if the user attempts to divide by 0, and prints a corresponding error message. Line 11. It catches a syntax error exception, which occurs if there is a syntax error in the user input, for example, an invalid Python expression, and prints a corresponding error message. Line 12. Executes this block of code regardless of whether an exception was raised or not. In this case, it simply prints done after the try except blocks are executed. Let's see the output. The user inputs the dividend as 40. Then, the user is prompted to enter the divisor, 5. The quotient, which is 40 divided by 5, resulting in 8, is printed. Finally, done is printed to indicate the completion of this iteration. Next, the user inputs a non-numeric value, ABC, for the dividend. This causes a name error because ABC is not defined as a variable. The program catches this error and prints variable not present. Done is printed to indicate the completion of this iteration. Next, the user inputs the dividend as 30. Then, the user is prompted to enter the divisor. The user inputs 0 as the divisor. This causes a zero division error because division by 0 is not defined. The program catches this error and prints division by 0 not defined. Done is printed to indicate the completion of this iteration. Next, the user inputs 20 plus for the dividend. This input is syntactically incorrect because it's not a valid expression. This causes a syntax error. The program catches this error and prints syntax error. Done is printed to indicate the completion of this iteration. Next, the user inputs the dividend as 100. Then, the user is prompted to enter the divisor. The user inputs 2 as the divisor. The quotient, which is 100 divided by 2, resulting in 50, is printed. Finally, done is printed to indicate the completion of this iteration. In this program, the print statement given in the finally clause is always executed irrespective of whether exception occurs or not. So done gets displayed after every iteration of while loop. The finally block in a try except statement ensures execution of specified code regardless of whether an exception is raised, serving as a mechanism for cleanup or finalization tasks. Congratulations on completing the Python advanced level in one shot. Thanks for watching. If this helped you, don't forget to like, share, and subscribe to Sallyann Bytes. Keep coding and keep growing.